All right, let's quickly go through our quiz solutions. At this point, most of these, if you've gone through the practice test and the lesson and all those things, you should be able to get them right away. So it says, for question 1, determine if true or false, a number can be both rational and irrational since both are part of the real number system. This is false. A real number can only be rational, okay, which we would say it can be expressed as the quotient of two integers, where the denominator is not 0, and in decimal form it either terminates or repeats, and then or it could be irrational, where neither of those would be true. In decimal form, it's not going to terminate or repeat the same pattern, and you can't express it as the quotient of two integers. So this is false. Okay, so to determine if true or false, this is number 2. The number 0 is considered an irrational number since it can't be formed as the quotient of two integers, division with 0. This is clearly false because 0 is a whole number, it's an integer, and it's also a rational number. I can write 0 over 1, which is still 0. This is the quotient of two integers where the denominator is not 0. So that is a false statement. Okay, for question number 3, we're given the set of natural numbers, so 1, 2, 3, 4, and then again the 3 dots to say the pattern continues forever. If we started with a set of natural numbers and added the number 0 to the set, we would obtain which set of numbers? So in other words, if we had something like this, and let me make that a little bit better. So if we had this right here, so 0, then 1, 2, 3, let's go to 4, our 3 dots there. So what would that give me? Would it give me the whole numbers, the integers, the irrational numbers, or the rational numbers? Well, basically this would give me the whole numbers, right? It's the set of natural numbers with the inclusion of 0. So it's going to be this guy right here. Okay, so for question number 4, if we started with the set of real numbers and removed all rational numbers, which set would be left? Well, remember, a number that's a real number is either irrational or rational. So if I take all the rational numbers away, I'm just left with the irrational numbers. Okay, last question, question number 5. The square root of 5 is considered an irrational number because of which reason? All square roots represent irrational numbers by definition. That is not true. The number 5 is irrational, so the square root of 5 is also irrational. That's not true. The irrational number property, which doesn't exist, states that 5 and each number divisible by 5 is irrational. That's clearly false. So this guy is going to be correct without even reading it, but the square root of 5 can be written as the quotient of two integers with a non-zero denominator. Also, you could say it's an irrational number because when you look at the square root of 5, whenever you're thinking about a square root, the number underneath, if this guy right here is not a perfect square, well then this is going to be an irrational number. All right, let's look at our quiz solutions. We're going to start with question number 1 here. So it says we want to determine if true or false. And what we're given is the negative of 3 squared. We're saying is that equal to, we have a negative 3. The negative 3 is wrapped inside of parentheses here, being squared. So hopefully you know that these two are not going to be the same. So this answer here is going to be false, okay? But to dig a little bit deeper, I could write negative 3 squared like this with no parentheses around the base as saying I have negative 1 times 3 squared. From the order of operations, this would be negative 1 times 3 being squared first, right? 3 squared is 9, so negative 1 times 9 would give me negative 9, okay? So the left side of this would be negative 9. Then for the right side of this, we have negative 3 inside of parentheses being squared. So if I look at negative 3 being squared like this, parentheses around the base, this is negative 3 times negative 3, which of course is positive 9. So if I replace this with a 9, it's crystal clear. We don't have the same value on the left as on the right, so these are not equal. Okay, these are not equal. So we can say that the answer here is false. The negative of 3 being squared is not equal to negative 3, with the negative and 3 wrapped in parentheses being squared. Okay, let's look at another example. So now we have negative 3 being cubed, and the negative and the 3 are wrapped in parentheses, and this is cubed. Is this equal to the negative of 3 cubed? Now, what happens is whenever you have a negative out in front like this, and basically it's not wrapped inside of some parentheses, the answer for this problem will always be negative, right? Because it's basically negative 1 times whatever you have. So it just changes the sign of this guy here, which would be positive. In this case, 3 cubed would be 27. So this is negative 27, right? If we're looking at this guy right here, so negative 3 cubed. Now, with this guy right here, because the exponent happens to be odd, Well, it doesn't matter that I have parentheses around the base. I'm still going to get negative 27 because I have an odd number of negative factors. If I have negative 3 wrapped in parentheses raised to the third power, this is negative 3 times negative 3, and then times negative 3 again, odd number of negative factors. This is negative, and then 3 times 3 times 3 is, of course, 27. So either way, you get negative 27. So the left side here does equal the right side. You get negative 27 equals negative 27. So this is going to be true. Okay, let's look at question number 3. It says the order of operations is sometimes summarized with the acronym PEMDAS. If we look at the letters individually, you have parentheses, exponents, multiplication, division, addition, subtraction. So we're looking at this problem. So it's 54 divided by 9 and then multiplied by 3. It says, would it be correct to multiply 9 and 3 first, since multiplication is listed before division in PEMDAS? So hopefully you know that the answer is no, right? Multiplication and division have the same priority level. These operations are worked from left to right, okay? So the correct answer would be 54 divided by 9 is done first, which would give you 6, and then 6 times 3 would give you 18, okay? So this right here is the correct answer. Okay, let's look at question number 4. So we have 5 plus, you have this negative 2 wrapped in parentheses cubed, then this is divided by 8, and this is over. You have 6 times the square root of 9 minus 9 times 2. Okay, so we're going to work the numerator and denominator separately. That's what you do with a fraction. And basically, if I look in this numerator, I have addition, I have an exponent operation, and I have division. No grouping symbol, so no parentheses to worry about. So I'm just going to start with negative 2 being cubed. That's, of course, going to be negative 8. So you would have 5 plus, you would have negative 8, and then divided by 8. Now, you look at this, you have addition and you have division. So let me go ahead and do my division first. If I do negative 8 divided by 8, that is going to give me negative 1. And you can, of course, just write this as minus 1 like this, and then 5 minus 1 is going to be 4. Okay, so the numerator up here is just 4. Now for the denominator, I'm looking at what I have. I have multiplication, I have square root operation, I have subtraction, and I have multiplication. So the square root operation is actually done with exponents, right? So it's the E step. So it's going to have a higher level of priority than multiplication or any division that you might see. So what I would do here is do the square root of 9, which is of course 3. So you would have 6 multiplied by 3, then minus 9, then multiplied by 2. So you want to do this multiplication first. We're working left to right. So 6 times 3 is 18. You can just erase that. So I'll put 18 here. Then you want to do this one. So 9 times 2 is 18. So this is 18. 18 minus 18 is, of course, 0. So if I put a 0 there, we run into a big problem, right? Because we know that 0 cannot be the denominator of a fraction, or it cannot be your divisor in a division problem. I can't do 4 divided by 0 legally. You punch that into any calculator, and it's going to say, give you some kind of error, but typically in math, we'll say undefined, okay? So this problem here is undefined. Okay, let's take a look at question number 5. So we have 5 minus the square root of 9, and then times, we have this negative 5 minus 3 being squared. This is over negative 7. And then we have minus 3 and then times 2. And this is all over. We have negative 9 minus the square root of 121 and then plus 3 multiplied by the cube root of 343. So this is quite involved. Let me copy this. Let's go to a fresh sheet of paper. Let me paste that in there. And again, I'm just going to work the numerator and denominator separately. If you look at the numerator, you do have these parentheses here. So I would start inside of there. And again, you have a fraction, so you want to work above and below that fraction bar separately. So let me just simplify that really quickly. You have negative 5 minus 3 squared. Well, you do the 3 squared first because it's the exponent operation. That would give you 9. So let's say we have negative 5 minus 9. And of course, you just do negative 5 minus 9. That's negative 14. So then you would have negative 14 basically over negative 7, right? So this is division. It ends up giving you 2. So let's go ahead and replace this guy as 5. We'll say minus the square root of 9. And then we're going to go ahead and say times 2 because this is basically multiplication here since these guys are next to each other. And then minus 3 and then times 2. Okay, so looking at this guy now, we don't have any grouping symbols in here. What we do have is subtraction. We have our square root operation, multiplication, subtraction, multiplication. Square root operation is going to have the highest priority here. The square root of 9 is 3. Okay, so now I have multiplication next, and you have it here, and you have it here. Let's do 3 times 2 first. That's going to give me 6. And then let's do 3 times 2 over here. That's going to give me 6. And now let me do my subtraction left to right. 5 minus 6 is -1. And then -1 minus 6 is going to be -7. So this is going to be -7 up here. So let me get rid of this. And let's come down here. In the denominator, you'll see that you have this subtraction, you have this square root, you have addition, you have this cube root here, and you have multiplication, okay? So let's perform the operations with the square root and the cube root first. The square root of 121 is 11, so this would be -9 minus 11, plus you have 3 times. The cube root of 343 is 7. Now looking at it, we have subtraction, we have addition, and we have multiplication. We want to do our multiplication first. So let's go ahead and do 3 times 7. That's going to give me 21. And then from here, I can just subtract and add left to right. So -9 minus 11 would be -20. And -20, let me erase this as I go, or I can actually just put this over here. You'd have -20 plus 21, so this would be +1. So you can put a 1 there for your denominator. And basically you have -7 over 1, which is just -7. So if we go back to this guy right here, you see this is the answer right there, which is -7. All right, let's take a look at our little quiz here. So for question 1, we're asked, what is the ratio of carrots to apples? Of course, you're looking at this image here, and you have 1, 2, 3, 4 carrots. So I'll just list that first, because that's given first here. And then I'll put my little colon. And then for the apples, I have 1, 2, 3, 4, 5, 6. So it's 4 to 6. But of course, when you give a ratio, just like when you give a fraction, you want to make sure it's simplified. So between 4 and 6, I have a common factor of 2. So I can basically just divide each part by 2. 4 divided by 2 would give me 2. So I'll just erase this and put 2. And then 6 divided by 2 would, of course, give me 3. Okay, so the ratio of carrots to apples is 2 to 3. And of course, if you take this as a row, you can see that, right? I have 2 carrots for the 3 apples that I have. And then if I look at the next row, I have 2 carrots for the 3 apples that I have. So the ratio here is 2 to 3. So I'm going to circle this one here as the answer. Let's look at question number 2 now. We have on a local field trip, there are 20 boys and 14 girls. What is the ratio of boys to girls? So again, we're told that there's 20 boys for the 14 girls, okay? And essentially all you want to do is just simplify this ratio. Each here is divisible by 2. Or we could say there's a common factor of 2. If I did 20 divided by 2, I would simply get 10. And 14 divided by 2, I would get 7. So the ratio here for boys to girls is going to be 10 to 7. So for every 10 boys, there's 7 girls. So that's going to be right here, 10 to 7. All right, let's look at question number 3 now. This one is a little bit tricky for most of you. So basically we have here that a sack of marbles contains a total of 152 marbles. I'm just going to write that here real quick. So 152 marbles, just so we can keep track of things. The sack contains only red and green marbles, so no other type. If the ratio of red marbles to green marbles is 5 to 3, so this is 5 red, okay, for every 3 green. Okay, so that's the ratio. We want to find the number of red marbles and the number of green marbles in the sack. Okay, so for this type of problem, my suggestion is always to do this. You know that you have 5 red marbles for every 3 green marbles. Okay, that's established. So that means in one group, we'll just say there's 8 marbles, okay? And where I'm getting the 8 from is I just added 5 plus 3. So that's 8 marbles in one group, okay? So that means in that one group, I have 5 red, okay? And I have 3 green. So from here, it's really easy to say, well, if this is one group, and if I have 152 total marbles, well, how many of these groups can I make? I would just divide 152 by 8, and I would get 19, okay? So basically, you can make 19 of these groups. And I think it's pretty clear now what you need to do. You're just going to multiply the number of red in each group times the number of groups. So in other words, 19 times 5 would give you 95. So in the 152 marbles, you're going to have 95 red, okay? Again, 19 times 5 is where I got that. And then in the 152 marbles, you're going to have 3, okay, multiplied by 19, which is 57. So 57 green, okay? And you can go through and add 95 plus 57, you're going to get your 152, okay? And then if you look at the ratio of 95 to 57 and you simplify that, you're back to your 5 to 3, okay? So this is all consistent with what we're told in the problem. And let me scooch this up here real quick. and we'll just look for our answer. It's going to be this one right here, 95 red marbles and 57 green marbles. So that's the one we want for this problem. Okay, let's look at our fourth question. We have that Jonathan is trying to purchase milk for the cheapest price per gallon. He visits the Gaffert grocery store and finds that he can buy 7 gallons of milk for $9.17. Then he visits the Mox Price Club and finds that he can buy 18 gallons of milk for $25.20. So find the price per gallon for each scenario. This is just finding a unit rate, okay? This is something you would do in your everyday life. If you went to the store and, for example, you go to Gaffert grocery store and you find that you can buy 7 gallons of milk for $9.17. Well, if you want to find the price per gallon, you would say, okay, well, I have $9.17 divided by, okay, my 7, and you could put for clarity here. I'm going to put gallons, and you could do of milk if you want, makes it a little bit long, okay? And when you do the division of this by this, you're going to get the unit rate or the price per gallon of milk at this particular grocery store. So if you do this on a calculator, you're going to get 1.31. Okay, so 1.31, which basically means that it's $1.31 per gallon. Okay, per gallon. Because basically this would end up being, we'll put equals, we'll put $1.31 over 1 gallon, okay, of your milk. And we just write that as $1.31 per gallon. Okay, that's all you need to do. Now, in the other scenario that we're given, it says that he can buy 18 gallons of milk. So let me change this to 18 now. And he's doing that for $25.20. You can just put 25.2 if you want. I think for clarity, you might want to put the 0 at the end. It's really up to you. So 25.2 divided by 18 is going to give you 1.4. Of course, since we're working with dollars here, I'll put $1.40 per gallon. Okay, so the answer we're looking for here, and we can just erase this, is just scratch work here. The answer we're looking for here is that at Mox Price Club, which was the second one, it's $1.40 per gallon. At Gaffert Grocery, which was the first one we did, it's $1.31 per gallon. So we want this answer right here. Okay, let's look at problem number 5. So we have Xantarf Bakery makes a 40-count cookie batch that requires 5 cups of flour and 2 cups of sugar. One day, the bakery receives an order for 120 cookies. Use the concept of a proportion to find the required amount of flour and sugar for the order. So this is something you really don't even have to use a proportion for. Most of you can do this in your head and say, well, if I have a 40-count cookie batch and that requires 5 cups of flour and 2 cups of sugar, well, now with a 120 cookie batch, basically it's 3 times the amount. So 5 times 3 would be 15 for the amount of flour, the cups, and 2 times 3 would be 6 for the cups of sugar. So that's pretty straightforward. But if you want to use a proportion, you can. You can say 5 cups of the flour over, okay, you can say 2 cups of sugar, okay? And basically you would just multiply this by 3 and this by 3. And this would be equal to, you would say your 15 cups, let me scroll down a little bit, of this flour to the 2 times 3 would be 6. So we'd have 6 cups of sugar. Okay, so that's really all it is. You really don't need a proportion in this case. It's a very simple problem, but in case you want to see it for clarity. So here's our answer here, 15 cups of flour and 6 cups of sugar. That's what we want. All right, let's look at our quiz solution. So for question 1, it says, what property allows us to change the order of add-ins in addition? For example, 7 plus 4 is equal to or the same as 4 plus 7. So it doesn't matter if you do 7 plus 4, you get 11, or 4 plus 7, you also get 11. So the property that allows us to change the order of our add-ins with addition, or if you're working with multiplication, the order of the factors, okay, that's called the commutative property. So the commutative property, in this case, since it's addition, of addition, if you're doing multiplication, would be of multiplication. For question 2, it says, what property allows us to change the way in which we group the multiplication of 3 or more factors? So for example, we're given here that 3 times 5, that's in parentheses, times 6 is equal to, we have 3 times, you have 5 times 6, or 5 times 6 is in parentheses. Well, on the left, if you do 3 times 5 first, because it's in parentheses, you get 15, and then 15 times 6 is 90. On the right, if you do 5 times 6 first, that's 30, and then 30 times 3 is 90. So it's the same either way. And remember, if you want to change the grouping of either your add-ins or your factors, okay, depending on if you're doing addition or multiplication, the property that allows this is called the associative property. Okay, so the associative property of multiplication, again, if you're doing this with addition, would just be of addition. Okay, for question 3, what happens when we multiply a number by its reciprocal? What's this property known as? So we're given an example here, 3 times a third, so 3 times 1/3. So what do you think is going to happen? Well, if you multiply a number by its reciprocal, you always get 1, as long as the number is not 0. Okay, so as long as the number is not 0. So let's cancel this with this and show that we have a 1. So this is what we're looking for here. The result is 1, and then we want the multiplicative inverse property. So again, multiplying a non-zero number by its reciprocal will always give you 1. All right, for question 4, use the distributive property to change our product into a sum. So we have 5x times the quantity, z plus 2y plus 4. You're just going to distribute this guy to each term inside of the parentheses. That's all it is. So you would have 5xz plus, you would have 5 times 2 is 10, then xy, then plus you have 5 times 4, which is 20, and then x. So I'm looking for that. I have that right here, 5xz plus 10xy plus 20x. So that's my solution right there. And then for question 5, it says use the distributive property to change our sum into a product. This is where we're going to basically be factoring. And again, we'll talk more about this later on in the course. This is something you should know how to do already, but if you don't, it's okay. We will go into depth on this, okay? So basically, I'm looking for what's common here, okay? So I can pull it out. So between 12 and 60, you have a common factor of 12, okay? So I can basically pull that out, right? And an easy way to do this, let me make this more clear. You could write this as 12 times x like this, plus for 60, I'm going to break this down into 12 times 5, okay? Now, if I pulled out the 12 from each guy here, so if I pull this out, you'd basically say, well, what's left to go inside? The 12 goes outside of a set of parentheses. I have my x inside, and then plus, I have my 5 inside, okay? So this becomes 12 times the quantity x plus 5. If you reverse this, 12 times x is 12x, and then plus 12 times 5 is 60. So you're right back to where you were. So we want this answer right here, which is 12 times the quantity x plus 5. All right, let's look at our little section quiz here. So for the first question, we have this set A, and we're going to use this actually for the next question. Let me write this over here. Our set A contains the elements. We have -4, we have the square root of 2, we have -1/4, we have 0, and then we have 17, okay? So the idea is that we want to find out which elements or which numbers in here are going to be integers, okay? Remember the integers, the set looks like this. You put the 3 dots there, you're going to put a comma, and then you're going to start with something like, let's just say -3, okay? Then a comma, then -2, then -1, then 0, then 1, then 2, then 3. And then again, I'll put a comma and 3 dots, okay? Again, the 3 dots tell me that the pattern continues indefinitely. So going to the right of 3, I have 4, then 5, then 6. I'm just increasing by 1. And then to the left of -3, I'm decreasing by 1. So I have -4, then -5, then -6, so on and so forth. So looking at these numbers, you can see that -4 is going to be an integer. The square root of 2 is not going to be. We'll talk more about this number in the next problem. The negative of a fourth or -1/4 is not, right? 0 would be, and so would 17, okay? So those are your 3 integers, -4, 0, and 17. Those would be members of this set, okay? So let's go ahead and click on this, and we want this answer here, -4, comma 0, and then comma 17. Okay, so now it asks which elements of set A, same set we're looking at, are irrational. So let me write this again. So set A, again, looks like this, and I can never make these braces. It's so difficult for me. So -4, you have square root of 2, you have -1/4, you have 0, and you have 17. Now, it's pretty obvious which one here is going to be the irrational one. But in case you haven't seen this, it's going to be this guy here, okay? Because -4 is going to be a rational number, so is -1/4, so is 0, so is 17. So remember, when you have a number, like let's say -4, you could write it over 1 and make it a rational number because it's the quotient of 2 integers where the denominator is not 0. Even with 0, I can write that as 0 over 1. -1/4, you could write that as -1/4 or 1 over -4. And 17, I could write that as 17 over 1. Okay, so those are all rational numbers. And by definition, if you have a rational number, it's not going to be irrational. A real number is either rational or irrational. But with this square root of 2 guy here, when you're looking at a square root, if the number underneath, in this case it's 2, is not a perfect square, then you have an irrational number. And a perfect square is where you have a rational number that multiplies by itself to give you the number. There's no such number that you can multiply by itself in terms of being a rational number that would give you 2. Okay, so that is what we're looking at there. So that's going to be our irrational number. So it's this guy right there. Okay, for the next problem, we want to evaluate each, and then we want to name the base and the exponent. So we've talked about this a lot so far. So we have the negative of 2 to the 4th power. Again, the idea here is to realize that the negative is not wrapped inside of a set of parentheses. So really, you could write this as negative 1 times 2 to the 4th power. So your base is 2, and your exponent is 4. Okay, the negative 1, you can think about that as a multiplier. Okay, something that's going to multiply the result of this. So 2 to the 4th power is 16. Negative 1 times that is negative 16. So your answer here would be negative 16, where 2 is the base and 4 is the exponent. For the next problem, problem number 4, this is a little bit involved. We have to kind of set this up. So since this is a fraction, we're going to end up doing the numerator and denominator separately. So let me copy the numerator, and let's paste this in here so we can work on it. Okay. So anytime you work on an order of operations problem, remember you always want to start inside of parentheses or grouping symbols that you might have. So we have parentheses here, and then we have absolute value bars here. Okay, so I'm going to just start inside of these parentheses here. When you go inside the parentheses, the idea is that you want to reapply the order of operations. So in other words, when I look inside of here, what's the highest level of priority? Well, it's going to be exponent operations. I have 2 to the 5th, 2 to the 4th, and 2 squared. So you can crank all of those out. 2 to the 5th is 32, and then 2 to the 4th power is 16, and then 2 squared is going to be 4, okay? So I'm still inside of the parentheses there, okay? And I can put equals here if I want. I'll fill out the rest of that in a moment. So once I complete that task, now I'm looking at subtraction and division. I know that I want to divide before I subtract. So what is 16 divided by 4? That's 4, okay? Let me just erase this as I go and just put this as 4. And then lastly, I would do 32 minus 4, which is 28. So the result of this inside the parentheses is 28. So now I have 28 here, and it's divided by, we have this absolute value bars here, so we're going to be working inside of here, okay? And inside of there, you'll notice that you have basically a cube root operation. You have multiplication, square root operation, addition, and exponent operation. Now, when you work with exponents or when you work with radicals, they have the same priority level. So let's go ahead and take care of all those. The cube root of 125 is 5, and we want the negative of that. So this is just negative 5. Then times the square root of 9 is 3. Then plus 2 cubed is simply 8. Okay? So from here I have multiplication and I have addition. We know that multiplication is the higher priority. So negative 5 times 3 is negative 15. So this is just negative 15. And then lastly, negative 15 plus 8 is going to be negative 7. So basically we want the absolute value of negative 7, which since this is a negative number, we're just going to make it positive. Okay. So the absolute value there would just be 7. Okay. So from here, we divide 28 by 7 and we get 4. So this is the result for the numerator. So let's go back and let's put this as our numerator. And then this is over. So everything in the denominator is enclosed inside of the absolute value bars. So we're just going to work inside of that. And when we look in there, we see that we have an exponent operation, we have addition, we have a square root, we have multiplication, and then we have subtraction and a cube root, okay? So let's do our exponents and our radicals. So basically you have the negative of 5 squared. So that is going to be negative 25. Remember, 5 squared is done first, then apply the negative, and then plus square root of 49 is 7, then times 5, and then I'm subtracting away the cube root of 216, which is 6. So inside of here, I have addition, multiplication, and subtraction. You want to do your multiplication first. So 7 times 5 is 35. Let's change this color here so that's 35. And now I can just add and subtract working left to right. So negative 25 plus 35 is going to be positive 10. So this is positive 10. And 10 minus 6 is going to be 4. And if I want the absolute value of 4, you can kind of tighten this down. The absolute value of 4 is going to give me 4. Okay, so if we go back, I'm going to put a 4 here. And of course, 4 divided by 4 after all that work is 1. So we come over here and this is our correct answer. All right, for question 5, we're told to use the commutative property to simplify each expression. Now, for most of you, when you hear the commutative property, you're used to just switching things and leaving it. But here we actually want to simplify the expression. So the idea is this. If you have negative 9x and you multiply it by 1 over 18, The idea is that I'm going to basically say that I'm going to do negative 9 times 1 over 18 basically first, and then times x. I'm just changing the order around so I can multiply these numerical values together first, and then when I'm done, I'll multiply it by x, or show the multiplication by x by having a coefficient. Okay, that's all it is. So this is going to cancel with this. 18 divided by 9 is 2, so this will basically be negative 1/2. So we end up with negative 1/2 times x. Let me write that over here, so negative 1/2 times x. So if I come over here, that's going to be this answer right here. So negative 1/2 times x. Okay, so now we're told to use the associative property to simplify each expression. Again, this is a lot more to do with just the grouping of things. So if I have 14 plus, we have 7 plus x, and these guys are grouped together, so that's a quantity. The idea is that I'm just going to change the grouping, and I'm going to say now I have 14 plus 7, okay, plus x like this. Well, if I'm doing 14 plus 7, that's 21, okay? So this is 21 plus, I wrote 21x, this should be 21 plus x, which is this guy right here, okay? So 14 plus 7, that quantity, okay, plus x, so that's changing the way it's grouped, and this is equal to the 21, which is 14 plus 7, and then plus x. So that's your solution right there. Okay, so question 7, we want to use the inverse and identity properties to solve each equation. So I put a hint here, isolate x by adding the same number to both sides of the equation. In other words, how do we get x by itself? So for some of you, you haven't taken a basic Algebra 1 course. We're going to go far into detail on how to solve equations later on. For right now, if you have something like x plus 5 is equal to negative 2, well, you just want to think about how can I get rid of this plus 5 here? We did a practice test exercise where we said, what number can I add to this number to make it 0? That's what I want to do. I want to add something to this side to make this 0, but I've got to also add it to this side to keep it balanced, okay? Well, if I add the opposite of 5, which is negative 5, to both sides, I will accomplish that. So in other words, x plus 5 plus negative 5 is equal to negative 2 plus negative 5, okay? That's all it is. And if you simplify here on the left, 5 plus negative 5 is 0. So that's gone. X plus 0 is just x, and this equals, on the right side, negative 2 plus negative 5 is negative 7, okay? So x equals negative 7 is the result. Again, don't get too worried or frustrated if you can't solve equations at this point. It's not that big of a deal. Okay, let's look at our next question. This is number 8. Use the inverse and identity properties to solve each equation. Hint, isolate x by dividing both sides of the equation by the same number. In other words, how can we get x by itself? So you have 3x is equal to 12, okay? What can I do here to get rid of the 3? Again, we talked about multiplying a number by its reciprocal, and you would get a result of 1, okay? So if I multiply both sides here by a third, or if I divide by 3, okay, both sides, what's going to happen is 3 divided by 3, or 3 times a third, is 1, okay? And 1 times x is just x. So this becomes x is equal to 12 divided by 3 is 4, okay? So here, x is just 4. All right, let's look at the next one. So we want to use the distributive property to rewrite each product as a sum. So we have negative 5y times the quantity 7x minus 2z, okay? So we're just going to, again, just distribute. So this is going to get distributed here and then also here. So you have negative 5 times 7, which is negative 35. And then x times y is just xy. And then negative times negative is positive. So we do 5 times 2, which is 10. And then y times z, which is yz. Okay, so negative 35 xy, or you can put yx. The order with multiplication does not matter. Then plus you have 10 yz. Okay, so it's this one right here. That's our solution. Okay, so now we're asked to use the distributive property to rewrite each sum as a product. So when you want to go backwards like this, you're given a sum and you want to get a product. Again, this is called factoring. So 14xy minus 49x. You want to look for what's common between the two. So for myself, I think about, okay, well, 49 is divisible by 7, and so is 14, right? So I'm thinking this is 7. Let's go ahead and put the x times 2y minus, I'm going to write this as 7. We'll go ahead and say x times 7, okay? I'm just breaking this down in such a way to where you can clearly see what's common to both. And then all you're going to do is just pull that guy out, okay? Let me scooch this up a little bit so it fits on the screen. You're going to pull this 7x out in front of a set of parentheses. So this is basically going to go right there. Inside, you're going to have the 2y, and then minus, you're going to have the 7, okay? So we're looking for 7x times the quantity 2y minus 7. So that's going to be this answer right here. Okay, now we're told to use the image above to solve the following problem. What is the ratio of pineapples to carrots? Well, I have 1, 2, 3, 4, 5 pineapples. And you can see I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 carrots. So the ratio of pineapples to carrots, you put the pineapples first, so that's going to be 5, to the carrots second, which is going to be 10. Okay, so it's 5 to 10. But whenever you report a fraction or a ratio or something like that, you want to make sure it's simplified. And 5 and 10 each have a common factor of 5. So if I divide 5 by 5, I get 1. If I divide 10 by 5, I get 2. Okay, so in other words, for every 1 pineapple, there's going to be 2 carrots. Okay, so if you look at this in a column, you have basically 1 pineapple for 2 carrots, 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 1 pineapple for 2 carrots. So that's all that ratio is telling you. So let me erase all of this actually, because it's going to get in the way of our answer. Okay, so we're looking for 1 to 2. That's what we have right there. That's our solution. Okay, for question number 12, a local farm grows strawberries and blackberries only. On a recent harvest, the ratio of strawberries to blackberries was 7 to 3. If a total of 390,000 berries were harvested, how many were strawberries and how many were blackberries? So we've seen quite a few of these problems. You know, my strategy at this point for solving this is to say, okay, well, if I have 7 strawberries, I'm just going to put straw for that, like that, to abbreviate it, to 3 blackberries, I'll just put black, okay? So if this is the ratio, well, I'm going to add 7 and 3 together to get 10. So out of every 10 berries that I collect, 7 are strawberries and 3 are blackberries. Again, on average, you might reach into the pile and get something different, but this is the ratio if we're looking at all of them, okay? So this is one group. I'll say one group is going to be 10 berries, okay, 10 berries. I don't know if I spelled that correctly. I got to look at it real quick. So yeah, that's right. And we'll have 7 strawberries. 7, I'll just put ST for strawberries. And 3, let's put BL for blackberries. Let's erase this and kind of slide this up a little bit. Okay, so once you have this set up, the idea is just to say, okay, well, one group is 10 berries. I can divide the total number here, 390,000, by 10 to see the number of groups. If you divide something like this with zeros in the end by 10, you just delete one of the zeros. So you would get 39000, or 39,000 such groups, okay? And so if you multiply 39,000 by 7, that's going to be the number of strawberries, right? 39,000 groups with 7 strawberries in each group. So that would give you 273,000 strawberries, okay? And then if you did 39,000 times 3, you would get 117,000 in terms of the blackberries, okay? So you actually want this answer here, the 273,000 strawberries and 117,000 blackberries. If you do the addition, you do get 390,000 berries in total, and the ratio is still the same. Okay, let's look at question 13. So the GTI-CA Model A car can drive 561 miles on 17 gallons of gas, whereas the Autorec Model B car can only drive 429 miles on 11 gallons of gas. What is the miles per gallon rating for each car? So this is just a simple unit rate problem. In the first one, you have 561 miles, and this is done on 17 gallons. You can put of gas if you want to make it a little bit longer, more descriptive, but I'm just going to put gallons. And then the other one is going to be 429 miles, okay? And this is done using 11 gallons of gas, so 11 gallons. All you need to do is divide the numerator by the denominator in terms of the numbers. So 561 divided by 17 is 33. So this would be 33 miles per gallon. So 33 miles per gallon. And this was for the, let's just go ahead and put Model A. The rest of the name is a bit long, so let's leave that out. And then this one, 429 divided by 11 is actually going to be 39. So for this Model B, it's 39 miles per gallon. And so that's going to be this guy right here, where the Model A is 33 miles per gallon and the Model B is 39 miles per gallon. All right, for the last question, question 14, it says determine if the following represents a proportion. So you have 13 students, I'll just put ST, over 2 teachers, I'll put TE, is equal to 91 students, I'll put ST again, over 12 teachers, I'll put TE again. So does this represent a proportion? Again, the idea is that you're going to cross multiply. So what is 12 times 13? Well, that's going to be 156. And then what is 2 times 91? Well, you know that's going to be larger because 2 times 90 is 180. So already you know that's not going to work out. This is going to end up being 182. but essentially you don't have the same values when you cross multiply. So we can officially say, no, this is not a proportion. All right, let's take a look at our little quiz. So for the first question, we're asked to determine if true or false. We have a simple statement. So we have that negative 11 is less than negative 5. So is this a true statement or is it a false statement? Well, when you think about comparing two negative values or two negative numbers, you want to think about the fact that the larger negative number in terms of its absolute value is actually the smaller number because it's going to be to the left of the other number on the number line. So in other words, the absolute value of negative 11 is 11. The absolute value of negative 5 is 5. So because negative 11 has a larger absolute value, because it's a bigger negative in terms of its absolute value, it's actually a smaller number. So negative 11 is less than negative 5. This is a true statement. Okay, for question 2, we're asked to determine if true or false, and we have 299 is greater than or equal to 299. So with this non-strict inequality, this greater than or equal to, it would be a true statement if 299 is greater than 299, which is not the case, or if 299 is equal to 299, which is the case. Okay, so with a non-strict inequality, again, you allow for the possibility that the two are equal to each other. So in this case, because 299 is equal to 299, our answer here is true. Okay, for question 3, we're asked to write the following numbers as an inequality statement. So we're given the numbers. Let me write these out. So negative 4, we have 11, we have 22, we have 5, we have negative 9, and we have negative 15. So the main idea here is to order this in the same way that you would on the number line. So I would just pick what is the smallest number. Well, we have positives and we have negatives, and we know that all negative values are automatically smaller than any positive value. Okay, so let's go ahead and say we have negative 4, negative 9, and negative 15. Let's think about those first. What is the smallest number? Well, in terms of the negatives, again, you think about them in terms of absolute value. The bigger negative number in terms of its absolute value is actually the smaller number, okay, because it's the furthest to the left on the number line. So that's going to go to negative 15. So negative 15 is the smallest number here. Again, because in terms of being negative, it's got the largest absolute value. So it's the biggest negative in terms of absolute value. So it is actually the smallest number. And I know this is confusing when you first hear it, but you just have to keep working the problems and it will come. So the next largest in terms of absolute value would be negative 9, right? So that's my next smallest number. So I'm going to go is less than negative 9. And then lastly, we would have negative 4. So is less than negative 4. So that takes care of these negative numbers. You can get rid of this, okay? And you can obviously pull out a number line and verify this. If you were on the number line, you'd have negative 4, which is to the right of negative 9. Negative 9 would obviously be to the right of negative 15. So this inequality here is true. Okay, now we're looking at these positive numbers, and we have 11, 22, and 5. I think at this point, everybody knows how to compare those. So basically, we would put less than. The next number on the list would be 5, right? So that's the next to go in our statement here. And then you would have is less than, you'd put 11. And then lastly, we would put is less than 22. Okay, so this is in terms of the number line. And you see we're using a less than in each case. So negative 15 is less than negative 9, which is less than negative 4, which is less than 5, which is less than 11, which finally is less than 22. Okay, again, you can make a little number line and put these numbers in place, and you'll see that this is a true statement. So to pick our answer, we're going to want this one up here, which again says negative 15 is less than negative 9, which is less than negative 4, which is less than 5, which is less than 11, which finally is less than 22. All right, for question 4, we want to write the following statement in interval notation. We're given that x is greater than negative 4. So this is a strict inequality. Remember, we want the smallest possible value, comma, the largest possible value. Well, in this case, I don't actually have a smallest possible value because it's strictly greater than negative 4. So I'm just going to put negative 4 here, and then I'm going to put a parenthesis next to negative 4 to identify that, hey, this isn't the actual smallest value, okay? Then over here on the right, because it's greater than negative 4, it can be any value going out to positive infinity. So I'm just going to put the infinity symbol here, and then we always use a parenthesis with positive or negative infinity. So I'm going to want this answer right here. So basically the negative 4 with a parenthesis next to it, comma, you have infinity, again with a parenthesis next to it. Okay, for question 5, we want to write the following statement in interval notation. So you have x is greater than or equal to negative 6, and less than 11. So again, I'm thinking about the fact that x could be -6. So in terms of the smallest value here, it could actually be -6. So I'd write -6 and I'd put a bracket there and then a comma. What's the largest value? Well, basically we're going to put 11 in here for that place, but it can't actually be 11. So to identify that, I'm going to use a parenthesis there, okay? So I'm looking for this answer right here, where the -6 is next to the bracket, then you have a comma, and the 11 is next to the parenthesis. All right, let's look at our little quiz here. So we want to simplify each, and what we're given is the negative of the absolute value of -21. So the idea is that you would take the absolute value of -21 first. So if we do that, we get +21. And so then we end up with a negative of 21, which is just -21. So we're looking for this answer right here. Okay, so this says solve the inequality for x, write the answer in interval notation. So we have that the absolute value of x is greater than 15. Okay, so remember we talked about this in the lesson. We also talked about it in the practice test. The idea here is that if you have this guy right here, the absolute value operation isolated, and then you have a number on the right-hand side that's not a negative, well, if this is a greater than here, you want to set it up where you say x is going to be greater than this number, so greater than 15, or x is less than -15. Okay, so the reason that works is if you think about it, with the absolute value operation, you're plugging this in and you're always getting a positive, or you could get 0 if you plugged in 0, but it doesn't matter if you plug in a negative or positive, you're going to get something that's non-negative, okay? So I want something that's going to be greater than 15, so I need, in terms of the positive values, I need something that is actually greater than 15, so that's where this comes from. But when you think about the negative values, again, it's flipping them to positive. So now I need something that's going to be less than -15. So for example, -16 would work. The absolute value of -16 is 16. 16 is greater than 15. But if it was something that was, let's say, -14, well, that's not small enough in this case because the absolute value of -14 gets flipped to 14, and 14 is not greater than 15. Okay, so that's where this part right here comes from. Okay, so you need those two. So your solution, if you're looking at it here, would be that x is greater than 15 or x is less than -15, okay? And then in interval notation, the way we do this for this negative part, we have from -infinity up to but not including -15. So you have a parenthesis next to each. Then you have this union symbol, which we'll talk more about later on in the course. And then we have this 15 out to +infinity. Again, the 15 and the infinity are not included. So you see this in interval notation. So this would be our solution for number 2. Okay, so we have, again, solve the inequality for x, write the answer in interval notation. So the absolute value of x is less than -1. Again. Whenever you see this isolated over here and you got a negative on the right-hand side, this is a trick question, okay? Can the absolute value of a number ever be less than -1? No. If I plugged in 0 there, I get 0. Is 0 less than -1? No. If I plugged in a positive, I'd get a positive. Is that less than -1? No. If I plugged in a negative, I'd get a positive. Is a positive ever less than -1? No. So this is not possible, right? So there's no solution. So we'll just circle this for no solution. Find the distance between the 2 points Q and R. So basically for this, use the formula where you're going to subtract inside of absolute value bars. It doesn't matter the order of the subtraction because the absolute value will make the operation positive, or we would say non-negative. And so you get the same answer either way. So point Q is 11, and then point R, we have 19. So you could do 11 minus 19, or you could do 19 minus 11. It wouldn't matter because you're taking the absolute value. 11 minus 19 is -8, and the absolute value of -8 would be +8. Okay, so that's what I'm looking for right there. Okay, so again, for question 5, we want to find the distance between the 2 points Q and R. So Q is going to be -1 and R is going to be -2. So again, inside of absolute value bars, I'll do -1 minus a -2. Okay, and minus a negative is plus a positive. So let me write absolute value of -1 plus 2. And if you do 2 minus 1, you basically get 1. So this is the absolute value of 1, which is 1. Okay, so we're looking for this answer right there. All right, let's look at our section quiz. So for the first question, we want to determine if each statement is true or false and state the reason. So the first thing is the statement. So we have -8 is greater than -6. So first and foremost, is this a true statement or is this a false statement? That's all you're wanting to ask. So I'm going to look at -8 and I'm going to look at -6. -8 is to the left of -6 on the number line. Therefore, it is a smaller number. So this statement is false, right? This is a false statement. okay? And remember, when you think about a number in terms of negative numbers, a bigger negative number, bigger in terms of absolute value, is actually a smaller number because it's to the left of the other number on the number line. So when we look at our choices here, you can mark out the ones that say true. That's not going to be possible. So you look at this one that's false and this one that's false. Let's read the first one. So we have -8 lies to the left of -6 on the number line. Yes, that's exactly what we want. So it's false for this reason. Okay, question number 2, same concept. We want to determine if each statement is true or false and state the reason. So we have 6 is less than or equal to -6. Well, here's 6 on the number line and here is -6 on the number line. Are those equal to each other? No. Is 6 less than -6? No. 6 is a bigger number because it's to the right of -6 on the number line. We all know that if I had $6 in my pocket, it's more money than if I owed you $6, okay? So if I look at this, the statement is false. So mark out the true and mark out the true, okay? So let's look at these two. So first off, we have false. 6 is not less than -6. Since it lies to the right of -6 on the number line, 6 is also not equal to -6. So this is what we want here, okay? If you read the other one, it says the number -6 has a smaller absolute value, which isn't even true. The absolute value of 6 is 6, and the absolute value of -6 is also 6. So this one's not true either. So this is the one you want. Okay, so now we want to write the following numbers as an inequality statement. We have -5, we have -8, and we have -1. So what are we trying to do here? Well, basically, if we think about these numbers, in terms of they're all negative, so the biggest negative number in terms of its absolute value is actually the smallest number because it's going to be the furthest to the left on the number line. So -8 is to the left of -5, and -5 is to the left of -1. So notice how -8 is the biggest negative number in terms of its absolute value, -5 is the next biggest in terms of absolute value, and -1 is the smallest in terms of its absolute value. Okay, so we would say this one right here, -8 is the smallest, and it's going to be less than -5, which is the next smallest, which is less than this -1, which in this case would be the largest. So that guy right there. All right, for question 4, again, we want to write the numbers as an inequality statement. So you have 9, let me write these out. So 9, -6, 0, -7, you have 2, and then -4. So let's think about our negative numbers first. You have this -7, which is the biggest negative value in terms of absolute value. That's here. Okay, so that's the leftmost number on this number line that we have. Okay, so that's going to go over here to the left. And this would be less than, if you look at -6, that's the next largest negative in terms of absolute value. You'll see that -7 is to the left of -6. So -7 is less than -6. Okay, or you could also say -6 is greater than -7. But the way we're writing this here, we're going to want to use less than symbols. So then the next number on our number line, we're going to have this -4. Okay, so I'm going to put is less than -4 like this. Okay, so we see that -4 is greater than -6, and -6 is greater than -7. And then we're done with these negatives. So now we just have 0, 2, and 9. That's pretty easy to figure out. We know that 0 is less than 2, and we know that 2 is less than 9. Okay, so let's put is less than 0, which is less than 2, which is less than 9. So -7 is less than -6, which is less than -4, which is less than 0, which is less than 2, which is less than 9. Okay, so it looks like our solution will be right here. -7 is less than -6, which is less than -4, which is less than 0, which is less than 2, which is less than 9. All right, for question 5, we want to write the following statement in interval notation. We have that x is strictly greater than 4. So again, the idea here is that we have a strict inequality. We want to put 4 here on the left. I'm going to put a parenthesis next to 4 because it's not included, and then comma. Because x can be anything that's greater than 4, for the right over here, I'm going to put infinity, right? Because there is no largest value, and then I'll put a parenthesis there. So I want this guy right here. So basically, that's my answer. All right, for question 6, it says, how can we graph the interval x is greater than 3 using the number line? So basically what you want to do is you want to find 3 on the number line. So that's going to be right here, okay? And then you want to use a parenthesis at 3 because this is a strict inequality. Again, some books will use, let me change my color here. Some books will use an open circle like this to show 3 is not included. I'm just going to stick with this parenthesis, okay? At 3, it's going to face to the right. And basically x is anything greater than 3, so 3 is not included. I'm just going to shade the number line going to the right to show that all these numbers satisfy the inequality. So if it was 4 or 5 or 6 or 7, so on and so forth, if I plug that in for x, it's going to be greater than 3. So what we want is this one right here. we want to go to 3 on the number line, draw an open circle or left parenthesis, shade everything to the right of 3, including the right arrow. All right, for question 7, we want to find the absolute value of each. We just want to find the absolute value of negative 21. And of course, when you find the absolute value of a negative number, it just makes it positive. So it's just going to be positive 21. So this guy right here. All right, so find the absolute value of each. This is question 8. We have the absolute value of 0.29. So it doesn't matter that this is a decimal number. We could have a fraction. Anything you work with in terms of our real numbers that we're used to, when you take the absolute value of it, if it's negative, it makes it positive. If it's 0, it stays 0. And if it's positive, it just stays positive. So this would just be 0.29. Okay, so that's all it is. So it's just going to be this guy right here. All right, let's look at question number 9. So we're told to solve each inequality, and we have the absolute value of x is greater than 6. So again, we talked about this a lot at this point. So the absolute value of x is greater than 6. So I'm looking to plug in something for x, take the absolute value of it, and the result is greater than 6. So I'm saying that the distance from 0 to that number that I plug in for x is going to be larger than 6. So if I look at 0 on the number line, and I look at 6, and I look at negative 6, well, I want the distance to be more than this right here, okay? So that means that I would put a parenthesis here, okay, at 6, and I would shade everything to the right. So it couldn't be 6, but anything larger, okay? And then going this way over here, it couldn't be negative 6, but it could be anything larger. And I'm going to get rid of this stuff in the middle because that's not part of the solution. But basically you see that graphically, if I plugged in something like, let's say 7 or 8 or 9 for x there, well, I take the absolute value, that's going to be greater than 6. If I plug in something that's less than negative 6, like negative 8 or negative 22, when I take the absolute value of that, that's going to be greater than 6 as well. So my solution here would be that x could be greater than 6, or x could be less than negative 6, okay? So this is always your setup when you have the absolute value operation of x and it's greater than some positive number like this, okay? So here we have x is greater than 6 or x is less than negative 6. Okay, for question 10, solve each inequality. So we have the absolute value of x is less than 8. So basically in this scenario, let me go back to this guy right here. We don't have a little graph, but I'm just going to erase this and use this real quick. If I have the absolute value of x is less than 8, all we're doing now is we're thinking about the opposite situation. So from 0 to 8, okay, this is going to be my solution because I've got to plug something in here to where I take the absolute value of it and it's less than 8. So it can't be 8, but it can be anything less considering from 0 to 8. And then going out to negative 8, again, I can take all this all the way to negative 8, but it can't quite be negative 8 because that wouldn't work. So if I plug in things like 2, absolute value of 2 is 2, that's less than 8. Or let's say negative 6, absolute value of negative 6 is 6, that's less than 8. But if I plugged in something outside of that, let's say I plugged in 9, well, the absolute value of 9 is 9, and 9 is not less than 8, okay? So for that one, what you'd want to do is say that x is going to be greater than negative 8 and less than positive 8, okay? So here we have x is greater than negative 8 and less than positive 8. All right, for question 11, we want to find the distance between the 2 points Q and R. So again, this is just us subtracting inside of the absolute value bars. So Q is going to be negative 9, and then R is going to be 12. So I'm going to do negative 9 minus 12 inside of absolute value bars. Again, if you switch the order, it doesn't matter because the absolute value is just going to make this positive, okay? So negative 9 minus 12 is going to be negative 21. So the absolute value of negative 21, which of course is 21. Again, if you did it the other way, and you did 12 minus a negative 9 inside of absolute value bars, well, this is 12 plus 9, which is 21. And the absolute value of 21, again, is just 21. Okay, so either way, you get 21 as your answer. Okay, for question 12, same setup. We want to find the distance between the 2 points Q and R. So basically now we have Q with 15 and R with negative 15. Okay, so you can imagine that this is going to be 30 because at one end of the number line, you're at 15. Okay, let's say here's 0. Let's say here's negative 15. You've got to travel from here to here to here. You're going 15 units and then another 15 units. So you should be able to visualize that as 30. But just in case you can't, you can do 15 minus a negative 15, okay, inside of absolute value bars. And then this is going to be 15 plus 15, which is 30. So the absolute value of 30, which equals 30. Or again, you could also do negative 15 minus 15 inside of absolute value bars. So this is the absolute value of negative 30, which is 30, okay? So your answer here would be 30. All right, let's look at our little quiz now. So we're asked to simplify each for our first question. And we have here 3x to the 7th power multiplied by 4x to the 5th power So again, all I'm going to do is just reorder this. So I'm going to put 3 times 4, put those guys next to each other, and then times you have your x to the 7th power times your x to the 5th power. So we know we can do 3 times 4. That is going to give me 12. And then x to the 7th power times x to the 5th power. Again, if you have the same base, which we do with x, we keep that the same, and then we add our exponents. So what is 7 plus 5? That's going to give me 12. So my correct answer here is 12x to the 12th power, so this guy right here. All right, for question 2, we want to simplify, and we're given, inside the parentheses, y to the 4th power, and then times 2y squared, and then times y to the power of 0, and this is all wrapped inside of parentheses and cubed. Okay, so we know that if we see something raised to the power of 0, as long as it's not 0 itself, it's 1. So we're going to assume that y here is not 0, so this will be 1. So you can get rid of that. Then you have y to the 4th power times 2y squared. So basically, y stays the same, and we add exponents. So 4 plus 2 is 6. The 2 is just going to come along for the ride. That'll be the coefficient. Let's wrap this in parentheses, and I'm going to cube this. So basically, the 2 gets cubed, so we have 2 cubed. If we look at our answers, we see that we're going to end up with an 8. So let's write this as 8. In some cases, you might want to write it as 2 cubed. It's really up to you. Then here we have times y to the 6th power being cubed, okay? So we're going to be using our power to power rule there. So basically, let me write my 8 here. And then we keep y the same, and we multiply the exponents. So 6 times 3 is going to give me 18. So my answer here is going to be 8 times y to the 18th power. So this 8y to the 18th power, that's my solution. Okay, for question 3, again, we're just going to simplify. And we see that we have inside of parentheses 2x to the 4th power, and then times you have y cubed. And again, this is all wrapped inside of parentheses, and it's raised to the power of 0. And then times you have 2x to the power of 0, and then times you have y cubed. So again, when you see something like this, this whole thing is raised to the power of 0. We're assuming that the expression is not 0. So if it's raised to the power of 0, this is going to be 1. This is going to be 1, right? That's raised to the power of 0. So what do I have left? I really just have left 2 multiplied by y cubed, or 2y cubed, which is going to be this answer right here. Okay, let's look at question number 4. And this one's pretty tricky to read, just kind of looking at it this way. So basically you have wrapped inside of these parentheses, I probably shouldn't mark this up, but wrapped inside of these parentheses, x cubed, and then you have y cubed, and then you have times 2x squared, okay, and then times y, and this closes the parentheses down, and this whole thing is cubed. Then this is over. We're going to have, wrapped inside some parentheses, q to the power of 0, and then times your z squared, okay, close the parentheses down, and this is raised to the 4th power. Okay, so let's look at this guy. All right, so let's start off in the numerator here. You'll notice that you have x cubed and you have x squared. So let's go ahead and write that as x raised to the power of 3 plus 2, or 5. Let me put this 2 over here. And then we have y cubed and y. Remember, you can put a visible 1 there if it helps you. Y stays the same. 3 plus 1 is 4. Okay, let me wrap this in parentheses and put a 3 up there as the exponent. And then let me write this. I'm just going to copy this. Let me come down here. So we have q to the power of 0 times z squared. This is wrapped in parentheses and raised to the 4th power. So what I'm going to do now is just apply my exponent up here to everything. So 2 would be cubed. So 2 would be cubed. And then x to the 5th power would be cubed. So x stays the same. And then we're going to multiply the exponents. So what is 5 times 3? That's 15. And then again, same thing. Y to the 4th power is cubed. Y stays the same. 4 times 3 is 12. Okay. So let's get rid of that marking there. Let me put my 5 back. And then down in the denominator, q to the power of 0. Again, we're assuming that q is not 0. This is 1. So you basically just have in the denominator z squared to the 4th power. So z stays the same. 2 times 4 is going to give me 8. Okay. Let me erase everything. Let me drag this up here. Let's see if we can find our answer. So here we have 2 cubed, but then we only have y to the 5th power in the numerator. And in the denominator, we have this q guy. So this can't be it. I can cross that one out. Down here, instead of 2 cubed, we have 8. So sometimes you would write it that way. 2 cubed is 8. And then you have x to the 15th power, y to the 12th power, over z to the 8th power. So this is what we want right there. All right, let's look at the 5th question. So let me see if I can write this one out. So we have inside of parentheses here, x cubed. Then we have y squared. Close the parentheses, it's squared. And then times, let me slide this down a little bit so I have some room. So times, I'm going to have 2x cubed y cubed. Okay, so that's my numerator. In the denominator, I'm going to have z to the 4th power, q to the 5th power. This is wrapped inside of some parentheses, and it's all raised to the power of 0. So we already know, before we even get started, that this guy right here is going to be 1. Okay, so forget about it. In the numerator, I can go ahead and say, if I apply my exponents, that x cubed squared, this would be x to the 6th power. And y squared squared, this would be y to the 4th power. Okay, and then I can say that x to the 6th power times x cubed would be x to the 9th power. Okay, so basically x stays the same. 6 plus 3 is 9. And then here, y to the 4th power times y cubed will basically have y to the power of 4 plus 3 or 7. So y to the 7th power there, and then times 2. So let me write this out as 2x to the 9th power, y to the 7th power. So this is going to be 2x to the 9th power, y to the 7th power, and that's going to be this answer right here. All right, let's take a look at our little quiz. So we want to, for question 1, determine if true or false. We have that negative 3xy and negative 5xy are like terms. Remember, for like terms, the variables in each case have to be exactly the same. So the same variable raised to the same power. So here you have x, here you have x. Here you have y, here you have y, right? So you have the exact same variables, x and x, y and y. So these guys are like terms. Don't ever look at the coefficients. Those don't matter. So the answer here is true. All right, so for question 2, it says determine if true or false. The following algebraic expression represents a polynomial. So we have 4x cubed plus you have 2x raised to the power of a half and then minus 4. So if you see something raised to the power of a half, as we'll learn later on, this is the square root, right? So I can also write this as 4x cubed plus 2 times the square root of x minus 4. Okay, if you see something like the square root of x or x to the 1/2 power, this violates the definition of a polynomial because a polynomial has to have exponents that are whole numbers, okay, on the variables. So for this particular case, it doesn't work. So this is going to be false. For the next problem, question number 3, we have write the following polynomial in standard form. We have x squared plus 3 plus 4x to the power of 8, and then minus 9x to the 5th power, and then minus x. Okay, so for this guy right here, all you really need to do is find the variable that's raised to the highest power, okay? So in this case, that's going to be this 8 here, so x to the 8th power. That term is going to get listed first, okay? So I'm going to put 4x to the 8th power all the way to the left. Then what's the next highest exponential power? That's 5. So I'm going to take this negative 9x to the 5th power. I'm going to put that second. And then I'm just going to keep going in a similar way. So basically next I would have x squared, so plus x squared, and then I would have minus x, and then finally I'd have plus 3, okay? So you can see how the exponents are listed to where the highest one is here all the way to the left, and then the next highest is here, the next highest is here, and then you can think about this as x to the 1st power, that'd be the next highest, and then 3 or constant term, that's at the end, okay? So if we look at our answers here, we want 4x to the 8th power first, then minus 9x to the 5th power, plus x squared, minus x plus 3. So we want this guy right here. Question 4. What is the name of a 3-term polynomial? So we have trinomial, triplenomial, trinomial, or trinitynomial. It's obviously this one. Hopefully this one didn't trip you up. It's just a definition. If you don't know it, it's not that big of a deal. But the name of a 3-term polynomial is a trinomial. A 2-term polynomial is a binomial. And a 1-term polynomial or a single-term polynomial is a monomial. Okay, so you need to know those definitions because they do come up quite often. For question 5, we're asked to find the degree of the polynomial. So we have 14x to the 5th power y cubed plus you have 11x squared y squared. And let me scooch this down a little bit. And then minus 2x, and then plus 1. To find the degree of the polynomial, what you do is you find the degree of each term, and you want the highest degree of any term, okay? So to find the degree of a term, you just sum the exponents. So this one is 5 plus 3, so the degree here is 8. 2 plus 2, the degree here is 4. This is a 1, right? And you can think about this term right here. Really, a lot of books will just show this as x to the power of 0 here because this is just 1. 1 times 1 would still be 1. So the degree of a constant term is just 0, right? Because you can use this little trick and say my exponent of x is 0. But the degree of the polynomial, again, what's the highest degree of any term? Well, it's going to be 8, okay? So this is going to be our answer here. That's your degree of the polynomial. All right, let's look at our little quiz. For the first question and for all the questions today, we're just asked to simplify each. To make this a little bit easier, because normally I would try to read this here, but it's a little bit difficult to read this text. You kind of have to write it out. So what I did was I just pre-wrote it for us and make it a little bit easier on us. So the quantity here is negative 10x cubed plus 2x to the fifth power plus 9. And then we're going to subtract away this other quantity, this negative 6x to the fifth power minus 13 plus x cubed. Okay, so let me put equals here. And we know for this first polynomial, or the leftmost, we can just drop the parentheses. So I'm going to write negative 10x cubed, and then plus my 2x to the fifth power, then plus 9. Now, in the lesson and also in the practice test, we learned that if we're subtracting away a polynomial, typically we would want to just change this into addition of the opposite, right? So instead of a minus, I would just put a plus here, okay? And then I would put a little -1 on the outside of the parentheses, and then I would just distribute that -1 to each term inside. That's just telling me that I want to change the sign of each term inside of the parentheses when I drop my parentheses, okay? So instead of negative 6x to the fifth power, you can think about that as minus 6x to the fifth power. I'm now going to have a plus, right? So plus 6x to the fifth power. Instead of minus 13, it becomes plus 13. And then instead of plus x cubed, it's minus x cubed. Okay, so I'm just changing the sign of each term inside of the parentheses. Okay, so what we want to do now is just combine like terms. Okay, so I'm going to put equals here. And if you want to write this in standard form, which is pretty typical for these assignments, you want to look for the highest power on x. You just have x here. You don't have x, y, or z or anything like that. So the highest power is going to be 5, right? So you have this 2x to the fifth power and 6x to the fifth power. I would start by combining those like terms. So just work with the coefficients. 2 plus 6 is 8. So this is 8x to the fifth power. Okay, so the next highest, if you look at the exponents, would be a 3. So it would be this negative 10x cubed and this negative x cubed. Let me write that for clarity as negative 1x cubed. Okay, so I'm just going to highlight that as well. And so if I do negative 10 minus 1, that's going to be negative 11. So this is minus 11, and then the x cubed would come along for the ride. Okay, so let me erase this and this. I don't have an x squared. I don't have x to the first power. I just have these constants here. So I have plus 9 and plus 13. So if I add those guys together, 9 plus 13 is going to be 22. Okay, so let me put plus 22. So that's my answer here, and it's in standard form. Okay, so let me grab this real quick. I'm just going to copy it. Let's see if we can find this answer. So we want 8x to the fifth power. So you see that twice. Then minus 11x cubed. You see that twice. Then plus 22. So that occurs only right here. Okay, so that's my answer. Okay, let's look at question number 2. Again, we're just asked to simplify each. And again, just to save some time, I went ahead and pre-wrote the question for us. So we have the quantity negative 3 plus 8x to the fifth power plus this 2x cubed. We are subtracting away this quantity, negative 8x to the fifth power plus 10x cubed plus 8. So again, let me just write my left polynomial. I'm just going to drop the parentheses. So negative 3 plus this 8x to the fifth power plus this 2x cubed. Again, if I'm subtracting away a polynomial, I'm just going to make it addition of the opposite. So plus, put my little -1 there, and then I'm going to change the sign of each term inside. Again, a lot of teachers will show this distribution of the -1 by each term to remind you, hey, you need to change the sign of each term inside, okay? So instead of negative 8x to the fifth power, I'll put plus 8x to the fifth power. Instead of plus 10x cubed, I'll have minus 10x cubed. And instead of plus 8, I'll have minus 8. Okay, so that's all we're doing. So let me put that as a 3 there. And now, what is the highest exponent? It's going to be a 5 again. So I'm going to use 8x to the fifth power and 8x to the fifth power. We'll combine those like terms first. So 8 plus 8 is 16. So we'll have 16. And then the x to the fifth power comes along for the ride. Let me erase this highlighting here. So then the next thing I would have is x cubed. So I have 2x cubed and negative 10x cubed. So what I would want to do is 2 minus 10, which is negative 8. So minus 8, then times x cubed, that comes along for the ride. And then lastly, we don't have x squared or x. We just have these constants, right? So I have negative 3 and I have negative 8. So basically, negative 3 minus 8 is negative 11. Okay, let's copy this answer and come back here and see if we can find this guy. So we have 16x to the fifth power minus 8x cubed minus 11. We want this guy right here. Okay, let's look at question 3, which is a little bit more challenging because there's 2 variables involved. So again, we just want to simplify, and rather than try to read it from here, I've already written it here. So we have the quantity negative 11x cubed y squared plus 10x squared y to the fourth power. Then we're subtracting away this quantity, 4xy to the fourth power plus 3x squared y to the fourth power minus 14x cubed y squared. Then we're subtracting away this final quantity here, negative 9x cubed y squared plus 6xy to the fourth power. Okay, So basically, the leftmost guy, I'm just going to drop the parentheses. So you'll see negative 11x cubed y squared plus your 10x squared y to the fourth power. I'm going to change this to plus and put a negative 1 here. And this is going to be distributed to each term inside of the parentheses. So just change the sign of everything. Right now I have 4xy to the fourth power. I'm going to change this to minus 4xy to the fourth power. I'm going to change this to minus 3x squared y to the fourth power. I'm going to change this to plus, so plus 14x cubed y squared. So we change the sign of this guy, and this guy. That's all we're doing. Then I'm going to put plus here. Again, put a negative 1 there and distribute it to this guy and this guy. So instead of this being negative, it's now going to be positive. So I'll put plus 9x cubed y squared. Instead of positive or plus, I now have minus. So 6xy to the fourth power. Okay, so we've set up our problem there. Let's scroll down and get some room going. And when you have standard form and you have two variables involved, this is typically not going to be the same in each textbook that you read. Again, as I mentioned before, a lot of textbooks just skip this over. So what I've always done and what I've always been taught is basically you want to go with the highest degree first, okay? Now, in a lot of cases, you get an issue because there's going to be a tie. And if there's a tie, you want to go in alphabetical order and see, okay, in the case of x and y, x comes before y. So which term has an x with a higher exponent? Okay, so again, if you have something different for standard form with two variables, you can use that. It's all the same in the end if you get the right answer. Okay, so if the terms are out of order with two variables, typically nobody's going to give you any missed points for that answer. Okay, so let's look at this guy. And basically I have a degree of 5, I have a degree of 6, I have a degree of 5, 6, 5, 5, and 5. So the degree of 6 is the highest. So that's going to be this 10x squared y to the fourth. And then we also have that here with negative 3x squared y to the fourth. And I don't have that anywhere else. So let me start with that. So 10 minus 3 would be 7. Okay, so let me write this out here. I'll put this as 7. And then x squared y to the fourth. And what I'm going to actually do is just put some check marks here just to show that I've used this. A lot of times when you're doing this, you can get mixed up really easily. So this helps me keep track of things. Okay, so the next highest degree would be 5, but you have it with this x cubed y squared, and you also have it with this xy to the fourth power. So which one should come first? Again, using the rules that I talked about earlier, because the x comes before y in the alphabet, this one's x cubed and this one's x to the first power. So I'm going to go with this one first. Again, I can't stress this enough. If you get a different answer or you do this a different way, it's fine. Okay, so I'm going to take this negative 11x cubed y squared, and then I'm also going to have this plus 14x cubed y squared and this plus 9x cubed y squared. Okay, so let's go ahead and work on that. So negative 11 plus 14, that is going to give me positive 3, and then positive 3 plus 9 is going to give me 12. So plus, we'll have 12x cubed y squared. Okay. And then lastly, what we're going to look at, let me put some check marks here and here and here and erase this highlighting. Okay. So lastly, we're going to look at this term with negative 4xy to the fourth power and then negative 6xy to the fourth power. So those two terms, so this guy and this guy. So basically you would have negative 4 minus 6, that's going to be minus 10, and then xy to the fourth power comes along for the ride. So as long as you have these terms here, you're basically good to go. Don't worry too much about the order. Again, the standard form when you have two or more variables is not consistent between textbooks. Okay, so let's go ahead and copy this. Let's come up here and paste this. And I'll put that in right there. So basically I'm looking for 7x squared y to the fourth power plus 12x cubed y squared minus 10xy to the fourth power. So this guy right here. All right, let's look at question 4. Again, we just want to simplify. So we're going to have the quantity 8x cubed minus 4x squared y minus this quantity 3x squared y plus you have 9x cubed minus 7x squared y cubed. Then minus this quantity 12x cubed minus 9x squared y. Okay, so again, all these subtractions, I'm going to end up changing them to plus the opposite, right? So let me write this first one. Put equals 8x cubed minus 4x squared y. I'm going to change this to a plus, put a negative 1 there. and just distribute that to each term inside. So this will be minus 3x squared y, this will be minus 9x cubed, and this will be plus 7x squared y cubed. Again, I'm just changing the sign of each term inside. That's all I'm doing. Then I'll put this as a plus, put a negative 1 there, and then I'm going to distribute that to each term. So I'll have my minus 12x cubed, and then plus 9x squared y. Okay, so let's look at this down here. Again, I'm going to impose my rules for standard form. So I'm going to think about what has the highest degree. You've got 3, 3, 3, 3. You've got 5, 3, and then 3. Okay, so this guy right here has the highest degree. You have x squared y cubed. I don't see that anywhere else, so I'm just going to start by just writing that. So 7x squared y cubed. Let me put a check mark there to show that I used it. So then do we have anything with a degree of 4? Again, this is 3, 3, 3, 3. This is 3, and this is 3. So the answer to that is no. Everything else is going to have a degree of 3, okay? So in this case, I'm going to go with since x comes before y in the alphabet, the x that has the higher exponent. So that's going to occur on this guy, just x cubed, okay? So we have 8x cubed, and we have negative 12x cubed, and then we have negative 9x cubed. So if I do 8 minus 9, that's going to give me negative 1. And then negative 1 minus 12 would be negative 13. So minus 13, then times x cubed, that comes along for the ride. Let me make that 3 a little bit better. Let me put a check mark here and here and here to show we've used those. And now I'm going to go with the final 3 terms. So this is negative 4x squared y. Then we have this negative 3x squared y. And then we have this 9x squared y. So I'm just going to combine those like terms. Negative 4 minus 3 is negative 7. And then negative 7 plus 9 is going to be positive 2. So I'm going to put plus my 2x squared y. Okay, so check this one, and this one. But basically we have our answer. Again, if your terms are arranged differently, it's okay. It's not that big of a deal. So let's grab this and let's look for that answer. So we have 7x squared y cubed minus 13x cubed plus 2x squared y. So we're going to want this one right there. Okay, let's look at the fifth and final problem. Again, we just want to simplify. So we're going to have the quantity negative 9x cubed y squared plus x to the 4th power y cubed, then plus. We have this quantity negative 8x squared plus 10x cubed y squared plus 12x to the 4th power y cubed, then minus this quantity 7x to the 4th power y cubed plus 9x cubed y squared. Okay, so for the first guy, I can just drop the parentheses. So negative 9x cubed y squared plus x to the 4th power y cubed, okay? And then this is plus here, so I can just drop the parentheses here. So basically plus, or actually this is negative. So let me put minus 8x squared, and then plus 10x cubed y squared, and then plus, I don't know if I can fit this here, so let me put this down here, plus 12x to the 4th power y cubed. Okay, so now I have a minus here, so I'm going to change this to plus, put the negative 1 there, and I'm going to distribute this to each term inside, okay? So basically, instead of 7x to the 4th power y cubed, I'll have a minus 7x to the 4th power y cubed, and this will now be minus 9x cubed y squared, okay? So because this was plus out in front of here, we didn't need to do that, right? You could just drop the parentheses for this guy and this guy. But this guy, because it's a minus, you got to change it to addition of the opposite, okay? So let's come down. And again, I'm just going to keep in mind my degree. If you don't want to do this for 2 variables, again, up to you. So this has a degree of 5, then 7, 2, 5, 7, 7, 5. So I'm going to start with this x to the 4th power y cubed. That has a degree of 7. And then this 12x to the 4th power y cubed. And then this negative 7x to the 4th power y cubed. Okay, so I'm going to put that first. So this has an implied coefficient of 1. Let me change colors here so that stands out. So I'm going to go 1 plus 12, which is going to be 13. And then 13 minus 7 is going to give me 6. So let me go ahead and put that this is 6, and then you have x to the 4th power y cubed. Again, that has a degree of 7. So let me put a check mark here and here and here, just so I'm not looking at that again. So let's get rid of this and this and this. And I keep erasing things. So this is cubed and this is cubed. So then now what I'm looking at, I have a degree of 5, 2, 5, and 5. So I want to go with the degree of 5. So I'm going to go with this 10x cubed y squared, this negative 9x cubed y squared, and this negative 9x cubed y squared. So basically 10 minus 9 is 1, and then 1 minus 9 is going to give me negative 8. So let me go ahead and write this as minus 8x cubed y squared. Okay, let's erase that and put that there. And then lastly, if I erase this, you can use your check marks like I've been doing. So let me stay consistent, okay? So the only guy I haven't used is this guy right here, this minus 8x squared. And there's nothing to combine with that. There's no other like terms there. So basically, this is my answer. Let me go ahead and copy this. So I'm looking for 6x to the fourth power y cubed minus 8x cubed y squared, and then minus 8x squared. So I'm looking for this guy right here. That's my answer. All right, let's look at our first question here. So we're told to simplify each. We have 4 times the quantity 4x plus 2. So let me put this out here. So 4 times the quantity 4x plus 2. All we're going to do here is use our distributive property. So 4 times 4x. 4 times 4 would be 16. X would come along for the ride. Then plus, we would have 4 times 2. 4 times 2 would just be 8. So we want 16x plus 8. So this is going to be our answer right there. Okay, for question 2, again, we're told to simplify. We have the quantity negative 2x minus 6 times the quantity x minus 4. Okay, so if you have two binomials, you can use something called FOIL, right? So first terms, outer terms, inside terms, and then last terms. So if I multiply the first terms, negative 2x times x would be negative 2, and then x times x would be x squared. And then the outer terms or outside terms, negative 2x times negative 4, that's going to be positive. So let me put plus here. And then 2 times 4 would give me 8, and then x would come along for the ride there. The inside terms, negative 6 times x would be minus 6x. And then the last terms, you have negative 6 times negative 4, that's going to be plus 24, okay? So from here, let me erase this too and make it just slightly better. From here, I just want to combine any like terms that I have. So what I'd see here is, let me put equals, I'd have negative 2x squared, 8x minus 6x, 8 minus 6 would be 2, so this would be plus 2x, and then plus 24, okay? So I'm looking for negative 2x squared plus 2x plus 24, so that's going to be this guy right here. Okay, let's look at our third question. Again, we just want to simplify. So I'm going to have negative 3x and then plus 3. That quantity is going to be multiplied by the quantity 5x minus 1. Again, I could just use FOIL. So first terms, negative 3x times 5x, you'd be negative here. 3 times 5 is 15. X times x is x squared. For the outer terms, negative 3x times negative 1, that just changes the sign. So this would just be plus 3x. For the inside terms, you have 3 times 5x would be plus 15x. And then for the last terms, 3 times negative 1 is going to be minus 3. Okay, so combined like terms in the middle, we would have 3x plus 15x is 18x. So let me put equals. You'll have negative 15x squared, and then plus 18x, and then minus 3. So let's look for that answer. We have negative 15x squared plus 12x, so that's not what we want. Here we have negative 15x squared plus 18x minus 3, so we want this one right here. All right, let's look at question 4. So again, we're asked to simplify each. We have this quantity 4x plus 4y times this quantity negative 8x plus 2y. Okay, so doing FOIL again, because we have the product of two binomials, we can do first terms, 4x times negative 8x. This is going to be negative. 4 times 8 is going to be 32. X times x is x squared. For the outside terms, we have 4x times 2y. So basically that's going to be 4 times 2, that's 8. And then x times y is xy, like this. Let me make this 8 a little bit better. And I didn't do that, so let me do that one more time. And then for the inside terms, 4y times negative 8x, that's negative. 4 times 8 is 32, and then we'd have xy, okay? And then lastly, I would have plus 4y times 2y. 4 times 2 is 8, and then you just have y times y, which is y squared. Okay, so combine like terms again in the middle. These guys can be combined. So basically what I'm going to have is negative 32x squared. And then, let me make that better. The 8xy minus 32xy, 8 minus 32 is going to give me negative 24. So minus 24xy. And then lastly, plus 8y squared. So let's see what we got. We got negative 32x squared minus 24xy plus 8y squared. We want that one right there. All right, for question 5, again, we just want to simplify. All right, so let's put this here. And we'll just work on this. So now I have a trinomial times a trinomial. I cannot use FOIL here, okay? What I actually have to do is go through and multiply each term from this, you could say the leftmost polynomial by each term of the rightmost polynomial, okay? And then when you're done with that, you're just going to combine like terms. So the way I'm going to set this up, and a lot of people just do this kind of freehand, but I'm just going to set this up to where I basically take the first term here, so 6x squared, and I'll multiply by the quantity negative 2x squared plus 3x plus 7, okay? And you don't have to actually do this once you get good at this. You can just multiply this again freehand, so this times this times this times this, then, plus this times this times this times this, plus this times this times this times this, and then you combine like terms. But I'm doing this for clarity, okay? So I'm going to put plus, I'll put negative 6x here. This is never going to fit, so let's put this down here. So I'll put negative 6x times this quantity, negative 2x squared plus 3x plus 7, then plus, the last guy is 1 times this guy, again, this quantity, negative 2x squared plus 3x plus 7. 1 times anything is itself, so really you could just drop this, but I'll do that later on. Let me put equals here. Let's get ourselves some room going. So all I'm going to do is multiply 6x squared by everything inside here. So 6x squared times negative 2x squared, this will be negative, and then 6 times 2 is 12. X squared times x squared is x to the 4th power. And then 6x squared times 3x would be plus 6 times 3 is 18. X squared times x is x cubed. 6x squared times 7 would be plus 6 times 7 is 42. And then you just have x squared, okay? You scroll down a little bit more. So now I'm going to have this negative 6x times everything here. So let me put negative 6x times negative 2x squared. That would be plus 6 times 2 is 12. X times x squared is x cubed. And again, this is plus because this is a negative times a negative, okay? So then, let me make that better. Then I have negative 6x times 3x. We basically have a negative there. 6 times 3 is 18, and then x times x is x squared. Then lastly, you have negative 6x times 7. You'd have a negative. 6 times 7 is 42, and then x would come along for the ride. Okay, so the last thing here, we're multiplying by 1. So you multiply something by 1, it remains unchanged. So let me just copy the polynomial there. I'll put minus 2x squared plus 3x plus 7, okay? Let's scroll down. Now let's think about what we can do. So we just have one variable here. And so our standard form is pretty simple, right? I'm just going to go for the exponent on x that's the highest. So I'm looking to list this one first because it has x to the 4th power. And so basically, there's nothing to combine with negative 12x to the 4th power. So I'm just going to write this all the way to the left. Negative 12x to the 4th power like this. I could probably make that a little bit better. So let's erase this. I'm just going to check this off to show that I used it. That's completely optional. I'll just do that to keep track of things. So next I'm going to go to anything with x cubed. So that's going to be 18x cubed. That's going to be 12x cubed. And that looks like that's it for that. All right, so 12 plus 18 would be 30. So plus 30. And then you have your x cubed that comes along. So let me check this off and check this off. And I'll erase this and this. So now we're going to x squared. So you've got 42x squared. You've got negative 18x squared. And you've got negative 2x squared. So basically you have 42. And then I'll go minus 18. That's going to be 24. And then 24 minus 2 is 22. So plus 22. Then you'll have your x squared. So let's check off this one and this one and this one. And I'll erase my highlighting for each. So that's gone. And then I'm going to go to x to the 1st power. So I've got minus 42x and I've got plus 3x. So negative 42 plus 3 is going to be negative 39. So I'll put minus 39 and then x there. Let me check this off and this off. Let me get rid of that and that. And lastly, I'll check this off. You just have plus 7. So let me slide this down so it fits. I'll put my plus 7. All right, so let's copy this. So you have negative 12x to the 4th power plus 30x cubed plus 22x squared minus 39x plus 7. So you're going to want this one right here. All right, let's look at our little quiz. For the first question, we're asked to simplify each. So what we have is this quantity x plus 19 times the quantity x minus 19. So of course, for this, we're going to use the formula for conjugates. We're going to square the first guy, so x is squared. Then we're going to subtract away the last guy, which is 19 being squared. So 19 being squared. Again, you can punch up 19 squared on a calculator. You're going to get 361. So this gives me x squared minus 361 as my answer. So I want this guy right here. All right, for question 2, we have the quantity x minus 11 being squared. So x minus 11 being squared. So I want to use your formula. So it's going to be the first guy, which is x being squared. Then there's a minus there, so you put a minus there. 2 times the first guy, which is x, times the second guy, which is 11, okay, plus the last guy, which is 11, being squared. So this gives me x squared minus 2 times 11 is 22, so 22x, and then plus 11 squared, if you punch that on a calculator, is 121. So you're looking for x squared minus 22x plus 121, so this guy right there. All right, let's take a question number 3 now. So again, we just want to simplify. So we're going to have the quantity 6x minus 3y squared multiplied by the quantity 6x plus 3y squared. So again, these are conjugates. You have 6x in the first position of each. You have 3y squared in the second position of each. The only difference between these two binomials is going to be the minus here and the plus here. So the difference is the sign. So that means we have conjugates. And when we have conjugates, we can use our little formula. So basically, I can just skip FOIL and just say, okay, I want the first guy squared. So 6x is squared. Then minus, I want the last guy, which in this case is 3y squared, being squared. Okay? So all I'm going to do is square 6x. Again, you've got to square the 6 and the x. Don't just put 6x squared like this. It's a common mistake. So square the 6, you get 36. Square the x, you get x squared. Then minus 3y squared is being squared, so 3 squared is 9. Y squared being squared, y stays the same. Multiply exponents, 2 times 2 is 4. So I get 36x squared minus 9y to the 4th power. Now again, when you have two variables involved, there's all kinds of rules for standard form floating out there. What I always try to do is just list this in terms of the highest degree first. So that's why I'm going to put the answer as negative 9y to the 4th power, so listing this term first, and then plus 36x squared, listing this term second. Again, two variables, there's no standard definition for standard form. So if you want to list your answer this way, it's perfectly fine. All right, let's look at question number 4. Again, we just want to simplify. So we have the quantity 3x minus 1 being cubed. And again, I'm going to use my formula for this. So the first guy here would be cubed. So 3x would be cubed. And then minus, we have 3 multiplied by, we have the first guy being squared. So 3x being squared. And then times the last guy here, which would be 1. And then I'm going to go ahead and say plus. Let me put this in here. So plus, we're going to have 3 times the first guy, which is 3x, times the second guy squared. So 1 being squared, of course, it's just 1, but we'll write it. And then lastly, we're going to put minus. We'll have this last guy here, 1 being cubed. Okay? So 3x being cubed, 3 is cubed, that's 27. X cubed is just x cubed. And actually, let me change colors here. So let me write this as 27x cubed like this, so it stands out. And then minus, we need to do 3x squared first, so 3 squared is 9. Let me write this here. So this is 9, and then x squared. So 3 times 9 is 27, so minus 27. And then we would have x squared. And then, of course, times 1, but times 1 doesn't really change anything. And then down here, you basically have 3 times 3 times 1 squared is just 1. So 3 times 3 is 9, then times x, so plus 9x. And then lastly, you have minus 1 cubed is just 1. So I'm looking for 27x cubed minus 27x squared plus 9x minus 1. So that's going to be this guy right here. Okay, for question 5, again, we just want to simplify. So we have 5x plus 8y being cubed. I don't think I can fit this on the screen, so let me cut this away. And so again, all I'm going to do is take the first guy and cube it. So 5x being cubed plus 3 times the first guy squared. So 5x squared times the second guy, which is 8y. And then plus, let me write this down here, plus, we're going to have 3 times, we're going to have the first guy, which is 5x, times the second guy squared, so 8y being squared, and then plus the last guy here, which is 8y being cubed. Okay, so now that we have all that written, let's go through and crank it out. Shouldn't be too bad. 5x being cubed, 5 is cubed, that's 125. X is cubed, that's x cubed. Then plus, what is 5x being squared? So again, 5 is squared, and so is x. So this is going to be 25x squared. So 3 times 25 is 75, and then 75 times 8 is 600. So you would basically have 600, you would have x squared, and then you would have y. So x squared and then y. So let's get rid of all this. So then plus, here you need to square 8 and y first. So 8 squared is 64, and of course y squared is just y squared. So this would be 3 times 5 times 64. So 3 times 5 is obviously 15. Then times 64 is 960. So plus 960. And then we're going to have x, y squared. So let's erase this. And then lastly, let me scooch this down. I think you can fit it all in the same line. So lastly, plus, you have 8y being cubed. So 8's being cubed. That's 512. And then y being cubed is just y cubed. So let me copy this and let's paste this in here. So we're looking for 125x cubed plus 600x squared y plus 960x y squared plus 512y cubed. So that's going to be this guy right here. All right, let's look at our little quiz. So for the first question, we're asked to divide each. And let me write this out. So we have 2x cubed plus 10x squared plus 30x. And it's divided by 10. So I'm going to write this in fractional form. So we'll say it's over this 10. So let me actually copy this real quick. And let me paste this in here so we have a lot of room to work. Basically, if you're dividing a polynomial by a single term, or what we call a monomial, you're just going to break this up into each part or each term from the polynomial divided by the monomial. So in other words, I'm just going to say that I have 2x cubed over 10 plus I'm going to have 10x squared over 10 plus I'm going to have 30x over 10. Okay, so that's all I'm doing. Just take each part or each term here and divide it by that monomial. So then you're just going to look to see what you can simplify. So if you go through here, 2x cubed over 10, well, I can't really do anything with the x cubed, so I know that's going to be there. But I can do something with the 2 over 10, right? Each has a common factor of 2. 10 divided by 2 is 5. 2 divided by 2 is 1. So you can write this as x cubed over 5, or some people will write 1/5 times x cubed. Whatever you want to do, it's the same answer. Then plus, you're going to have 10x squared over 10. The 10s would cancel. 10 divided by 10 is obviously 1. So this is just x squared. Can't do anything else with that. Then plus, you have 30x over 10. 30 divided by 10 is 3. So this would just be 3x. So let me copy this. And let's paste this in here and see if we can find this answer. So we want x cubed over 5. So it looks like that's right there. Then plus, we want our x squared. Then plus, we want our 3x. So that's going to be our answer right there. Okay, let's look at question number 2. We're asked to divide each. So we have this x cubed and then minus 10x squared and then plus this 26x and then minus 35. We're going to divide this by this x minus 7. So I'm going to put this in long division format. So I'm going to put this x minus 7 like this. Now let me go ahead and copy this. Again, when you set this up, make sure both the dividend and divisor are in standard form, and also make sure you don't have any missing powers. Okay, but we'll see questions like that in a moment. So the first thing I'm going to do is leading term into leading term. So this guy into this guy. What is x cubed divided by x? Again, that's just going to be x raised to the power of 3 minus 1, which is 2, so x squared. And I'm going to write that here, okay, over where I have negative 10x squared. Then I'm going to multiply. X squared times x is going to be x cubed. And then x squared times negative 7 is going to be minus 7x squared. And at this point, I want to subtract. So to subtract away a polynomial, remember you add the opposite. So I'm going to go minus and then plus. All I'm going to do is change my signs for each term that's being subtracted away, and then I'm just going to combine like terms. So this guy right here, this x cubed minus x cubed, that's gone, right? That's just going to cancel. Then negative 10x squared plus 7x squared, we can go ahead and say that's negative 3x squared. Now I'm at my bring down step, so I'm going to bring down the next term, so plus 26x, and then I just repeat the process. So I'm going to start over with leading term into leading term, and now I'm working with this guy right here. So what is negative 3x squared divided by x? Well, we know it would be negative 3, so let me just write that. And then x squared over x is just x. So now I multiply. Negative 3x times x is negative 3x squared. Negative 3x times negative 7 is plus 21x. Okay, I want to subtract now. And again, to do that, I'm going to change this sign and I'm going to change this sign. And then just combine like terms. This is going to cancel. 26x minus 21x is going to be 5x. And then I just want to bring down this last term here. So minus 35 goes there. And then one last time, I'm going to go leading term into leading term. So what is 5x divided by x? Well, 5 is going to be there. And x divided by x is just 1, right? That's going to cancel. So I just get 5. Now I multiply. 5 times x is 5x. And then 5 times negative 7 is going to be negative 35. So again, if I want to subtract, what I'm going to do is I'm going to change this to a minus and this to a plus. Just combine like terms. 5x minus 5x is 0. Negative 35 plus 35 is 0. So because this is a 0 here, that means you don't have a remainder, right? So the answer, or the quotient, if you want to be more specific, is x squared minus 3x plus 5. And let's paste that in right there. So I'm looking for x squared minus 3x plus 5. So I'm looking for this guy right there. Okay, question number 3. Divide each. So again, we have another long division problem. So we have x cubed. We have minus 15x squared. Then plus 47x. Then plus this 72. Let me go ahead and set this up in long division format. I'll put my x minus 8 over here. Again, I'm not missing any powers, and everything is in standard form. So let's go ahead and grab this real quick. So again, I'm just going to start with division. So leading term into leading term. What is x cubed divided by x? Well, that's just going to be x squared. Let me change my color up a little bit. I'll go x squared like this. X squared times x is x cubed. And then x squared times negative 8 is minus 8x squared. Let me make that 3 better. You're going to change the sign of everything so that you can subtract, right? If you subtract away a polynomial, again, you just want to add the opposite. So just change the signs and then combine like terms. This is going to cancel. Negative 15x squared plus 8x squared would be negative 7x squared. Bring this guy down, so plus 47x. And again, you're going to just start the process over. So we're just going to repeat as they say. So we're going to go leading term into leading term. So what is negative 7x squared divided by x? Negative 7 is going to be there. And then x squared over x is just x. Multiply negative 7x times x would be negative 7x squared. Negative 7x times negative 8 would be plus 56x. Again, if I want to subtract here, let me go ahead and erase this. I'm going to change this to plus and change this to minus. And now this is going to cancel. 47x minus 56x is going to be negative 9x. And then one more term to bring down. So let's drop this plus 72 here. And again, I just repeat the process. So leading term into leading term. What is negative 9x divided by x? That's going to be negative 9. So let's put that there. If I multiply negative 9 times x, I get negative 9x. If I multiply negative 9 times negative 8, I get plus 72. And I put 2 there for some reason. It should be 72. Again, change the sign. So this is plus, this is minus. So you're basically going to get 0 there. So there's no remainder. So your answer is x squared minus 7x minus 9. Let's go ahead and copy that. Let's paste this in here. So I'm looking for x squared minus 7x minus 9. So it's this guy right here, x squared minus 7x minus 9. Okay, let's look at question number 4. Again, we're just dividing. So 4x to the 4th power. Then we have plus 18x cubed. We have minus 56x squared plus 42x minus 17. And then we're looking over here at 4x minus 6. Not missing any powers. Everything's in standard form, so we're basically good to go. And again, I'm just going to start the process leading term into leading term. So what am I looking at here? What is 4x to the 4th power divided by 4x? Well, the 4's are going to cancel. X to the 4th power over x is x cubed. So this is just going to be x cubed right here. X cubed times 4x is going to be 4x to the 4th power. X cubed times negative 6 is going to be minus 6x cubed. And then again, I'm going to make this a minus and this a plus. Just change your signs and then combine like terms. Let me get rid of this highlighting here. Didn't mean to mess that up. This is going to cancel. 18x cubed plus 6x cubed is going to be 24x cubed. Let's drop this guy down. So minus 56x squared. And then again, I just want to repeat the process. So leading term into leading term. So we know that 24 divided by 4 is going to give me 6. So let me put plus 6. X cubed over x would be x squared. Multiply 6x squared times 4x, that would be 24x cubed. 6x squared times negative 6 is minus 6 times 6 is 36. X squared will come along for the ride there. So I'm going to change this to a minus and this to a plus. Let's see what we got here. Let me bring this down a little bit so that we don't run out of room. Get rid of this highlighting. This is going to cancel. Negative 56x squared plus 36x squared would be negative 20x squared. Let me come up. It's going to be hard to keep everything on the screen. So I'm going to be dropping this guy right here. So negative, or actually plus 42x. And so again, I just want to go leading term into leading term. So what is negative 20x squared divided by 4x? We know that this is negative. We know this is negative. Let me scroll up a little bit so you can see everything. And we would do 20 divided by 4, which is 5. And then we would do x squared over x, which is x. Multiply negative 5x times 4 would be negative 20x squared. Negative 5x times negative 6 is going to be positive 30x. Scroll down a little bit. Let's change this to addition and this to subtraction. This is going to cancel. 42 minus 30 is going to give me 12. So this would be 12x here. And I've got one more term to bring down. So I want to bring down this negative 17. So let's come over here. So minus 17. And again, things are getting cut off. But you know the leading term here is 4x. Okay. So basically what we'd be doing is saying leading term into leading term. 12x divided by 4x is going to be 3. So let me come up here and just put plus 3 here. So I'm going to have 3 times the quantity 4x minus 6. So 3 times the quantity 4x minus 6. That would give me 12x and then minus 18. Okay, let's get rid of this. Let's change our signs. This would be minus, this would be plus. So it looks like our answer here for the remainder would be 1. Okay, so let me go ahead and go up. Now we had a remainder of 1, so let's put plus 1 over. You want to put this over the divisor, which is 4x minus 6. So let's look for x cubed, and everything has an x cubed. So plus 6x squared, so everything has a 6x squared. Minus 5x, everything has a minus 5x. Then plus 3, so that's limit to this one. And then plus, you have your 1 over 4x minus 6. So this is what I'm looking for here in terms of my answer. All right, let's look at question number 5. I think this is the only problem on this test that gave people any trouble. So if you notice where we're asked to divide, if you notice the dividend here is missing x to the 4th power. So when you write this, it's x to the 5th power plus, you want 0 as a placeholder, so 0x to the 4th power, and then you want minus 2x cubed, and then you want plus 2x squared, then minus 35x, and then plus 14. So it's in standard form, we're just missing that x to the power of 4. Now, we have this part. For the divisor, you have x squared plus 5, you're missing x to the 1st power. So we're going to go x squared plus 0x plus 5. So let me go ahead and copy this, or actually cut it, and let's just get started on this. It's really not that bad. So leading term into leading term, x squared goes into x to the 5th power. You could say x to the 5th power divided by x squared. That's going to be x stays the same. 5 minus 2 is 3. So this would be x cubed. You're going to multiply x cubed times x squared. Let's say that's x to the 5th power. X cubed times 0x. Let's say that's plus. I'll say that's 0. And then I'll go x to the 4th power. X cubed times 5, I'll say plus 5x cubed. Okay, we want to subtract the polynomial away. And to do that, I'm going to change the sign. So this is minus, and this is minus. You don't have to worry about these first two. Those are just going to go away. Don't worry about them. This last one, negative 2x cubed minus 5x cubed, that's minus 7x cubed. Bring this guy down. So plus 2x squared. And now we can repeat the process. So leading term into leading term. What is negative 7x cubed divided by x squared? Well, we know it's negative. We know it would have a 7. And then x cubed divided by x squared would just be x. Now, you can write this way. I like to maintain the places when I'm working with these types of problems. It's completely unnecessary. But for myself, I'm going to put plus 0x squared here. And then I'm going to put my minus 7x like that. Again, completely unnecessary. And I'm going to remove this when I report my answer. This is just so that I personally can keep this maintained. Okay, that's just how I like it. So then I'm going to multiply. So negative 7x times x squared is negative 7x cubed. Then negative 7x times 0. Let's just say this is minus. You'll go ahead and say 0 and then x squared. Then negative 7x times 5. I'll say this is minus 35x. Okay. So let's go ahead and change the sign of these guys. This will be plus, this will be plus, and this will be plus. Now, this guy's going to cancel. 2x squared plus 0x squared, that's just 2x squared. Okay. And then you just have your plus 35x. Now, here's the first part that gives everybody trouble that solves this problem. You're going to bring down this next term. So you're going to bring down this next term. So minus 35x. So let's pause for a minute and think about what I need to do. If I saw, forget about the fact that we have a division problem. If I saw 2x squared plus 35x minus 35x, what would I do? I would combine like terms and these would cancel, right? That's 0. Those are opposites. You have 35x and negative 35x. Basically, the coefficients are opposites, and so those are opposite terms, and so they're going to cancel. So you can erase it. You can leave it there as being canceled for clarity, whatever you want to do. But essentially, you just move on at this point, and you go leading term into leading term. So what is 2x squared divided by x squared? Well, that's just going to give me 2, right? So this is plus 2. So then 2 multiplied by x squared would be 2x squared. And then 2 multiplied by 0x, let's just say that's plus, I'll say that's 0x. And then 2 times 5 would be 10. Okay, so plus 10. Okay, let's change this to minus. Let's change this to minus. And let's change this to minus. And basically, you just have 2x squared here, minus 2x squared. That is going to be 0. That's going to cancel. The minus 0x, that's just a placeholder. It's really just 0. So you basically just have negative 10 there. So I'm just going to write negative 10 here as the result. Now, you have one more term to bring down. So I'm going to bring down this plus 14 here. And again, I'm just going to combine like terms. Negative 10 plus 14, we know that's positive 4. So I can just say that the result of this, you can line it out, or you can just put 4. You can put 4 a little bit below. Actually, I'm just going to probably line this out like this and put 4. This is my remainder, right? I can't do anything else with this. This guy has a degree of 0 if you want to get technical. You could write this as 4x to the power of 0. That's how the book would show that. The degree of this polynomial here, or this monomial, is 0, okay? The degree of this divisor here is 2. So you can't continue your division because this degree here is less than this degree here. So you would just say your remainder is 4. So you would take your x cubed. Let me just copy this real quick. Let me copy this. You would take your x cubed plus, I'm going to get rid of this. This was just a placeholder. So your x cubed minus your 7x plus 2, and then plus you had that remainder of 4 over the divisor, which was x squared minus 5. Or actually, sorry, it was x squared plus 5. So x squared plus 5. So if we look through the answers here, we see that we have x cubed minus 7x plus 2, then plus the 4 over your x squared plus 5. So this is the answer we want right here. All right, let's take a look at our quiz on synthetic division. We're told to divide each using synthetic division. So we have 11x cubed plus 23x squared plus x to the 4th power plus 14 minus 6x. This is divided by x plus 8. So I went ahead and already wrote this for us. And I put this guy, the numerator or the dividend, in standard form. And then for the divisor, remember, you need to make a little change. If this is plus some positive number, you need to switch this to minus a negative. So minus a negative 8. Again, that works out to be plus 8 in the end. Minus a negative is plus a positive. But you need this to set up your synthetic division. So what I'm going to do is I'm going to take the coefficients, again, in order. That's why we put this in standard form. So this is an implied coefficient of 1. This is an 11. This is a 23. This is a negative 6. And then this is going to be a 14. Okay, so let me set this up like this. Then over here to the left, I'm going to want to grab this negative 8 here. So I'm going to put that right there. And let me go ahead and drop this first guy down, and we can get started. So remember, you're just going through a pattern of multiplication, then addition, multiplication, then addition, multiplication, then addition, just over and over till you reach the end. So negative 8 times 1 is negative 8. 11 plus negative 8 is positive 3. Negative 8 times 3 is negative 24. 23 plus negative 24 is going to be negative 1. Negative 8 times negative 1 is positive 8. Negative 6 plus 8 is going to be 2. And then negative 8 times 2 is going to be negative 16. 14 plus negative 16 is negative 2. So let me actually erase, or I could just copy. Let me just copy this. So how do I interpret this answer? Remember, you're looking for the degree from your dividend, and this guy's going to be 1 degree less. So this had a degree of 4 because we had x to the 4th power here. So this guy right here would start out being the coefficient for x cubed. So in other words, I would have 1x cubed, or just x cubed, and then I would have plus 3x squared, and then minus x, and then plus 2. And then this guy right here, all the way to the right, is the remainder. So we're going to have minus 2. Let me scooch this down so it fits on the screen. We're going to have minus 2 over the divisor, which was x plus 8. So x plus 8. So I'm looking for my answer here. I want to start off with x cubed. Everything does, of course. Then plus 3x squared, so these 3. And then minus x, and then plus 2. And I know I have a remainder, so it's going to be this one. So then minus after that, you have 2 over x plus 8. So I want this guy right here. This x cubed plus 3x squared, and then minus x plus 2, and then minus, you have this 2 over this x plus 8. So that's what we're looking for. Okay, let us look at question number 2. Again, divide each using synthetic division. So we have 9x cubed plus 24x squared plus 21x plus 8 divided by, you have this x plus 2. So I went ahead and wrote this for us. Again, if this is x plus 2 like this, you've got to convert this to x minus a negative 2 for this to work. So I'm going to grab all the coefficients. Again, this is already in standard form. I'm not missing anything. So you're going to go 9, 24, 21, and then 8. Okay, so I'm going to take 9, 24, 21, and then 8. Let me go ahead and set this up. And then I want this negative 2. So you're going to grab this right here, whatever's to the right of the subtraction. So I want this negative 2. Okay, let me scroll down a little bit and get some room. I drop this down here, and then I'm going to start multiplying. So negative 2 times 9 is negative 18. And then I'm going to add 24 plus negative 18 would be 6. Multiply negative 2 times 6 is negative 12. Add 21 plus negative 12, or 21 minus 12, however you want to read that, would be positive 9. And then you're going to do negative 2 times 9 for your multiplication. That would be negative 18. And then add 8 plus negative 18 would be negative 10. So if I look at my degree of this guy, it was 3. So the degree here would be 2. So this would be 9x squared plus 6x plus 9. And then you go minus 10 over. Your denominator was x plus 2. So x plus 2. Of course, we wrote that to x minus a negative 2 for technical purposes. So let me go ahead and cut this away. So we're looking for 9x squared and then plus 6x plus 9 and then minus your 10 over x plus 2. So we want this guy right there. All right, let's look at question number 3. Again, we want to divide each using synthetic division. So we have this 3x cubed plus 28x squared plus 55x plus 41. And this is divided by, or you could say over, x plus 7. So I've already written this guy. Everything's in standard form. So we're good to go here. 3x cubed plus 28x squared plus 55x plus 41. And then over x plus 7. Again, you've got to make a little change here. We're going to write this as x minus a negative 7 like this. And then again, you're just going to grab your coefficients. So 3, 28, 55, and 41. So 3, you have 28, you have 55, you have 41. Put that like that. And then I want this negative 7 right here. So I'm going to put that over here. And then again, I'm just going to drop this first number down. And then I'm going to go through and multiply, then add. Multiply, then add. Just keep doing that till you get to the end. So negative 7 times 3 is negative 21. And then if I do 28 minus 21 or 28 plus negative 21, that's going to be 7. Negative 7 times 7 is negative 49. 55, I'll just go ahead and say minus 49 is going to be 6. And then negative 7 times 6 is going to be negative 42. 41 minus 42 or 41 plus negative 42 is negative 1. So again, if this degree is 3, this degree will be 2. So let me erase this. And we can write the answer as 3x squared. And then plus 7x. And then plus 6. And then that's my remainder. So minus, I'll go 1 over x plus 7. So let me grab this, paste that in. So I'm looking for 3x squared. Of course, everything has that. Then plus 7x. So that's going to be here and here. Then plus 6, also here and here. And then minus, you want this one, right? Because it's minus 1 over x plus 7. So this is the answer we're looking for. So 3x squared plus 7x plus your 6. Then minus, you have 1 over x plus 7. All right, let's look at question 4. Again, we're going to divide each using synthetic division. So we have this 6x cubed minus 63 minus 10x plus x to the 4th power divided by x plus 6. So this is not in standard form. So I've already rewritten it in standard form. And I've already accounted for the fact that we don't have an x squared. So I put this as x to the 4th power plus 6x cubed plus, you need that 0 as a placeholder. So 0x squared, then minus 10x, then minus 63. This is over x plus 6. You want to rewrite this as x minus a negative 6. Again, so you can grab negative 6 and put it in your problem. So again, I'm just going to grab this. This is an implied coefficient of 1. So I want 1, 6. I want the 0 there as a placeholder, negative 10, and negative 63. So let's put those in. So 1, 6, 0, negative 10, and negative 63. Let's put this like this. Let's grab this, again, this negative 6 here. So put that there. Let's drop this down. And then let me scroll down so we have enough room. So we'll have negative 6 times 1, that's negative 6. 6 plus negative 6 is 0. Negative 6 times 0 is 0. 0 plus 0 is 0. Negative 6 times 0 is 0. Negative 10 plus 0 is negative 10. And then negative 6 times negative 10 is 60. Negative 63 plus 60 is negative 3. So what do these zeros mean? Well, again, they're placeholders. So if I go back up and think about the degree of this polynomial is 4, well, the degree of this guy is going to be a 3, right? So it's going to be, let me actually erase all this. We don't even need it. This will be 1x cubed, then plus, this 0 is telling you have 0x squared. This 0 is telling you have 0x, and then you have minus 10, and then you have, this is your remainder, so you can say minus 3 over x plus 6. Again, you can delete these once you've set it up. You don't need them anymore. It's just giving you the information that you want. So let me scooch this down like this, and let me copy this or cut it away, and let's go ahead and paste this in here. So we have x cubed, then minus 10, and then minus, we have 3 over x plus 6, so we want this guy right here. Okay, let's look at question number 5. Again, we're just using synthetic division to divide. So we have 8x to the 4th power minus 80x cubed plus 7. We're dividing by x minus 10. So we're missing x squared and x to the 1st power. Other than that, it's in standard form. So let's go down. So we've already written this as 8x to the 4th power minus 80x cubed plus 0x squared plus 0x plus 7 over x minus 10. So again, this is a placeholder. This is a placeholder where we're missing x squared and x. So that's what you need to do. Okay, so this is already in the form of x minus k, so I can just grab 10 as it is. Don't need to do anything special there. And let me set this up over here and make that 10 a little bit better. Again, you're just grabbing the coefficients. So the 8, the negative 80, the 0, and the 7. So we're going to have the 8, the negative 80, the 0, and the 7. Let's drop this down here. And let me move this down. So 10 times 8 is 80. Negative 80 plus 80 is going to be 0. 10 times 0 is 0. 0 plus 0 is 0. 10 times 0 is 0. 0 plus 0 is 0. 10 times 0 is 0. 7 plus 0 is 7. So what does this mean? Again, if this degree up here is a 4, well, this degree will be a 3. So what I can say is that this would be 8x cubed plus 0x squared plus 0x plus 0, then plus 7's the remainder, so 7 over x minus 10. So I don't need any of these. You can just basically get rid of all of that. Those are just placeholders. Let's move this down. And 7 is positive, so let me put a plus there. Let's cut this away, paste this in here. So I'm looking for 8x cubed, then plus you have 7 over x minus 10. So I want this answer right here. All right, let's take a look at our section quiz. So we're going to begin with question number 1. We're told to simplify each. And what we have here is x that's cubed, and it's multiplied by x to the 7th power. So again, we know at this point that we can use something called the product rule for exponents. So if we have the same base and we're multiplying these exponential expressions, we're going to keep the base the same. So x stays the same. We're just going to add exponents. So 3 plus 7 would be 10. So this would be x to the 10th power. So we want this answer right here. All right, so for question 2, again, we're asked to simplify. So now we have x that's raised to the 4th power, and then this is raised to the 9th power. So for this example, we want to use our power to power rule. So what we want to do here is keep our base x the same, and then we want to multiply the exponents. So 4 multiplied by 9 is going to give me 36. So this would be x to the power of 36. So I'm looking for this answer right here. All right, let's look at question 3. We're asked to state the degree of the polynomial. So we have 5x, this is raised to the 5th power, then yz, then plus, we have 19, this is x squared, y cubed, and then z, and then minus, let me scooch this down so it all fits. Scooch this down. So as I was saying, minus, we have the 12x to the 4th power, we have y squared, and then we have z squared. So if you want to find the degree of a term, what you want to do is sum the exponents on your variables from that term. So in other words, on the 5x to the 5th power yz, this is an exponent of 1 and this is an exponent of 1. So you would take the 5 plus the 1 plus the 1. 5 plus 1 is 6. 6 plus 1 is 7. The degree of that is 7. For this one, you would go 2 plus 3 plus 1. So 2 plus 3 is 5. 5 plus 1 is 6. And the degree here is going to be 4 plus 2 plus 2. 4 plus 2 is 6. 6 plus 2 is 8. Now, the degree of the polynomial is going to be the largest degree of any of the what we call non-zero terms. So in this case, it's going to be 8, right? Because this term right here, this negative 12x to the 4th power y squared z squared has a degree of 8, and that's the largest of any of these guys. So that's the degree of the polynomial. And actually, I can just erase this, and we'll circle our answer here of 8. All right, for question 4, we're asked to simplify each expression. So a basic subtraction problem with some polynomials. So we have negative 9x to the 5th power, and then plus we have 10x cubed. Let me make that better. So 10x cubed and then minus 13x squared. And then we're subtracting away this quantity negative 14x to the 5th power minus 8x cubed plus 10x. So you know what I tell you to do? You put a plus here, so you change this to addition, and change all of these terms inside into their opposites. So in other words, negative 14x to the 5th power would be, we'll go plus 14x to the 5th power. And let me scooch this down. Or actually, let me not do that. Let me just write this down here. So I'll put plus, and then down here I'll put 14x to the 5th power. And then here, instead of negative 8x cubed, I'm going to put plus 8x cubed. And then here, instead of plus 10x, minus 10x. So again, we change the subtraction to addition. We change all the terms for that polynomial that's being subtracted away into their opposite. So we got 14x to the 5th power plus 8x cubed minus 10x. So let me scroll down. I'll come back up in a minute. And you can actually just drop the parentheses here. You don't need them. All we're going to be doing is combining like terms. because I want to write my answer in standard form, I'm going to look for the highest exponent, which is a 5 in this case. So you have negative 9x to the 5th power, and you have 14x to the 5th power. If I add those guys together, 14 minus 9 is going to be 5. So this would be 5x to the 5th power. Let me erase this and this. And then we would go down to x cubed. So you have 10x cubed and 8x cubed. 10 plus 8 is 18. So this is plus 18x cubed. And then you have this minus 13x squared. Let me erase this and this. Nothing to combine with it, so minus 13x squared. And then you have minus 10x, nothing to combine with that. So let me erase this, and let's look for our answer. So 5x to the 5th power plus 18x cubed minus 13x squared minus 10x. So that's going to be this guy right here. All right, let's look at question number 5. So we're asked to simplify each expression. So this one will be probably pretty long. Let me write it down, and then we can go to another sheet. So we're going to have 14 and then x squared y cubed, and then plus 9y to the 4th power. You can just drop the parentheses on that because it's the leftmost guy. You don't have to worry about the parentheses there. You have minus this quantity here, so I'm just going to write this as plus, and I'm going to change the sign of all of these guys inside. So what I'm going to do is have this 10x to the 4th power y squared, and then I'm going to put minus y, and then I'm going to put minus 7x squared y cubed. So all I did was I changed this minus into a plus. This became a positive, this became a negative, and this became a negative. Okay, so that's all I'm doing. Then this guy is plus. So you can just drop the parentheses here. You have your negative 6x squared y cubed, and then you have your minus 12y. Let me grab this. Or actually, I think we can just slide down. It's not that big of a deal. I'll just come back up. I'm going to put equals here. Again, the definition for standard form is going to vary based on your teacher, your textbook, all these things that are going on. I always try to just list the term with the highest degree first. So if we look at this guy, it's 5. This guy is 4. This is 6. This is 1. This is 5. This is 5. And this is 1. So we had something with 6. That was 10x to the 4th power y squared. Let's go ahead and list that first. And there are no like terms to combine with that, so we're just going to leave that as is. I'm going to check it just to say that we've used it. And then if we go through the list, the next highest would be the degree of 5. So you have this x squared y cubed. So 14x squared y cubed. You have negative 7x squared y cubed. And you have negative 6x squared y cubed. Let's go ahead and combine those like terms. 14 minus 7 is 7. 7 minus 6 is 1. So I'll put plus x squared y cubed. So let's go ahead and check this guy, and this guy. And I'll erase that and that and that. And then the next guy that I'm looking at, we have a degree of 4 and a degree of 1. So I'm going to put this plus 9y to the 4th power next. And I'm going to check that off. And then lastly, I have this minus y and minus 12y. So that's a degree of 1. So I'm going to take this guy and this guy. Obviously, that would be minus 13y. So let's get rid of this and this. So I'll just check this one off and this one off. So we've used everything. So let me erase this. And if we look at our answer, we're looking for this guy right here. So we have 10x to the 4th power y squared plus x squared y cubed plus 9y to the 4th power minus 13y. So this is our answer right here. All right, let's look at question number 6. So we have, to simplify here, we have 2x plus 1, this quantity, times x squared minus 9x minus 11. So again, all I'm going to do is I'm going to take each term from this first polynomial, or the left polynomial, so the 2x and then the 1, and I'll multiply it by each term of this second polynomial, or this rightmost polynomial. And then when I'm done, I'm just going to combine like terms. So you can write this out if you want, if you need that for clarity. I'm just going to do this mentally to make it a little bit quicker. So 2x times x squared is going to be 2x cubed. 2x times negative 9x would be minus. 2 times 9 is 18. X times x is x squared. Then 2x times negative 11 is minus. You'll go 22. 2 times 11 is 22. And then x. Now I'm going on to this 1 here. Remember, 1 times anything is just itself. So I can just copy this polynomial. So I can go plus x squared. And then let me do this down here. Minus 9x and minus 11. And then we're basically good to go. All I have to do from this point is just combine like terms, and I'm done. So we have 2x cubed. I don't have anything to combine with that. I'm going to have this 18x squared and this plus x squared. Again, you can write this as a visible coefficient of 1. Negative 18 plus 1 is negative 17. Let's put minus 17x squared. Let's check that and that. Then you'd have negative 22x minus 9x. That is going to give me negative 31x. Let's check that and that. And lastly, you have that minus 11, nothing to do with that. So let's erase this. So I'm looking for 2x cubed minus 17x squared minus 31x minus 11. So I want this guy right there. Okay, let's look at the next one, problem number 7. So we're asked to simplify, and we have 4x squared minus y, and this quantity is cubed. Okay, so I want to write out the formula for this. Again, some of you have memorized this at this point and others haven't. It's not that big of a deal. I mean, it's something you do want to have memorized if you're going into a standard test like the SAT or the ACT, or you're working tons of polynomial problems. But in general, you can just look up the formula. So x plus y, quantity cubed, is x cubed plus you're going to have 3 times x squared y plus you're going to have 3xy squared. And let me scooch this down so it fits on the screen. Then lastly, you're going to have plus y cubed. So in other words, the first guy is cubed and the last guy is cubed. Those go in the first and last position. In the middle, you're always multiplying by 3. And then one of the guys is squared and the other one isn't. If you can just remember that part, I think it's pretty much going to be good to go for you. I always remember it's 3 times the first guy squared times the last guy, and then plus 3 times the first guy times the last guy squared. However you want to remember it, it's kind of up to you, but you're just going to match this formula. I'm going to erase this. You can pause the video now and write it down if you want, but I'm just going to erase this and go from memory. So I want the first guy here to be cubed, so 4x squared would be cubed. And then this is a minus, and actually I gave you the formula for plus. I wasn't really thinking. But with a minus sign, it's going to give you the second and the fourth terms. In front of those guys, you'll have a minus. So in front of this second term here, I'll just have a minus instead of a plus. That's the only change in the formula. And then what I want to do here is I want to go 3 times the first guy squared, so times 4x squared being squared, then times the last guy, so then times the y. Okay, then plus. I want to now take 3 times, again, the first guy now is not squared, so 4x squared, but the last guy is squared, so y being squared. Then again, in front of the second term, like we saw here, in the final term, if this is a minus here, you want to put minuses there. So the last guy now, the y will just be cubed. Okay, so we're done with the formula. Again, it's just something you want to copy down. If you want this, it's x minus y quantity cubed. It's x cubed minus 3x squared y, and then plus 3xy squared, and then plus, actually this is minus, so this is minus y cubed. So this is the formula we just used. The minus is going to go there and there, like you see here and here. Okay, so that's the only difference between the plus and the minus. Okay, so let's come down here and see what we can get. So 4x squared being cubed, 4 is being cubed. What is 4 cubed? Well, it's 4 times 4, which is 16, times 4 again, which is 64. So this is 64. X squared is being cubed. X stays the same. 2 times 3 is 6. Then we have minus. Again, 4x squared is being squared. 4 squared is going to be 16. So I'm going to write this as 3 times 16 here. X squared is being squared. That's x to the 4th power. And then you have your y. So this, 3 times 16 would be 48. So let's write that in there like that. And let me slide this down just a little bit so it fits a little bit better. And then we have plus. So over here we have 3 times, you have 4x squared times y being squared. This is just y squared. So 3 times 4 is 12. And then we'll say that this is going to be x squared, y squared. And then lastly, you just have this minus y cubed. Okay, so this is your answer here. Let's get rid of all this. So we have 64x to the 6th power minus 48x to the 4th power y plus 12x squared y squared minus y cubed. So we're going to want that one right there. Okay, let's look at question number 8. It says to perform each division. So we have this 9x squared minus 27x plus 2. So this quantity divided by 3x. So if I'm dividing by a single term or a monomial, you just set this up as a fraction. And then what you can do, let me do this up here so you have some room, take each term from this dividend or numerator and divide it by the monomial or the divisor. So I'm going to say this is 9x squared over 3x. And then this is minus. Let me go plus negative 27x over 3x. And I'll go plus 2 and then over 3x. So just simplify what you can. You can actually get rid of this. You don't even need it. We're going to divide 9 by 3 and get 3. X squared over x is x to the 1st power. So let me go ahead and just put 3x like this. And then over here I have minus 27x over 3x. Well, negative 27 divided by 3 is negative 9. So I'm going to write negative 9 there. And then x over x is going to cancel. So I'm going to put minus 9. And then lastly, I have plus 2 over 3x. I can't really do anything to simplify there. So I'm going to put plus 2 over 3x like this. And I'm just looking for this as my answer. So we have 3x minus 9 plus you have 2 over 3x. So I want that answer right there. Okay. So now we're told to perform each division. And this is going to be a long division problem. So let me go ahead and set this up. So we have 12x cubed. And then we have minus 36x squared minus 12x plus 38. So notice that this is in standard form. I'm not missing any powers. Let me go ahead and set this up. My divisor is 6x minus 6. Obviously, we're going to need a new sheet to do this. Let me cut this away. And because this is not of the form x minus k like this, we can't use synthetic division if that's what you're wondering. So again, to start this off, I'm going to do division, leading term into leading term. 12 divided by 6 is 2. X cubed divided by x is x squared. So this is going to be 2x squared. Go ahead and multiply. 2x squared times 6 is 12x cubed. 2x squared times negative 6 would be minus 12x squared. You're going to change the signs of everything. That's your subtraction step. So I'm going to go minus and then plus and then combine like terms. So this is going to cancel, and I'm going to actually erase that highlighting. Negative 36x squared plus 12x squared is negative 24x squared. Bring down the next term, and you just repeat the process. So leading term into leading term. Negative 24 divided by 6 is negative 4. So let me put minus 4 there. X squared over x is just x. So now we're going to multiply. Negative 4x times 6x would be negative 24x squared. Negative 4x times negative 6 would be plus 24x. Okay, let me erase this highlighting here. Let me change this to plus and this to minus. And again, this is going to cancel. Negative 12x minus 24x would be negative 36x. Let me drop this guy down here, so plus 38. And let me highlight this guy right here. So leading term into leading term. What is negative 36 divided by positive 6? That's going to be negative 6. Let me put minus 6 here. X over x is 1. Okay. So now what I want to do is multiply. Negative 6 times 6x would be negative. We'll go 36x. Negative 6 times negative 6 is plus 36. We're going to change the sign. So this is going to be plus, and this is going to be minus. And what do we have? This is going to cancel. And I'm basically going to have 38 minus 36, which is 2. So that's going to be my remainder. Okay, so now that I have this, I can actually just grab this guy right here. Let me copy this. So my answer is going to be 2x squared minus 4x minus 6. And then remember, my remainder was 2. So let me put plus. You're going to go 2 over 6x minus 6. Now, when you look through the answers, you might say, well, this looks very similar, but it's not the same. Your remainder is 1 over 3x minus 3. And the reason for that is this can be simplified. So we haven't gotten to rational expressions yet, but this can be factored into 6 times the quantity x minus 1. And 6 can be broken up into 2 times 3. So in other words, this would become a 1, and this would become a 3. And then if I went back through and said 3 times x is 3x, and then minus 3 times 1 is 3, well, I'd end up with exactly what I have there, right? 1 over 3x minus 3 there for the remainder. So that's how we get this answer, 2x squared minus 4x minus 6, and then plus, we're going to have 1 over 3x minus 3. All right, let's look at the next problem. So we have another long division. So we have 3x cubed, and then minus 2x squared. I don't have x to the first power, so I'm going to put plus 0x, and then minus 150. Let's go ahead and set this up there. And then I have x squared minus 4 as the divisor. I'm missing x to the first power, so x squared, and then I'm going to put plus 0x, and then minus 4 like this. Let's go ahead and cut this away, paste this in here, and let's go ahead and knock this out. So leading term into leading term. We know that 3x cubed divided by x squared would be 3x. So this is going to be 3x. You're going to multiply 3x times x squared is 3x cubed. 3x times 0x, you can just say that's plus 0x squared. And then 3x times negative 4, let's put minus 12x. I'm going to change all my signs. So minus, this will be a minus, and this will be a plus. You're going to combine like terms. This cancels. This just comes down. It's negative 2x squared. And this guy right here would be plus 12x. Go ahead and bring this down. So minus 150 there. And then you're going to go leading term into leading term. So negative 2x squared divided by x squared would be negative 2. So negative 2 or minus 2, however you want to think about that. So negative 2 multiplied by x squared is negative 2x squared. The negative 2 times 0x, let's write that as minus, I'm going to go 0x. And then negative 2 times negative 4 is going to be positive 8. So remember, you want to change all your signs. So this is going to be plus, plus, and then minus. And then let's put this down here. So then this is going to cancel. Let me bring this down a little bit so we have a little bit of room. This is going to cancel. We'll have 12x here. 12x plus 0x is like 12x plus 0. And then negative 150 minus 8 would be minus 158. Now, here's where you actually have to stop. This guy right here is your remainder because the degree of this guy right here is 1, and the degree of this guy right here is 2. So you can't continue your division. This guy is going to be your remainder. So basically, what you would say is that you have your 3x minus 2, and then plus, you would have this 12x minus 158 over this divisor of x squared minus 4. Let me cut this away. So 3x minus 2, and then plus, you have the 12x minus 158 over the x squared minus 4. So that's what we're looking for right there. Now we want to perform each division using synthetic division. This is question number 11. So I'm going to go ahead and take this 5x cubed plus 9x squared plus 10x plus 6. It's in standard form, not missing any terms. So just take the coefficients. I want the 5, the 9, the 10, and the 6. And over here, remember, for your divisor with synthetic division, it's got to be of the form x minus k. We have x plus 1. So this is equal to x minus a negative 1. If you just put 1 out here, you're going to get the wrong answer. You got to change it into this form. And once it's in this form, you take what's to the right of that subtraction symbol. In this case, it's negative 1. So let's go ahead and take and put a negative 1 there. And I'm going to erase this. And let's just go to a fresh sheet of paper. And again, I'm just going to drop this first number down. And then I'm going to multiply, then add. Multiply, then add till I get to the end. So negative 1 times 5 is going to be negative 5. And then 9 plus negative 5 is 4. Negative 1 times 4 is negative 4. 10 plus negative 4 is 6. Negative 1 times 6 is negative 6. 6 plus negative 6 is 0. So these numbers, again, are the coefficients for our quotient, right? This one all the way to the right is going to be your remainder. In this case, you don't have one. Let's go ahead and select these numbers. You can just copy them. You come back up and you can paste them. We'll make it make some sense. You can get rid of the 0. We don't have a remainder here. You always want to make this as 1 degree less than the polynomial in your dividend. So in the dividend, we had an x cubed there, so the degree was 3. So this degree would be 2. So basically, we would have 5x squared plus 4x plus 6. That's going to be our answer. So here we have 5x squared plus 4x plus 6. Let's look at 12. This is our final problem for this test. Again, I just want to perform each division using synthetic division. So I have x cubed plus x squared minus 74x plus 20. I'm not missing anything, and it's already in standard form. So I'm just going to go ahead and put 1, which is the coefficient for x cubed, a 1, which is the coefficient for x squared, a negative 74, which is the coefficient for x to the first power, and then a 20. Okay, so that guy right there. And then you have x minus 8. So if it's of the form x minus something, just take whatever it is. So this is x minus 8. I'm just going to take the 8. I don't have to do an additional step here because this is not a plus sign. This is a minus, so this matches the x minus k form. So just take 8. That's all I want. And then I'm going to grab this, and let's paste this in. And I'm just going to drop this down. 8 times 1 is 8. 1 plus 8 is 9. 8 times 9 is 72. Negative 74 plus 72 is negative 2. 8 times negative 2 is negative 16. 20 plus negative 16 is 4. So again, this is your remainder, okay? All the way to the right, that's your remainder. Let me highlight that, and I'm just going to grab this whole thing here. Let's paste this in here. So again, these coefficients here are going to be starting with a variable that's raised to the power that's 1 less than the highest power in your dividend. So in other words, the degree here was 3. You have x cubed, so this guy's going to have a degree of 2. So this would be 1x squared, or just x squared, plus you'd have 9x, and then minus 2. And then your remainder is 4, so I'll put plus 4 over. The divisor is x minus 8. Let me grab this and make this come into the center. So I'm looking for x squared plus 9x minus 2, plus I have 4 over x minus 8, so I'm looking for this guy right here. All right, let's look at our test. So we're told to find the GCF, or greatest common factor. We're given negative 9x squared y. we're given 45xy. Again, you're going to look at the number part first. Forget about the fact that it's negative. You have 9 there, which is 3 times 3. And you have 45, which is basically 9, or 3 times 3, and then times 5. So what's common to everything? Well, it's going to be 3 times 3, or 9, right? Here and here is going to be common. So when you build out your GCF, your number part, or your coefficient for that guy, is going to be a 9. Then for the variable part, you're going to check to see if the variable is going to be present in each. So I have an x here and an x here, a y here and a y here. So for sure, you're going to have an x and you're going to have a y. And then for your exponent on the variable, you want to check for the smallest exponent on either term. So in this case, you have a 2 for the exponent of x, and here you have a 1, so you want a 1. Here it's a 1 for y, and here it's a 1 for y, so you want a 1 there. Okay, so basically we just have 9xy. And if I look through my choices here, I see I have negative 9xy and positive 9xy. Now, in some cases, when you're asked to find the GCF or factor out the GCF, it might make sense to have the negative 9xy. We're going to see that come up in factoring by grouping. But for this just straight answer, you want to just put positive 9xy as your answer. Let's find the GCF again for problem number 2. So we're given 14x squared y cubed. We're given 56x squared y to the 5th power z to the 7th power. And then we're given, I'm going to put this down here, 112xz. So for the numbers, you have 14, you have 56, which is 14 times 4. And then you have 112, which if you divide that by 14, you're going to get 8. So the number part would just be 14. And then for the variable part, I have an x here, here, and here. So x is going to go in. Let me change colors. And then the exponent on that, you have a 2, and a 1. So it's just going to be the 1. That's the smallest. And then y and z are not going to go in. You have a y here and here, but not here. It's got to be common to everything. And then for z, it's not going to be here, but it's here and here. It's got to be common to everything. So it's just going to be the 14x. So I'm looking for this answer right here. Okay, for question 3, it asks to factor out the greatest common factor. So we have 12x squared y squared z plus 20x squared y cubed z to the 4th power minus 4xy. Let me copy this and let's paste this in here real quick. So for the number part, you can see you have a 4, a 20, and a 12. Well, 20 is 4 times 5 and 12 is 4 times 3. So the number part would just be 4, right? That's common to everything. Now for the variable part, you can see that z is not common to everything, so that won't be in there. Everything has an x and everything has a y. The smallest exponent on x and y is 1, so this would be 4xy. So basically, this guy right here is your GCF. We're going to put it outside of the parentheses. And everything inside, again, I'm just going to take this term here, divide it by this greatest common factor that's outside the parentheses to get what goes here. So 12 divided by 4 is 3. X squared over x is x, y squared over y is y, and z comes along for the ride. Then plus 20 divided by 4 is 5, x squared over x is x, y cubed over y is y squared, z to the 4th power will come along for the ride. Then minus, you have 4xy divided by 4xy, that's going to be 1. So let me copy this, and let's just paste this in. And let's see if we can find this. So we want 4xy outside. So it looks like it's just going to be this one. On the inside of the parentheses, you have 3xyz. Then plus, you have 5xy squared z to the 4th. And then you have minus 1. So you can go ahead and circle this guy right here as your answer. All right, let's look at the next problem. So we have 9x to the 6th power y squared minus 63x cubed y minus 90x squared y. So again, let me copy this and let's paste this in here. So if I'm looking at this, I have a 9, a 63, and a 90. Again, if I think about this, I know that 9 is common to everything. 63 is 9 times 7, 90 is 9 times 10. So let me go ahead and just say that the GCF, the number part of the coefficient is 9. For the variable part, well, everything has an x and everything has a y. For x, the smallest exponent is a 2, so this would be x squared. For y, the smallest exponent is a 1, so this would be y. So inside the parentheses, again, I'm just going to divide. So this divided by this. So 9 over 9 is 1. X to the 6th power over x squared is x to the 4th power. And then y squared over y is y. Then minus 63 divided by 9 is 7. X cubed over x squared is x. Then y over y is 1. Then minus 90 over 9 would be 10. X squared over x squared is 1. Y over y is 1. So let's close that down. Let's grab this, paste that in here. So I want this guy right there. All right, question 5. We want to factor out the GCF. So we have 6 times the quantity x plus 1. and then plus 9 times the quantity x plus 1. So again, this is a common binomial factor. We'll talk more about this in the next lesson on factoring by grouping. But for right now, to pull that out, I would just put that outside here. And then what's left? Well, I have literally a 6 and then plus a 9. Okay, I'm just pulling this out in front of those parentheses there. Well, what is 6 plus 9? Well, I can simplify that and say that's 15. So this would be 15 times the quantity x plus 1. Okay, that's all it's going to be. So it's this answer right here. All right, let's look at our quiz. So for the first question, we want to factor each using the grouping method. So we have this 3xy plus 12x minus 8y minus 32. The GCF here is 1, so you don't have to worry about that. So from the first group, I could pull out a 3x, and I would be left with y plus 4. From the second group, let's pull out a negative 8, and I would have y plus 4 inside. So my common binomial factor is y plus 4. So you'd have y plus 4. That gets pulled out. And what's left inside these parentheses, you'd have the 3x, and then minus the 8 there. So I'm looking for 3x minus 8, that quantity, times y plus 4, that quantity. So this guy right here. Okay, so look at question number 2. So again, we're factoring each using the grouping method. 32xy minus 160x. Let me make that better. And then minus 40y plus 200. Okay, so can I pull anything out? Yes, because everything is even there in terms of the numbers. Let's see, I have 32, I have 160, 40, and 200. Looks like I could also pull out a 4. Can I pull out an 8? Yeah, it looks like I can do that as well. So if I pulled out an 8, inside, I'm going to have a 4xy, and then minus 20x, and then minus 5y, and then plus 25. Okay, so from here, let me scroll down and get some room going. We'll come back to the answers in a moment. From here, I can make 2 groups of 2 each. So let's go 8 times. Inside from the first group, I'm going to take out a 4x. And then inside, I'm going to have y minus 5. From the second group, let me go ahead and pull out a negative 5. So inside, you'll have y minus 5. And then if I look at this guy, I have a common binomial factor now, which is going to be this y minus 5. So let me pull that out. You'll have 8 times the quantity, y minus 5. Then times the quantity, you'll have your 4x, and then minus your 5. Okay, so that's going to be your answer. Pull this up here and see if we can find it. So we want 8 out in front. So that's this one, or this one. Then we have times the quantity y minus 5. So that looks like it's not there, and it's not there. So it would have to be here. And then times the quantity 4x minus 5. So yes, this is what we want. 8 times the quantity 4x minus 5 times the quantity y minus 5. All right, let's look at question 3. So we want to factor each using the grouping method. So we have this 28xy minus 12 plus 24x minus 14y. Let me bring this down here a little bit so we have some room. Let me scroll down a little bit. So for sure I can pull something out. It looks like I can pull out a 4 because this is divisible by 4 and so is this and so is this. But actually 14 is not. So it looks like I can only pull out a 2. So let me pull out a 2 and then we'll have 14xy minus 6 plus you're going to have 12x and then minus 7y. Okay. So can I make this work with the way that I have this? Again, this would be x, y, and this would be no variable here, and this would be x and y. So that doesn't look like that's going to work. So we need to change this around. So let's say that we put the x, y, and the y next to each other. I'm just thinking about the variables here because the y would come out. So you'd have x and then no variable. And then here, if these guys were next to each other, you'd have x and no variable. So it looks like I want to rearrange this. So we'll have 2 times, I'll do 14xy, and then I'll go minus 7y like this, and I'll put plus 12x, and then minus 6 like this. Looks like that would work. So I'll go 2 times. So from the first group, I can pull out a 7y, and inside now I'm going to have 2x minus 1. So then plus, from the second group, I can pull out a 6. So inside I'll have 2x minus 1. And so again, I have this common binomial factor of 2x minus 1. So let's go ahead and come down here. see what we have. So we have 2 times the quantity. It'll be this 2x minus 1 times the quantity 7y plus 6. All right, let me erase everything. So we want 2 out in front, so only here and here. Then times the quantity 2x minus 1, so both of those have that. Then times the quantity 7y plus 6, so I want this one right here. 2 times the quantity 2x minus 1 times the quantity 7y plus 6. All right, let's look at number 4. Again, we're using grouping, so 147 xy plus 96 plus 168x plus 84y. Okay, let me scroll down a little bit, get myself some room. So what can we pull out from here? It looks like we can pull out a 3. You can use the trick for divisibility by 3. Again, you sum the digits. If that number that's produced is divisible by 3, it's going to be divisible by 3. So everything here is divisible by 3. It looks like that's what we can pull out. I know that I can't pull out anything more because 147 divided by 3 is 49, and 49 is 7 squared. So it doesn't look like anything else is going to come out. So let's put 3 out in front. 147 divided by 3 is 49, and then times xy, and then plus 96 divided by 3 is 32, then plus 168 divided by 3 is 56, and then times x, and then plus 84 divided by 3 is going to be 28. So this would be 28y. Okay. So again, you need to reorder things. It's not going to work. Again, just look at the variables. This is x, y, and this is nothing. This is x and y. So again, I'm going to put these next to each other and these next to each other. So let me go ahead and say this is 3 times. I'll say that we have this 49xy plus 28y, then plus 56x, and then plus 32. So let's see what this gives us. So we'll have 3 out here. And then from this one, I can pull out a 7y. And then inside, you'll have 7x, and then plus your 4. From this one, I can pull out, it looks like an 8. 32 is 8 times 4. 56 is 8 times 7. So I can pull out an 8. And inside, you would have 7x plus 4. Okay, just like that. So you have the common binomial factor of 7x plus 4. So if we pull that out, you'd have 3 times the quantity 7x plus 4. Then times the quantity, you have this 7y. Then plus this 8 that's going to be there. So let me erase everything. Pull this up here. So 3 times the quantity 7x plus 4 times the quantity 7y plus 8. This guy right here. All right, let's look at question number 5. So again, we're just factoring each using the grouping method. We have 60xy. Then plus, you have 56x. Then plus, you have 70x squared. Then plus 48y. Okay, so thinking about what I could pull out here, everything is even. So I know I could pull out a 2. I know that for sure. Could I pull out a 4? Well, this would be 15 times 4. This is 14 times 4. But 70 is not divisible by 4. So that's not going to work. Now, when you look at the answer choices, because this is multiple choice, you already know that this one's going to be the answer without doing anything else, because I know I can pull out a 2, right? This one I pulled out a negative 4x, this one a negative 8x, and this one a 4. So you can just move on with the test if you don't feel like practicing anymore. But I'm just going to do this for the sake of completeness so that we get the full work up here. And I'm going to pull out my 2, and I'll have 30xy, then plus we'll have 28x, and then plus we'll have 35x squared, then plus 24y. So I just pulled a 2 out from everything, okay? So inside here, again, I got to think about if this is going to work. You would have x, y, and x. So you'd pull out the x, you'd have y and nothing. Here you would have x squared and y, so that's not going to work. I want to put these next to each other and these next to each other. That way it would work. So 2 times inside of here. Let's go ahead and say we have 30xy plus 24y plus, I'm going to rearrange that, 35x squared plus 28x. Close that down. Let's come over here, and I want to say we have 2 times the quantity. I could pull out a 6y, and I would have 5x plus 4. And then plus, here I could pull out a 7x, and so I would have a 5x plus 4. Okay, so again, I got my common binomial factor of 5x plus 4. I'm going to pull that guy out. So we would have what? 2 times the quantity 5x plus 4, then times the quantity 6y plus 7x. Let me grab this. And you can see that this matches what we found earlier, right? We knew it was already this one, but 2 times the quantity 5x plus 4 times the quantity 6y plus 7x. So that's your answer right there. All right, let's look at our quiz now. So we're told to factor. We have this x. Let me make this better. So we have this x squared, and then minus 2x, and then minus 80. So we know that if the coefficient here is 1, this sets up to be, you have x, and then you have x when you set up your binomials. I know this sign is negative here. if you get a negative product, that can only come from a positive times a negative. So one of these would be positive and the other would be negative. So I just want you to think about positive numbers for right now. What are the positive factors of 80 that I could work with to where the sum is going to be -2 when you play with the signs, okay? So I think about positive numbers and then I start working with the signs. So in other words, with 80, I have 1 and 80, nothing I can do. I have 2 and 40, nothing I can do. Not divisible by 3, I have 4 and 20, nothing I can do. I have 5 and 16, nothing I can do. Not divisible by 7, you have 8 and 10. Now, here's what I mean about playing with the signs. When you have negatives, you have to play with the signs. So if I had a positive 8 and a negative 10, would that work? Yes. If I put a negative 10 here and a positive 8 there, I'm basically going to be good to go. That's exactly what I want, because if I look at this, positive 8 plus negative 10 is -2. And then positive 8 times negative 10 is -80. So I want this answer right here, the quantity x minus 10 times the quantity x plus 8. Okay, let's look at the next one, question 2. So we have x squared minus 4x minus 45. Let's go ahead and set this up. Again, 2 binomials. This will be x and this will be x. I know something's plus and something's minus because this is a negative here. Okay, so thinking about this, 45, I've got 1 and 45. No. I've got not divisible by 2. 3 and 15. No. It's not divisible by 4. It's 5 and 9. So I can make that work. Again, you got to play with the signs because this guy is going to be negative. So I want, because this ends up being negative, the larger in terms of absolute value to be negative. So I want -9 and +5. So again, 5 plus -9 is -4. 5 times -9 is -45. So I want the quantity x plus 5 times the quantity x minus 9. So that's this guy right here. Okay, let's look at question 3. So we have 4x squared minus 44x plus 120. Again, if you're in this section of your textbook or in a course and they say we're talking about a leading coefficient of 1 and you don't get that, well, you're expected to factor that out, okay? You're expected to say, okay, well, there's a GCF of 4. If I pull that out, I'm going to have x squared minus 11x and then plus, this is going to be 30. Okay, so what can I do here? Let me put the 4 out in front. I have an x and then I have an x. Well, I know that I have a negative here and I have a positive here. Well, a negative sum is going to come from a negative plus a negative, and a positive product can come from a negative times a negative. So I know these signs are each negative. Now, let's think about the factors of 30, and we'll work out the signs. You got 1 and 30, doesn't work. You got 2 and 15, doesn't work. You got 3 and 10, doesn't work. You've got not divisible by 4, 5 and 6. Can I make that work? Yeah, if they're both negative. So a -6 and a -5. -6 plus -5 is -11. -6 times -5 is +30. So this is what I'm looking for. I'm looking for 4 times the quantity x minus 6 times the quantity x minus 5. So I want this answer right here. Okay, let's look at question number 4. Again, we're told to factor each. We have 4x squared minus 68xy plus 288y squared. So a lot of people freak out when they see this second variable. It's really easy to deal with. First, let's factor out the GCF of 4. So we can get back to having a leading coefficient of 1. So this is x squared minus 17xy, and then plus, you'll have 72y squared. Okay, let's close that down. Let me see where we're at now. So I have 4. And then I'm going to set this up as we usually do, okay? And I want you to think about the fact that you have a y here in the middle term, and you have a y squared here. Where does y squared come from in a product? Well, it's y times y. So just put a y here and a y here. Does that work out for the middle term? Well, yeah, it comes from this and this, right? So you have x, y, and x, y. So you're basically good to go by putting the y in to that last position. You just need to work out what is the coefficient for this guy and this guy. Okay, that's all you got to do. Same rule, you're just going to look at 72, think about the factors, and I want the sum to be -17. So again, you got to play with the signs. So I've got 1 and 72, I've got 2 and 36, I've got 3 and 24, I've got 4 and 18, not divisible by 5. I've got 6 and 12, not divisible by 7. And then I've got 8 and 9. So it looks like 8 and 9 would work, right? Because you want a minus and a minus. The sum is negative, okay? The sum is negative or subtraction there. And the product is positive. Negative times negative is positive. Negative plus negative is negative. So let's go ahead and put a 9 here and an 8 here. The order really doesn't matter. You can put it in 8 here and a 9 here. It doesn't matter. You have your negative 9 plus your negative 8 gives you negative 17, and you have your negative 9 times your negative 8 gives you your positive 72. So again, you can FOIL this out and you can prove that this works, but this is going to be our answer. So let's look for 4 times the quantity x minus 9y times the quantity x minus 8y. So we're looking for this guy right here. All right, let's do question number 5. So we're looking for 6x squared minus 90xy plus 300y squared. So again, I'm pulling the 6 out. Inside I'd have x squared minus 15xy, and then plus, this will be 50y squared. Okay, so again, if you have this y squared here and the y in the middle term, don't freak out. Just put the 6 out in front. You have x here, you have y here, you have x here, you have y here. Okay, everything else is usual business. So I'm thinking about some factors of 50. Again, I want the sum to be negative 15. So again, I got to play with the signs because I got a negative. I know this will be minus and this will be minus. Negative plus negative is negative. Negative times negative is positive. So for me, immediately I think about 10 and 5, right? Because 10 plus 5 is 15. Well, if I had negative 10 plus negative 5, that would be negative 15. Negative 10 times negative 5 is positive 50. So let's just put our negative 10 there and our negative 5 there. And so this is what we're looking for. Again, you can FOIL this and check to make sure that it works. I can promise you that it does. So 6 times the quantity x minus 10y times the quantity x minus 5y. So this guy right there. All right, let's take a look at our quiz. So for the first question, we're asked to factor each using the AC method. And before I even read the problem, I want to make sure everybody's crystal clear on this. So remember, the standard form for the trinomial, it's ax squared plus bx plus c. So when we say the AC method, we end up doing what? First, we look for anything we can factor out. So is the GCF not 1? If it is 1, you move on. If it's not, you pull it out. Then the next thing you're going to do is you're going to figure out what is a times c. So you want this product here. Then you want to figure out what are two integers such that it gives me a product of this AC guy and a sum of b. Now, if AC is positive, then you're going to be adding these integers. I always forget about the sign, okay? I always just think about things being positive and I work the signs out later. So if AC is positive, you either have a positive times a positive or a negative times a negative. So you're going to be adding. Forget about the signs. It doesn't matter. You'll get it later. Then if this AC is negative, you need a positive times a negative. Okay, so you're going to be subtracting. And again, don't worry about the sign. Just think about things in terms of their absolute value. When you get something that works, you just play with the signs until you got it. So once you have these integers, you use that to rewrite your middle term, right? You're going to expand this into a 4-term polynomial instead of a trinomial, which only has 3 terms. And then once you have it in that format, you're going to be able to use factoring by grouping, okay? So quite a tedious method overall, but it is easier in most cases than using the reverse FOIL that we're going to talk about in the next lesson. Okay, let me get rid of this. I think we know what's going on there. Let me write out this problem. So this is going to be 8x squared minus 25x, and then minus 28. I'm going to go a little bit quicker through this one. I think we already know at this point what to do. Again, the GCF here, if you look at it, would be 1. The way you can tell, 8 is 2 cubed, and 25 is 5 squared, so nothing in common there. And then variable-wise, you don't have an x everywhere, so you couldn't pull anything out. So if I look at AC here, A times C, this is going to be negative, because positive times negative is negative, and then 8 times 28 is 224. So this is negative 224. So again, if this is negative, when I come up with these pairs of integers that are multiplying together to give me this, I want to end up subtracting them to see if I can get something like 25. Again, forget about the fact that's negative. It doesn't matter for right now. Just work with everything being positive. So if I think about factors of 224, I would have 1 and 224. Again, this is obviously not going to work. And if I was doing this problem for real, I would just forget it. But for the sake of completeness, I'm going to go through everything. Then you would have 2 and 112. Again, too far away. You would have 4 and 56. That's getting closer, but 56 minus 4 is 52, so that's not going to work. If you look at continuing here, you would skip 5 and 6. It would be 7 times 32, and this would work, right? If you do the subtraction, again, because this is negative, 32 minus 7 is going to give you 25. The fact that it's negative just means you have to play with the signs, right? So you'd make this negative and this positive, and that would work. So let me get rid of all this. We have our two integers. And again, the purpose of this is just to rewrite the middle term. So we're going to say that we have 8x squared, and then I'll take this plus 7x. The order that you grab these in does not matter at all. It works out the same in the end. So then I'll put minus 32x, and then I'll put minus 28. Let me erase this, and let's go ahead and say equals. So now I'm just going to use my factoring by grouping. From the first group, I'll go ahead and pull out an x. You'll have 8x plus 7. From the second group, this is minus and this is minus. So I'm going to pull that out, and I'm also going to pull out a 4. And inside, I'm going to have 8x and then plus 7. So you see you have this common binomial factor, and that's what we're trying to find. Once you have that, it's really a piece of cake. And all you're going to do here is just say, okay, we'll have the quantity 8x plus 7 times the quantity. You'll have this x here, and then minus this 4 here. So minus 4, that quantity. So 8x plus 7, this quantity, times x minus 4, this quantity here. So let's get rid of this. So it's in a different order, but that doesn't matter. So here we have the quantity x minus 4 times the quantity 8x plus 7. So that's going to be our answer. All right, let's take a look at question number 2 now. So again, we just want to factor each using the AC method. I'm going to take a look at 10x squared, then plus this 23x, and then minus 42. So fairly easy problem overall. Again, we think about A, B, and C. So A is 10, B is 23, C is negative 42. So first off, can I pull anything out? No. This is 10, which is 2 times 5. 23 is a prime number, so you can stop with that. And then you can just go into A times C. So 10 times negative 42 would be negative 420. Again, if this is negative, you're looking to subtract the integers that you come up with. If it's positive, you're going to add. Okay. Now, again, I always think about things being positive. So if I think about 420, well, I'm just going to start with 42 times 10. So 42 times 10, and I'm going to subtract. So 42 minus 10 would be 32. So obviously that's not 23, and I need to get a smaller result. So I want this number to go down, and I want this number to go up. Now 420 is not divisible by 11, but it is divisible by 12. So you could do 35 and 12, and if you subtract there, 35 minus 12 will in fact give you 23 that you're looking for. So you have a positive 35, and you're going to have a negative 12. Let me write that over here. So 35, this is positive, and 12 is going to be negative. And let's put equals here. Let me change colors so it stands out. I'm going to put my 10x squared. I'm going to use these two guys. It doesn't matter the order you use them in. So I'm going to put, let's go plus 35x, and then you go minus 12x. Again, we're just rewriting that middle term. And then we're going to go minus 42. So once we have this set up, the hard part, or I would say the tedious part, it's not necessarily hard, that part is over. And basically we're just factoring using grouping. From the first group, if you think about 10 and 35, you could pull out a 5. And then x squared and x, you could pull out an x. So inside you would have this 2x plus 7. And then this is minus and this is minus. So you want to pull that out so that you match the plus and the plus. Here with 12 and 42, you could pull out a 6. So inside you would have your 2x and then plus your 7. So you see you have a common binomial factor. This guy right here, this 2x plus 7. So again, you're just going to pull that guy out. That's all you're doing. So you have the 2x plus 7 on the outside. And then inside these parentheses, you'll have this 5x from right here, and then minus 6 from right there. So we get 2x plus 7, this quantity, times 5x minus 6, this quantity. And let's look for this answer. So 2x plus 7, so it looks like that's right here. And then we have 5x minus 6. So this is what we want. We want the quantity 2x plus 7 times the quantity 5x minus 6. All right, let's look at question number 3. So again, we're factoring using the AC method. So we have 9x squared plus the 42xy, and then plus 40y squared. So seeing a second variable here is not any more difficult. You're going to use the exact same procedure. With this strategy, with the AC method, you don't have to worry about it at all. Okay, so let me start out by saying, can we pull anything out? You have 9, which is 3 times 3, and you have 42. That is 6, which is 2 times 3 times 7. So no, let's just go ahead and stop there. This has an x, this has an x, this doesn't have an x. This and this has a y, and this doesn't. So the GCF is 1. All right, so what is AC? 9 times 40 is 360. And I want a sum of 42. Everything's positive. So I would start here. Let's just go ahead and start with 36 times 10. Make this a little bit quicker. Obviously, you're adding things because this is positive. So this would be 46. It's pretty close to 42. And pretty much all I would want to do is decrease this and increase this. So it's not going to be divisible by 11, but it will be by 12. I could do 30 times 12, and 30 plus 12 would give me 42. So I want positive 30 and positive 12. So that's what I'm looking for. So let's use that. So we're going to have 9x squared plus, you have two variables here, so just use that. You're going to have your 12xy and then plus your 30xy. Again, the two variables there, you're just combining like terms. 12xy plus 30xy, that's still 42xy. You haven't done anything illegal. then plus 40y squared. Again, I'm just going to factor it using grouping. From this first guy over here, you've got 9 and you've got 12. So that means you can pull out a 3. Then you've got x squared and x. That means I can pull out an x. So the 3x comes out, and inside you would have 3x and then plus 4y. From this guy over here, it looks like I can pull out a 10, and then I have y and y squared, so I could pull out a y. So this would be inside 3x plus, again, 4y. So once again, we have this common binomial factor of 3x plus 4y. So let me go ahead and put equals here. I'll scroll down a little bit. All right, so let's pull this out. We'll have 3x plus 4y. And then that quantity is multiplied by the quantity. We'll have 3x plus 10y. So let's go ahead and get rid of this. So we have the quantity 3x plus 4y times the quantity 3x plus 10y. So we're looking for this guy right here. All right, let's look at question 4. So again, we're factoring each using the AC method. We have 6x cubed minus 5x squared y, and then minus 21, we have y squared x. All right, so immediately when you see something like this in this section where you have something that's cubed, you know you have to pull something out. That's just a given. So if you notice here, you have for the numbers 6 and then 5. 5 is a prime number. 6 is 2 times 3. So forget about that. Number-wise, you're not pulling anything out. But variable-wise, you have x cubed, x squared, and x. So that means I can pull out an x. That just sits out there, and you don't worry about it again. You just keep copying it. You don't have to think about it. So inside, I'll have 6x squared minus you'll have 5xy minus your 21y squared. So now the inside here looks like something we know how to deal with. So if you get scared when you see stuff like that, just know that there's just additional factoring you need to do. So what is AC here? What is 6 times negative 21? That's going to be negative. 6 times 20 is 120. And then 6 times 1 is 6. So 120 plus 6 would be 126. So negative 126 is what our product would be. The sum would be negative 5. So again, I always work with positives. If this is negative right here, I'm going to be subtracting. Now, in the interest of time, you already know how to go through here and brute force this. In other words, start with 1 times 126, do the subtraction, keep moving through the factors. At this point, I'm just going to give them to you. Basically, you would find that you have 9 and 14. When you get to that, 14 minus 9 would give you 5. And of course, you want the larger in terms of absolute value to be negative. So the two integers you need would be negative 14 and positive 5. So let's get rid of this. I think we can just remember that. So let me put x here. Inside, I'll have 6x squared. I'll put minus 14xy, then plus 9xy, then minus 21y squared. Okay. So from here, again, I'm just factoring using grouping. Keep my x out in front. From the first group, I'm going to pull out a 2x. Inside, I would have 3x and then minus 7y. From the second group, I'm going to pull out a 3y. That would give me 3x minus 7y. Close that down there. You have your common binomial factor of 3x minus 7y. And so let's grab this real quick. I'll pull this out. The x stays out in front. You'll have your quantity 3x minus 7y, and then times your quantity 2x plus 3y. Okay, let's look for our answer. So we want an x out in front, so that's only here or here. Then we want times the quantity 3x minus 7y, so only here. Then times the quantity 2x plus 3y, so this is what we're looking for right there. All right, let's look at question 5, our final question here. Again, we want to factor each using the AC method. So we have 4x squared y minus 32xy squared plus 63y cubed. Again, can I pull anything out? Number-wise, this is a 4. 32 is divisible by 4, so it looks good. But then 63 is 7 times 9, or 7 times 3 times 3 if you want to get specific. So we can't really pull anything out number-wise. But variable-wise, if we look, we have an x here and here, but not here. But we have a y here, here, and here, so I can pull out a y. Smallest exponent is a 1, so I'm just going to pull out that y. So you'd have 4x squared minus 32xy, and then plus 63y squared. Okay, so thinking about this now, I'm just dealing with what's on the inside. What is AC? What is 4 times 63? Well, 4 times 60 is 240. 4 times 3 is 12. 240 plus 12 is 252. So 252. And again, this is positive, so I'm going to be summing the integers that I'm working with. And I want a sum of negative 32 in the end. So let's think about this. Do I want to go with 1 and 252? No, you can skip those things. Using my divisibility rules, I know this guy is divisible by 4, so I would probably start there and just work my way down. I'm just going to give you the integers again. When you get to 14 and 18, you're going to see that 14 plus 18 is 32. And again, because you want a negative 32, you just want negative 14 and negative 18. Let me get rid of this. And let's write this out. I'll change my color here. So y, and then inside I'll have 4x squared minus 18xy, and then minus, we'll go 14xy, and then plus 63y squared. Okay, let's go ahead and put equals here. From the first group, I can pull out a 2x. Inside I'll have 2x minus, you'll have 9y. From the second group, I want you to notice that this is minus and this is plus, but here this is plus and this is minus. So you got to pull out a minus or a negative here to make the signs match. And then I want to pull out a 7y. Inside that's going to give me a 2x, and then it's going to be minus, this would be 9y. Let me close that down. Let me actually scooch this over a little bit so everything fits. Let me put my equals there. And then here, let me go ahead and put my y out in front. I'm going to factor out, again, this common binomial factor of 2x minus 9y. So that's coming right here. And then inside, I'll have this 2x minus 7y. That's pretty much it. So let me erase everything. Now for solutions, I want one with a y out in front. So that's here and here. And then times the quantity 2x minus 9y. So only here. Then times the quantity 2x minus 7y. So this is the answer we want. All right, let's look at our quiz. So for the first question, we're asked to factor each using reverse FOIL. We're going to be looking at 5x squared. And then this is plus the 39x. And then minus 54. Okay. Is there anything I can pull out? In other words, is the GCF not 1? Here you have a 5, which is a prime number. And then you have a 39, which is 13 times 3. So you can already stop. Nothing you can pull out. So what I want to do is go ahead and set up some parentheses here. And because my leading coefficient is a 5, which is a prime number, this is the easier scenario. I have less stuff that I actually have to check. I'm going to put a 5x here and an x here because 5x squared is only going to come from 5x times x. Now here's where it gets tricky. Let me scroll down and get some room. We have this guy right here, this 54, which is actually a negative 54. So again, if you have a negative in the end, it comes from this guy times this guy. So a negative comes from a positive times a negative. So I know when I do my O and my I steps in FOIL, that means that I'm going to have 1 plus and 1 minus. So I want to do subtraction here when I'm working out my integers. Okay, so I'm going to list the factors of 54. I'm going to work with everything being positive. And if I get something that subtracts to 39, then basically I'm good to go. I just have to play with the signs. So let me start with 1 and 54. It's going to be 2 and 27. You would have 3 and 18. And then lastly, you would have 6 and 9. So again, when you get 1 in something, it usually does not work. So if I put a 54 here, it's obviously going to be too big because you'd have a 1 there. So you can just skip that one. You could reverse that and put a 54 here and a 1 here, but that's just still too big. So you can get rid of this one right away. Don't even worry about it. The 2 and 27, if I put a 27 here, again, it's too big. If I put the 27 here and the 2 here, let's do that real quick. So if I put a 27 here and a 2 here, the outer is going to be 10. The inner is going to be 27. So 27 minus 10 would be 17. That's too small. So you can get rid of this. That's not possible either. So now I come across 3 and 18. If I put a 3 here and an 18 here, remember I'm subtracting, so this would be 15 and this would be 18. So 18 minus 15 would be 3. So that is out, going in that order. I could put an 18 here and a 3 here, but 5 times 18 is 90, so that's just too big. So let's get rid of this. It's just not going to work. So we're left with 6 and 9. So I can put a 9 here and a 6 here. And if I go with my outer, I would have 45. My inner would be 6. Now 45 minus 6 would give you 39. So we found the right integers. And we have them in the right position, but we need to work out the signs. I know that one is positive and one is negative. If this guy right here is positive, that means the larger in terms of absolute value needs to be positive. So in other words, I want a plus here so that when I do my outer, 5x times 9 would be 45x. Then I want a minus here so that when I do my inner, negative 6 times x would be minus 6x. And then 45x minus 6x would give you that correct middle term of positive 39x. Okay, so let's erase everything and let's look at what we got. We have 5x minus 6, this quantity, times the quantity x plus 9. I want this guy right here. All right, let's look at the next question. This is number 2. Again, factoring each using reverse FOIL. So we've got 5x squared plus the 24x plus 27. Okay, let's scroll down a little bit. And let me put equals here. Can I pull anything out? Again, this is a 5. This is 24, which is 2 cubed, or 8, multiplied by 3. So no, I can't really get anything out. So let's go ahead and just put a 5x and then an x. Again, we're lucky because this is a prime number, so we only have to check this one. For 27, if you think about the factors of it, it's 1 and 27. And then you would also have 3 and 9, and that is it. So this one should go by pretty quickly. This is an ideal scenario for using reverse FOIL. So do I want to put 27 here and 1 here? No, it's too big. Because this is a plus here, we're going to be adding, and in fact, it's all addition, so we know that the sign here is plus and the sign here is plus. I don't really need to do anything for that. But this wouldn't work, and flipping it around wouldn't work either, because if you put a 27 here and a 1 here, you're going to end up adding 27 plus 5, and that's just still too big for 24. Let's get rid of this and this, so this is out. So we need 3 and 9. If I put a 9 here, it's too big. I'm trying to get to 24. So let me put the 9 here and the 3 here. Let me erase this. If I do my outer, 5x times 3 would be 15x. If I do my inner, 9 times x would be 9x. 15x plus 9x would give me the 24x. So this is what I'm looking for here. So let me get rid of this. So we are looking for the quantity 5x plus 9 times the quantity x plus 3. So that guy right there. All right, let's look at question number 3 now. So again, we're just going to factor each using reverse FOIL. We're going to have 36x squared, then minus 188x, and then plus 40. Let me scroll down here. We'll come back up to the answers in a moment. So if I look at the numbers, I have 36, which I know is 4, or 2 times 2, multiplied by 9, which is 3 times 3. I have 188. I don't work with that very often, but if you look at the final 2 digits of the number, you have 88, which I know is divisible by 4, and 40 is obviously divisible by 4. So it looks like I can pull out a 4 here, and we'll look inside after we do this. We'll see if there's anything else we can pull out, but I think that's it. So we'd have 9x squared, then minus. If you divide 188 by 4, you get 47, so this would be 47x, and then plus, obviously 40 divided by 4 would be 10. So looking inside, there's nothing else I can pull out. So let's go through here and set this up. I have a 4 here. Now we're unlucky because this 9 here, this leading coefficient, is not a prime number. So we have more than one scenario to check. You could put a 9x here and an x here, because of course 9 is 9 times 1. And then you could also do 3x and 3x, because 3 times 3 would give you 9 as well. Okay, let me scroll down and get this all on the screen. So again, because this guy right here is positive, what I want to do is I want to add. Because what's going to end up happening is you have a negative times a negative. That's going to give you that guy right there. Okay, so you want to add the integers you're working with. So we have a 10, and the factors of 10, you really just have 1 and 10, or you have 2 and 5. So if I put a 10 here and a 1 here, does that work? No, it's too big. 9 times 10 is 90, and then this would be 1. So if you add those together, you get 91. So that's too big. If you flip this around and you put a 1 here and a 10 here, well, now it's going to be too small. You're going to have 9 plus 10, which is going to be 19, so that doesn't work. You can try this over here. Of course, you only have to try this once. Let's put a 10 here and a 1 here. You're going to have 3 times 10, which is 30, and then 1 times 3, which is 3. So if you had 30 plus 3, that would be 33. So 1 and 10 will not work. We can get rid of this. And then next up, we're looking at 2 and 5. So if I put a 2 here and a 5 here, does that work? 9 times 5 is 45. And then 45 plus this would be 2. That would give me 47. Looks like we found what we're looking for. Let me get rid of this. And of course, both the signs here need to be negative, because a negative plus a negative would give me a negative. In other words, the outer here would be negative 45x. The inner here would be minus 2x. So those would combine to give you the negative 47x that you're looking for. So let's erase everything. So what I have here is 4 times the quantity, 9x minus 2, and then times the quantity x minus 5. So I'm looking for this answer right here. All right, let's look at question number 4 now. So we want to factor each using reverse FOIL. We're looking at 50x cubed plus 235x squared plus 210x. Let me write that out. So 50x cubed, then plus this 235x squared plus 210x. So obviously you can pull an x out. What else can we pull out? These numbers look pretty big. So generally you can pull something out. This ends in a 0, this ends in a 5, and this ends in a 0. So everything's going to be divisible by 5. Let's pull out a 5x then. 50 divided by 5 would be 10. And then x cubed over x would be x squared. Then plus 235 divided by 5 is going to be 47. And then x squared over x is x. And then plus 210 divided by 5 is 42. And then the x is going to disappear there. Okay, close that down. So unfortunately, our leading coefficient here is a 10, and that's not a prime number. It's not that bad, though. 10 is 10 times 1 or 2 times 5, so it's not that many possibilities. So we'll go 5x here, I'll put a 10x here, and I'll put an x here, and then I'll put a 5x here, and I'll go ahead and put a 5x here, and then I'll put a 2x here. Okay, so let me move these down, actually. A little bit too tight. So I'm looking at everything being positive here, so we know we're going to have positives everywhere. And then when we think about 42, let me come down here real quick. I'll write 42. We have 1 and 42. We have 2 and 21. We have 3 and 14. Let me make the 3 better. And then it's not divisible by 4 or 5, but you can do 6 and 7. Okay, and that's it. Now, these are quite a few possibilities to check. But remember, when you think about something, think about the fact that inside here, what we're trying to factor, this 10x squared plus 47x plus 42, there is no common factor other than 1, right? So the GCF is 1. So when you're going through and filling these out, you can quickly eliminate things if you get something that has a common factor that's not 1. So in other words, I don't need to try to put a 42 here because there's a common factor of 2. Or I don't need to put a 42 there because there's a common factor of 2. So if you put a 42 on the outside, remember, because this is addition here, you're going to be adding. This is too big. 10 times 42 is 420. That's out of the question. And then the other guy, if I put a 42 here, just think about 42 times 2 is 84. It's just too big, right? You're adding, so get rid of this. That's gone. Then with 2 and 21, again, I don't need to check a 2 here or here, but I can put a 21 here and a 2 here. Looks like that's going to be too small. 10 times 2 is 20, and then you'd have 21. Well, 20 plus 21 is 41. That's too small. I need 47. So that doesn't work. Not going to put a 2 there, but I could put a 2 here and a 21 here. 5 times 21 is 105. That's way too big. You can stop there. Get rid of this. Now you have 3 and 14. Don't put a 14 here or here. You don't have to check that because you have a common factor of 2. So you could put a 3 here and a 14 here. But again, 10 times 14 is 140. That's just way too big. So let's get rid of that. And then I could put a 14 here and I could put a 3 here. Now 5 times 3 is 15 and 14 times 2 is 28. But 15 plus 28 is going to be 43. And that's just going to be too small. So that doesn't work. So you can get rid of 3 and 14. Okay, so now we're down to 6 and 7. I think we can remember 6 and 7. I can't put a 6 here or here. Okay, so I'm going to have to put a 7 here and a 6 here. Or if I was doing this, I would put a 6 here and a 7 here and check that. Well, from the first one, you'd have 10 times 6, which is 60. And then you'd have 7. So you can get rid of this as a possibility. That's not going to work out. Let's drag this up here so we can get it in line. Let me come back up so you can see everything again. So the final possibility is you have 5 times 7, which is 35, then plus 6 times 2, which is 12, so that does work. I want a plus here and a plus here. The outer here is 35x, and the inner here is going to be 12x. Of course, 35x plus 12x is 47x. So this is what we're looking for. Move this up here. So we have 5x multiplied by the quantity 2x plus 7 times the quantity 5x plus 6. So I want this guy right there. All right, let's look at question number 5. Again, we're just factoring using reverse FOIL. This problem is a bit tedious. Let's write out 30x to the 4th power plus 159. We'll go x cubed y, then minus 126x squared y squared. So the first thing is you would identify, you have x to the 4th power here. You're factoring trinomials, and generally speaking, you want x squared to be in the leading position. So that tells me I have some additional work to do. So what is the GCF here? Everything has an x, and the smallest exponent is a 2, so I know I can pull out an x squared. Number-wise, I see 30, 159, and 126. So this number right here is an odd number, so I know I can't pull out 2 or 4 or 6 or anything like that. But if you notice, 30 is divisible by 3, and then you can use your divisibility rules for 159 and 126 to determine that they're divisible by 3 as well. 1 plus 5 is 6, 6 plus 9 is 15. and then 1 plus 2 is 3, 3 plus 6 is 9. So I know I can pull out a 3 here, and this is going to end up being 3x squared on the outside. Okay, so if I divide everything by this 3x squared, I'm going to get 10x squared, and then plus 159 divided by 3 is going to be 53, and then you're pulling out the x squared, so this would be x and then y. Then minus 126 divided by 3 is going to be 42, and then x squared gets pulled out, and then you'd have the y squared. Okay, so let's come down here. First off, I know a lot of people freak out when there's two variables. It's not any more difficult to factor this. When you're setting this up, let me put my 3x squared out in front. When you're setting this up, all you have to do is put a y in the final position of each. Y times y is y squared. And then when you have your x here and your x here, the xy and the xy from the O and the I steps, that's going to combine to give you this xy in the middle. Okay, so don't worry about it. Now, when we think about 10, our leading coefficient, this is not a prime number, so we really have to check multiple things. We're going to have to put a 10 here and a 1 here, or just an x here, however you want to do that. Then you're also going to have to check a 5 and a 2, right? So 5x here, y here, and then 2x here and y here, because 5 times 2 would also give you 10. All right, so let's think about this. We have this minus here, so we know we're going to be thinking about subtraction. Because again, if you have a negative, that comes from this guy times this guy. So the last times the last, and it's got to be a positive times a negative. So you want to use subtraction here. Okay, so let's think about 42. I'll come back up in a minute. We want 42. This is 1 and 42. This is 2 and 21. You could also have 3 and 14. And then you could also have, it wouldn't be 4, it wouldn't be 5, it would be 6 and 7. Okay. So we would go through this. Again, if you're working this problem on your own, you can skip things like 1 and 42. I would always start in the middle because this is just too big. If I put a 42 here, think about 10 times 42, that's 420. It's just way too big. You're never going to get to 53 through subtraction with that, so you can get rid of that. You can't put a 42 here. It's not a possibility because, again, you'd have a common factor of 2. And this guy right here, this trinomial you're trying to factor, the 10x squared plus 53xy minus 42y squared, there's no common factor of 2 there. The GCF here is 1, so all the binomials should have a GCF of 1. So this is impossible. You can get rid of it. So you don't have to check a 42 there for the same reason. You'd have a common factor of 2. You could put a 42 here and a 1 here, but again, that's going to be too big. If you look at the inside, 42 times 2 would be 84. And on the outside, you'd have a 5. You're subtracting here. 84 minus 5 is 79. So that's too big. We're looking for 53. That doesn't work. Okay, so you can get rid of this right away. And I messed my y up. So let's get rid of that. Next, you'd have 2 and 21. So again, we could save some time. We don't need to put a 2 here, and we don't need to put a 2 here. So really, we would only have to check a 21 here and a 2 here. So this would give me 10 times 2 or 20. And this would be 21. 21 minus 20 is 1. So that doesn't work there at all. You can get rid of this. If I put a 21 here and a 2 here, well, the 5 times 21 is going to be 105. That's just way too big. This is going to be 4. 105 minus 4 is 101. That doesn't work. Again, you don't have to put a 2 there because you'd have a common factor, so you can get rid of this. So now I'm down to 3 and 14 or 6 and 7. So with 3 and 14, I don't need to check a 14 here or here because of a common factor of 2. But I could put a 3 here and a 14 here. But again, 10 times 14 is 140. It's just way too big. So get rid of that. And then I don't need to put a 14 here like I just said. You could put a 14 here and a 3 here. So this would be 15. And this would be 28. 28 minus 15 is going to give you 13. So that's too small. I'm looking for 53. So let's get rid of that. This is out. So now I'm just left with 6 and 7. Can't put a 6 here, but I could put a 6 here and put a 7 here. Does that work? 10 times 6 is 60. 7 times 1 is 7. So 60 minus 7 is 53. Okay. Looks like we found what we need, but we got to work out the signs. So what do I want? Let me scroll up so we can see everything again. What do I want? I want this guy right here in the middle to be a plus or positive. So that means the larger in terms of absolute value has to be positive. So that means this guy times this guy, I want a plus here. This would give me 60xy. Then I want this guy, which is going to be smaller in terms of absolute value, to be negative. You'd have negative 7y times x. That's going to be minus 7xy. Combined like terms, 60xy minus 7xy gives you the 53xy. So this is what I'm looking for right here. Let me erase everything. So we have this 3x squared multiplied by the quantity 10x minus 7y multiplied by the quantity x plus 6y. So not in the same order, but it's the same thing. Obviously, you can multiply in any order. So that's going to be our answer right there. All right, let's go ahead and look at our little quiz. So for the first question, we're asked to factor each, and we're going to be looking at 63x squared minus 343. So whenever you see a two-term polynomial and you're asked to factor, you should always be thinking the difference of squares. Let me scroll down a little bit. So 63 is not a perfect square, and neither is 343. So if you look at that and you're eyeballing this, you might think about, well, what can I pull out? Is there a GCF that's not 1? 63, you know, is 9 times 7. And 343, you may know this or you may not know this. You could put into the calculator, is it divisible by 9 or 3 or 7? It is going to be divisible by 7. So what you can do is pull a 7 out. So if I did that, inside I'm going to have 9x squared minus 343 divided by 7 is 49. So now you'll notice that 9 is a perfect square and so is 49. To make this crystal clear, let's write this as 3x being squared like this, and then minus 7 being squared like this. If you need to do this a few times to match things up with the formula, just take the extra step. It's not that big of a deal. It'll ensure you get the right answer. So let's scroll down a little bit more. I need more room here. And what do we do from here? Remember your pattern. Let me write the 7 here. I'm going to have 2 sets of parentheses. So whatever's in the first position being squared, you put that in the first position of each. So 3x goes there and there. You alternate your signs, so plus and minus, and this last guy that's being squared goes in the last position of each. So you're going to have 7 times the quantity 3x plus 7 times the quantity 3x minus 7. Let's erase all this. So what am I looking for? I want a 7 out in front, so here, here, and here. And then I want times the quantity 3x plus 7, and then times the quantity 3x minus 7. So I want this answer right here. All right, let's look at question number 2. Again, we're asked to factor each. So we have 2x squared minus 24x plus 72. So what do we notice? We have a trinomial here. And so we should be thinking a perfect square trinomial, which factors into a binomial squared. But the problem is, if you look at this 2, that's not a perfect square. But everything here is an even number, so it means I can pull a 2 out. So if I do that, what are we going to have? We'll have a 2 out in front. Inside we'll have x squared minus 12x, and then plus, this will be 36. Okay, so this is x being squared, and 36 is 6 squared. So now I do have perfect squares on the outside. But what about the middle part? Remember, that's got to be 2 times the first guy times the last guy. So let's see if this matches. We're going to go 2, and then here I'll just write this as x being squared like this for clarity. Then minus 2 times, the first guy is x times, let's go ahead and write this as 6 being squared like this for clarity. And I'll put a 6 there, and then we'll close this down. Does this match? 2 times 6 is 12, so we'd have negative 12x as that middle term. And I forgot to put a plus sign here, but basically this matches up. So all I want to do here is factor this into, let me take my 2 and put it out in front. You take the first guy, in this case it's x. This is a minus, so that sign comes with you. And then take the last guy right there, which is 6. This is quantity squared. So 2 times the quantity x minus 6 being squared. Okay, let's look for our answer. So we want 2 times the quantity x minus 6 being squared, this guy right here. All right, let's look at question number 3. So we're asked to factor each. And so we have 96x to the 6th power minus 54. So this one might be a little bit tricky because you might be looking at it thinking, okay, well, I know I can pull out something number-wise, but this is a 6 here. So what in the world are we doing? I didn't see any formulas with the 6 in it. So let's first factor out what we can. Between 96 and 54, what could I pull out? Well, they're both even numbers, so I know I could pull out a 2. If I pulled out a 2, this would be a 48, and this would be a 27. Now, I still don't have anything that matches what I need. This 27 here is 3 times 3 times 3. 48 is not a perfect square, and it's not a perfect cube, so I must have to pull something else out. Remember, if you sum the digits, you can see if it's divisible by 3. 2 plus 7 is 9, 4 plus 8 is 12, so it looks like I can pull out also a 3, which means I can pull out a 6. So let's go ahead and write this. We'll put equals here. I'll bring out a 6. Inside, 96 divided by 6 would be 16, which is a perfect square. Then x to the 6th power. Then minus 54 divided by 6 would be 9, which is also a perfect square. Okay, so now let me go ahead and rewrite this as 6 times the quantity. Now here's where I'm just going to use some rules of exponents. With the power to power rule, remember you multiply exponents, you keep your base the same. So if I wanted this exponent here to be a 2, all I would have to do is take this 6 and divide it by 2, and that would be 3. So in other words, I could write this as 4x cubed being squared. Okay, that's all I did. Because I wanted something here that was going to be squared, so I just took the 6 and I divided by 2 and I got the 3. That's all I did. Because when you reverse this, 4 is going to be squared, that's 16, but x cubed is being squared, x stays the same, and you're multiplying 3 times 2, which gives you 6. So if you take 6 and divide by 2, you're back to 3. Okay, so that's all I did. Then minus for 9, I'm going to write that as 3 being squared. Okay, so I think we got it at this point. Let me go ahead and write this as 6 right there. And we'll go ahead and set up the parentheses. So what will we do now? Take the first guy that's being squared, so the 4x cubed, put it in the first position of each, plus and then minus, different signs. And then take the last guy that's being squared and put it in the last position of each. So we end up with 6 times the quantity 4x cubed plus 3 times the quantity 4x cubed minus 3. All right, so looking for our answer, again, it's this one right here. So 6 times the quantity 4x cubed plus 3 times the quantity 4x cubed minus 3. Okay, let's look at question 4. Again, we're told to factor each. We have 125x being cubed, then plus 343y being cubed. Now, before we think about anything, 343, it's going to be a perfect cube. It's 7 times 7 times 7. 125 is 5 times 5 times 5. So you can't pull anything out number-wise. You can't pull anything out variable-wise. But each of these is going to be a perfect cube on its own. So I can do 5x cubed like this. And then plus, let me make this 3 better, at least somewhat readable. And then for 343, I'm going to write that as 7. And then let me put the y in there. And this whole thing is going to be cubed. Okay, so from here, we know we can use our formula. Let me go ahead and write that out real quick. Remember, if you have x cubed plus y cubed, this is going to factor into, you take the first guy and the last guy. And then you take the first guy squared. You take the multiplication of the first guy times the second guy. And then you lastly take the last guy, and you're going to square that. Now, in terms of the operations that go here, remember, it's same, different, positive. So same, I want a plus, different, I want a minus, and then positive. So all I have to do is plug in everywhere there's an x, now I want 5x, because that's the first guy being cubed. And everywhere there's a y, I want 7y, because that's the second guy being cubed. We can erase this and just do it from memory, or hopefully you can. Let's go ahead and get rid of that, and let's go ahead and go through it. So I'm going to put equals here. Again, I want this set up. I want the first guy, so 5x, and then the sign is the same, so plus. I want the last guy, so 7y. And then what do I want? Let me slide this down because I don't think it's going to fit. I want the first guy being squared. So 5 being squared is 25, and then x being squared is just x squared. Then I want a different sign. First sign's the same, second sign's different. Then I want the product of the first guy times the second guy. So what is 5 times 7? That's 35. What is x times y? That's just xy. And then the last sign is always a plus. We're going to take this last guy squared. 7 squared is 49. And then y being squared is just y squared. Let's close that down. We'll have the quantity 5x plus 7y times the quantity 25x squared minus 35xy plus 49y squared. All right, let's take a look at this. So we want 5x plus 7y. So either this one or this one. And then we want 25x squared minus 35xy plus 49y squared. So we want this answer right here. Okay, let's look at the last one. We're told to factor each, and this one's kind of messy. So we have 1,458 x cubed and then y cubed and then minus 432z cubed. Okay, so I might be looking at that and thinking, okay, what in the world do we have to pull out here? Well, for these big numbers, I would actually use a factor tree, and I would just do this off to the side and just use my calculator to help. I know they're even numbers, so at least I can take out a 2 in each case. So if I divide this by 2, I get 729. Let me move this 2 over a little bit. I can circle that because that's prime. Now, I happen to know that 729 is basically a perfect square. It's 27 times 27. But if you didn't know that, you could use some divisibility rules to keep cutting this down. But I'm going to put 27 times 27. So at this point, we really don't need to keep going with the factor tree. I know 27 is 3 cubed, and I basically have 3 cubed here and 3 cubed here. If you multiply those together, you keep 3 the same, add the exponents, 3 plus 3 is 6. So you would have, for this guy, 2, let me put to the first power, times 3 to the 6th power. Okay, for 432, it ends with a 32, so I know it's divisible by 4. Let me punch that into the calculator. So that's 108 times 4. This, of course, is 2 times 2. And 108 is 4 times 27. So I can stop here. 4 is 2 times 2. So I would have basically 2 squared times another 2 times another 2. So I would have 1, 2, 4 factors of 2. So 2 to the 4th power times 27 is 3 cubed. Okay, let's get rid of this. So Let me make that better. Let me move this over here. What am I going to be able to pull out? Look for what's common. You have a 2 and a 2. You have a 3 and a 3. What's the smallest exponent? So here it's a 1, and here it's a 3. So in other words, I want to pull out 2 multiplied by 3 cubed, or 2 times 27, which is 54. Okay, so that's what I'm going to be pulling out. Let's go ahead and get rid of this. And I know when you get large numbers, it's very tedious to do this, but it's just something you're going to get sometimes. So let's pull out our 54. And if we divide 1,458 by 54, we get 27. So this will be 27x cubed y cubed. So you see that'll be a perfect cube. Then minus, if you divide 432 by 54, you're going to get 8. So this will be 8z cubed. So again, another perfect cube there. Okay, so let's go ahead and set this up. We'll put 54 here. I'll write this as 3xy being cubed like this. And then minus, I'll put 2z being cubed like this. So it's crystal clear. So now we've done the hard part. We're just going to plug into that formula. Hopefully you know it at this time. Again, the first sign is the same. Second one is different. And then the last one is always a positive or a plus. Okay, so let's put the 54 out in front. And then I'm going to take the first guy, so 3xy. Again, same sign, so minus. Second guy, 2z. Close that down. First guy being squared, so 3 being squared is 9. And then x squared, y squared. Then the next sign is going to be different. So this is a minus, so it will be plus. And then basically you're going to have the multiplication of this guy times this guy. So 3 times 2 is 6. And then you'd have xyz. So xyz. And then the last sign is always a plus. You're going to take this guy in the last position and square it. 2 squared is 4. Z squared is just z squared. So we're basically good to go here. Let me erase everything. And let's come up here. So we want 54. So obviously this is the only one that has 54 on the outside. Well, let's keep going. So times the quantity 3xy minus 2z. So that matches. Then times the quantity 9x squared y squared plus 6xyz plus your 4z squared. So this is the answer we're looking for right there. All right, let's look at our quiz. For the first question, we're going to be looking at x to the 4th power. Then we'll have plus 15x squared. Then we're going to have plus 54. So this guy right here, you can factor it without using substitution. In fact, if I was looking at this problem on my own, I would. But just to get some practice with substitution, because we're going to need it later on in the course, let's go ahead and let something like u be equal to what? Well, this is quadratic in form. Remember, if you see something where you have this exponent here, that's double this exponent here. So you have a 2 and then a 4. So 2 times 2 is 4. Then it's quadratic in form. And you want to take the guy raised to the smaller power. And you want to set a variable like u or w or z or whatever you want to use equal to that. Then you want to make a little substitution. So let me put this as equal to. I'm going to slide this down. And I'm going to rewrite this so it's crystal clear. So I'm going to put x squared being squared. And then plus 15, let's put x squared here in parentheses, then plus 54. So everywhere there's an x squared, I'm just going to plug in a u. And let me actually move this down a little bit more. And let me scroll down so I don't run off of the screen. So this would actually be a u here, squared, plus it would be 15u plus 54. Again, you don't have to do this. We're just practicing this skill because we're going to need it later on. Let's move this down here. Let's put equals. I'm going to put a u in the first position of each because the leading coefficient here is 1. Just give me two integers whose sum is going to be 15 and whose product is 54. It jumps out to me 6 and 9. So plus 6 and plus 9. If it didn't jump out to you, you could just go through the factors of 54 till you get it. Okay, so let's erase this. I'm going to replace my u with x squared. So I'm going to replace this with x squared. And x squared. So I'm looking for the quantity x squared plus 6 times the quantity x squared plus 9. So I'm looking for this answer right here. All right, let's look at question number 2. So we're told to factor each, and we have 50x to the 8th power, then minus 15x to the 4th power minus 20. Let me erase this 8 here. And let me scroll down a little bit. Now, again, you can use a substitution, or you might not want to. You would realize that, forget about what the number of the coefficient is. If you had x to the 4th power here, and you had x to the 4th power here, well, when you do your first times your first, you're going to get your x to the 8th power. When you do your outer and your inner, you're going to have the x to the 4th power there that comes in the middle. So you don't really need to use substitution. Again, we're just doing this over and over and over again so that later on in the course, when we really need this, we're going to have this down, okay? So instead of x to the 4th power, let me erase this. I'm going to let u be equal to that x to the fourth power. And of course, I could write this as x to the fourth power being squared. So I'm just going to say, and let me get rid of the equal so it's not wrong. I'll put 50u squared because, again, u is going to stand for x to the fourth power. And I put let and didn't put a u there. So let me put let u be equal to x to the fourth power. And then minus, this will be 15u, and then minus 20. So I'm just going to factor this, and then we'll replace it in the end. And let me actually get rid of this. I think we can remember it, or we can actually put it off to the side. So we'll put u be equal to x to the fourth power. Okay, so from here, let me put equals. I'm going to pull out a 5, and inside I'd have 10u squared minus, if I pulled out a 5 from that, I'd have 3u, and then minus, this would be 4. Pretty easy to factor this. I'm just going to use reverse FOIL. You can use the AC method if you want. It's really up to you. So I'm going to put a 5 out in front. You're going to have two scenarios with 10. You'd either have 10 and 1 or 2 and 5. So let's put 10 and 1, and let's put 2 and 5. Let's put u and u, and then u and u. So for 4, it's what? It's 1 times 4 or 2 times 2. Now, can I possibly go with 2 times 2? No. Why? Because if I put a 2 here and a 2 here, this has a common factor of 2. There's no common factor of 2 here. If I put a 2 here and a 2 here, this has a common factor of 2, and this doesn't have a common factor of 2. So 2 and 2 is not possible. It has to be 4 and 1. Can't put a 4 here, but I could put a 4 here and a 1 here. Too big. So get rid of this. It's gone immediately. Can't put a 4 there, but you could put a 4 here and a 1 here. Remember, you have a minus here, which is a negative. So that means I want to subtract. So the outer here is going to be 8, and the inner is 5. 8 minus 5 is 3, so yeah, I can make that work. I want my larger guy here in terms of absolute value to be negative. So this would be negative 8u. This guy would be positive, the smaller in terms of absolute value, so 5u. Negative 8u plus 5u would be negative 3u. So this is exactly what we want. Let's get rid of all of this. And again, anywhere you see a u, you're just going to put x to the fourth power in there. Okay, I'm looking for 5 out in front. So only here and here. Then times the quantity 2x to the fourth power plus 1. So it looks like this guy. And then times the quantity 5x to the fourth power minus 4. So this is what I'm looking for right there. All right, for question 3, again, we're told to factor. So we have 18x to the sixth power minus 200. So again, whenever I see a binomial or a two-term polynomial and I'm asked to factor, I'm thinking, is this the difference of squares or is this the difference of cubes? First and foremost, if you look at 18, it's not a perfect square and it's not a perfect cube. But I noticed that 18 and 200 are each even numbers, so I can pull out a 2. So let's just start with that. If I pulled out a 2, you would have 9x to the sixth power minus, this would be 100. Now 9 is a perfect square, it's 3 times 3. 100 is a perfect square, it's 10 times 10. So it looks like what I'm meant to do is figure out that this is the difference of squares. But I have this 6 here. Now, how can I make this squared? Remember, let me roll down here a little bit and put this here. I'm going to put 2. And then I'm going to put something here. I know it's a 3 and then an x to something. Let me leave some space. And I want a 2 here. Then minus, I'm going to put a 10 here. This will be squared. How can I get the missing exponent here? Remember, power to power rule tells me that this times this would give me 6, right? So whatever this is times 2 gives me 6. So 6 divided by 2 would give me 3. So that's what's missing. So I want a 3 there, right? X cubed squared is x stays the same. 3 times 2 is 6. So 3x cubed being squared would give me this 9x to the sixth power back. All right, now you can use a substitution here if you want. You can basically say that this whole 3x cubed is u. And you could set this up and say, okay, well, we're going to let u be equal to 3x cubed. And then you could go through and use your difference of squares formula. You're going to have to substitute twice. I think it's kind of unnecessary with this problem, so I'm just going to skip it. If you want to solve it that way, it's really up to you. You're going to get the same answer. It's just a lot more work. So let me come down here. I'm just going to use my formula. So with the difference of squares formula, the first guy being squared goes in the first position of each. So let me throw that in there. Then you have alternating signs, so plus and minus. The last guy being squared goes in the last position of each. Now again, if you had used u, you'd have a u here and a u here, and then you'd have to substitute again to get back to this answer, right? So you'd be plugging in a 3x cubed here and a 3x cubed here. Okay, let me erase everything. All right, so I'm looking for a 2 out in front, and then I want 3x cubed plus 10, and then 3x cubed minus 10. So it looks like I want this guy right here. 2 times the quantity 3x cubed plus 10 times the quantity 3x cubed minus 10. All right, let's look at problem number 4. So now we have x squared times the quantity x plus y, and then plus 4xy times the quantity x plus y. Let me slide this down. This is going to be a lot to fit on the screen. Then plus you have 3y squared times the quantity x plus y. Let me scroll down here. Now, we know from factoring by grouping that I can take out a common binomial factor. So again, I don't have to use substitution. I can just immediately write x plus y out in front of a set of parentheses, and I would have x squared plus 4xy plus 3y squared. But again, we want to practice this. So what I could do is I could let something like u, or let's use w, be equal to this quantity x plus y, and then I could just replace it here, right? So I could put this like this, or if you wanted to be more complete, you could put a w here and here and here, just pull it out. It's really up to you how you practice this. It's just something you need to know for later on. Okay, so now I have this w, so I'm going to forget about it. Let me put this as equal to here. I'm going to put the w out here, and then I'm just going to factor this into the product of two binomials. Notice that you have this y squared at the end and this single y here. So you want a y here and a y here. This is a coefficient of 1. I want an x here and an x here. I just need to work out the coefficients. Give me two integers whose sum is 4 and whose product is 3. Well, 3 is only 1 times 3, and everything's addition here, so I'll just put plus 3 and plus 1. So your outer here is xy, your inner here is 3xy, so that gives you your 4xy, 3y times y would be 3y squared, so that's good to go. So let me erase all of this. All you really have to do now is just swap the w back out for x plus y, so x plus y, like this. And let me erase all of this. And the way we're expected to write this, remember, if you have x plus 1y, this is x plus y. So if I had x plus y multiplied by x plus y, what is that? That is x plus y quantity squared. So you could write it this way. The other way is not incorrect. It's just a different way to write it. So x plus y quantity squared times the quantity x plus 3y. So I'm looking for the answer in this format. So x plus 3y, this quantity, times the quantity x plus y being squared. All right, let's look at the last one. So we're told to factor each. We have 3 times the quantity x plus y being squared, minus 7 times the quantity x plus y, and then minus 20. So again, this is quadratic in form. You have something raised to the second power and then something raised to the first power. So without even thinking about it, you could just put u in. So usually when I do this, I'll just go, okay, what is 3u squared minus 7u minus 20, knowing that I'm basically going to let u be equal to this x plus y, right? So this guy right here. So I'm going to erase this. I hope you can remember that. If not, I'm going to write it back on the screen in a moment, just so I have enough room to work. Basically, I just want to factor this real quick. What is that going to give me? So 3 is a prime number, so it's only going to be 3u times u. And then for 20, you have a few different possibilities. You have 1 and 20, but that's just going to be too big. If you put a 20 here, forget about it. Even if you put a 20 here, then it's just still too big, so forget about that. Then you have 2 and 10. If I put a 10 here, it's too big, because the first part's going to be 30. If I put a 10 here and a 2 here, remember, you're subtracting. So you'd have 3 times 2, which is 6, and then 10. So that would be 4, right? 10 minus 6 is 4, so that's not going to work. So let's get rid of this. So next you'd have 4 and 5. So let's try that out. If I put a 5 here and a 4 here, you'd have 15 minus 4, which is 11, so that does not work. Flip it around and put the 4 here and the 5 here. You're going to have 12 minus 5, which is 7. Okay, so what I want to do is make sure, since I want a negative 7, I'm going to put a minus here and a plus here. So this outer would be negative 12u. The inner would be positive 5u. Negative 12u plus 5u would give me the negative 7u there. So that is what I'm looking for. And again, when I started this problem, I said that I'm going to let u be equal to this x plus y. So this right here and this right here, I've got to plug in an x plus y. You've got to be extremely careful if you have a coefficient on that, because 3 is multiplying the quantity x plus y. So in other words, it has to multiply the x and the y. So you want to wrap that in parentheses. So I'm going to go 3, and let me put parentheses here, times the quantity. This is going to be x plus y. Okay, I'm just plugging in for the u there, the x plus y. And then plus that 5 there, close that down. And then here, it's really not so important. Let's just put in the x plus y. You could put parentheses around it, but you'd end up dropping it. It really doesn't make any difference. And then minus 4 there. Let's get rid of this. And you could put equals here if you wanted to. And all I'm going to do here is just distribute the 3. So this is going to give me 3x plus 3y. then plus 5. I really can't simplify that any further. And over here, it's x plus y minus 4. Let's get rid of everything. Let's come up here. So let's look through these choices. So it looks like it's going to be this guy right here. It's not in the same order, but the quantity x plus y minus 4, so this guy right here, then times the quantity 3x plus 3y plus 5, so this guy right here. So this is the answer we're looking for. All right, let's look at our section quiz. For the first question, we're asked to factor out the GCF, and we're given this 13x cubed, and then minus this 26x squared, and then plus 39x. So I think this one is really not that bad. If you look for the greatest common factor here, you have 13, you have 26, and you have 39. So hopefully you know that each one of these guys is divisible by 13. 13 is a prime number, 26 is 13 times 2, and 39 is 13 times 3. So first and foremost, I know I'm going to be able to pull a 13 out in terms of number-wise. Then when we look at the variable part, this has an x, this has an x, and this has an x. So now I can pull an x out, but I'm looking for the smallest exponent that occurs. So this is to the first power, this is to the second power, and this is to the third power. Okay, so what I want is to the first power. So let me put 13x here. And then to get these spots on the inside, remember, you're just going to take each term and divide it by this GCF. So what I'm going to do here is say 13x cubed divided by 13x. 13 over 13 is 1. X cubed over x is x squared. And then I'll put my minus here. 26 divided by 13 is 2. X squared over x is x. And then plus 39 divided by 13 is 3. X over x is 1. So I end up with 13x times the quantity x squared minus 2x plus 3. And let's see which one is our answer. So we want 13x out in front. So that's obviously going to be this one. Then times the quantity x squared minus 2x plus 3. So this is what we're looking for. All right, so look at question number 2. Again, we're just asked to factor out the GCF. So we have this 6x squared y cubed, and then plus this 18x squared y to the fourth power. Lastly, plus 27x y to the fifth power. Let me scroll down a little bit. Again, we'll just come back up and select the answer when we're done. So number-wise, what do you notice? You have a 6, an 18, and a 27. Now, not everything is divisible by 6 because 27 is going to be 3 cubed, right? So this is basically 3 times 3 times 3. 18 we know is 3 times 3, which is 9, then times 2. And 6 we know is going to be 3 times 2. So what's common to everything is just going to be one factor of 3. Okay, so let's pull that out number-wise. Let me erase all this highlighting here. And I erased my 7. Didn't mean to do that. So let's put a 3 out in front. And then variable-wise, does everything have an x? Yes, yes, yes. The smallest exponent is 1, so we're pulling out a 3x. And then variable-wise, does everything have a y? Yes, yes, and yes. The smallest exponent is a 3, so we're actually pulling out a 3xy cubed. Okay, so inside the parentheses, you already know the deal. We're going to take this term and divide it by this GCF, and that's how we get the positions inside. So 6 divided by 3 is 2. X squared over x is x. And then y cubed over y cubed is 1. So then plus 18 over 3 is 6. X squared over x is x. Y to the fourth power over y cubed is y. And then plus 27 over 3 is 9. X over x is 1. Y to the fifth power over y cubed is y squared. And let's come up here and look through our answers. So we want 3xy cubed. Then times the quantity 2x plus 6xy plus 9y squared. So we're looking for this guy right here. Again, in some classes, they may make you rewrite this into their version of standard form, whatever that is. For this class, we're just going to leave that answer as is. Okay, let's look at question number 3. So we want to factor each using grouping. So let's go ahead and take this as 56. This is x cubed, and then y cubed, and then minus 105 x squared y squared. And then minus 70x cubed y squared, and then plus 84x squared y cubed. So let me actually scooch this down just a little bit so we can fit it on the screen. Let me scroll down a little bit. We'll come back up in a little while. So the first thing you want to do for any factoring problem is figure out, can I pull something out before I start? In other words, is the GCF not 1? Well, here you have 56. I'm just going to do a rough estimate. This is 7 times 8. I know 8 can be further broken down, but let's forget about that for right now. 105, I know it ends in 5, so it's divisible by 5. It would be 21 times 5. So 21 times 5. Now remember, 21 is 7 times 3. So I'm going to write this as 7 times 3. Okay. For 70, I know that's 7 times 10. Again, I'm not breaking this all the way down. I don't need to. For 84, if you notice so far, everything has a 7. So just check that. 84 divided by 7, if you did that on a calculator, would be 12. Okay, so what do I notice? Again, everything has a 7 in common. But then other than that, it doesn't. So if you look at this one, I wrote this 3 terribly. If you look at this one, this is 3 times 5 here. This 8 here is 2 cubed, so I know I can't pull anything else out. So let me go ahead and just pull out a 7. Or actually, let me keep those things in there. Might make it a little bit easier. So I'm going to put a 7 way down here. And then inside, I'm going to write an 8. I'm going to write a 15. I'm going to write a 10. And I'm going to write a 12. And we'll fix this up in a minute. So let me get rid of all of this. And then variable-wise, what can I pull out? I have an x, I have an x, I have an x, and I have an x. The smallest exponent is a 2, so I know I can pull out x squared there. And then I have a y, a y, a y, and a y. The smallest exponent is a 2, so I know I can pull out a y squared. So inside, what am I going to have? All I have to do is figure out the variables because I've already pulled out the number part. So for the variables, x cubed, y cubed over x squared, y squared would be xy. And then I'm going to have a minus here. And then this is going to disappear because it's basically going to be the same thing over itself. This guy here, let me tighten this down and put a minus. This guy here, you would have an x left. The y squared would go away. And then let me put a plus here. The x squared would go away and you would have a y. Okay, so now I just have to factor what's inside. This 7x squared y squared, this GCF that I pulled out, you can forget it exists, right? So you just keep copying it, but don't even worry about it. So we're going to put 7x squared y squared. And then let me change colors here. On the inside, I have 8xy, minus 15, minus 10x, and then plus 12y. Now, in its current setting, meaning if I took the first two as a group and the last two as a group, you're not going to be able to factor this using grouping. And the reason you can tell right away is that if you look at the first two, in the first guy I have an xy, in the second one I'll have a variable at all. And this guy I have an x, and this guy I have a y. So obviously, variable-wise, without even looking at the numbers, it's not going to work. So what I want to do is actually put these two next to each other so that I can pull out a y, and I'll have an x and then no variable. And then I want to put these two next to each other, and I want the negative 10x to be first, so I have an x and then no variable. Okay, so let's go ahead and do that. So we're going to have 7x squared y squared. Then inside, let's just go ahead and say we have 8xy, and then plus 12y. And then here, I'm going to write minus 10x first, and then minus 15. All right, let's put equals here. And now we can just factor using grouping. So again, I'm just going to keep copying the 7x squared y squared. From the first group, I can pull out a 4y. And so inside, I would have what? I would have 2x and then plus 3. And then from the second group, I need to pull out this negative because these two terms are positive. So I'm going to pull out a negative 5. Inside, I'm going to have 2x and then plus 3. Close that down. And now we can pull out this common binomial factor, this 2x plus 3. So I'm going to have 7x squared y squared times the quantity. You'll have 2x plus 3. Then times the quantity. What's left? You have the 4y. And then you have that negative 5, so minus 5 there. And this is my factorization. So let me erase everything. All right, let's go ahead and look for our answer now. So we want 7x squared y squared times the quantity 2x plus 3 times the quantity 4y minus 5. So this one's in a bit of a different order, but that doesn't matter because, again, you can multiply in any order. So that's going to be our solution right there. Okay, let's look at question 4. So again, we're told to factor each using grouping. So we have 12x to the 5th power y plus 126x to the 5th power, then plus 42. This is going to be x to the 6th power. And then looks like we have plus 36x to the 4th power y. So let me actually slide this over a little bit so it fits on the screen and drop myself down. And the first thing you always want to do again is think about, is there something I could pull out other than 1? Is the GCF not 1, in other words? So I see 36. I know that's 6 times 6. Again, you can break this down further, but I'm just eyeballing this because this guy is 6 times 7. So it looks like I can pull out a 6. This guy is going to be 6 times 21. And then this guy right here is obviously 6 times 2. So I could pull out a 6 from everything. So let me put a 6 out in front. Variable-wise, I know that I could pull out what? Not everything has a y, but everything does have an x. And the smallest exponent is a 4. So I could pull out 6x to the 4th power. So inside, what's left? I would have a 2, and then I would have basically xy. and then plus, from here, if I get rid of the 6, I have 21, and then x to the 5th power over x to the 4th power is x, and then plus, from here, if I pull out a 6, I have a 7, and then x to the 6th over x to the 4th would be x squared, and then plus, if I pulled out a 6, I'd have a 6, x to the 4th over x to the 4th is 1, and you just have the y. Okay, so let me put equals here, and I'm just going to get rid of this. I'm not going to be able to make this work, taking the first two as a group and the last two as a group. You can immediately tell because this is x squared and this is y, so I can't pull out anything. But here I have x, y, and x. I could pull out an x, so I'd be left with y and no variable. Here I'd have x squared and y, so that does not work. So I want to, again, rearrange this to where these guys are next to each other and these guys are next to each other. So let's go ahead and put 6x to the 4th power. And then in the first group, let's just put 2xy. And then plus, I'll go 6y. And then in the second group, you're going to put, I need to change the order. Let's put 7x squared and then plus 21x like this. And then it would work out to where the first two, you could pull out a y. And you can also pull out a 2, but I'm just thinking about the variables. In the second two, you could pull out an x. You can also pull out a 7, but again, I'm just thinking about the variables. So let's put equals here. So I have my 6x to the 4th power out in front. From the first group, I can pull out, again, a 2y. Inside, I'm going to be left with x plus 3. Then plus, from the second group, I can pull out a 7x, and I'll be left with x plus 3. So you see we have this common binomial factor of x plus 3. So we're going to pull that guy out. So we'll have this 6x to the 4th power times the quantity x plus 3. Then times the quantity, what's left? You have the 2y, and then plus this 7x. So close that down. Let me erase everything. So now we have 6x to the 4th power times the quantity x plus 3 times the quantity 2y plus 7x. So this is what we're looking for right there. Okay, for question 5, we're just told to factor each. And what we have is 2x squared plus 12x plus 16. So again, before I start any factoring problem, the first thing I want to do is say, is the GCF not equal to 1? In other words, can I pull something out? Well, here everything's even. You have 2, you have 12, and you have 16. So I know I can pull out a 2, and I would have x squared plus 6x plus 8 inside. So once I have it into that format, I know that I'm in the easier scenario because I'm just trying to factor this. I'm not worried about that 2 anymore that's on the outside. I just keep copying that. So to factor the trinomial on the inside, if it's 1x squared, in other words, this has an implied coefficient of 1, well, I could just put x here and x here, and only have to figure out this and this. I know both signs are plus, so I can put a plus here and a plus here. And I just need to think about two integers that give me a sum of 6 and give me a product of 8. Well, that's pretty easy. It's going to be 4 and 2. Right? So let's put 4 here and 2 here. And let's erase everything. So we're looking for 2 times the quantity x plus 4 times the quantity x plus 2. So again, it's in a different order, but that doesn't matter. That's what we want right there. All right, let's look at question number 6 now. So we're told to factor each. We have this 4x squared, and then minus 40xy, and then plus 84y squared. All right, so again, can I pull anything out? You notice that you have everything is even. So 4, 40, and 84, those are all even numbers. 4 and 40, you should know that they're both divisible by 4. You might not know that 84 is, but you could check that by dividing 84 by 4 in a calculator, and then basically you get 21, right? So you can pull a 4 out here, and you'd have x squared minus 10xy, and then plus 21y squared. Now, again, if you have a leading coefficient here of 1, this is the easier scenario. Just copy the 4, and let me set up these binomials here. I know I get an x here and an x here. Now, the fact that you have an extra variable here, this y squared and this y, that doesn't make this problem any more difficult. You're just going to put a y here and a y here, and you go about your business, right? I know I need two integers whose sum is negative 10 and whose product is positive 21. Remember, if you get a positive product, it can only come from a negative times a negative or a positive times a positive. So I know here both signs need to be negative because, again, a negative plus a negative is a negative, and a negative times a negative is a positive. So think about some factors of 21. We'll just work with the absolute value. We're trying to sum them and get to 10. And basically, I would do 1 and 21, that's 22. But then when you get to 3 and 7, that's 10. So again, I just want negatives in front of those to make the signs work. And this is my factorization. So let me erase everything. Okay, so what I want is 4 times the quantity, x minus 3y, times the quantity x minus 7y. So I want this guy right here. In a different order, but again, that doesn't matter because we're multiplying. Okay, let's look at question number 7 now. So we're told to factor each, and we have 36x squared minus 104x minus 160. So 36x squared minus 104x and then minus 160. Let me scroll down a little bit here. So can I pull anything out? It looks like I can pull out a 4. Remember your rule for divisibility by 4. If the final two digits of the number forms a number that's divisible by 4, then the original number is. So here 60 is divisible by 4. 4 is obviously divisible by 4, and 36 is divisible by 4. So I know I can pull that out. I would have 9x squared and then minus. This is going to be 26x and then minus. This would be 40. Now this guy right here does not have a leading coefficient of 1. It has a leading coefficient of 9. The problem with doing reverse FOIL here is I think there's probably too many possibilities. So the AC method might be a little bit faster. It just depends on your personal preference. I'm going to do the AC method for a few of them, and then I'll do a reverse FOIL for the next few. So let's just do the AC method. Remember, what you want to first do is multiply A, which is the coefficient for x squared, times C, which is your constant. Okay, in this case, it's 9 times negative 40. So A times C is negative 360. Now, basically what you want to do from here is find two integers such that the product is this negative 360 and the sum is this negative 26, or what we call B. Okay, once you find that, you can use that to rewrite your middle term, and you're going to expand this into a 4-term polynomial, and then you're going to use grouping. So it is a bit tedious, but I think in this particular case, it might be a little bit faster or easier to understand than reverse FOIL. So for factors of 360, there's quite a few. So you could use your divisibility rules. Again, I would start here because it's 360. I would start with 36 and 10. And I know that's the exact integers we need. But even if I didn't know that, because it's divisible by 10, I would start with that. And then I would start breaking things down. But these two integers happen to work for us. You just need to make this sign negative and this sign positive. Okay? So what I want to do, let me get rid of this, is rewrite this guy and put a 4 here. I'll have 9x squared, and then I'll put minus 36x, and then I'll put plus your 10x, and then minus 40. Again, all I'm doing here, if you're confused by this, I'm rewriting this middle term. If you combine like terms, this negative 36x plus 10x gives me the negative 26x. I'm just writing this in such a way that it allows me to have a 4-term polynomial where I can use my factoring by grouping. Okay, so let's come down here. So from the first group, I'm just going to pull out a 9x. That's going to give me x minus 4. From the second group, I'm going to pull out a 10, and that's going to give me x minus 4. So what can I pull out? I have this common binomial factor of x minus 4. So we have 4 times the quantity. Let's do x minus 4. Then times the quantity, you'll have 9x, and then plus your 10 right there. So let's erase everything. So again, I'm looking for 4 times the quantity x minus 4 times the quantity 9x plus 10. So I want this guy right here. Okay, let's look at question number 8. So we have 48x cubed plus 156 x squared y, then plus 126 x y squared. So can I pull anything out? Again, is everything an even number? Yes. So I know I can at least pull out a 2. Using your divisibility rules, again, if a number's digits sum to a number that's divisible by 3, then the number's divisible by 3. So 4 plus 8 is 12. 1 plus 5 is 6. 6 plus 6 is 12. And 1 plus 2 is 3. 3 plus 6 is 9. So all the numbers here are divisible by 3. And so if a number is divisible by both 2 and 3, we know it's divisible by 6. So I'll be able to pull out a 6 here. And then for the variable part, I can pull out an x, and that's it, right? Because not everything has a y, and the smallest exponent on x is a 1. So if I pull out a 6x, I'm going to have 8x squared, then plus, what is 156 divided by 6? That would be 26, in case you need to do that on your calculator. X squared over x would be x, and then y would come along for the ride. Then plus, 126 divided by 6 would be 21. X over x is 1, so y squared would come along for the ride there. Okay. So we have everything. And again, if you pull stuff out and you're not sure, you can just recheck and see, okay, well now all the numbers are not even. 21 is 7 times 3. And you can just check 8, right? 8 is 2 cubed. So I know between 21 and 8, there's no common factor other than 1. So I know I've achieved pulling out my GCF. So from here, I'm basically good to go. And again, if I do my AC method here, because 8 is 8 times 1 or 4 times 2, and 21 is 7 times 3, or 21 times 1. I think maybe the AC method would be slower here, and probably reverse 4 would be faster, but let's use the AC method just to get some practice. So 8 times 21 is what? That's 168. So I need two integers whose product is this 168 and whose sum is this 26. So again, you can use your divisibility rules and go through everything. With this guy, I would probably start somewhere in the middle, so somewhere around 8 and 21, and see, because I'm only going to be working with these addition signs, I want to add them to see if I can get to 26. So 8 plus 21 is 29. That's a little bit too far away. So if I worked my way up, the next guy I would come to would be 12, and 168 divided by 12 would be 14. 14 plus 12 is 26, so that's what I want. So let's go ahead and rewrite this, and I would say 6x times this quantity 8x squared plus, you can put 14xy here first, or you could put 12xy here first. It works out the same. Then plus 12xy, and then plus 21y squared. Okay, close this down. And let's go ahead and put equals here. Let's put 6x here. From the first group, you can pull out a 2x. That would leave me with a 4x, and then plus a 7y. From the second group, it looks like I can pull out a 3y. That leaves me with 4x and then plus 7y. Okay, so again, I have my common binomial factor of 4x plus 7y. Let me go ahead and get that real quick. And then let me change colors here. I'll have my 6x out in front. I'm going to pull out this 4x plus 7y, so this quantity, and then times this other quantity, you'll have the 2x here. And then plus, you're going to have this 3y here. So let me get rid of everything. All right, so what are we looking for? We want 6x out in front, so it looks like that's only here. Then times the quantity, it lists 2x plus 3y here. Here it's on the other side, but that's okay. We're doing multiplication. Then times the quantity, 4x plus 7y, so that's here. So this is the answer we're looking for. 6x times the quantity, 2x plus 3y. Then times the quantity, 4x plus 7y. All right, let's take a look at question number 9. So we're told to factor each. Let me scroll down a little bit so we can fit this on the screen. We want 40x squared minus 76xy, and then minus 224y squared. All right, so can I pull anything out? Again, all the numbers are even, so I know I can pull out at least a 2. 40 I know is divisible by 4, and I know that 224 is because, again, you can look at the last two digits. 24 is divisible by 4, so 224 will be. But what about 76? Well, that's not something you work with often, but it's going to work out to where it's 4 times 19. So I know I can pull out a 4 here. And again, if you didn't know that, you could just punch into your calculator. What is 76 divided by 4? You get 19, so you know you can pull it out. So this would be 10x squared on the inside minus 19xy, and then minus 224 divided by 4. You do that on a calculator, you get 56, and then y squared. Okay, let's scroll down a little bit. Again, I think I'm just going to use the AC method because 56 does have quite a few possibilities. But let's go ahead and do 10 times 56, or actually 10 times negative 56. So AC here is negative 560. And so I need two integers that are going to sum to negative 19 and give me a product of negative 560. So you would want to go through these factors and you would want to subtract, right? Just use everything in terms of absolute value and then subtract. See if you can get 19. And then if you can, just play with the signs. Okay, that's all you have to do. So let's come down here. Let's think about 560. So again, because this number ends in a 0, I'm going to start with 56 and 10. If you subtract there, you get 46. That's pretty far away. So I'm going to bring this number up and bring this number down. It's not divisible by 11. It's not divisible by 12. It's not divisible by 13, but it is divisible by 14. You could do 40 and 14. But again, that's too far away. If I do the subtraction there, I'm going to be at 26, and I need to be at 19. So I'm going to bring this up and this down. Not divisible by 15, but it is divisible by 16, and that's what I want. So it's going to be 35 and 16. If you do the subtraction there, you're going to end up with 19, right? I want negative 19, so I want this one negative and this one positive. So again, just work with the absolute values. When you find your integers that work out, then just work with the signs. That's all you have to do. So I'm going to put the 4 out in front. I'll go 10x squared. Again, you can choose any of these in any order. It won't matter. I'll put negative 35xy first, and then plus 16xy second, and then minus 56y squared. Okay, so we're going to factor using grouping now. Let me go ahead and change colors here. So the 4 just stays out in front. From the first group, I can pull out a 5x. Inside, I'm going to have a 2x and then minus. If I pulled out a 5 there, I'd have a 7. The x comes out, so minus the 7y there is what I want. Then plus from this second one, it looks like I can pull out an 8y. and 8y. So inside you'd have your 2x and then minus your 7y. Close that down. You have your common binomial factor of 2x minus 7y. So let's go ahead and say we have 4 times the quantity 2x minus 7y. And then times the quantity you have 5x plus 8y. Okay, let me erase everything. All right, so I'm looking for 4 out in front, so only this one. Then times the quantity 2x minus 7y times the quantity 5x plus 8y. So I want this guy right here. Okay, let's look at question number 10. Again, we're told to factor each. We have this 5x squared minus 27x minus 18. So the idea here is to look for a GCF if it's not 1. In this case, you have 5, which is a prime number. 27 is 3 cubed, so you can already stop. Now for this one, because 5 is a prime number, let's go ahead and just use reverse FOIL. And I'll use reverse FOIL for the rest of these just to get some practice with that. But this one's a good candidate for that. 5 can only come from 5 times 1. So I'm going to put 5x here and x here. Now, considering the fact that this guy is negative here, that means that what? It means that I have a positive times a negative. Now, when I do my outer and inner, what I want to do is just think about the possible factors of 18, and I want to subtract them and see if I can get to negative 27. So in other words, I would start with 1 and 18. Is that going to work? So I could put an 18 here and a 1 here. The outer is too big. And then if I flip this around and I put an 18 here and a 1 here, this is now going to be too small. Remember, you're subtracting. So you would have 5 and you would have 18, just number-wise. 18 minus 5 is 13. There's no way to make that work. So we would move on. So now you have 2 and 9. So I could put a 9 here and a 2 here, but that's just too big, right? 5 times 9 is 45. 45 minus 2 is 43. So that doesn't work. You could put a 9 here and a 2 here, but that's too small. So you can get rid of 9 and 2. So what's next? You have 3 and 6. You could put a 6 here and a 3 here. 5 times 6 is 30. And then 3 times 1 is 3. 30 minus 3 is 27. So that works. You just got to play with the signs. I want this to be negative here. So basically, I want this guy to be negative because I need it to be larger in terms of absolute value. This would be negative 30x for my outer. And then this would be plus, so my inner would be plus 3x. So negative 30x plus 3x would give me the negative 27x there. So this is the factorization I'm looking for. So I want, you scroll up a little bit, I want the quantity 5x plus 3 times the quantity x minus 6. So I want this guy right here. All right, let's look at question number 11. So we're told to factor each. You scroll down a little bit. We have this 28x squared minus 84xy plus 63y squared. Okay, so let's think about this for a moment. Everything is not even. So this is even and this is even and this is odd. Okay, so that means I can't pull out a 2 or 4 or anything like that. Now 63, for right now, let me write as 7 times 9. And the reason I'm thinking about that is 28 I know is 7 times 4. So we would just need to check 84. Is 84 divisible by 7? And yes, it is. It would be 12 if you divided it by 7. And you could use the divisibility rule for 7 there, but it's probably just faster to use your calculator. So let's say this is 7 times 12 here. And then let's put equals here. I'm just going to pull out a 7 there and see what I get. So let me change colors. I'll have 7 out in front. Inside, I'll have 4x squared. And then minus, I'm going to go ahead and say 12xy. And then plus, I'll go ahead and say 9y squared. All right, so how are we going to factor this? Some of you are thinking AC method, others are thinking reverse FOIL, and others are thinking, hey, this right here can be written as 2x being squared. So the 2 and the x both being squared. This right here can be written as 3y, the 3 and the y being squared. So if I know that, I know I might have a perfect squared trinomial. So let me go ahead and say 7, and then inside of here, I'll put this as 2x being squared like this. I'll put a minus, and then I'll fill this out in a second. Let me put plus. This is 3y being cubed, or actually squared here in this case. And then what is this in the middle? This is supposed to be 2 times the first guy that's squared, so 2x, times the last guy that's squared, so 3y. Does this work out? Negative 2 times 2 is negative 4. Then this doesn't really look that clean, so let me put times 3 like this. And then that negative 4 times 3 would give me the negative 12, and then you have xy. So this matches the formula for a perfect square trinomial. And so we can just factor this into a binomial squared. So 7 times the quantity, you want the first guy that's squared, so the 2x. This sign comes along for the ride. And then the last guy squared, which is the 3y. Okay, so this is quantity squared. Let's get rid of this. Move this up here. So I'm looking for the 7 out in front, then times the quantity 2x minus 3y being squared. So this guy right here. Okay, let's look at question number 12. So we're told to factor each. We have 8x to the 6th power plus 125y to the 9th power. All right, so for something like this, when you see a two-term binomial, you're asked to factor, the first thing is if you have a minus sign, you're going to check for difference of squares and also the difference of cubes. But here you have a plus sign. There is no sum of squares formula. We don't work with that. So you're thinking immediately, okay, this must be the sum of cubes. So let me go ahead and think about, can I write this guy right here as something being cubed? So in other words, something here raised to the 3rd power. Then plus something here raised to the 3rd power. Well, yeah, I know number-wise that 8 is 2 cubed. Let me slide this down a little bit. I don't think I gave myself enough room. 8 is 2 cubed. So let me put 2 there. Let me put an x here and put a little blank there. Over here for 125, I know that's 5. Let me put a y here. And then let me put something there, right? So 2 cubed is 8, 5 cubed is 125. We got that worked out. How do I get the exponent that goes here and here? Well, basically, you just do a division, right? So 6 divided by 3 would give me 2, and 9 divided by 3 would give me 3. How did I know to do that? Because again, when you reverse this, you use your power-to-power rule. X stays the same and you multiply. 2 times 3 gives me 6. So if I need to reverse that, I would divide. 6 divided by 3 would give me 2, right? So 3 times 3 gives me 9. 9 divided by 3 gives me 3. So that's how I did that. Okay, so now from here, we can use our little formula. And maybe you have forgotten that, so let me write that real quick. If you have something like, let's say, a cubed plus b cubed, this factors into, the first sign is the same. Remember, so this is plus. You put a and b here. So whatever's being cubed, in this case it's a, in this case it's b. And then over here, you're going to have the first guy that was cubed squared, so a squared. And then this sign is different, right? So since this is a plus, it becomes a minus. Then you multiply the two together, so ab. And then the last sign is always plus. You're going to take this last guy here that was cubed, you're going to make it squared. Okay, so that's the formula. Again, just something you have to memorize. And if you want to copy that down real quick, you can. And I'm just going to erase this. So let's go ahead and get rid of that. And let's try to do this from memory. So for the first set of parentheses, remember, the sign is the same. So you're going to have a plus there. You take the first guy, that's going to be cubed. So in this case, that's the 2x squared. Let me slide this down a little bit. And then you take the second guy being cubed. So in this case, that's 5y cubed. So that's your first set of parentheses. Let me move this down. Then for the second set of parentheses, remember, you take the first guy that was cubed and you're going to square it. So 2 is squared, that's 4. X squared is squared. X stays the same. Multiply 2 times 2, that's 4. Then the second sign here is always different. So this is a minus because this is a plus. Okay, so now you're going to multiply these two guys together. So 2x squared times 5y cubed. 2 times 5 is 10. And then x squared y cubed. X squared y cubed. Let me make that 2 a little bit better. And let me slide this down a little bit more so I can fit it on the screen. And then lastly, I'm going to have a plus. This is always plus. Take this guy and square it. So the last guy that was cubed, you're going to square it. 5 squared is 25. And then y cubed squared. Y stays the same. 3 times 2 is 6. Okay, close that down. So let me copy this. Okay, so what we're looking for is the quantity 2x squared plus 5y cubed times the quantity 4x to the 4th power minus 10x squared y cubed plus 25y to the 6th power. So we want this answer right here. All right, let's look at question number 13. So we're asked to factor each, and we have 20 times the quantity 4 minus x being squared minus 3 times the quantity 4 minus x, and then minus 2. So this guy right here is a perfect candidate to use substitution. So what I would do is I would let something like u or w or whatever you want to use be equal to this 4 minus x. And then I would just substitute everywhere inside my problem. So here and also here. So let me go ahead and say that this is going to be 20u squared minus 3u minus 2. And I'll go ahead and use a reverse FOIL just to get some practice with that. So 20 does have a lot of possibilities. So let me scooch this out here. So you would have 1 and 20, but I'm going to avoid that. You would also have 2 and 10. I'm going to skip that. Those are just too far away. I'm going to start with 4 and 5. So let's do 4 and 5. And this might not work. I actually don't know in advance. I'm just trying them because if I look at this guy right here, it's pretty small. And if I look at this guy right here, it's pretty small. So I know I need something that's a little bit close together. Okay, so for -2, forget about that, and let's just think about +2. The factors, since it's a prime number, it's only going to be 1 and 2. So that means I can try a 2 here and a 1 here. Remember, I can't put a 2 here because I'd have a common factor of 2. That doesn't work. So if I look at 4 times 2, that's 8, and 5 times 1 is 5. Well, 8 minus 5 would be 3. Again, I want negative 3 there. So let's just make this negative. So you get negative 8u on the outside. Let's make this positive. So you get plus 5u on the inside. And that looks like that works out perfectly. All right, let's get rid of all this. So recall that we let u be equal to this 4 minus x. So what you have to actually do to solve this problem or to finish it, you need to plug in everywhere there's a u of 4 minus x. Now you have to be careful because you're doing some multiplication here. If you have 5 times this u, well, 5 is multiplying this 4 minus x, this quantity, the whole thing. The common mistake is just to multiply 5 times 4, and you just get 20, and then you have minus x. That doesn't work. You need 5 times 4, and then 5 times negative x. So to accomplish this, I'm going to wrap this in parentheses and say I have 4 times the quantity, 4 minus x, then plus 1. And then inside here, 5 times the quantity, 4 minus x, and then minus 2. You scroll down a little bit here. This would give me 4 times 4 is 16, so this would be 16. And then minus 4 times x is 4x, and then plus 1. Of course, you can combine like terms there. You would basically have 16 plus 1, which is 17. So let me write negative 4x, and then plus 17. From this guy, you would have 5 times 4, which is 20, and then minus 5 times x is 5x, and then minus 2. Well, 20 minus 2 would be 18, so you can go ahead and write 18 here, minus 5x like this. So let me erase everything, and let's look for our answer here. So if we look through the answers, we don't see anything that really matches this, but there's a little trick you need to use in order to get this answer right here. This is going to be the correct answer. You have 5x minus 18, this quantity multiplied by the quantity 4x minus 17. And you might be thinking, well, that doesn't match. This is going to be positive and this is negative. Here, this is negative and this is positive. Same is true for this. This is positive and negative. This is negative and positive. So how do we flip things? Remember, if you factor out a negative 1, you can change the sign of stuff inside. So in other words, if I put, let me actually do this in a longer format so no one gets confused. If I pulled a negative 1 out of the first guy here, in the inside I would have what? Positive 4x and then minus 17. Okay, then this guy would stay the same. And I'm just going to rewrite this. I'm going to put negative 5x plus 18. I'm just reordering it. That's completely legal. Now, could I also factor out a negative 1 from this? Sure, why not? I could say I have a negative 1 times a negative 1 now, and then times my 4x minus 17, and then times, since I pulled a negative 1 out from here, now I have 5x minus 18. So negative 1 times negative 1 is 1, so this ends up giving me what? Just 4x minus 17, this quantity, times the quantity 5x minus 18. So if you ever get something like that on a test or something, just stop and say, hey, can I pull out a negative 1 to make this match up? Can I pull out another negative 1? A lot of times that's all you need to do to make your answers match. And if we come back up here, again, we've already circled this answer. We want the quantity 5x minus 18 times the quantity 4x minus 17. All right, let's look at question number 14. So again, we're told to factor. We have 2 times the quantity 1 plus, looks like the square root of x, and this is quantity squared. Then minus 13 times the quantity 1 plus square root of x, and then plus 6. So if you see something like this where you have this same binomial here and here, and this is squared and this is to the first power, well, this is telling you want to use substitution. So let me let u be equal to this 1 plus square root of x. And basically what I'll do here is factor 2u squared, and then minus 13u, and then plus 6. This is really easy to do with reverse FOIL. 2 is a prime number, so you just need a 2u there and a u there. 6 is going to be 1 times 6 or 2 times 3, so not a lot to check. You can't put a 6 here, but you could put a 6 here and a 1 here. The outer would be 12, and the inner would be 1. Now, I'm adding here because this is a plus, so 12 plus 1 is 13. I just need to make this negative, so I want a minus here and a minus here, and that's my factorization that I'm looking for. Now, again, because I let u be equal to this 1 plus square root of x, I've got to plug back in. And again, I've got the same situation here. 2 is multiplying this u. So when I set this up, it's 2 times the quantity, 1 plus square root of x, and then minus 1. Close that down. Here, you don't have to worry about it because u is by itself. So you just plug in 1 plus square root of x, and then minus 6. Let's get rid of this. Let's come down a little bit. So basically, all I need to do is multiply it here. You'll have 2 times 1, which is 2, and then plus your 2 times square root of x, that's 2 times square root of x, and then minus 1. Well, 2 minus 1 is going to be 1, so let's close this down. Let's put a 1 here. And then over here, you just do 1 minus 6, which is negative 5. So you can put negative 5 plus square root of x. Let me make that a little bit better. Square root of x like that. Close that down. So let me copy this. So I'm looking for this answer right here. It looks a little bit different. You have the quantity square root of x minus 5. Here you have negative 5 plus square root of x. Of course, you can just flip that around. It doesn't matter. And then times the quantity, 2 times square root of x plus 1. Again, this one's just flipped around. 1 plus 2 times square root of x. You could flip this around. It wouldn't make any difference to your answer. So this is the guy we want right there. All right, let's take a look at our quiz now. So we're told to find the restricted values. And what we're given, we have this rational expression 3x minus 9. And this is over x minus 3. So when you're told to find the restricted values, you don't want to simplify anything. What you want to do is you want to just take whatever's in your denominator, as long as there's a variable in it, you want to set it equal to 0. You want to solve the resulting equation. So the solution or solutions that you get are going to make your denominator 0, which means you would have an undefined rational expression, right? You can't divide by 0. So what I would do here is just take this x minus 3, and I would just set it equal to 0. If I add 3 to both sides of the equation, I would get x is equal to 3. So essentially, I need to exclude 3 from the domain of this rational expression, or I would say that's the restricted value, because if I plugged in a 3 here for x, well, 3 minus 3 is 0, and obviously you can't divide by 0. Division by 0 is undefined. So the answer I'm going to want is this x is not equal to 3. Okay, let's look at question 2. Again, we're just told to find the restricted values. So we have x plus 12 over, we're going to have x squared minus 2x and then minus 48. Let me copy this. Let's paste this into a fresh sheet. Again, just take your denominator, your x squared minus 2x minus 48, set it equal to 0 and solve. Everything I'm giving you at this point is able to be solved using factoring. So we really don't have to get into the quadratic formula or anything like that. You can just factor the left side, and we're going to use the zero product property. So I'm going to put an x here and an x here. And basically, I want two integers whose sum is negative 2 and whose product is negative 48. So I'm thinking negative 8 and positive 6. So this would be negative 8x and positive 6x. So that would give me my negative 2x that I want. All right, so you take each factor with a variable, you set it equal to 0, and then you solve those equations. So here I would have x plus, let me make this better. So x plus 6 equals 0. Subtract 6 away from each side. You get x equals negative 6. And then over here, let me do x minus 8 equals 0. Add 8 to each side, you get x is equal to 8. So these two values, if you plug them in for x in the rational expression, your denominator would be 0, and so you need to exclude those. So I'm looking for x cannot be negative 6 and 8, so this guy right here. Let's look at question number 3. Again, just finding the restricted values. So we have x squared minus 10x plus 21. This is over. You have x squared plus 7x minus 30. So just take, again, the x squared plus 7x minus 30. Set that equal to 0. I don't even need to take the whole thing. I'm just going to take the denominator here. Let me cut this away, and let's paste this in here. Again, I'm just going to factor the left side here. So this is x and this is x. Two integers that give me a sum of 7 and have a product of negative 30. Well, I know that's going to be, let's say, positive 10 and then negative 3. The outer would be 10x, the inner would be negative 3x. So that would give me my 7x in the middle. Okay, so I'm just going to set this guy, this x minus 3 equal to 0, and this guy, this x plus 10 equal to 0, and then just solve. So I would have a plus 3 over here and a plus 3 over here. So add 3 to both sides of the equation. So this would be x is equal to positive 3. Over here, minus 10 and then minus 10. So subtract 10 away from each side. You get x is equal to negative 10. So x can't be 3 and x can't be negative 10. So again, looking for my answer, x can't be 3 and x can't be negative 10. All right, let's look at problem number 4. So again, find the restricted values. We're going to have this 2x squared plus 5 over, for the denominator, we have 21x cubed plus this 192x squared minus 180x. So again, I'm just going to take the denominator. You really don't need anything else here. You're just going to be setting that equal to 0. Let me come down here a little bit, and let me paste this in and get rid of this bar here. So I'm going to set this equal to 0. Now this one is a little bit tougher to factor. First, you have to think about, well, I have larger numbers here. Am I meant to pull something out? You see immediately that you could pull out an x, so I would just start with that. And then number-wise, I have 21, which is 7 times 3. I have 180. Forget about the fact that it's negative. I have 180, which is 60 times 3. What about 192? We don't work with that very often, but you can sum the digits. 1 plus 9 is 10. 10 plus 2 is 12. Since 12 is divisible by 3, 192 will be, and it turns out that it's going to be 64 times 3. So I can pull out a 3x here, and inside I would have 7x squared plus the 64x, and then minus, this would be 60. Okay, close that down and put this equal to 0. Now this is still tough to factor in the inside, and if you want to use reverse FOIL or if you want to use the AC method, it's kind of going to be up to you. This is one of those things where it does take a little bit of time. In the interest of the speed of the video, I'm just going to give you the integers you need. So I'm going to set this up in a reverse FOIL pattern. Since this 7 is a prime number, I'll put 7x here and x here. And again, some tricks. Remember, if this is a minus here, you work with everything in terms of the absolute value, and you're going to do the subtraction. So factors of positive 60, you have 1 and 60. You're going to have, let me put this over here, you would have 2 and 30. Then you would have 3 and 20. You would have 4 and 15. Then you'd have 5 and 12. And then for the last thing you would have, it would be 6 and 10. Now, what you're going to find is that you need 6 and 10. And basically, you want the 10 to go here and the 6 to go here. Right? 7 times 10 is 70, and 6 times 1 is 6. 70 minus 6 would give you the 64. So you would want this to be a plus and this to be a minus. And again, this is just something that you have to go through with trial and error, or you can do the AC method, whatever you want to do. All right, so now that we have the factors, we're going to set each one with a variable, which is going to be this one, and this one equal to 0. We're going to solve those three equations. So let me slide down a little bit. We'll have 3x and set that equal to 0. We'll have 7x minus 6, set that equal to 0. We'll have x plus 10 and set that equal to 0. Most of these you can just solve in your head. This is obviously 0. You divide both sides by 3. You get x equals 0. Here you add 6 to both sides. You can visibly cancel that if you want. You would have 7x is equal to 6. Divide both sides by 7. You get x equals 6/7. And then here I'm just going to subtract 10 away from each side. You get x equals negative 10. So x can't be 0, 6/7, or negative 10. So I'm looking for x can't be 0, 6/7, or negative 10. I want that guy right there. All right, let's look at the last one. So for question 5, again, find the restricted values. You have 70x cubed minus 80x squared plus 10x. This is going to be over. You have 50x cubed minus 30x squared minus 80x. Okay, so obviously I just want to take the denominator here, and let me just copy this, and let's just paste this in here. Get rid of that bar. Put this equal to 0. So I know I could pull out an x. Looks like I can also pull out a 10. Everything ends with a 0 there. So let's pull out a 10x. That would give me 5x squared minus 3x, then minus 8. Again, this is equal to 0 here. So you have 10x here. Let's go ahead and set this up out here. Scroll down a little bit. So I know 5x squared is going to come from 5x and x. And then for this guy, again, it's negative here. So I'm going through the factors of 8, and then I'm subtracting. Again, I'm trying to get to 3. Forget about the fact that it's negative 3 for right now. So you'd have 1 and 8, and you'd have 2 and 4. All right, so if we think about 1 and 8, if I put an 8 here, it's too big. If I put an 8 here and a 1 here, so this would be 8, and this would be 5. 8 minus 5 is 3. Again, you just got to make the signs work. I want this to be negative. So let's go ahead and say that this guy right here needs to be negative. So this needs to be a negative 8x. So put a minus there, and then put a plus here, so that this guy right here is going to be positive 5x. Negative 8x plus 5x gives you that negative 3x in the middle. Okay, so let's go ahead and erase this. And I'll say that we have 10x set equal to 0. So this guy right here. And then we'll say 5x minus 8 is equal to 0. That guy right there. And then x plus 1 is equal to 0. So 10x equals 0. Again, the solution is just 0, but you can divide both sides by 10 if you want, and say x equals 0. Here I'm going to add 8 to both sides. Let me go ahead and cancel this. So you get 5x is equal to 8. Scooch down a little bit. Divide both sides by 5. So divide both sides by 5. You get x is equal to 8/5. Here, subtract 1 away from each side. You get x equals negative 1. So x can't be 0, 8/5, or negative 1. So x can't be 0, 8/5, or negative 1. I want that guy right there. All right, let's take a look at our quiz. For the first question, we're asked to simplify each and state the restricted values. We're given 2x cubed plus 5x squared minus 7x over. we're going to have 7x squared minus 7. So let me scroll down. We'll come back up and get the answer in a minute. Remember, when you work with a rational expression, you always want to find your restricted values, or you could say your domain first. You do that because when you simplify, sometimes you get a broader domain or fewer restrictions, and you always want to carry your restrictions over from the original rational expression that you started with. So for this one, I would set 7x squared minus 7, this denominator, equal to 0, and I would solve the resulting equation. Because again, the solutions for this guy are going to tell me what values I can't plug in for x because they make the denominator 0. So let me scroll down a little bit. I'll come back up again in a minute. Well, we could factor this. We could take out a 7. You'd have x squared minus 1. This equals 0. Now remember, when you have x squared minus 1, this is the difference of squares. So you can factor this again and say this is x plus 1 times x minus 1. So these two quantities, set that equal to 0. So now to use something called the zero factor property or the zero product property, some people call it that, you take each factor with a variable, so the x plus 1 and the x minus 1, you set them equal to 0, and you solve those two resulting equations individually. So you could say x plus 1 equals 0, and then x minus 1 equals 0. You don't have to worry about the 7 there because it's just 7. You're not going to set 7 equal to 0. That doesn't make any sense. If you had something like 7x out there, then you would need to set that equal to 0, but that's not the case here. So here I would subtract 1 away. You get x equals negative 1. Add 1 to both sides. You get x equals to 1. Okay, so we get x equals negative 1 or positive 1. Those are our restricted values because, again, you plug that in for x, you're going to get a denominator of 0, which is undefined. Let's get rid of this. So I'm just going to state my restricted values here. X cannot be 1 or negative 1. Okay, so for simplifying, again, all you have to do is really just factor everything. So it just goes back to our last section on factoring, and then just canceling common factors. So in the denominator, we just factor that. It's 7 times the quantity x plus 1 times the quantity x minus 1. In the numerator, let me just use reverse FOIL. If you want to use factoring by grouping or the AC method, that's up to you. So I could pull out an x to start. Let me put that out here. And so that would give me, let me slide this down. I think people get confused if I do this in my head. That would give me 2x squared plus 5x minus 7. Let me wrap that in parentheses and put the x out in front. So I would want a 2x here and an x here. And then I'm looking for 7. Forget about the fact that it's a negative. When I think about 7, it's only 1 and 7. So I can put a 7 here and a 1 here. That would be 14 minus 1 would be 13. That does not work. You could put a 1 here and a 7 here. That would be 2 and 7. So I can make that work if I make this guy positive and this guy negative, right? Because the outer would be negative 2x, and the inner would be positive 7x. That will combine to give me my plus 5x that I need. Okay, so once you've factored everything, you're just going to cancel common factors. Remember, this guy right here, this is multiplying this guy right here. So these are two quantities or two factors, right? The x is a factor. The quantity 2x plus 7 is a factor. The quantity x minus 1 is a factor. So those are three factors. Down here you have 7 as a factor, you have the quantity x plus 1 as a factor, and you have the quantity x minus 1 as a factor. So we cancel common factors. So I'm going to cancel this quantity of x minus 1 with this quantity of x minus 1. That's gone. So all I have left is the x times the quantity 2x plus 7 over the 7 times the quantity x plus 1. Let me get rid of this. And let me get rid of this. Let me just do this, and then I'm going to keep this restriction from the original one. So x does not equal 1 or negative 1. Again, I can't say this enough. If you did the restricted values now, you'd have a broader domain. You would only find that x can't be negative 1. But again, if you work with the original rational expression, it couldn't be 1 as well. So you have to carry that restriction over. So let's get rid of this. So what am I looking for? Well, from the restrictions, I see it can only be this one or this one. And this one doesn't look anywhere close to what I have. So I'm going to go with this one. So x times the quantity 2x plus 7. And then over, you have 7 times the quantity x plus 1, restricted values of 1 and negative 1. So this is what I want. All right, let's look at question 2. So we have 5x cubed minus 5x squared minus 10x over, you have 8x squared plus 92x plus 180. Let's scroll down here. So again, the first thing is to figure out what are the restricted values. So set the denominator, 8x squared plus 92x plus 180 equal to 0. It seems like that's going to be a little bit hard to factor. I know I can pull out a 2 because everything's even. What about a 4? Well, 92 divided by 4 is 23, and 180 divided by 4 is 45. So let's pull out a 4. So inside I'm going to have 2x squared, and then plus, this will be 23x. And then plus 180 divided by 4 again is 45. Close it down, set that equal to 0. And then let's set this up like this. Again, you're welcome to use the AC method if you want to pause the video and try it like that. It's really up to you. I'm just going to keep using reverse FOIL. I think it's probably faster, especially when you have this guy, the 2 being a prime number. So let me set that up. Everything is plus here, so I know I'm going to have all positives. So thinking about 45, what jumps out at me is 9 and 5. If I put a 9 here and a 5 here, my outer is 18, my inner is 5. 18 plus 5 is 23. So I think this is what I'm looking for. You can check it if you want, but it looks like that works out. All right, let me get rid of this. So I'm going to set each factor with a variable equal to 0. Again, since 4 doesn't have a variable in it, you just don't worry about it. I only have to think about the 2x plus 5, set that equal to 0. And then the x plus 9, set that equal to 0. Over here, if I subtract 9 away from each side, this cancels, you get x equals negative 9. Over here, if I subtract 5 away from each side, you get 2x equals negative 5. Divide both sides by 2, you get x equals negative 5 halves. So these two values here, again, are the restricted values. If you plug them in for x in the original rational expression, what are you going to get? You're going to get 0 as a denominator, and division by 0 is undefined. So we're restricting negative 5 halves and negative 9. So let me put this as x is not equal to negative 5 halves and negative 9. Now, I want to factor the numerator. And it looks like I can pull out, let me just copy this real quick, 5x cubed minus 5x squared minus 10x. I'll come back up in a moment. So I can pull out a 5x. Inside, I'm going to have x squared minus x minus 2. That's pretty easy to factor. This would be 5x stays out in front. You would have an x here and here. I basically want a sum of negative 1 and a product of negative 2 for my two integers. And so I'm going to go ahead and say that's going to be negative 2 and positive 1. So I want a negative 2 and a positive 1. Okay, let me erase this. Come back up here. And let's see if we can cancel anything. It looks like we can't, actually. So that's not that big of a deal. Sometimes that happens. But I just want to put my restriction. So x is not equal to negative 5 halves and negative 9. Let's get rid of this. And just looking at everything, you see this last answer here. I guess you could call it D or position 4, whatever you want to say. Essentially, you have 5x times the quantity x minus 2 times the quantity x plus 1. That's your numerator. In the denominator, you have 4 times the quantity x plus 9, then times the quantity 2x plus 5. So these are just in a different order, which is fine. And then your restrictions, you have x can't be negative 9 and negative 5 halves. So this is the guy we want. All right, let's look at question 3. So let's take a look at 3x squared minus 8x minus 60 over, we have 9x cubed minus 69x squared plus 90x. Let me do that there. All right, so again, same thing. We take the denominator, the 9x cubed minus 69x squared plus 90x, set that equal to 0. Well, the first thing is, again, I'm solving all of these with factoring. I know I can pull out an x, but I can also pull out what? 69 is not divisible by 9, but it is divisible by 3. And I could pull out a 3 from 90 and also 9. So I'm going to pull out a 3x here, and I'm going to get 3x squared minus 69 divided by 3 is going to be 23. So let's say 23x. And then plus 90 divided by 3 is 30. And then x divided by x is 1. Close that down. So now I need to factor this. And let's set this up here like this. Set that to equal. We'll go 3x and we'll go x. Let me think about 30. I know this is plus here and this is minus here. So there's two negatives. I know that 30 is what? 1 and 30. Would that ever work? If I put a 30 here, it's too big. And I can't put a 30 here because it'd have a common factor of 3. So that's out. Then you could go 2 and 15. I can't put a 15 here, but I could put it here. I could put a 2 here. That's going to be 45, so that's not going to work. It's going to be too big. So get rid of that. You have 3 and 10. Can't put the 3 here, but I can put it here. I could put a 10 here. That's going to give me 9, and that's going to give me 10. So let's not use that. That's gone. So what else do we have? Not divisible by 4. You could do 5 and 6. So let's get rid of this. Can't put a 6 here, but I could put a 5 here and a 6 here. The outer is 18 and the inner is 5. So this is exactly what we want. I know I did everything in terms of absolute values, but essentially the outer here is going to be negative 18x, and the inner here is going to be minus 5x. And if you add those two together, you get your negative 23x. So this is what we're looking for. Now, when you look at these guys and you're trying to solve an equation by factoring, you take each factor with a variable and you set it equal to 0. So in other words, I need to set 3x equal to 0 because there's an x there. If it was just 3, you wouldn't have to worry about it. Then I have to take the 3x minus 5, set that equal to 0. Then I have to take the x minus 6, set that equal to 0. Okay, let's scroll down a little bit. This obviously is x equals 0. You could just divide both sides by 3. 0 divided by 3 is just 0. This, I would add 5 to both sides. You would get 3x is equal to 5. Divide both sides by 3. X is 5/3. And then for this, I would just add 6 to both sides, so x is equal to 6. So the restricted values here, you're going to have 0, 5/3, and 6. All right, let's write that x cannot be equal to 0, 5/3, or 6. So we have our factor denominator. For the numerator, I have 3x squared minus 8x minus 60. So nothing I can pull out. I'm going to do 3x and x. So I know this is a negative 60 here, so I'm going to be subtracting. You have for 60, 1 and 60. You have, let me make this more clear. You have 2 and 30. You have 3 and 20. You have 4 and 15. And then you have 5 and 12. And then you have 6 and 10. So again, because I'm suspicious, I think maybe 6 would work. So if I tried something like a negative 6 here and a positive 10 here, just think about if that works. Again, it's not always going to work out this way, but just eyeballing that, I'm suspicious if that's going to work. So my outer here is going to be negative 18x. My inner here is going to be positive 10x. Negative 18x plus 10x is negative 8x. So that's what I want. So I know that I can cancel this with this. So that's gone. And really, I'm just left with my 3x plus 10 in the numerator. You can get rid of the parentheses. You don't need them. In the denominator, you'll have 3x times the quantity 3x minus 5. Let me make this better. And then again, I use my restrictions from the original rational expression. So x does not equal 0, 5/3, and then 6. So let's look for our answer now. So we want 3x plus 10 in the numerator. Looks like that's the only one with that. Then over for your denominator, 3x times the quantity 3x minus 5. And then your restrictions, x is not equal to 0, 6, or 5/3. So I want this one right here. All right, let's look at problem number 4. So let's see what we have. We have 7x squared minus 35x minus 42 over 6x cubed minus 24x squared. All right, let's scroll down here a little bit. See what we got. So the denominator, let me just factor this real quick. I'm going to pull out a 6x squared. And inside, I'm going to have x minus 4. And I'm just going to set this equal to 0 and solve this guy. So you would have 6x squared equals 0. Obviously there, the solution, let me write this out so no one's confused. So 6x squared equals 0. So here x would equal 0. Then you have x minus 4 equals 0. Here x would equal positive 4. So these are your two restricted values. Let me get rid of this. So let me put x is not equal to 0 or 4. And then again, we factored this. We pulled out the 6x squared, and that left with this x minus 4, this quantity inside. For the numerator, it looks like I can pull out a 7 from everything, and you would have x squared minus 5x minus 6. What does this factor into? Well, two integers that sum to negative 5 and have a product of negative 6. So for that, you could do a negative 6 and a positive 1. So let me do x minus 6, this quantity, times x plus 1, this quantity. So in this case, there's really nothing we can cancel. Just leave it in factored form. That's how the teachers usually want it. Just copy your restrictions here. Let me erase this. Move this up here. So what I want is 7 times the quantity x minus 6 times the quantity x plus 1. Then over, I want 6x squared times the quantity x minus 4. And then I want restrictions of x is not equal to 0 or 4. So I want this guy right there. All right, let's look at problem number 5, the last problem. So let's scroll down a little bit. See if we can fit this on the screen. So we have 35x cubed minus 140x. This is going to be over 35x squared plus 49x. So for the denominator, it looks like from here I could pull out a 7x. You would have 5x plus 7. Again, just set this equal to 0. And you're going to set these two factors, the 7x and the 5x plus 7, each equal to 0. And for completeness, 7x equals 0. We know x equals 0. And then for this one, let me subtract 7 away from each side. We'll have 5x is equal to negative 7. Divide both sides by 5. You're going to get x is equal to negative 7/5. Okay, let me erase this. Let's put x is not equal to 0 or negative 7/5. Then up here in the numerator, can we factor anything out? Well, if I think about 35 and 140, I know they're each divisible by 7, but they're also both divisible by 5. So they'll both be divisible by 35. So I could actually pull out a 35x here. And inside I'd have x squared, and then minus this would be 4. Now again, when you factor something, you need to make sure you factor completely. So you always have to check for additional stuff, like x squared minus 4 is the difference of squares. So this is x plus 2, then times x minus 2. I can't really cancel anything between these guys. I know x over x is 1, so that's going to go away. And then if I think about 35 divided by 7, that's going to be 5. So really, let me just rewrite this. This is 5 times the quantity x plus 2 times the quantity x minus 2 over this 5x plus 7. Let me copy these restrictions. X is not equal to 0 or negative 7/5. We have 5 times the quantity x minus 2 times the quantity x plus 2 over 5x plus 7. And then x is not 0 or negative 7/5. So I want that answer right there. All right, let's take a look at our quiz. So for the first question, we're asked to simplify each. And let's see what we have. We have x squared minus 7x plus 12. This is going to be over. We have x squared minus 10x plus 21. Let me slide this over so it fits. And it didn't pick up my 1, so let me move this over here. This is divided by, we're going to have 4x plus 8 over, we have x squared minus 5x minus 14. Okay, so not really a hard problem, just a lot of work in terms of factoring and then seeing what's going to cancel. Let's start at the top. This x squared minus 7x plus 12. Let's see if we can factor that guy to start. I'll put an x here and an x here. Give me two integers whose sum is negative 7 and whose product is positive 12. Well, that's going to be negative 4 and negative 3. So then this guy down here, let's put an x here and an x here. Let me move this over actually. So two integers that sum to negative 10 and have a product of positive 21. So that's going to be negative 7 and negative 3. So before you really get into the problem, you can see that you can already cancel this guy here with this guy here. So a common factor of x minus 3. Now I'm going to multiply. Remember, if you have a division problem, you're going to multiply by the reciprocal. So this x squared minus 5x minus 14 is going to come into the numerator. Let's go ahead and factor that up here. So I'm going to put an x here and an x here. Give me two integers whose sum is negative 5 and whose product is negative 14. So that's going to be negative 7 and positive 2. And then down here, I'm going to have this 4x plus 8 is going to come. So we're going to pull out a 4, and I'll have x plus 2. Okay, so what can I cancel here? Let's see. Let me change colors to something I didn't use, maybe orange. So this x minus 7 here would cross cancel with this x minus 7 here. This x plus 2 here would cancel with this x plus 2 here. And it looks like all I really have is this x minus 4 here, that's not canceled, and this 4 here, that's not canceled. So basically, you can put equals here and equals here. To write our answer, we're going to have this x minus 4. You don't need any parentheses there because it's not really multiplying anything. You could wrap it in parentheses if you want, but it's just unnecessary. And then in the denominator here, we're just going to have 4. So let me erase everything. Let's see what we have. So x minus 4 over 4. I want that guy right there. All right, let's look at question 2. Again, we just want to simplify. So 2x plus 4 over x plus 2. And then times, we're going to have this, let's see, 9x cubed plus 9x squared over 9x plus 9. Okay, so multiplication, really we just need to factor things and cancel. No need to worry about taking reciprocals or anything. On the left, this 2x plus 4, you can pull out a 2, so that's x plus 2. Then down here, if you want, again, you can always wrap this in parentheses and multiply it by 1 to show that you're canceling this with this. So a common factor of x plus 2. And of course, you could get rid of the 1, but we're just going to keep it for right now. Then times up here, I could pull out a 9x squared. So this would be x plus 1 here. Down here, I could pull out a 9. This would be x plus 1 inside. So I can cancel this x plus 1 with this x plus 1, this 9 with this 9. And really all I'm left with is 2x squared, right? Everything's canceled in both denominators. And then I have a 2 here and an x squared here. So it's just 2x squared. And we'll look for that. So again, 2x squared. So I want this guy here. All right, let's take a question number 3. So we have our 5x plus 35 over we're looking at 7x cubed, then minus 35x squared. And then I have division. You can flip it now, but let me just write the whole problem out. So divided by, we have 10x plus 20 over. We have 14x cubed plus 28x squared. Okay, let me come down here. So let's just factor as we go. So we see 5x plus 35. I could pull out a 5. That would be x plus 7 inside. From this guy, I could pull out a 7x squared. And that would be what? This would be x, and then minus, this would be 5 here. Close that down. I'm going to multiply by the reciprocal. So this 14x cubed plus 28x squared, that's going to come in the numerator. I could pull out a 14x squared, and that's going to give me an x plus a 2. And then from this guy, this 10x plus 20, that's coming down here. If I pull out a 10, that is going to give me an x plus a 2. All right, so let's think about all the things that we can cancel. So this x plus 2 with this x plus 2, that's gone. Then I can say that 10 divided by 5 is 2. And I could say 14 divided by 2 is 7. And 7 divided by 7 is 1. So those numbers are all canceled. Then x squared over x squared, that's going to cancel. And then it looks like that's pretty much it. We're going to be left with this x plus 7 over this x minus 5. So we're going to be left with this x plus 7 over this x minus 5. So x plus 7 over x minus 5. So we want that guy right there. All right, let's look at question number 4. So again, we're asked to simplify. Let me come down here a little bit. We'll have 5x squared minus 32x plus 35. This will be over 7x minus 10. Let me slide this over a little bit. We're multiplying here, so in the numerator we'll have 7x squared plus 11x minus 30. Over, we're going to have 15x minus 21. Okay, so let me put equals here. On the left, this guy right here, let me go 5x, and let me go x. So 35, I got 1 in 35, but I can't put a 35 here because I'd have a common factor of 5. I could put it here, but it's way too big. So then you have 5 and 7. So I can't put the 5 here. I'd have to put the 5 here and the 7 here. So because this is a plus here, remember when you do this and you're working with absolute value, just add. 5 times 5 is 25. 7 times 1 is 7. 25 plus 7 is 32. So you want a minus and a minus, right? The outer is negative 25x. The inner is negative 7x. Those combine to give you negative 32x. This is over your 7x minus 10. So far, I can't cancel anything. Over here, let's set this up, and I probably need to slide this down so it fits. So we'll have a 7x here and an x here. So let's think about this negative 30 here. So again, that means we're subtracting. 30, it's 1 in 30. If I put a 30 here, it's too big. If I put a 30 here, it's still going to be too big. So then you have 2 and 15. So if I put a 15 here, it's too big. If I put a 15 here and a 2 here, that's too small, right? You'd end up with 15 minus 14, which is 1. So it's not 2 or 15. Then you've got 3 and 10. So I could try a 3 here and a 10 here. The other way would be too big. This is 21 minus 10. 21 minus 10 is 11. So it looks like we got what we want. So I need to make sure the signs match up. So the bigger one in terms of absolute value needs to be positive, and the smaller one needs to be negative. Okay, so that's what we want. So it looks like we're going to be canceling with that. So let me wrap that in parentheses. Then down here, let me pull out a 3. You'll have 5x minus 7 inside. So what can we cancel? This 5x minus 7 with this 5x minus 7. This 7x minus 10 with this 7x minus 10. And it looks like we just have, let me come down here, this x minus 5 times this x plus 3. And this is over 3. That's all it is. We don't have anything left that we can cancel. So looking through my choices, I have the quantity x minus 5 times the quantity x plus 3. And this is over 3. So I want this guy right here. All right, let's look at question 5. The last question here. So we have our 5x squared plus 12x minus 32. This is over. You have 12x minus 20 multiplied by, we're going to do 12x minus 20. So we know that's going to cancel. Then over 35x cubed minus 56x squared. So without factoring this, you can actually legally cancel this. You don't need to factor it. You can if you want. It's up to you. I'll leave that for you as a bonus. But these two, that's what I'm going to focus on now. So I'll go ahead and say, okay, for this one, I'd have a 5x and I'd have an x. And then let me think about negative. We have a negative 32 here. So what can that come from? So 1 and 32, again, I always stay away from these because it doesn't end up working out. It's going to be too big here and too big if I put it there. So that's just not going to work. So then you have 2 and 16. That seems like that's still a bit too big. If I put a 16 there, that's way too big. If I put a 16 there and a 2 there, let's try that. So 16 and 2, this would be 10 and 16, so that does not work. So these two are out. So what do I have next? It's going to be 4 and 8. So if I put a 4 here and an 8 here, this would be 20 minus 8, which would be 12, right? So I want this one to be positive and this one to be negative. Okay, so that's what I'm looking for. So let me put this over 1, then times. This is canceled, so let me put a 1 up here and come down a little bit. From this guy, I could pull out 35 and 56 share a common factor of 7, and then you could pull out an x squared. So this would be 5x and then minus 8 like this. So it looks like we can cancel this 5x minus 8 with this 5x minus 8, and that is all we can really do. So we're really left with the x plus 4, and then over the 7x squared. Again, the parentheses here are unnecessary, not multiplying by anything. So what am I looking for here? For my answer, I want x plus 4 in the numerator and 7x squared in the denominator. So I want that guy right there. All right, let's take a look at our quiz. For the first question, we want to find the LCD for each group of rational expressions. So we're given 11x minus 10 over, let's see, we have x squared minus 5x. And then we have 2x cubed minus 19 over x minus 5. So the very first thing you want to do if you get a problem like this, just like if you were going to add rational expressions or subtract them, you'd want to make sure that what you're adding or what you're subtracting is simplified. You want to do that here first, okay? So this 11x minus 10, I can't do anything with that. I can factor the denominator. I can pull out an x, and I would have x minus 5 here. So really, there's nothing I can cancel between numerator and denominator, so I'm just going to go with that. This 2x cubed minus 19, I can't factor that. And down here, I just have the x minus 5. So these are the denominators I'm going to consider. Again, when you build your LCD, you take each factor and put it in. But again, you go with the highest number of repeats between any of your factorizations. So x is going to go in, and then the quantity x minus 5 is going to go in, but it's only going to go in once. A lot of people make the mistake of putting it in twice. Again, if it's a repeated factor, 1 here and 1 here. So the highest number of repeats is a 1. So that's why we just put 1 in when we build the LCD. So let's erase this and let's look for this. So we have x times the quantity x minus 5. I want that one right there. All right, let's look at question 2. Again, same thing, finding the LCD. So we have x minus 3 over, we have x squared minus 3x minus 10. And then here, x squared minus 3 over, we have x squared minus 6x plus 5. Let me put an x here and an x here. And two integers that sum to negative 3 and have a product of negative 10. So I know I want opposite signs there. So let me put a plus and a minus. 10, it could be 1 and 10, but that would never work. You could do 5 and 2. I want the minus 5 and a plus 2. Okay, so that would work there. And then nothing's going to cancel. So let me just keep this over here. Over here, I could factor the denominator as x and then x here. So two integers that sum to negative 6 but have a product of positive 5, well, that's going to be negative 5 and negative 1. Okay, so nothing's going to cancel between numerator and denominator there. So if I look at this guy, again, everything when I build the LCD, everything goes in, but if there's a repeated factor or a duplicate factor, go with the largest number of repeats, or you could really say the highest exponential power on that factor, okay? So this guy right here, you have this x plus 2, only occurs once, so let me throw that in there. And then you have this x minus 5. So that's once and then once. So between the two, it only occurs once here and once here. So I only want to put 1 in when I build my LCD. Don't put 2. Then lastly, we have this x minus 1. Let's just throw that in there. It only occurs once there and not over here. So this will be my LCD. Let me get rid of this. So I'm looking for the quantity x plus 2 times the quantity x minus 5 times the quantity x minus 1. So this guy right there. Now let's take a question number 3. So find the LCD for each group of rational expressions. So let's see what we have. We have 2x cubed minus 5 over, we have x squared minus 16x plus 63. Let's continue that. And then over here we have 9x minus 1, and then over x squared minus 7x. Okay, let's get some room here. So the numerators here, they're not going to factor. We're just going to focus on the denominators. Again, if you see something that can be simplified, simplify it, and then work with the simplified denominators. But for this guy, I'm going to factor this into x here and x here. And then two integers that sum to negative 16 and have a product of positive 63, that's negative 9 and negative 7. So we've got that there. Of course, nothing cancels between this 2x cubed minus 5 and this guy in the denominator here. So just leave that as it is. Then for this x squared minus 7x, you could pull out an x, and you'd have x minus 7. So again, nothing's going to cancel between numerator and denominator. So the LCD, again, when you build this, the x minus 9 is going to go in. The x minus 7 is here and also here. So again, this is to the first power, this is to the first power. There's only one in each factorization, so you only have to put one in when you build your LCD. And then you have this x. So typically, we'll just put the x out in front. If you put it behind, it's technically not wrong, but this is typically how we write it. So let me erase this, and let's look for the answer. So we want x times the quantity x minus 9 times the quantity x minus 7. So this guy right here. All right, let's look at the fourth question now. Again, just finding the LCD. We're going to have 4x minus 7 over, this is a big one, so 3x cubed minus x squared minus 3x plus 1. So let me go ahead and see if we can cancel anything here. I'll come back up and get the rest of that. So this guy right here is a 4-term polynomial. So that means we want to factor using grouping. From the first group, let me pull out an x squared. That's going to give me 3x minus 1. From the second group, let's go ahead and pull out a negative 1. And that's going to give me 3x minus 1. So if you pull out this common binomial factor, you'd have 3x minus 1. Let me highlight that for clarity. So we have that guy pulled out. And then left inside, we have the x squared minus 1. Now this x squared minus 1 further factors, right? It's x plus 1 times x minus 1. So let me actually erase all of this. And I'm going to write this up here as 3x minus 1. And then times, again, this is the difference of squares. So this is x plus 1, then x minus 1. So those two quantities. Okay, so that's the first guy. Nothing cancels between numerator and denominator, so you just leave that as is. Let's go back up and grab the second guy. So we have 5x cubed minus 13. Nothing you can really do with that. And then you have 3x squared plus 2x minus 1. So let me factor this now. What do we have here? So we have 3x, and then we have x. Well, the good thing here is that 1 can only come from 1 times 1. I know it's negative, but basically it can only come from 1 times 1. So if I put a 1 here and a 1 here, the outer is 3, the inner is 1. So I want this to be plus and this to be minus. So that would give me the 3x on the outside and the minus x on the inside to give me the 2x in the middle when you combine like terms. Okay, let's get rid of this. And let's move this up here. All right, so again, nothing's going to cancel. So looking at building the LCD here, you have a 3x minus 1 and you have a 3x minus 1. So only one of them. So I'm just going to put one 3x minus 1 in when I build my LCD. You have an x plus 1 and an x plus 1. So you're just going to put 1 in when you build your LCD. And then you have x minus 1 here, not over here, but you're still just going to throw 1 in. So I was saying my LCD here is the quantity 3x minus 1 times the quantity x plus 1 times the quantity x minus 1. So we want this guy right here. All right, let's look at question 5 now. So this one is not hard, but it is a bit tedious. So you have this 14x squared, then minus x, and then minus 11. And this is over. You're going to have this x cubed, and then plus 4x squared, then minus 9x, and then minus 36. So first off, before we go any further, maybe we should just factor this, make it a little bit neater. I could pull out an x squared from the first group, and then I would have what? X plus 4. From the second group, again, if I'm using factoring by grouping, match the sign. So I want to pull out a negative, and then I want to pull out a negative 9. So this would be x plus 4 inside. So you have this common binomial factor of x plus 4. So that's going to get pulled out. Let me scroll down a little bit. I'll come back up. So basically, you'd have this x plus 4, and then you'd have this x squared minus 9. But what happens is, I can just erase this, we don't need this anymore. This x squared minus 9 is the difference of squares. So we're always looking for additional factoring. So this would be x plus 4. And then this x squared minus 9 would factor into x plus 3, and then times the quantity x minus 3. Okay, so that's fully factored. Now for the numerator, maybe you would try to factor that, but it's going to end up being prime. You could use reverse FOIL here because 11 is a prime number. And really for 14, you just have 1 times 14 or 7 times 2. I'll let you pause the video and try that on your own. You won't be able to make that work. This guy is a prime polynomial. Okay, for the next one, we have 22x cubed minus 5 over, you have x squared, so x squared minus x minus 20. So x squared minus x minus 20. So I want an x here, and I want an x here. Two integers whose sum is -1 and whose product is -20. That would be -5 and +4. Okay, so no canceling between numerator and denominator there. Now the last one is a bit lengthy, and it's actually a bit tricky. So we have this 85x cubed minus 17x squared, then minus x, then minus 1, over. We have this x cubed, then plus 7x squared, then plus 12x. So let me actually grab this real quick. Let's come down here. I'll just put a comma here, maybe extend this for clarity. Put a paste in here. For the denominator, I'm actually going to do that first. This can be factored because I could pull out an x, and I would have x squared plus 7x plus 12. Then put the x here. You would have two integers. Let me put the x here and the x here. Two integers that sum to 7 and give me a product of 12. Well, that's going to be 4 and 3. So let's get rid of this. And let's bring this up here. Now, the purpose of this is to find the LCD. So really, if I was going to be able to simplify this, forget about if I could factor it or not. You could try to use grouping, but that's not going to work out. All you would have to actually do is use synthetic division if you were thinking that this would cancel with one of these, okay? And the way you would do that is you would set up your synthetic division. You would divide this by this x plus 4. Remember how to do that. Now, if you get a remainder of 0, then this guy is divisible by this guy, and basically you can write that as two separate factors. I've already done this. It doesn't work. And you could also try it with this guy. It's not going to work. So you can pause the video and do that on your own. If you got this problem on a test, then your teacher would expect you to do that, okay? So you could simplify it. Sometimes they'll throw you a curveball like that. But in this particular case, it's not going to simplify, so we're not going to worry about it. The other thing is if you try to factor this with grouping, you're not going to be able to make that work. It's a 4-term polynomial, but if you pull out a 17x squared from the first group, then you're going to have a 5x and then minus a 1. In the second group, the signs don't work. You've got a negative and a negative, and you're missing the 5. Okay, so it's somewhat close, but it's really not close. I know most people were thinking that. So you're not going to be able to cancel anything. So these are our denominators that we're working with. Let's scroll down a little bit. Let's set up our LCD now. So everything goes in, again, if it's duplicated between the factorization, it goes in the largest number of repeats. X plus 4, x plus 4, x plus 4. Let me check these off as I use them. Only occurs once in each factorization, so let's go ahead and put that in. Then you have x plus 3, and then you have x plus 3. Just put in 1. Only occurs once in each factorization. You have x minus 3. That only occurs once. Let's put that in. And then you have x minus 5. That only occurs once. Let's put that in. And then don't forget about this x hanging out over here. So that goes in. So the LCD here is x times the quantity x plus 4 times the quantity x plus 3 times the quantity x minus 3 times the quantity x minus 5. So I'm looking for x times the quantity x plus 4 times the quantity x plus 3 times the quantity x minus 3 times the quantity x minus 5. So I want this guy right here. All right, let's take a look at our quiz now. So we're told to simplify each, and we're going to have this 8x over x minus 2. We're subtracting away. We have 2 over 18x plus 18. All right, let me grab this. This guy here can be simplified. If I had 2 over, this guy in the denominator could pull out an 18, and I would just have x plus 1. The 2 and the 18 have a common factor of 2, so you can cancel this with this. Put a 9 here and a 1 here. So let me write this as 8x over x minus 2. Then minus, this is going to be a 1 now, over. You're going to have 9 times the quantity x plus 1. All right, let's get rid of this. So what can we do from here? The LCD here is just the product of the denominators. There's really nothing in common there. So all I would really need to do is multiply 8x by what this denominator is missing, which is this 9 times the quantity x plus 1. In this particular case, I'd probably want to speed this up and say this is 9x plus 9. So let's say that this is 8x times the quantity 9x plus 9, like that. And then minus. Remember, for this, I want to use some brackets or parentheses so I don't make a sign mistake. This guy right here needs to multiply by what this denominator doesn't have. So in this case, that's this x minus 2. 1 times anything is just itself, so you can just write x minus 2 inside of there. Let's close that down. Let's put this over our LCD, which in this case is just the product of the denominators. So 9 times the quantity x plus 1 times the quantity x minus 2. Okay, so let's scroll down here a little bit. And I'm just going to distribute this. 8x times 9x is going to be 72x squared. Then 8x multiplied by 9 is going to be plus 72x. Then basically to drop this, you're just going to remove the brackets and change the sign of everything inside. So minus x and then plus 2. Well, 72x minus x would be 71x. So let's just get rid of that. And let's put this plus 2 here. I'm going to tell you in advance this is not going to be something you can factor. So this, let me put this 9 times the quantity x plus 1 times the quantity x minus 2. This is going to be our simplified answer. And so we're looking for 72x squared plus 71x plus 2 over 9 times the quantity x plus 1 times the quantity x minus 2. So the denominators in a different order, but that doesn't matter. This is our answer right here. Okay, let's look at question number 2. So we're going to have 7x over x minus 2. Then plus we have 8 over 7x plus 6. So nothing I can really do. Probably don't need a fresh sheet, but let's just use one anyway. Let's paste this in here. So again, the LCD is just the product of the denominators. So this quantity x minus 2 times this quantity 7x plus 6. Nothing else I can really do. Neither of these is going to be factorable, and there's nothing in common. So this guy 7x needs to multiply by this guy here. So 7x times the quantity 7x plus 6. And then plus 8, that needs to multiply by this guy here. So times the quantity x minus 2. Okay, so what does this yield here? 7x times 7x is going to be 49x squared. Then plus 7x times 6 is 42x. Then plus 8 times x is 8x. Then minus 8 times 2 is 16. So 49x squared, nothing I can do with that. 42x plus 8x is going to be 50x. So let's put 50x here. And then let's put our minus 16 like this. And then let's write x minus 2, this quantity times the quantity 7x plus 6. Let's grab this guy. And I'm just going to tell you this in advance. This 49x squared plus 50x minus 16, that's going to be prime. So you really can't do anything with that. So you want this answer right here, 49x squared plus 50x minus 16 over this x minus 2, this quantity times the quantity 7x plus 6. So I want this answer right here. All right, let's look at question 3. So again, we're told to simplify each. Now we have 5 over 5x plus 7 plus 3 over x minus 2. Paste that in here. The LCD would be the product of the two denominators, so x minus 2, then times this 5x plus 7, so those two quantities. And then 5 needs to multiply by the x minus 2. And then plus 3 needs to multiply by the 5x plus 7. Let's scroll down here a little bit. See what we have. 5 times x is 5x, then minus 5 times 2 is 10. Then plus, we have 3 times 5x, that's 15x. And then plus 3 times 7 is 21. This is over our LCD, x minus 2, this quantity times the quantity 5x plus 7. All right, so in the numerator, 5x plus 15x is going to be 20x. So let's put that there. And then negative 10 plus 21 is going to be plus 11. This is over your quantity x minus 2 times the quantity 5x plus 7. So 20x plus 11 is my numerator. And then my denominator is x minus 2, this quantity times the quantity 5x plus 7. So it looks like I want this answer right here. All right, let's look at question number 4 now. So again, we want to simplify, and we're going to have 6x over x minus 1. And then plus, we're going to have 4x over x minus 2. So between these two, you have an x that's common and you have a 2 that's common. So you're going to be able to pull that out. You could do it now if you want. I'm probably just going to wait. The LCD here is going to be the product of the two denominators. So the quantity x minus 1 times the quantity x minus 2. And then each guy here is going to multiply by the opposite denominator. So you would have 6x, which I'm going to write as 2x times 3. And then times the quantity x minus 2. And then plus, I'm going to write 4x as 2x times 2. And then times the quantity x minus 1. So the reason I'm writing it that way is that I can pull out this 2x here before I do anything, because if I don't do that, I'm going to have to pull it back out after, right? So it doesn't make too much sense to basically distribute it in and then have to pull it back out. So we just pull it out now. It's a little bit quicker. All right, let's put equals here. I'm going to pull the 2x out. So let's put that out in front of some parentheses. And then basically inside, 3 times x is 3x. And then minus 3 times 2 is 6. Then plus, this is coming out. So 2 times x is 2x. And then 2 times negative 1 is minus 2. Close that down. Okay, so inside, 3x plus 2x would be 5x. Let's get rid of that and put that as a 5x. Then negative 6 minus 2 would be negative 8. So let's close that down. And this will be over our LCD, which is the quantity x minus 1 times the quantity x minus 2. So I'm looking for 2x times the quantity 5x minus 8 over the quantity x minus 1 times the quantity x minus 2. So again, the denominators are in a different order, but that doesn't matter. We're just multiplying. So this is the answer we want right there. All right, let's take a question 5. So we have 7 over x minus 6. Then minus, we're going to have this 7x over this x plus 4. Now I could pull out a 7 before I start, but let's actually work through a little bit. And we'll pull our 7 out. So again, if I look at these denominators, there's nothing I can really do. There's nothing in common. And basically, they're both as factored as they're going to get. You got x minus 6 and you got x plus 4. So the LCD here is just the quantity x minus 6 times the quantity x plus 4. So let's go ahead and write that first. In the numerator, before I do anything, just realize that you have a 7 here and a 7 here. So that means I can pull that out. So in other words, when I go to do my multiplication, let's say I do 7 times, what does this denominator need? It's going to need this x plus 4 to achieve the LCD. So I'm going to put times x plus 4 here, this quantity. Then I'm going to put minus. And I'm going to hold off on my brackets for just 1 second. I'm going to put this 7 here times this x here. And then I'm going to do times, what does this denominator need? It needs this quantity x minus 6. And basically, I'm subtracting away this whole thing. I'm going to put brackets here in a moment. I don't want to confuse you. This 7 here and this 7 here, I'm going to go ahead and pull that out. So now that I've highlighted that, I'm going to put my bracket here and here. And then let me put this down here. Come down this way. And so pulling the 7 out would put a 7 out here. And then inside the parentheses, I'm just going to have this x plus 4. You could really just think about this as I pulled out a 7, so I just have a 1 in that place. So basically, I just have the x plus 4. Then I'm pulling out a 7 there. So minus, you just have this guy right here. Let me put the brackets here. X times x is x squared. And then x times negative 6 is minus 6x. If you want to drop those brackets, you're just going to change the sign of everything. So that's minus and this is plus. So it's really that simple. Go ahead and close those parentheses down. And inside, I'm basically going to have this negative x squared. And then plus 6x plus x would be 7x. And then plus 4. So negative x squared plus 7x and then plus 4. Let me close that down. Then this is over. You have this quantity x minus 6 times this quantity x plus 4 like this. So this is actually the one we want. It looks a little bit different because in this answer here, we factor out a negative. So a lot of people want to do that so that they have a leading coefficient that's positive. So if you pulled out a negative 7 here, so this becomes plus, this becomes minus, and this becomes minus. Okay, so I'm just pulling out a negative 1. I've already pulled out the 7. So you have negative 7 times the quantity x squared minus 7x minus 4. So from that guy right there, over you have your quantity x minus 6 times the quantity x plus 4. So I want this answer right there. All right, let's take a look at our quiz. So we're told to simplify. We're given 4, then this is over. We have 1/5 like this plus 5 over x. And let me paste this in here. I'm going to first write this as 4 over 1 over 5 plus 5 over x. So among all the denominators, the 1, the 5, and the x, what is the LCD or the least common denominator? It's going to be 5 times x or 5x. So I'm going to use that to multiply by the numerator and denominator of the complex rational expression. So 5x times 4 is just going to be 20x. Down here, 5x times 1/5. The 5 is going to cancel with the 5, and you're just going to have x. And then plus 5x times 5 over x. The x's are going to cancel. 5 times 5 is 25. So can I do anything with 20x or x plus 25? No. So this would be my answer. Let's cut this away. Let's paste this in here. So I want 20x over x plus 25. So I want this guy right here. All right, let's look at question number 2. So we're going to have x over. Then we have this x squared over 4. And we're subtracting away. We're going to have this x minus 4 and then over 2 like this. I'm going to go ahead and write this x as just x over 1. So I have a denominator of 1, 4, and 2. So the LCD here would be 4, right? So 4 over 4. We're going to multiply this complex rational expression by this. In the numerator, it's just 4 times x. That's just 4x. In the denominator, 4 is going to multiply by each part here. 4 divided by 4 is 1, so this part would just be x squared. And then minus, I'm just going to use some brackets, or you could use parentheses if you want. Basically, the 4 divided by 2 would be 2, and you would have 2 times the quantity x minus 4. Okay, so like this. All right, so let's see what we can do down here in the denominator. I'm just going to copy the numerator. So I have this x squared, and then minus 2 times x is going to be 2x. Let me use some parentheses here. You could keep the brackets. It's up to you. And then basically 2 times negative 4 is minus 8. So let's set that up like that. And again, if you want to drop these parentheses or the brackets, if you want to use those, then basically we need to change the sign of everything. So this is minus and now this is plus. So what I have here, let me slide this down a little bit, is x squared minus 2x plus 8. Can I factor that? Let's see. You'd have an x here and an x here. Can you give me two integers whose sum is negative 2 and whose product is positive 8? So this would have to be a negative and a negative. And the factors of 8, you have 1 and 8. There's no way to get that to work. And then you have 2 and 4. There's no way to get that to work. So this guy is prime. So let's go ahead and copy this real quick. So let's look for this 4x over. You have x squared minus 2x plus 8. So we want this guy right there. All right, let's look at question number 3. So it looks like we have 5 over 9, then minus 5 over x minus 2. This will be over. You have x minus 2 over 5, and then plus you have x minus 2 over 3. And let's see what we have here. Okay, so for the LCD, it looks like I have 9, 5, 3, and x minus 2. So number-wise, 3 and 9, you would just go with 9, and then 5 comes along. So this would be 45 times the quantity x minus 2, and then 45 times the quantity x minus 2. So we're going to multiply here. So 45 divided by 9 is 5. And then 5 times 5 is 25. So let me just put 25 here. And then times this quantity here, which is x minus 2. Okay. Then minus. The 45 is not going to cancel there, but the x minus 2 would cancel with the x minus 2. So you'd have 45 times 5. Let me write 5 times 45 like this. And what I'm going to do, because I'm going to end up pulling this out, I'm going to break this into 25 times 9. So let's put this as 25 times 9 like this. And you can see I'm going to factor that 25 out in a moment. So let's come down here a little bit, put this over. So 45 divided by 5 would be 9. So you would have 9 times the quantity x minus 2. And let me write this out times the quantity x minus 2. You could put x minus 2 quantity squared. Then I'm going to put plus. 45 divided by 3 is 15. So you're going to have 15 times the quantity x minus 2, then times the quantity x minus 2 again. So let's put this over here like this, and let's slide down. Okay. So from the first guy, again, I mentioned I could pull out a 25. That's why I wrote it that way. So let's go ahead and pull that out in front of some parentheses. Inside, you have this x minus 2, and then basically you have this minus 9. So from here, you just do the simplification. Negative 2 minus 9 is negative 11. So let's just write x minus 11 like this, and that part's done. Then down here, it looks like I can factor this guy out right here, right? So I can pull that out. It's probably easier in this case to write the quantity x minus 2 being squared, but I didn't know how that was going to work out, so that's why I expanded it there. So let's write x minus 2 quantity squared. Inside the parentheses, you're going to have 9 plus 15. So 9 plus 15 is 24. So let me put a 24 out in front of this. And basically, we're done. Let me go ahead and grab this. So we would have 25 times the quantity x minus 11 over 24 times the quantity x minus 2 being squared. So I want this guy right there. All right, let's look at question number 4. So we're told to simplify each. And what we have is 2 over x minus 7. And then plus, we have 2/3. Then this is over. We have 4 over x. And then plus, we have 4 over x minus 7. Now my LCD, I have x minus 7 and x minus 7. I have 3 and I have x. So let's put 3x times the quantity x minus 7. And then 3x times the quantity x minus 7. So what is this going to give me? For the first one, the x minus 7s would cancel. And essentially, you would have 3x times 2, which is going to be 6x. Then plus, for this guy, the 3's would cancel. So you're going to have 2x times the quantity x minus 7. So I'm going to write this as 2x times 3 like this, because obviously we're going to factor the 2x out. So let's put this over. Let's come down here. So for this one, the x's would cancel, and I would have 3 times 4, which is 12. times the quantity x minus 7, and then plus, here the x minus 7s would cancel, and I'm going to have 3x times 4, which is 12x. Okay, so let's see what we can do here. Doesn't look too bad. I'm going to pull out the 2x from here and here, and what is that going to give me? 3 plus x minus 7 inside, and then 3 minus 7 will be negative 4. So let's write x minus 4 like this. I'm going to wrap this and then put that 2x out in front. Okay, so down here, I'm going to pull out a 12. Let me highlight that. So I'm going to pull out this 12. And so that's going to give me 12 out in front. Inside, I'm going to have x minus 7 plus x. So this is just 2x minus 7. So 2x minus 7 like this. So I can cancel this 2 with this 12 and put a 6 here. So let's go ahead and say this is x times the quantity x minus 4 over, you have 6 times the quantity 2x minus 7. So I'm looking for x times the quantity x minus 4 over 6 times the quantity 2x minus 7. So I want that guy right there. All right, let's look at problem number 5. So this one looks like it's going to be very tedious. So we have x minus 1 over y minus 3, then plus 2x plus 3 over y minus 3, then over, let me slide this up here. So we have x minus 1 over 2x plus 3, then plus 4 over y minus 3. What is my LCD? We have y minus 3, y minus 3, y minus 3, but then you have 2x plus 3. So I'm going to multiply by, you have y minus 3 times this quantity 2x plus 3. So y minus 3, and again 2x plus 3. Okay, let's knock this out. All right, so for this one, I'm going to multiply this by this and this. Notice that the y minus 3 is going to cancel in each case, and you're going to have this 2x plus 3 that's going to multiply by this and this. Rather than doing that, let's just speed this up and put the 2x plus 3 on the outside, like this. And then on the inside, let's put the x minus 1, and then plus the 2x plus 3. So I'm just factoring this in advance. I know this is a little bit quicker. Maybe this loses you, but essentially all I'm doing is I'm saying this is going to cancel with this and this. So essentially I'd have 2x plus 3 times this, then plus 2x plus 3 times this. And I'm just pulling it out in advance because we're going to have to do that anyway. So then x plus 2x inside of here would be 3x. So let's write 3x, and then negative 1 plus 3 is going to be 2. So let's put 3x plus 2 here, like that. Okay, then let's go over. For the denominator, I think it can slide down a little bit, maybe fit everything on the screen. For the denominator, I can see that for the first one, 2x plus 3 is going to cancel with 2x plus 3. So I'm going to have this x minus 1 times this y minus 3 like this. And then I'm going to go plus. Now the y minus 3 is going to cancel, so I'm going to have 4 times the quantity 2x plus 3 like this. Can I pull anything out? It doesn't look like we're going to get lucky with that. So let's just go through and distribute x, y here for the first. Then I'd have minus 3x, then minus y, then plus 3. Then I'd have plus, this would be 8x, and then plus 12. Okay, so let me go ahead and say that we have negative 3x plus 8x. That's going to be plus 5x. So plus 5x, let's get rid of this and this. And then 3 plus 12 would be 15. So I'd have plus 15. So let me write this as xy. I'll put plus 5x. And then we'll go ahead and say minus y. And then plus 15. Okay, so let's get rid of this. And we can just erase this denominator. I don't think you need it. Slide this up here. Can you really do anything with this? No. I'm just going to leave this as my answer here. So we have 2x plus 3, this quantity, times the quantity 3x plus 2. So it looks like that matches that guy right there. And then over, you have xy plus 5x minus y plus 15. So this is what we want right here. All right, let's look at our section quiz. For the first question, we're asked to find the restricted values. So let me write this out. We have the 2x squared minus 24x plus 40. Over, we have the 10x cubed minus 80x squared minus 200x. So if you're asked to find the restricted values, or if you're asked to find the domain and you're working with a rational expression, remember you can never divide by 0. So you don't want to simplify. You always want to work with the original rational expression, and you want to just grab the denominator, whatever it is, set it equal to 0, and then solve the resulting equation. And I'll get rid of this guy here, and I'll set this equal to 0. So the idea here is that the solution or solutions for this equation, those are going to make the denominator 0, so they have to be restricted from the domain. So from this guy right here, all these that I give you, you can solve from factoring. I'm going to pull out a 10x, and that's going to give me x squared. Then minus, this will be 8x, and then minus, this is going to be 20. So let me close that down and set that equal to 0. So you can further factor this guy right here. Let me go ahead and put an x here and an x here. I need two integers that sum to -8 and have a product of -20. Well, that's going to be -10, so -10 and +2, right? -10 plus 2 would give me -8, and then -10 times 2 would give me -20. Okay, so once you've factored everything completely, we're going to talk about this later on in the course, but for right now, just know that you can solve this using something called the zero product property. So you can take each factor with a variable, so the 10x, the x minus 10, and the x plus 2, set that equal to 0, and then solve. So I'm going to set 10x equal to 0. I'm going to set x minus 10 equal to 0, and I'm going to set x plus 2 equal to 0. And you can solve these pretty quickly in your head, but just for completeness, let's divide both sides by 10. You get x is equal to 0. Let's add 10 to both sides. We'll get x is equal to 10. And let's subtract 2 away from each side, so you're going to get x is equal to -2. So to translate this into the restricted values, you would say x can't be 0, can't be 10, and can't be -2. So if we come back up here, we have this listed in set builder notation. So the domain would be the set of all x such that x can't be -2, 0, or +10. So this is the answer we want right there. Okay, let's look at question 2. We're asked to find the restricted values. So we have the 14x minus 12. This is over, we have 6x squared plus 26x and then plus 28. Again, I just want to work with the denominator. Don't worry about the numerator in this particular case. Let me get rid of this bar once again. You just have to set this equal to 0. So it looks like from this guy, I can for sure pull out a 2. This would be 13, so it doesn't look like I can pull anything else out. So if I pull out a 2, I would have 3x squared plus 13x and then plus 14 here. Set that equal to 0. So let's go ahead and factor the inside if that's possible. So this is going to be a 3x and this is going to be an x. Now I'm thinking about 14. Everything is plus, so I know these are all additions here. But 14, you have 1 and 14, but that's going to be too big, right? If I put a 14 here, forget it. If I put a 14 here, it's still too big. And then you have 2 and 7. So if I put a 7 here, it's too big, but I could put a 7 here and a 2 here. My outer would be 6x, my inner would be 7x. That would give me the 13x I need. Okay, so now that we have this factored, remember, you want to set each factor with a variable equal to 0. The 2 does not have a variable, so you can just forget about it in this case. You don't have to do anything else. We would say 3x plus 7 equals 0. We'd solve that. And then we have x plus 2 equals 0. We'd solve that. Let me scroll down here a little bit. For this one, I would subtract 7 away from each side of the equation and say 3x is equal to -7. Divide both sides by 3. You get x is equal to -7/3. Then over here, I would subtract 2 away from each side. You get x is equal to -2. Let me make this -2 better. Okay, so we have -7/3 and -2. Those are the values that if I plug them in for x in the original rational expression, I get 0 as my denominator, and so it's an undefined result. So I need to exclude -7/3 and -2. So my domain here, the set of all x such that x does not equal -2 and -7/3. I want this answer right here. All right, let's take a look at question number 3. Now it says to simplify each and state the domain. So if you get this type of question, now you're just not working with the denominator, you need to work with both. But you need to always take, when they ask you for the domain or the restricted values or whatever it is, you need to figure out what are the restrictions first from the original rational expression. Those are going to carry over to the simplified rational expression. So if I have something like, let's say 5x squared minus 5 over, this is 7x squared plus 10x plus 3. So I can factor everything completely now just to get it out of the way, but just don't cancel anything yet. This, I'm going to pull out a 5 from the numerator. This would be x squared minus 1. But we know this is the difference of squares. So I can further factor this into x plus 1 times x minus 1. So let's go ahead and do that real quick. We'll put x plus 1 and then x minus 1 like that to completely factor. Then down here, I can't pull anything out. I could do a 7x and an x. And let's think about this. This last guy is a 3, so that can only come from 1 times 3. So I'm going to have to put a 3 here and a 1 here. The outer would be 7x, the inner would be 3x, so that would give me the 10x if everything is a plus sign there. Okay, so obviously you can cancel the x plus 1s, but I don't want to do that yet because, again, what I want to do is I want to take my denominator. In this case, it's in factored form, so 7x plus 3, this quantity, times the quantity x plus 1. I want to set this equal to 0, and I want to solve. So I would set 7x plus 3 equal to 0, and then I would set x plus 1 equal to 0. So let's come down here, subtract 3 away from each side, cancel this. 7x is equal to negative 3. Divide both sides by 7. You get x is equal to negative 3/7. So that's one restriction. The other one, if I subtract 1 away from each side, I get x is equal to negative 1. So let's get rid of this. Let's say x is not going to be equal to the negative 1 or negative 3/7 like this. Okay, so down here, I'm just going to cancel this x plus 1 with this x plus 1. So basically what I would have is 5 times the quantity x minus 1. And then over this basically 7x plus 3. Again, these are my restrictions. We could write them over here. We could say x is not equal to negative 1 or negative 3/7. Again, you always carry the restrictions over from the original rational expression. This part right here is what confuses a lot of students because when I simplify this guy, you no longer have a restriction where x can't be negative 1. You could plug negative 1 into this guy, but again, we're always thinking about in terms of the original rational expression, what are the restrictions, and those guys are going to carry over. So I'm looking for this answer right here, it looks like. So 5 times the quantity x minus 1 over 7x plus 3 with the domain where it's the set of all x such that x is not negative 1 or negative 3/7. All right, let's look at question number 4. So again, we want to simplify and state the domain. So we have 45x plus 18. This is going to be over 27x squared plus 117x plus 90. So for the numerator, let me go ahead and factor this. And actually, I need to slide this down so it all fits. Let's pull out a 9. That's going to give me 5x plus 2 inside. Down here, what can I pull out? 27 is 3 times 3 times 3. 90, let's just think about that as 9 times 10. So I know I can pull out a 9 from those two. 117, 1 plus 1 is 2, 2 plus 7 is 9. So I know I can pull out a 9. So let's pull that out. Of course, that's going to cancel. And you're going to have 3x squared. And then plus, what is 117 divided by 9? If you punch that into a calculator, you're going to get 13. So this would be 13x. And then plus this would be 10. Okay, close that down. So let's slide this over just a little bit. Let me put equals here and drag that over. Okay, so can I further factor this guy right here? Let's see. So we would have 3x here, and we'd have x here. And then we need all plus signs. 10 is either 1 times 10 or 5 times 2. If I put a 10 here, it's too big. If I put a 10 here and a 1 here, that looks like that works. So this would be 3x plus 10x. That would give me my 13x. So let's erase this right here and then just drag this up here like this. So it doesn't look like anything's going to cancel other than these 9s. And you can actually cancel that right now. You don't have to worry about it because there's no variable involved. So this isn't going to throw anything off in terms of your domain. So simplifying this guy would be 5x plus 2 over, you would have the 3x plus 10, then times this x plus 1. So now I can just find my domain. And again, if you had a variable involved, you'd want to wait to cancel. In this case, I'm just canceling it now because it's just a 9. So that's not going to affect anything. So let's come down here and let's go ahead and say that 3x plus 10 would be equal to 0. And then or we'd have x plus 1 equal to 0. Again, I would just set this denominator equal to 0. And then each factor with a variable gets set to equal to 0. Subtract 1 away from each side. You get x is equal to negative 1. And then subtract 10 away from each side. Let's cancel that. You get 3x is equal to negative 10. Divide both sides by 3. And you get x is equal to negative 10/3. Okay, so we'd say x cannot be equal to negative 10/3 or negative 1. And I'll just paste this in here real quick. Let's see. So I want 5x plus 2 over this quantity x plus 1 times the quantity 3x plus 10. And then I want a domain set of all x such that x is not equal to negative 1 or negative 10/3. So I want this guy right here. Okay, let's look at question number 5. So it looks like we're dividing rational expressions now. So we have 5x squared minus 9x plus 4. This will be over. You have just 9x squared. Let me slide this down a little bit. Then we're dividing this by, you have 35x squared minus 78x plus 40. Then this is over. You have 63x cubed minus 90x squared. So for this one, you would just want to factor everything first. Again, this is going to get flipped. So this guy over here on the left, what can I do with that? Let me put a 5x here and an x here. Well, I know I need two negatives, so this would be negative and this would be negative because you have a negative sum and a positive product. Now 4, again, just think about this in terms of absolute value. 4 is 1 times 4. So if I put a 4 here, that's 20. That's going to be too big. If I put a 4 here and a 1 here, remember, you're adding these guys. So if there was a 1 here and a 4 here, this would be negative 5x, and this would be negative 4x. That would give you negative 9x. So that's what I'm looking for there. Then this is over this 9x squared. Let me slide this over. It'd be hard to fit this. So then times, I'm going to bring this into the numerator from the, and this is a 3 here. I wrote that terribly. I could factor out a 9, and actually I can factor out a 9x squared, so I missed that. This would be 7x here, and then minus 10. Okay, now down here, this one is a little bit difficult to factor. You have 35x squared minus 78x plus 40. You can't pull anything out to start. 35 is 5 times 7, and then when you start getting into 78, it's 13 times 3 times 2. There's nothing in common between those two other than 1. So don't even worry about 40. So we're not going to be able to pull anything out. So we're going to have to factor this guy like this. Now you could use the AC method here, but just keep in mind that 35 times 40 is a really big number. So I think you're probably better off using reverse FOIL here because 35 is only 1 times 35, which is unlikely to work, and then 5 times 7. So I'm going to start with 5x and 7x, and I'm just going to think about 40 here. Remember, this is negative and this is positive. So a negative sum and a positive product means I have two negatives. So you'd have 1 and 40, which is unlikely to work. You have 2 and 20. Would that work? If I put a 20 here and a 2 here, remember you're adding, it's just going to be too big because I'm trying to get to this 78 here in terms of absolute value. So next you would come to 10 and 4. Can I make that work? If I put a 10 here and a 4 here, the outer is 50, the inner is 28. Again, in terms of absolute value, if you add those together, you would get 78. So this is what I want. The outer is going to be negative 50x. The inner is going to be negative 28x. You sum those together, you get negative 78x. So now all I really need to do is some canceling. This is going to cancel with this. That's gone. This is going to cancel with this. That's gone. This is going to cancel with this. And I'm just left with x minus 1. So I can really just say this is x minus 1 as my answer. So we're just looking for x minus 1. Okay, let's look at question 6. Looks like we have a multiplication problem now. So it's 7x squared minus 42x plus 35. And if you want, you can just factor that now. You could pull out a 7, and you would have x squared minus, this would be 6x plus this would be 5. And let's just go ahead and keep factoring here. So 7 times, let's put this as x and this is x. And give me two integers whose sum is negative 6 and whose product is positive 5. That's going to be negative 5 and negative 1. So that one's taken care of already. And then over here in the denominator, I have 14x squared minus 14. So that's 14 times the quantity x squared minus 1. But remember, this can be further factored because it's the difference of squares. So this is x plus 1 times x minus 1. Now you can cancel this at this point if you want. I'll probably do that in a moment. So then times over here, I have 2x squared minus 12x minus 14. You could pull a 2 out from that. You'd have x squared minus 6x and then minus 7. So 2 times, let's go ahead and do this like this. So x here and x here. And let's think about this. So 7 is only 1 times 7. And I need two integers that sum to negative 6 and give me a product of negative 7. So that's going to be negative 7 and positive 1. Okay, so let's get rid of all of these. And let's slide this up here like this. Let's do this like this. And then the denominator is just 8. All right, so what can we cancel? We can cancel this x plus 1 with this x plus 1, this x minus 1 with this x minus 1. And let's see, I think in terms of binomials, that's pretty much it. So now I'm looking at this 8 and this 2. That would give me a 4 here. And this 7 and this 14 would give me a 2 here. So essentially, in the numerator, I just have this x minus 5 and this x minus 7. So let's go ahead and multiply those two together. This would be the quantity x minus 5 times the quantity x minus 7. Again, you would typically leave this in factored form to show that nothing else is going to cancel. In the denominator, you would have 2 times 4, which is going to be 8. I'm looking for the quantity x minus 5 times the quantity x minus 7 over 8. So I want this guy right here. All right, let's look at question number 7. So we want to find the LCD now. So basically you have x plus 4 over this x squared minus 2x minus 3. And then you have 2x minus 3 over x squared minus 5x plus 6. All right, so we do want to simplify these first if it's possible. Let me go ahead and factor this real quick and see if anything's going to cancel. So x here and x here. I need two integers that sum to -2 and have a product of -3. That would be -3 and +1. So let's put that like that. Let's get rid of this and slide this up. Does anything cancel between numerator and denominator? No, not in this case. So for this one, x squared minus 5x plus 6. Again, give me two integers that sum to this -5 and have a product of +6. That's -2 and -3. So let's get rid of that. Nothing's going to cancel here either. So when I build my LCD, remember, each factor is going to go in, but only up to the largest number of repeats between any of the factorizations. So in other words, when I build this guy, I have x minus 3 here and I have x minus 3 here. So between the two factorizations, what's the largest number that it occurs? Well, basically, it's only going to occur once in each, so I only put in 1 when I build my LCD. So the common mistake is just to put everything in here. So some people put x minus 3 quantity squared, and that is not building the LCD. You only want 1 in. Then times this x plus 1, that's going to go in, then times this x minus 2. So if it's not duplicated between the factorizations, just throw it in. If it is duplicated, look for the largest number of repeats. That's what's going to go in. So this guy right here. So the quantity x minus 3 times the quantity x plus 1 times the quantity x minus 2. All right, let's look at question 8. Again, we want to find the LCD. So we have 3x squared plus 9x and then minus 1. Over x squared minus 7x plus 10. Let me slide this down. And then we have 12x squared minus 5 over, we have 2x squared minus 11x plus 5. All right, so the numerator is not going to factor. The denominator, let's go ahead and put this x here and x here. Two integers that sum to -7 and have a product of +10. That's going to be -5 and -2. Let's erase this. And let's drag this up here like that. And then this guy right here, 12x squared minus 5, can't really do anything with that. For this guy, let's go ahead and put 2x here and x here. 5 is only 1 times 5, so if this is going to factor, I'm going to have to use 5 and 1. And then this guy is negative, so a negative sum and a positive product means a negative and a negative. So I could put a 5 here and a 1 here. The outer would be -10x, the inner would be -x. Those would combine to give me the -11x that I need. So let's get rid of this, and let's drag this up here. You can see nothing's going to cancel. So my LCD, again, is going to be what? X minus 5 occurs here and here. Only once in each case. So when I build the LCD, I only need to put 1 in. So x minus 5. Then I've got x minus 2. Then I've got 2x minus 1. So this would be my LCD. And our LCD is the quantity x minus 5 times the quantity x minus 2 times the quantity 2x minus 1. So I want this guy right here. Okay, let's look at question 9. So we're asked to simplify each. We have 2x over x plus 7. Then we're going to subtract away. Looks like we have 7x over x minus 6. So for this one, again, if the LCD in this case is just going to be the product of the two denominators, and there's nothing in common, so really the shortcut for this is I'm going to take this guy right here, this 2x, and I'm going to multiply by the other denominator, x minus 6. But at the end of the day, my denominator is just going to be this x plus 7 times x minus 6, so this makes the process a little bit shorter. Then I'm subtracting away. Remember, you want to use brackets or parentheses or something so you don't make a sign mistake. I would have 7x times, in this case, the other denominator, which is x plus 7. So you just need to multiply the numerator by whatever the denominator needs to obtain the LCD in each case, and you can write the denominator as the LCD. Okay, let's come down here, and let me think about, can I pull anything out before I start? Doesn't look like it. So let's go 2x squared, and then minus 12x, and then minus, inside the brackets there, you would have 7x squared, and then you would have plus 49x. Close that down. Let's put this over. We have x plus 7 and then x minus 6, those quantities there. So we just have 2x squared minus 12x. I'm going to remove these brackets, but to do that, I need to change the sign of everything. So minus 7x squared and then minus 49x. So it looks like I can do 2x squared minus 7x squared. That would give me negative 5x squared. So let's erase these two and just put negative 5x squared like that. Probably should make that better. And then negative 12x minus 49x would be negative 61x. Let's slide this over a little bit, and I'll put negative 61x there. Of course, you could factor out an x, or you could probably factor out a negative x. That would probably look better. So negative x, inside you'd have 5x, and then plus 61 like that. So let's erase this, and let's drag this up here, and then let's put this over. We have this x plus 7 quantity times the quantity x minus 6. Let me make that a little bit better. So this would be our answer. Again, everything is factored, so you're showing your teacher that you can't cancel anything else. So let's grab this one right here. All right, let's look at question 10. We're told to simplify each. So we have 5 over 7x plus 3. And then plus, we have 2x over 2x plus 7. Again, all I need to do in this case, the LCD would be the product of the two denominators. So what does this denominator need to become the LCD? It needs this guy right here. So I'm going to multiply this numerator 5 by this other denominator, 2x plus 7. Then plus this 2x, what does this denominator need to become the LCD? It needs the 7x plus 3. So times the other denominator, the 7x plus 3. Let's go over the LCD, which is 7x plus 3. This quantity times the quantity 2x plus 7. Okay, let's see what we have here. So at this point, I can't really pull anything out. So I would have 10x plus 35. And then plus, I would have 14x squared plus 6x. So this is done here. Let's see, can we combine anything? We would have 6x plus 10x, that would be 16x. So let me write 14x squared plus 16x plus 35. Let's bring this up here. I don't think you can factor this. Let me think about that real quick. Can you factor that? No, I don't think you can. That's going to be prime. So down here, this would be 7x plus 3, then times 2x plus 7. 14x squared plus 16x plus 35, and then over the quantity 2x plus 7 times the quantity 7x plus 3. So again, the denominators are in a different order, but that doesn't matter. All right, let's look at question number 11. So we're told to simplify, and this one looks a bit tedious. So we have x plus 1 over y minus 3. We're subtracting away y minus 3 over 9. Then this is going to be over x plus 1 over 3y minus 9. Let me factor out the 3 now. So 3 times the quantity y minus 3, and then plus 1 half. So for the denominators, you've got a 9, a 2, a 3 times the quantity y minus 3, and a y minus 3. So for the LCD, again, for the number part, you have a 9, a 2, and a 3. So 9 is 3 times 3, and 3 is just 3. So when I build this guy, I'm just going to put 9 in, and then times 2. So 9 times 2 would give me 18. And then, of course, you need this quantity y minus 3. So that would be the LCD there. And we're going to multiply the numerator and denominator of this complex rational expression by this LCD, and then we're going to simplify. So let's see what we get. If I multiply this guy by this guy, the y minus 3s are going to cancel. And I'm going to have 18 times the quantity x plus 1. Then minus. Here, the 18 divided by the 9 would give me a 2, and I would have the quantity y minus 3 squared. So it looks like I could factor out a 2 here. So let me actually write this as 2 times 9 like this. Make that a little bit easier. Then down here, 18 divided by 3 would be 6. The y minus 3 would cancel with the y minus 3, and then you'd have times the quantity x plus 1. Then plus 18 divided by 2 is going to give me 9. So I would have 9 times the quantity y minus 3. Now down here I could pull out a 3. So let's put this as 3 times 2. Let me make that sign a little bit better. And let's put this as 3 times 3. So 3 times 3. Let's put equals here. Let's slide down a little bit. And again, from the numerator, I'm going to pull out a 2. So let's go ahead and do that first. So we'll pull out this 2. And we'll have, it's going to distribute this now, 9x plus 9. 9 times x is 9x, 9 times 1 is 9. Then minus, if I pull the 2 out, I'm just left with this quantity y minus 3 squared. Remember, if you're subtracting that, you're subtracting the whole thing away. So you want to put parentheses, or I like to use brackets here. And inside I'll do the formula. This is y squared minus 6y, then plus 9. Close that down and close this down. If you want to go ahead and simplify now, which I think is a good idea, removing the brackets means you need to change the sign of everything inside. So we'll remove this, and then this will be minus, this will be plus, and this will be minus. Can I simplify anything? Yeah, if you look at it, 9 and negative 9, those would cancel. So really, I could just say this is negative y squared, and then you could write plus 9x and then plus 6y. Again, the order of this really doesn't matter. I know a lot of people are finicky about standard form, but when two variables are involved, there's nothing that's really standard. So let's close this down. You might want to factor out a negative here. I think that would be cleaner. A lot of people like the leading term to be positive. Let's put this as negative, put this as positive, negative, and negative. Okay, let's put this over. Down in the numerator, I can pull that 3 out. And then inside, I'm going to have 2x plus 2. So 2x plus 2. Again, I'm just multiplying 2 times x to get 2x, and then 2 times 1 to get 2. Then plus, if I pull this 3 out, and I should probably highlight this. This is what I'm pulling out here so that's clear. If I pull out the 3 there, I'm going to have a 3 times the quantity y minus 3. So that would be 3y and then minus 9. Okay, so inside of here, looks like I can just do 2 minus 9, which is negative 7. Let's get rid of this. Let's slide this down a little bit like that, and then I'll put a minus 7 there. So I want this negative 2 times the quantity y squared minus 9x minus 6y over this 3 times the quantity 2x plus 3y minus 7. So this is what I'm looking for right there. All right, let's look at question 12. So I think this one's a little bit easier. We have 3 over y minus 2, then minus 9 over y minus 2. Then this will be over. We have x minus 3 over 3 plus y minus 1 over y minus 2. Let me fix that. So what's my LCD? I have y minus 2, y minus 2, y minus 2, and 3. So just 3 times the quantity y minus 2. So let's go ahead and do that real quick. So what is this going to give me? Well, in the numerator, the y minus 2s are going to cancel. So basically, I'm just multiplying these numbers here by 3. So 3 times 3 is 9, and then minus 3 times 9 is 27. If you perform that operation, you're going to get negative 18. So let's put negative 18 there. Then down here, the 3 is going to cancel with the 3, and I'm going to have x minus 3, this quantity times the quantity y minus 2, then plus the y minus 2s are going to cancel here, and I would have 3 times the quantity y minus 1. Make that over there. Okay. For the denominator, can I pull anything out? It doesn't look like it, so I pretty much just have to distribute. So I have negative 18 over. This would be xy. The outer would be negative 2x. The inner would be negative 3y. And then the last would be plus 6. Let's keep going down. So then plus, this would be 3y, and then minus 3. Let me slide down just a little bit more and see what we have. So let me change colors there. I'll have negative 18 over. Let's just put xy first. Again, the order of this is completely irrelevant. Then I'll just put negative 2x next. And then negative 3y and 3y. Those are going to cancel. You can just get rid of those. And then 6 plus negative 3, or 6 minus 3, is plus 3. So this would be my answer here. Let's go ahead and circle this one as our answer. All right, let's take a look at our quiz now. So for the first question, we're told to simplify and write each answer with positive exponents only. So what we have is 3xy to the 4th power. This will be over. We have 3x squared y to the power of negative 1. Okay, so let's just use our quotient rule for exponents. So we have 3 and we have 3. Obviously, we can just cancel that. We don't really need anything there other than just to line that out. And then here we have x and we have x squared. So x stays the same, and we subtract the exponent in the denominator, which is 2, away from the exponent in the numerator, which here would be 1. So this is to the power of 1 minus 2. And then we're going to have this y here. Again, I would subtract this negative 1 away from this 4. So 4 minus a negative 1. Be very careful there. It's minus a negative 1. Minus whatever's down here. This is a negative 1 down here. So let me put this as x to the power of 1 minus 2, which is negative 1. And then times y to the power of 4 minus a negative 1 is like 4 plus 1. So this would be 5. Okay, I'm actually going to erase all of this. And I'm just going to simplify this further. And let me scooch this up a little bit. And basically, you know the rule for negative exponents. If you drag this guy across the fraction bar, you want to just change the sign of the exponent. So in other words, I'm going to take y to the 5th power and keep that in the numerator. I'm going to make a little fraction bar, and I'm going to take this and drag it across. So across the fraction bar. And so now the x part is the same, but the exponent, the sign's going to change. Instead of it being a negative 1, it's a positive 1. So you just leave it as x there. So I'm looking for y to the 5th power over x. So I want this answer right here. For question 2, again, simplify, write each answer with positive exponents. So I'm going to have 2x y to the power of negative 3. This will be over. We have 4xy cubed. All right, so I'm going to write 4 as 2 squared. So I'm going to write this as 2 squared here. And I'll just go ahead and say, let me scroll down a little bit. I'll go ahead and say I have 2 raised to the power of what? This is an implied exponent of 1. So I'm going to go ahead and say 1 minus 2. And then I'll have x to the power of, this is a 1 and this is a 1. Again, you could just cancel it there. You could say 1 minus 1 is 0. But I think for the purposes of this video, we already know that. So let's just cancel this out. And then we have y to the power of negative 3 minus 3. So negative 3 minus 3. So what does this give us? Let me slide down a little bit and get a little room going here. We'll erase everything and come back up. So this is going to be 2 raised to the power of 1 minus 2 is negative 1. And then times y to the power of negative 3 minus 3 is negative 6. So basically, these can both go into the denominator. We need to change the sign of the exponent, though, in each case. So I'm just going to say this is 1 over. This would be 2 to the 1st power, or just 2. And then this would be y to the power of 6. So we'd have 1 over 2y to the 6th power. So I want to get this answer right here. 1 over 2y to the 6th power. All right, for question 3, we have xy squared over, we have 2y to the power of negative 2. We have x to the 4th power, y to the 4th power. And then all this is wrapped in parentheses, and it's going to be squared. So let me actually copy this. I don't think we can do that in line. All right, so let's see what we can do here. I'm going to use my power to power rule here to apply this exponent of 2 to everything inside. So this would be x squared. Y would be raised to the power of 2 times 2, which is 4. So it'd be over 2 squared. Y would be raised to the power of negative 2 times 2, which is negative 4. Then you would have x to the power of 4 times 2, which is 8. And then y to the power of 4 times 2, which is 8. Okay, let me see what we have here. It looks like for x, you have x squared here and you have x to the power of 8 down here. So x stays the same. You would do 2 minus 8, which is, of course, negative 6. So you can go ahead and just write that now. And then you would have y. Now, this one's a little bit tricky because you have y to the 4th power here, y to the power of negative 4 here, and y to the 8th power here. So in the denominator, you would need to use the product rule for exponents there to simplify that. So what's going to happen is I'm going to take this first guy here of 4 from right here, and then I'm going to subtract away the result of adding negative 4 plus 8. So negative 4 plus 8. Again, the reason this works is that if I combine these through multiplication, y stays the same. Negative 4 plus 8 is going to be positive 4. So basically, I would have y to the 4th power here and y to the 4th power here. So that's why I want to do it this way, right? Don't just do this, because this is going to give you the wrong answer. So make sure you wrap this operation in parentheses. Of course, we know that 4 minus 4 would be 0, and this is all going to cancel out. So this is y to the power of 0, just 1. And then lastly, you have this 2 squared in the denominator. So you can put that like that. And again, we don't want any negative exponents, so I'm going to put a 1 up here. I'm going to drag this into the denominator, and I'm going to make this exponent positive. And let me put the 2 squared out in front. So I want to look for 1 over 2 squared x to the 6th power. Written a little bit differently. You can put 4 there if you want. It's the same thing. So we want 1 over, in this case, 4x to the 6th power. If you listed this as your answer, it would be perfectly acceptable. Okay, let's look at question 4 now. Again, simplify, write each answer with positive exponents. So it looks like I have 2x cubed, y to the power of 0, and then z, and then we're multiplying this by, you have yz inside of parentheses being squared. This will be over, you have your x squared z to the 4th power. We know that y to the power of 0, again, assuming that y is not 0, is going to be 1. So you can go ahead and line that out and put that that's 1. Just get rid of it. You don't need it. For this one right here, y would be squared and z would be squared. So let me write 2x cubed, then z, then y squared, z squared. Okay. Now again, at this point, if you wanted to make your life a little bit easier, you can combine z and z squared and say that this is z cubed. So let's just go ahead and do that. Okay. Then down here, I have x squared and I have z to the 4th power. So let's go ahead and simplify now. The 2, don't do anything with that. There's nothing to really combine. X stays the same. 3 minus 2 is 1, so just leave x. And then z stays the same. 3 minus 4 is negative 1. And then y squared, nothing to do with that. So let's go ahead and write this as 2xy squared over, again, z to the power of negative 1. I'm going to put z in the denominator, and I'm going to make that exponent now positive. So this would be my answer, 2xy squared over z. So I'm looking for this guy right here, this 2xy squared over z. That's what I'm looking for. All right, let's look at question 5. So we're asked to simplify and then write each answer with positive exponents. So it looks like I have x, y raised to the power of 0. And then we have this z raised to the power of negative 1. And then this is wrapped in parentheses and raised to the third power, or you could say cubed. Then down here for my denominator, I'm going to have x, y squared, z to the fourth power. And this is multiplied by 2x to the power of 0, and then z to the fourth power. And let's see what we're working with. Again, whenever you see something to raise to the power of 0, just cancel and say it's basically 1. You're going to assume that y is not 0 here. I'm going to say that x is raised to the third power or cubed, and then z raised to the power of negative 1 is cubed, so z stays the same. Negative 1 times 3 is negative 3. This would be over. You would have your x, y squared, z to the fourth power, and then times 2. X to the power of 0, I'll just say that's 1, and then z to the fourth power. Again, if you want to do this all in one shot, you can. I think a lot of people like to just combine things in the numerator and denominator separately and then do the main simplification, but it's really up to you. We can do it all in one shot just to get some practice with that. So I have an x here and an x here. So really it's just x raised to the power of 3 minus 1, which is going to be 2. So that's x squared. Then for y, looks like I just have that in the denominator, just a y squared. So let me check these off. I use this, and I use this. And then I have a 2. Let me go ahead and put that out here so we can get rid of that. Now we have the z's. And the z's, that's where it gets a little bit tricky. So you have z raised to the power of what? This is negative 3 up here. And I'm going to subtract away the result of adding 4 plus 4. Because again, z to the 4th times z to the 4th is z to the 8th. So I want to subtract away 8. So again, I don't want to just put 4 here, okay, and then put 4 here because this is going to give me the wrong answer. What I want is to wrap this in parentheses so that this gets done together. 4 plus 4 would give me 8. Negative 3 minus 8 would be negative 11. So let's go ahead and put a negative 11 here. And to completely simplify, let's say this is x squared over, I'm going to say 2y squared, and then I'll bring the z down into the denominator, and I'll make this exponent positive. So this will be my answer. So I'm looking for x squared over 2y squared z to the 11th power. So I want that guy right there. All right, let's look at our quiz. For the first question, we're asked to rewrite using fractional exponents. So let's see, we have the square root of x plus 14. And hopefully you remember this from the lesson. Basically, you would take your radicand, which is this x plus 14. I'm going to wrap this in parentheses. And then I'm going to raise this to the power of 1 over whatever this index is. In this case, it's implied to be a 2. So this would be a 1 over 2 or a 1/2. So I want x plus 14, this quantity raised to the 1/2 power. So I want this answer right here. Okay, let's look at question 2. So here we're just asked to simplify. And this one's pretty easy overall. You have 81 x to the 4th power. This is raised to the 3/2 power. So again, just use the power to power rule. 81 is raised to the 3/2 power. So we'll simplify that using a radical in a moment. And then x to the 4th power is raised to the 3/2 power. So x stays the same. You're going to multiply 4 times 3/2. 4 cancels with the 2 and gives you a 2. 2 times 3 is 6. So this x to the 6th power, that's going to stay unchanged. This part right here, you can simplify that using your radical notation. So essentially, remember, you could break this up into 81 raised to the power of 1/2, and then that could be cubed. And let me write the x to the 6th power there. Okay. So essentially, 81 to the 1/2 power is the square root of 81. So let me write the square root of 81 cubed like this, and then times x to the 6th power. And of course, the square root of 81 is 9. And then 9 cubed would be 729. So this would give me 729 x to the 6th power. And I'm looking for this guy right here. Again, 729 x to the 6th power. Okay, let's look at problem number 3. Again, just asked to simplify. So 343 x to the 9th power. This is raised to the 4/3 power. So 343 to the 4/3 power, let's just do that real quick. Again, you would take the cube root of 343. So 343, let me take the cube root of that first. So that is going to be 7. And then you would raise that to the 4th power. So this would be 7 to the 4th power. So let me just write that way. So 7 to the 4th power. And then you would have x raised to the power of 9 times 4/3. 9 divided by 3 is 3. 3 times 4 is 12. So what is 7 to the 4th power? Well, if you punch that into your calculator, you're going to get 2,401. So this is what we want here. We want this 2,401 x to the 12th power. Okay, let's look at problem number 4. And this one looks complicated. So let's go ahead and say we have y to the 1/4 power, and then z to the 2/3 power. And it looks like this whole thing is wrapped in parentheses, and it's raised to the 7th power. Okay, let me put this over. Down here, it looks like this part right here is going to simplify to 1. Let me go ahead and write it out, though. So x to the 3/2 power, and then y to the 5/3 power, z squared. Again, this is all wrapped in parentheses here and raised to the power of 0. So we know as long as x, y, or z are not 0, and we're going to assume that they're not, when you raise this expression to the power of 0, you're going to get 1. We'll do that in a moment. So I'm going to put times. Over here, you have this y to the 7/4 power, and then you have z to the power of negative 1/2. And let's see what we have. I'm going to use my power to power rule in the numerator. So you'd have y to the power of, let's go ahead and say this is 7/4, 1/4 times 7. And then z to the power of, let's just go ahead and say this is 14/3. And that's coming from 2/3 times 7. Okay, so the numerator's done. In the denominator, again, this right here, we're going to assume that that's not 0, and raising it to the power of 0 would give me 1. So this is going to be a big fat 1 there. Okay, so I'm left with this y to the 7/4 power, and then I have z to the power of negative 1/2. Well, I really don't have to do much to see that this is going to cancel with this, right? Same thing over itself is 1, as long as it's not 0. And so let me scroll down here a little bit. I just have to deal with this z to the power of 14/3 over z to the power of negative 1/2. So keep z the same, and I'm going to do 14/3 minus a negative, so minus a negative 1/2. You would need a common denominator there. So the LCD would be 6. So let me multiply this by 2 over 2. This would be 28 over 6. So 28 over 6. I'm going to change this to plus instead of minus a negative. And then this I could change to 3/6. Okay. So if I do the addition here, 28 plus 3 is going to be 31. So this would just be 31 over 6. So 31 over 6. So we're looking for z to the power of 31 over 6. So I'm looking for this guy right there. Okay, let's look at question 5. All right, so inside of parentheses here, it looks like I have x to the 4/3 power, and then y is going to be squared. Z is raised to the power of negative 2. X is squared. Y is raised to the negative 3/2 power, and then you're going to have another z. Okay, so let me close that down. This is all going to be cubed. Okay, in the denominator, it looks like you have x to the power of negative 1, and then y to the power of 1/2. Okay, so just a lot of simplifying. All right, so to start off, let me just use my power to power rule. X would stay the same. 4/3 times 3 would be 4. So this is x to the 4th power. Let me change colors here. So this is x to the 4th power. And then basically you'd have y raised to the power of 2 times 3, which is 6. And then z raised to the power of negative 2 times 3, which is negative 6. And then you have x raised to the power of 2 times 3, which is 6. And then you have y raised to the power of negative 3/2 times 3. That'll be negative 9/2. And then lastly, z to the power of 3. Okay, so let's write this over. You have x to the power of negative 1 and y to the power of 1/2. Let's just simplify everything in one go. So I'm going to say I have x raised to the power of what? In the numerator, I have a 4 and I have a 6, right? So those would be added because this is multiplication. So let's go ahead and do 4 plus 6. That would give me an x to the 10th power. In the denominator, I have a negative 1. So really, this should come up here, right? It would be x to the 1st power. But I'm just going to subtract away a negative 1, which is like adding a 1. So really, I could just do 4 plus 6 plus 1. So this would be x to the power of 11. And again, if I wrote x to the power of 1 up here, you would have x to the power of 4 plus 6 plus 1. So again, if you do it this way, 4 plus 6 first, then subtract away a negative 1, it's the same thing. You get x to the power of 11. So let me check off this and this and this to just show that I used it so we can forget about it. Now you're going to have this y here. Okay, so I have a 6 and a negative 9/2 here. So 6 plus negative 9/2. And then I'm going to subtract away this guy in the denominator, which is a 1/2. Okay, so let's think about this. I need a common denominator. Let me write this as 12 over 2. And 12 minus 9 is 3, so this is going to be 3/2. So this is going to be 3/2. And then basically minus a 1/2. So 3 minus 1 is going to be 2, and 2 over 2 is 1. So this will just be y. All right, so let me check off this and this and this. And now I have z to the power of negative 6 times z cubed. Z stays the same. Negative 6 plus 3 would be negative 3. So I could really just drag this across the fraction bar and say this is z cubed down here. So I'm looking for this answer right here. I want x to the 11th power y over z cubed. All right, let's take a look at our quiz. So for the first question, we're told to evaluate each, and we're given the principal fourth root of 1,296. So again, what I'm looking for is a number that when multiplied by itself 4 times gives me this radicand of 1,296. And because there's not a negative sign out here, it's a principal root, right? So we want a positive number. Now, when I think about this guy, if we didn't want to use a calculator, we'd have to go back to our pre-algebra days, and we'd basically have to make a factor tree or factor enough to where it's extremely obvious what the answer is going to be. So I would start by just looking at this guy. It's kind of a big number. You could do long division with it. I would say something like, I know it's even, so it's divisible by 2, but I would look at the final 2 digits and say, okay, I know it's going to be divisible by 4 now. So I would start with that. I would do some long division and say, what is 1,296 divided by 4? And that would give me 324. So I would have 4 and 324. Of course, 4 is 2 times 2, and then we're going to stop there. Those are prime. This guy ends with 24. So again, I can divide by 4. So I would put 4 here, and I would put 81 here. Okay. At this point, you can stop because you know 81 is 9 times 9, and 9 is 3 times 3. But for the sake of completeness, let's just fill this out. So this is 2 times 2, and this is 9 times 9, and this is 3 times 3. So at this point, you can see what it's going to be, right? Because you have 4 factors of 2, and you have 4 factors of 3. So basically, you have 4 factors of 6. So 6 to the 4th power gives me 1,296. So that tells me the 4th root, or the principal 4th root to be more specific, of this 1,296 is going to be positive 6. Okay, let's look at question 2. So we're asked to evaluate each, and so we have the cube root of this negative 512. So again, because this guy is odd here, I can have a negative radicand in the real number system. It just means I'm going to have a negative here. So I usually just put that there and forget about it. And I would just think about 512. And again, if you're using your calculator, in most cases, that's what you're going to do. You'd already have the answer, right? But if you didn't have the calculator handy, what could you do? Well, you would look at 512, and again, you would just make a factor tree. It ends in a 12, so I know it's divisible by 4, so let's start with that. And this is going to be 128 times 4. Now, a lot of you know 128 is 2 to the 7th power, but if you didn't, you could keep going, right? So I could divide this by 4 again, because it ends with 28, and this would give me 32 here. Now, once you get it down to 32, then pretty much everybody knows this is 8 times 4, right? So I could go 8 times 4 here, and then 8. Let me slide down a little bit. I'll come back up in a second. 8 is 4 times 2, and let me put 2 times 2 in each case. So 2 times 2, and 2 times 2, and 2 times 2. Right, so if I circle all these, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So basically, 512 is 2 to the 9th power. And we can think about this with exponents, just get a little practice. This is a 3 here, so I want to write this as 2 to something raised to the 3rd power. Again, I just said that it was 2 to the 9th power, so I could divide 9 by 3 and get 3. Basically, because reversing that and using my power to power rule, 2 stays the same. Multiply exponents 3 times 3 gives you 9. So basically, 2 cubed is cubed to give me this 512. Again, forget about the fact that's negative. So 2 cubed is 8. So 8 is what I'm looking for. Put the negative out in front, and I'm looking for negative 8. That is going to be my answer here. Okay, let's look at question 3. Now, this one's going to be really hard without a calculator, or I would say really tedious. The number 16,384 is a perfect fourth. So what does it mean when we say something's a perfect square or a perfect cube or a perfect fourth? Remember, a perfect square means that there's some rational number that will multiply by itself to give you the number. So 4 is a perfect square. 16 is a perfect square, so on and so forth. Perfect cube, there's some rational number that multiplies by itself 3 times to give you the number. So 8 is a perfect cube, right? 2 cubed is 8. Perfect fourth means there's some rational number that multiplies by itself 4 times to give you the number. But the problem is this number is gigantic. So what do? Again, if you don't have a calculator, you have to do some long division. You would notice that it ends with a 4, so it's an even number. It also ends with 84. So you would say, okay, I know it's divisible by 4. And then you could also check 384. You might know that that divided by 8 would give you 48. So I know this entire number would be divisible by 8. So I could start with 16,384. And I could just do long division and divide it by 8 to start. and that would give me 2,048. Now, again, this is still a really big number, but I'm a little closer. I can see immediately that this is 48 here, and I know that 48 is divisible by 8, so I could do this again. I could put an 8 here and put 256 here. Now, most people know that 256 is 2 to the 8th power. But again, if you didn't, you could divide by 8 again, and you could get this to 32 here. Okay, now I'm not going to complete this factor tree because I think it would be too long. Let me just put this as 8 times 4, and I think that's good enough. We have 1, 2, 3, 4 factors of 8, and then we have 1 factor of 4. So each time I have 8, that's 2 cubed, right? So I have 2 cubed, and then I'm going to raise this to the, again, I have 1, 2, 3, 4 of those guys. And then times, I'm basically going to have 4, which is 2 squared. So let me get rid of this. So this, 2 stays the same. Multiply exponents, 3 times 4 is 12. And then times 2 squared. So this tells me I have what? 2 stays the same, add exponents. 2 plus 12 is going to be 14. So this number here, if I go to the prime factorization of it, is 2 to the 14th power. Now, given this information, is this a perfect fourth? No, because 14 is not divisible by 4, right? You would have to write this as something like, let's say 2 to the power of 7 halves raised to the 4th power like this in order to get that to work. And 2 to the 7 halves power, that's not a rational number, right? This would be like if I said the square root of 2, which is not a rational number, and I raise that to the 7th power, okay? And then I raise this to the 4th power. If I did all this stuff, I would end up with that number, the 16,384. So obviously this is not a perfect fourth, right? This guy is not a rational number. So let's go ahead and put false here. Okay, let's look at question 4. So this one's pretty straightforward. It says here we're going to assume that our variable is a real number. So remember, when you get that assumption, you have to think about absolute value bars. We're told to simplify, and we have the square root of, looks like x to the 8th power and then y to the 6th power. So what you want to do here is try to match up the index with what this is raised to. So again, a square root has an implied index of 2. So I'm just going to try to say that I want something here squared. So put your x and put your y, and again, for these exponents, just divide. So 8 divided by 2 is 4, and 6 divided by 2 is 3, okay? And the reason I'm doing that is because, again, this is an index of 2. Well, this is going to cancel with this, right? So the radical is gone. And what we're left with is the x to the 4th power, and then we're left with the times the y cubed. Now, the problem here is that you were squaring this guy, okay? So if you're squaring something that's negative, you get a positive, okay? If you square something that's 0 or positive, you just get what you started with, okay? But you have to account for that, so you need to use absolute value bars here. But with x to the 4th power, it's always going to be non-negative. So you really can drop the absolute value bars there and just say your answer is x to the 4th power times the absolute value of y cubed. So I want this answer right here. So x to the 4th power times the absolute value of y cubed. All right, let's look at question 5. This is very similar to the last one. Again, we're going to assume that our variable is any real number. So we want to simplify. We have the square root of x squared minus 20x plus 100. So that's going to factor into x minus 10, quantity squared. So the idea here, again, is that this guy here is going to cancel with this guy here. So the radical is going to cancel, and you're left with this x minus 10. But again, you need to use absolute value bars here because let's say you plugged in something here. As an example, I used 6. So if I did 6 minus 10, I would have negative 4. And then if I squared negative 4, I would get positive 16. And then if I took the square root of positive 16, I'm going to be back to 4, but not negative 4. Okay, I started with negative 4, but I ended up with positive 4. So that's what the absolute value bars are going to do for you. Okay, so you need to make sure you do that here. So this is going to be my answer, the absolute value of x minus 10. All right, let's take a look at our quiz now. So we're told to simplify, and we're going to start with the square root of 75x. Again, what I'm looking to do is factor this number and look for any perfect squares. So in other words, 75 is what? I can think about it as 25 times 3, and 25 is a perfect square, right? It's 5 times 5. So let me break this up and say this is the square root of 25 times the square root of what's left over will be this 3, and then don't forget about your variable x. So the square root of 25 is 5, so we can just replace this and say that this is 5 times the square root of 3x like this. So this is as simple as we can make this. So I want this answer right here, which is 5 times the square root of 3x. All right, let's look at question 2. Now we have negative 5 times the square root of 200x cubed. So I'll deal with the variable in a moment. Again, when you have a square root, you're looking for factors of this number under here that's going to be a perfect square. So 200 I know is 100, which is a perfect square. It's 10 times 10 times 2, right? So I'm going to break this up and say this is -5 times the square root of 100, and then times the square root of 2. I'm going to deal with the variable now. So we have x cubed. Again, this index here, it's not written, but it's implied to be a 2. So whenever this exponent here is greater than or equal to this here, you can simplify. So what I'd want to do is take out the x squared part, right? Because x squared times x is x cubed. So I'm going to put the x squared right there, and I'm going to put the x right there, okay? So breaking it up in this way, I can have this guy. This is really 10x being squared underneath the radical symbol. And you could write it like that for clarity. If you're confused about what's going to come out, you could write it like this and say, okay, well, I have an index of 2, so this is going to cancel with this, and I'm left with just the 10x. So I could say this is -5 times that 10x, and then times the square root of 2x. -5 times 10 is -50. So this would be -50x times the square root of 2x. So I'm looking for this guy right there. All right, let's look at question number 3. So let me actually get a little room. I'm going to write this here and I'll get some room. So 2 times the cube root of, we're going to have 72x to the 8th power. We have y squared, and we have z to the 4th power. So again, I'm thinking about just the number part for right now. 72 is what? Most of us know this is 8 times 9. If you don't know, again, you can factor it using your divisibility rules. But it's 8 times 9, and 8 is really what? It's 2 cubed, so it's a perfect cube. And then times 9 is 3 squared. So I can't do anything with 9, but I can do something with 8. So let's go ahead and break this up and say, put the 2 out in front. I'm going to go ahead and say I have the cube root of 8, and then times, I'm going to have the cube root of this 9. Again, 8 times 9 gets me back to 72. Perfectly legal. Now, variable-wise, again, when you think about this, if your exponent on the variable, so you have an 8, a 2, and a 4, if that guy is greater than or equal to your index of that radical, then you can simplify. So in the case of y squared, you can't do anything, right? So you can just throw that in there now, just to get it out of the way if you want, okay? But for x to the 8th power and z to the 4th power, we can simplify. So here's how I think about it. If I have an 8 there, I think about the next whole number going down that's divisible by 3. Okay, so 8 is not divisible by 3, 7 is not, but 6 is. So let me go ahead and put this as x to the 6th power, okay? And then what would I need to put over here? Well, again, you just use subtraction. 8 minus 6 would give me 2, so this is x squared here. Why did I use subtraction? Because it's the opposite of addition. If I was to multiply this x to the 6th power times x squared, I would use addition. 6 plus 2 would give me back to 8, right? So if I'm trying to get this way, I'm going to use subtraction. 8 minus 6 would give me to 2. Okay, so that's what I'm doing. Then I know that I have z to the 4th power. Again, going down, I would go to 3, right? So I would want z cubed here, and then I would need z here, right? Because again, 3 plus 1 would give me back to 4. So 4 minus 3 will get me to 1 here. Okay, so you can put 1 there for clarity if you want. Now, to think about how this is going to simplify, again, if it's not clear, you can always write this as something here that's going to be cubed. So you could put x raised to some power is going to be cubed. Again, how do you get this? You do the opposite. You do division, right? Because this times this gives me this. So 6 divided by 3 would give me 2, right? Again, 2 times 3 gives me 6. 6 divided by 3 gives me 2. So for clarity, if you want, let me scroll down a little bit, because I know some of you get this completely and some of you will be absolutely lost. I'm going to write this as 2 times the cube root of, again, 8 is 2 cubed. So let me write 2. And then this would be x squared that's going to be cubed. And then z is being cubed. So write it like this, and then cube the whole thing. I think when you first start, this stops you from making silly mistakes. So you know that when this cancels with this, you're left with the 2x squared z, okay? Then times, you have the cube root of 9x squared y squared z, okay? And let's put equals here, and let's put equals here. Forgot to do that. Let's come down here. So we have 2 times, again, when you simplify this, this is going to cancel with this, okay? And you're going to have this 2x squared z, and then times the cube root of 9x squared y squared z. 2 times 2 is 4, so let's just replace that real quick. And basically, this is our answer we're looking for. So I'm looking for this 4x squared z, and then times the cube root of 9x squared y squared z. So I want this answer right here. All right, let's take a question number 4. So we have 3 times, this is going to be the 4th root. We have 567 x to the 7th power, y to the 7th power, z squared. So 567 is not a number we work with very often, but again, you can use your divisibility rules to break it down. I know it's an odd number, so it's not going to be divisible by 2. Let me sum the digits. 5 plus 6 is 11, and then 11 plus 7 is 18. Now, 18 is going to be divisible by 3 and also 9. So let's start by just dividing this by 9. You do that on a calculator, and what you're going to get is 9 times 63. Now, the good thing about 63 is it's 9 times 7. Now, you can keep going and obviously break this into 3 squared and 3 squared, but you don't need to, because essentially what you have here is 3 to the 4th power. So 567 is 3 to the 4th power times 7. Okay. So what I see here is that I can say 3 to the 4th power is 81. So let's write 3 times the 4th root of 81. If you want to write 3 to the 4th power in there so it's clear, that's up to you. And then you're going to put times the 4th root. Let's put 7 there. Okay. So for the variables, again, follow the same rule. This is x to the 7th power, y to the 7th power. This index is a 4. This exponent's a 2. So just put z squared in there now, so you don't have to worry about it. So for x to the 7th power, again, going down, what's the next number that's divisible? It's going to be 4. So let's put x to the 4th power here. Same thing for y, so y to the 4th power. And then what do I need? Again, use subtraction. 7 minus 4 gives you 3. So this would be x cubed, and this would be y cubed, okay? Again, if you go through and multiply, you're going to be adding. So x stays the same, 4 plus 3 gets me back to 7. Y stays the same, 4 plus 3 gets me back to 7. Okay, so that's all you need to do. So then from here, it's really simple. This would be 3 times, again, the 4th root of this guy right here, this would be 3xy. So times 3xy, and then times the 4th root of 7, let's put x cubed, y cubed, z squared. And again, if you're struggling with this step here, you can always take the extra step and say this is 3xy being raised to the 4th power. So wrap it in parentheses, raises to the 4th power. And then you'll see it's more clear when you cancel this with this, and you get this 3xy here. Okay. Last step is just to multiply these two together. And so you're going to have 9xy times the 4th root of 7x cubed, y cubed, z squared. So let me see what I'm looking for. So it looks like this one, 9xy times the 4th root of 7x cubed, y cubed, z squared. So I want this answer right here. Question number 5. We're told to simplify each. And what we have is the 5th root of, we have the square root of 7. So essentially this problem, again, you can use exponents if you want, but I think it's probably easier just to look at it and say, okay, well, this index is 5 and this one's 2. So at the end, your index is going to be 10, right? 5 times 2 is 10. So it's the 10th root of 7, right? So we want this one right here. Again, if it's a little bit confusing for you, you can always rewrite this using exponents. So you can say that you have 7 raised to the 1/2 power. Again, that's from taking the square root. And then you can raise this to the 1/5 power. Again, that's from taking the 5th root. And then power to power rule, this 7 stays the same. 1/2 times 1/5 is 1/10. And again, in radical form, this is the 10th root of 7. So that's how I got that answer right there. All right, let's look at our quiz. So for the first question, we're asked to simplify each. We have -5 times the square root of 12, then plus 5 times the square root of 3. So again, you can only add or subtract like radicals. At this point, they're not like radicals. We do have the same index. We have a square root and a square root, but what we don't have is the same radicand. So if you're faced with this situation, you want to try to simplify. And for the square root of 12, remember, I can put this as the square root of 4 times the square root of 3, right? So I'd have -5 times the square root of 4, which is 2, times the square root of 3, then plus 5 times the square root of 3. I'm just going to replace this square root of 4 with 2. So basically, I'd have -5 times 2, which is -10, then times the square root of 3, then plus 5 times the square root of 3. And now I have like radicals, right? I have the square root of 3 and the square root of 3. So I can add those guys by just taking this number here, -10, and adding it to this number here, which is 5. -10 plus 5 is -5. And then times that common radical, which is the square root of 3. Okay, so I want -5 times square root of 3. I want this guy right there. Okay, let's look at question 2. So we're told to simplify each. We have 2 times the square root of 2x, and then minus 3 times the square root, and I really messed that up, so times the square root of 8x. And again, we need to do some simplifying before we can try to add anything. I know that 8 is what? It's 4 times 2. 4 is a perfect square. So let's go ahead and say this is 2 times the square root of 2x, and then minus 3 times, I'll put the square root of 4, and then times the square root of 2x like this. Square root of 4 is 2, so let's go ahead and say that this is 2 times square root of 2x. Again, square root of 4 is 2, so 2 times 3 is going to be 6, so this is minus 6 times square root of 2x. So again, once we do some simplifying, we have like radicals, so square root of 2x in each case. So we'll go ahead and just say 2 minus 6 is going to give me -4, and then times that common radical, which is the square root of 2x, right? So nothing else I can do to simplify. So let's look for our answer, -4 times the square root of 2x. I want that guy right there. All right, let's look at question 3. So this one looks like it's a bit long. So let's go ahead and say this is -3x times the 4th root. Looks like we have 2x squared y to the 4th power. And let me drag this over here so it all fits. Then I'm going to have plus this 2x times the 4th root. Looks like I'm going to have 405y to the 4th power. And then let's put this down here. Minus 2 times the 4th root of 80x to the 4th power, y to the 4th power. Okay, so a lot of work to do. For this one, let me break this up. I have -3x times, I'm going to go the 4th root of y to the 4th power, and then times the 4th root of 2x squared. Now, you're going to be able to simplify this in the end, but for right now, let's just leave this as it is. We know the 4th root of y to the 4th power would be y. Okay, so I'm going to replace that in a moment. Or actually, I think it's pretty clear. You can write this down in your notes. I'm just going to erase this and put y for right now and move this down so we don't have more steps than we need. So then plus, from this one, let me put the 2x here. For 405, that would be, if you divide it by 5, you get 5 times 81. 81 is 3 to the 4th power. So let's put times, I'm going to go the 4th root of 81, and then let's put y to the 4th power there as well, and then times the 4th root of 5. Okay, so this right here, again, the 4th root of 81y to the 4th power, this is basically going to be 3y, okay? So this is 3y. 2 times 3 is 6, so this would be 6xy. So 6xy. Let's slide this down here. And maybe I can fit this all in one line. Let me move this over a little bit. I think it's possible. So minus, you have 2 times the 4th root of, for 80, it's 16 times 5. Remember, 16 is 2 to the 4th power. So let's put 16 here. And x to the 4th power and y to the 4th power, let's throw those in there, okay? And actually, I don't think I can fit this. So let me bring this down here. And then times, let's go ahead and go the 4th root of, again, this would be 5 here, right? Because 5 times 16 is 80. So this right here, if you simplified it, the 4th root of 16x to the 4th power, y to the 4th power is going to be 2xy, okay? So let's get rid of this and put times our 2xy here. And so -2 times 2 would be -4. So let's write minus 4xy like this. Let me tighten this down a little bit, and let me scooch this down. Okay, so from here, we have like radicals here and here, right? Forget about this one. We're going to simplify this one in the end. I can't really combine that with anything. But for right now, I can focus on these. So basically, I would think about this right here and this right here. Well, those are like terms, right? If I had 6xy minus 4xy, I could combine those, right? Those are like terms. So I could do 6 minus 4, that's going to be 2, and then xy would come along for the ride. Now, this guy right here, this 4th root of 5, we just write that, right? That's our common radical. Now I have the minus 3xy, and then times the 4th root of 2x squared. Now, I can actually simplify this a little further. Sometimes you would leave it like this, but remember, we talked about the fact that if this is a 4 and this is a 2, you can do some further simplifying. So what I could actually do is I could write this, and I'm actually going to put this in front. It doesn't really matter the order, but just for the sake of completeness, let's put negative 3xy. I'm going to write times the 4th root of 2, and then times the 4th root of x squared. And then I'll go ahead and say plus my 2xy times the 4th root of 5. Now again, if this and this has a common factor, right, it's a common factor of 2, you can just divide it away. So I can basically say this is a 2 and this is a 1, right? So this is the square root of x here. Again, if this is not clear or you're confused about why that works, again, if I had something like the 4th root of x squared, this is equal to x squared being raised to the power of a 4th, right? And then power to power rule tells you have x raised to the power of 2 over 4 or 1/2, right? So this is just the square root of x. So if it gets confusing for you when you see it in this form, you can take the extra step or the extra time to go through and write it like this to make it crystal clear what's going on. But the shortcut is just to say, okay, well, I have a common factor between this guy and this guy, cancel the common factor, and you'll just get this here. So I'm looking for this guy on the top here, this negative 3xy times the 4th root of 2 times the square root of x, then plus this 2xy times the 4th root of 5. So this is my answer right there. All right, let's look at question number 4. So what we have here is negative 4 times the square root of 3 minus 5 times the square root of 2. Let me slide this down a little bit here. Then times this quantity 5 times the square root of 3, then minus 2 times the square root of 3. So first terms, negative 4 times 5 would be negative 20. And then square root of 3 times square root of 3 would be 3. So times 3 there. Then the outside, negative times negative would be positive. 4 times 2 would be 8. Square root of 3 times square root of 3 would be 3. Then the inside, negative 5 times 5 would be negative 25. Square root of 2 times square root of 3, let's put square root of 6. Then for the last, you have negative times negative, which is positive. 5 times 2 is 10. Square root of 2 times square root of 3, let's put square root of 6. Okay, so negative 20 times 3 is negative 60. Let's go ahead and replace that. 8 times 3 is going to be 24. So let's replace that. And negative 60 plus 24 is negative 36. And then if we look at this guy, again, you have like radicals. You have the square root of 6 and the square root of 6. So if I do negative 25 plus 10, that's going to give me negative 15. And then times that common radical, which is the square root of 6. So I want negative 36 minus 15 times square root of 6. So I'm looking for that answer right there. Okay, let's look at the last question, question 5. So we have 4 times the square root of 2 minus 4 times 3 times the square root of 2 minus 1. Okay, so first terms, 4 times 3, that's 12. Square root of 2 times square root of 2 is 2. So if you multiply that, you're going to get 24. Then for the outer, 4 times negative 1 is negative 4. Then times your square root of 2. For the inner, you have negative 4 times 3, that's negative 12. Then times the square root of 2. And then for the last, negative times negative is positive. 4 times 1 is 4. Okay, so 24 plus 4 is 28. And then you basically have this negative 4 minus 12, that's negative 16, times this common radical, which is the square root of 2. Okay, so times the square root of 2 like this. So I'm looking for 28 minus 16 times the square root of 2. So that guy right there. All right, let's take a look at our quiz now. So we're told to simplify each. And we're going to start out with the square root of 5 over the square root of 3. Again, we never want to have a radical in our denominator. That's considered not simplified. So to fix this, I'm just going to multiply the numerator and denominator by the square root of 3. Again, this process is called rationalizing the denominator because we're changing this denominator into a rational number. So in the numerator, I just have the square root of 5 times the square root of 3. We can just put that as the square root of 15. Nothing else we can really do. Then over, down here, square root of 3 times square root of 3 is 3. So this would be a simplified answer here. So we're looking for the square root of 15 over 3. So I want this answer right here, square root of 15 over 3. Okay, let's look at question 2. Again, we just want to simplify. We have 2 over 4 times the square root of 3x. So let me make that a little bit better. So the first thing you would do here is notice that you have a 2 and a 4, right? So there's a common factor of 2. 2 divided by 2 is 1. 4 divided by 2 is 2. So I'll go ahead and say this is 1 over 2 times the square root of 3x. And again, just rationalize the denominator there. I'm just going to multiply the numerator and denominator by the square root of 3x. That's all I need to do. So I'm going to have the square root of 3x over. This would be 2 multiplied by square root of 3x times square root of 3x is going to be 3x. So 2 times 3 would give me 6. So let's go ahead and say our simplified answer here is the square root of 3x. You can't do anything with that, over 6x. So I'm looking for this answer right here, square root of 3x over 6x. Okay, let's look at question 3. And this one looks a little bit tougher. So let's go ahead and say we have 3x squared minus 2 times the fourth root of, looks like 3x to the fourth power. Then we're going to be over, and let me make this 4 better. I think that's not legible. So down here in the denominator, 3 times the fourth root, and looks like we have a 3x down here. I don't think we could fit that on the original page. So let's think about this for a second. The fourth root of x to the fourth power, I can simplify that. So let's go 3x squared minus 2. Again, you could write this out. So again, this is all I'm doing. The fourth root of x to the fourth power is equal to x. So this would be x here. And what's left inside, I would have the fourth root of now just 3. Okay, so that's done. All right, so then down here, I have this 3 times the fourth root of 3x. Can I simplify anything else? No. I could factor out an x from here and here, but I can't cancel with anything. So I really don't see the point. So let's go ahead and just copy this actually, or I'll just drag it down here. And I'm going to multiply this numerator and denominator by what I need to make this 3x here into a perfect fourth, right? So it's not as simple as just saying, okay, I want the fourth root of 3x over the fourth root of 3x. You can do that when you have a square root, but when you have a fourth root, really, when you think about it, 3 times 3 is going to be 9. 9 is not a perfect fourth, right? So you have to do more work. You have to think about, okay, well, I have 3x here. What would I need to multiply 3x by to obtain a perfect fourth? Well, this is 3 to the first power, x to the first power. So I need 3 more copies of 3, and I need 3 more copies of x. So 3 cubed is going to be 27, and then x cubed is obviously just x cubed. So what you'd want here is the fourth root. So the fourth root of 27x cubed over the fourth root of 27x cubed. So in the numerator, you really can't do anything other than just multiply this. So 3x squared times your fourth root of your 27x cubed. Nothing there is really going to simplify in terms of that. Then minus, you have your 2x multiplied by. Here, you can do something because the fourth root of 3 times the fourth root of 27 would be the fourth root of 81. Okay, and we can replace that with 3 in a moment. And then times the fourth root of x cubed. So again, the fourth root of 81, remember, 81 is 3 to the fourth power. So this is just 3, right? And if I multiply negative 2 times 3, it's negative 6. So let's put this as negative 6x like this. Let's slide this down. You can get rid of the multiplication symbol if you want, or you can keep it there if you want. It's really up to you. Doesn't matter. Then this is over. Down here, the 3 would be there. And then the fourth root of 3x times the fourth root of 27x cubed would be the fourth root of, this would be 81x to the fourth power. And again, this is a perfect fourth, right? This is going to be 3x raised to the fourth power like this, right? So if I take the fourth root of that, I get my 3x. So let's go ahead and say this is times 3x. And instead of multiplying that together, I'm just going to leave it like this because some of you see that you can cancel, right? So I could write this. Let me go ahead and put minus 3 like this and put times 2 like this, because you might notice, and actually let me put times x like this, you'll see the 3x here, the 3x here, and the 3x here, right? So you see what I'm going to do? I'm going to factor and cancel. So let's come down here for a moment. And let's go ahead and say that we're going to pull out a 3x. Inside, we're going to have x times the fourth root of 27x cubed, and then minus 2 times the fourth root of x cubed. Again, nothing else I can pull out, nothing else I can do inside of there. This is over. I'm going to write the 3x here times 3 like this. Let's go ahead and cancel this with this. And now this is going to be my simplified answer. So basically, I have x times the fourth root of 27x cubed. And let me put that 4 where it goes. And then minus, you have 2 times your fourth root of x cubed. This is over 3. And let me look for the result. It looks like it's this one down here. So x times the fourth root of 27x cubed minus 2 times the fourth root of x cubed. So that matches the numerator. And then over 3, right? So this is what we want down here. That's our answer. All right, let's take a question 4. So negative 5 over, you have 3 plus 5 times the square root of 3x cubed. The square root of x cubed, remember, you could write this as the square root of x squared times the square root of x, right? So this would be x times the square root of x. So let's go ahead and simplify this. And I'll change this to 5 times x times the square root of 3x like this. Let's go ahead and erase this. And let's bring this up here. And now if I want to simplify this, I have this radical here that I need to get rid of. But it's not so simple. If I multiply the top and bottom by the square root of 3x, the problem is I'm not going to get rid of the radical completely. And the reason for that is because I'm still going to have it here, right? So what I actually have to do is use the concept of multiplying conjugates, right? So I'd want to go times 3 minus, right, because this is a plus, 5x times the square root of 3x over 3 minus 5x times the square root of 3x. So doing this is going to completely clear the radical from the denominator, okay? So in the numerator, negative 5 is going to multiply, let me wrap this in parentheses so this is crystal clear. Negative 5 is going to multiply by 3, that's negative 15. And then negative 5 times a negative 5x is positive 25x. And then times the square root of 3x. Okay, down here, again, if you have conjugates, it's the first guy squared, so that's 9. Then minus the second guy squared. Again, don't worry about the guys in the middle because they're going to cancel. So 5x being squared is 25x squared. If you square the square root of 3x, it's just going to be 3x. So 25 times 3 is going to be 75. And then x squared times x is going to be x cubed. So we no longer have a radical in our denominator. And so let's see, can we cancel anything? We have a 15, we have a 25, common factor of 5. Down here we have a 9 and a 75, so nope, doesn't look like it. This is going to be as good as we can get this. And what are we looking for? Looks like this answer right here, so negative 15 plus 25x times the square root of 3x over 9 minus 75x cubed. That's what we want right there. All right, let's look at the fifth question. So what do we have? 5 plus 4 times the square root of 2x over negative 2 minus 4 times the square root of 2x. And let's think about this. Can we simplify anything before we start? It doesn't look like it. So basically, again, because you have this radical down here and there's two terms, you can't just do this. A lot of people will try to just do this, right? And that's going to fall short because when you multiply this by this, you're still going to have a radical, okay? So what you have to do is use the conjugate here, okay? And so you're going to say negative 2 plus 4 times the square root of 2x. Again, you're just keeping these terms the same. You're just changing the sign. So a minus becomes a plus. Okay, that's all you're doing. Terms are the same. So then same thing over here. So negative 2 plus 4 times the square root of 2x. Let's wrap this in parentheses for clarity. Okay. And this is more work because in the top you have two terms. So basically you have to use FOIL. So 5 times negative 2 is negative 10. And then your outer would be, let's see, plus 5 times 4 is 20 times square root of 2x. Inside, 4 times negative 2 is minus 8, then times the square root of 2x. And then the last, we would basically have 4 times the square root of 2x squared. So that's plus 16 times, you'd have 2x, right? Square root of 2x times square root of 2x is 2x. So 16 times 2 is 32. So let's put this as 32x. All right, so can I simplify anything? Yes. So it turns out that I'm going to have like radicals. And basically, I can just do 20 minus 8. That's going to be 12. So let me just get rid of this. And I'll put this as 12 times the square root of 2x. And I'll probably just reorder this. So let me move this over here. And I'll put 32x. And let's put plus, I'll go ahead and say 12 times square root of 2x and then minus 10. How about that? Let's write it like that. Let's bring this up here like that. Okay, so that's my numerator. Again, negative 2 would be squared. Again, if I squared negative 2, I'm squaring both the negative and the 2. So that's going to be positive 4. Then again, you always use a negative there, okay, because you would have, when you do your last terms, negative times positive. And then you're going to square the last guy. So 4 is squared. That's 16. Square root of 2x is squared. So that's going to be 2x. So this is going to give me 32x here. 32x here. Now, am I done? No, because I can factor, right? This is even, this is even, this is even, so I could factor out a 2. This is even, so I could factor out a 2. So let's go ahead and do that real quick. Let's see what we can cancel. So this, I would pull out a 2. I'd have 16x plus 6 times square root of 2x minus 5 over, if I pull out a 2 here, I'm going to have 2 minus 16x like this. And basically from here, I can just cancel this common factor of 2, and that's all I can do. Right, so I have 16x plus 6 times square root of 2x and then minus 5. So you could write it like this. You can really write it in any order that you want. It's kind of up to you. And then I'm going to put this over 2 minus 16x. So I want 16x plus 6 times the square root of 2x minus 5. So if you do this, it's in a different order. So I have negative 5 plus 6 times the square root of 2x plus 16x. So again, it's the same thing. It's just in a different order. And this is over. We have negative 16x plus 2. Same thing, 2 minus 16x. So we'll go ahead and circle this as our answer. All right, let's take a look at our section quiz. We're told here to simplify each for the first problem. Man, it looks like we're going to have 2x to the power of negative 3. Then y to the 4th power. We have z to the power of 0. And this is wrapped in parentheses, and it's all raised to the power of negative 4. And then continuing, we have y that's cubed, and then we have z that's squared. Okay, so that's the numerator. Then this is over. In your denominator, you have x cubed, you have y, and then you have z squared. Before I do anything, you would notice immediately that you have z squared here and z squared here. Just cancel that. It makes your life a lot easier. You have y cubed here and y here. I'm going to remove this, and I'm basically going to cut this down by 1. So this would be y squared. And then basically, let me go ahead and write this as 2x to the power of negative 3, y to the 4th power, z to the power of 0. Again, we're going to assume that z is not 0, so this would be 1. You don't even have to write it. So close this off and put this to the power of -4, and then you'd have y squared right there. And then this is over your x cubed. Now, at this point, you could make a decision. You could use your power to power rule, or if you wanted to, you could drag this entire thing. So you could drag this entire thing into the denominator, and you could change this exponent from -4 to +4. It's really up to you. There's no right or wrong way to do it. It's just what you feel more comfortable with. I'm just going to use the power to power rule because it's a little bit quicker. So 2 to the power of -4, I'll just do that. And then x raised to the power of -3 is raised to the power of -4. So x stays the same. -3 times -4 is going to be +12. And then y raised to the power of 4 is raised to the power of -4. So y stays the same. Multiply exponents. 4 times -4 is -16. And then you have your y squared there. Okay. If you want, you can simplify this at this point. Basically, you're multiplying here. So you would add the exponents. -16 plus 2 is going to be -14. So let's just put that like that. And put this over my x cubed here. Now, x to the 12th power over x cubed. Again, x stays the same. 12 minus 3 would be 9. So let's put this x as x to the 9th power. For these two negative exponents, I'm going to drag these guys into the denominator, and I'm going to change the sign of the exponent. So this would be 2 to the 4th power. Get rid of that. This would be y to the 14th power. Get rid of that. So this is going to be x to the 9th power over 2 to the 4th power, which you could write as 16 if you wanted to, times y to the 14th power. So let me grab this. So it looks like we want this one, x to the 9th power over, again, 2 to the 4th power is the same thing as 16, then times y to the 14th power. So we want this guy right here. Okay, let's look at the second question. Again, we just want to simplify. So it looks like we have 2xy wrapped in parentheses, and that's cubed. And then we have x to the 4th power, y, z to the power of -3. This will be over. We have this 2z cubed. Okay, let's go ahead and say this is 2 cubed x cubed y cubed. Okay, so all I did was use my power to power rule. Basically, this exponent of 3 gets applied to everything inside. Then I have x to the 4th power. I have y, and then we have z to the power of -3. And this is over 2z cubed. Okay. Let's see what we can do to simplify. This one looks pretty easy overall. So we see that we have 2 cubed and we have 2, you could say to the 1st power. So this is 2, and then subtract exponents. 3 minus 1 would be 2, so 2 squared, or you could put 4, whatever you want. And then you have x cubed and x to the 4th power. X stays the same, add exponents. 3 plus 4 is 7. And then basically you have y now, so y cubed and y. Again, this is y to the 1st power. Y stays the same. 3 plus 1 is going to be 4. And then you have a z, right, to the power of -3 here and z cubed here. So let's go ahead and say this is to the power of -3 minus this 3 here. So this would be to the power of -6. And again, all I have to do for this is take this across the fraction bar. So I'm going to put a z down here, and I'm going to change the sign of this exponent. So when you cross the fraction bar, you change the sign of your exponent. So instead of -6, it becomes +6. So this would be my answer, 2 squared, or again, you could write 4, x to the 7th power, y to the 4th power over z to the 6th power. So we want this guy right here. Again, 2 squared is the same as 4. All right, let's look at question 3. So it looks like we have x to the 5/4 power, and then y is going to be squared. Z is raised to the 1/2 power. Let's wrap this in parentheses, and everything is going to be raised to the 2nd power. Then this is over. You have x to the power of 0. You could choose to not write that if you want. I'm just going to put it for completeness. Then y, z to the power of -1/4. And all I'm going to do is use my power to power rule. So let's start off by saying I have x raised to the power of 5/4 times 2. Let me do this off to the side. So 5/4 times 2. This is going to cancel with this and give me a 2 down here. So this is the 5/2 power. Okay, so let's get rid of that. Then y, 2 times 2 is 4. Then z, 1/2 times 2 is 1. Okay, then this is over. Again, x to the power of 0, we're always going to assume that x is not 0 when we get something like that. So we're just going to say that's 1, so you don't even have to write it. Then you have y. Then you have z to the power of -1/4. So we'll deal with that in a moment. So the simplest thing to deal with is going to be this y. So let me just start with that. Y to the 4th power over y. Again, keep y the same, and then subtract exponents. 4 minus 1 is 3. So I know I have y cubed. Let me just check this and this so I don't lose my place in terms of what I'm doing. So then x to the power of 5/2. So x to the power of 5/2. Now that's pretty much all we're going to be able to do. So let me check that off. The last one is z. So this one is a little bit more tricky. So we're going to say to the power of 1 minus, again, this is a negative, so minus a negative 1/4. So with this guy, I changed the minus a negative into plus a positive, and I've got to get a common denominator. So let me go ahead and say this is 4 over 4. So 4 plus 1 is 5 over 4. So let's go ahead and say this is 5/4 like this. So I'm looking for x to the 5/2 power, and then y cubed, and then z to the 5/4 power. So I want this guy right here. Okay, let's look at question number 4. So we're told to evaluate each, and what we have is 32 raised to the power of 7/5. So the idea here is you're going to write this in radical form first. So remember, to do that, just focus on this guy in the denominator. So I'm going to set this up, and I'm going to put this as my index, and this as my radicand, okay? This 7 here, in this instance, it would be best to do it like this. Again, you could raise this to the 7th power first, but that kind of defeats the purpose of what we're trying to do, okay? So what I would do here is first say the 5th root of 32 is going to be 2, and then I would raise 2 to the 7th power, and that would give me 128, okay? So if you get a problem like this, always simplify like this first. So you want to take and simplify your radical, and then whatever that number is, raise it to the power, okay? This gives you a smaller number. If you do it the other way, you're going to get a huge number, okay? And it's going to be harder to deal with. So this is going to be 128 as the answer. All right, let's take a look at question number 5. So we're told to evaluate each, and we're given the cube root of negative 1,728. So we'll take the cube root of negative 1,728. So again, if you're dealing with an odd index here, and this guy's negative, you can go ahead and just put that as a negative. You can forget about it. And just think about the number 1,728. And of course, you can use a calculator and get this answer right away. But if you didn't have one, or if your teacher is not letting you use one for this section, what could you do? Again, you would just want to factor the number and think about, okay, well, the last 2 digits, that's 28. So I know it's going to be divisible by 4. So let me just start by dividing this by 4. And I would end up with 432. And you can see, again, the last 2 digits, that would be something divisible by 4. So you could divide by 4 again. And that would get me to 108 here. So now I'm getting to something that I recognize, because if I divide by 4 again, now I'm going to have 27 here. So let's come down here for a moment, and let's think about what we have. So this 4, let's put this as 2 times 2. And you could circle that. This 4, let's put this as 2 times 2. You can circle that. This 4, let's put that as 2 times 2. Let's circle that. 27 is 9 times 3. Let's circle that. And 9 is 3 times 3. Let's circle those. So I've got 1, 2, 3, 4, 5, 6. So 2 to the 6th power times, I've got 1, 2, 3. So 3 cubed. And let me write 1,728 as 2 to the 6th power times 3 cubed. Now, what I want is something that's cubed, so it can cancel with this index of 3. So this one fits perfectly, but this one doesn't. Okay, so what I can do, again, think about the reverse of the power to power rule. I want something here that is raised to the 3rd power, so I just divide 6 by 3 and I get 2. So this is basically going to be 2 squared or 4, that's cubed, and then times 3 being cubed. So again, we can use some more rules of exponents and say this is 4 times 3 or 12 being cubed. Okay, so this number inside would basically be negative 12. Let's go ahead and write this. I'm just going to get rid of this for a second. I'm going to say this is the cube root of negative 12, like this being cubed. So this ends up being negative 12 as our answer. Okay, so this is what we want right there. All right, let's take a look at the next one. So we want to evaluate. We have the square root. I made that terribly. So the square root of 121 over 400. So the idea here is you're going to split this. So you're going to say the square root of 121 over the square root of 400. And the square root of 121, again, this is going to be 11 squared, right? So the square root of 121 is 11. Again, we're asking for the principal square root. If you had a negative out in front, that's the negative square root. That's where you would get the negative 11, but we're not asked for that. Then your square root of 400, again, the principal square root, that would be 20. And again, if you don't know these things, you can always factor 400. 400 is going to be 100 times 4, okay? And 100 is a perfect square. It's 10 times 10. Well, we also know that 4 is a perfect square. It's 2 times 2. So basically, you could take 2 times 10 and get 20. That's how you could get that square root really quickly. So this is going to be 11 over 20. So I'm looking for this answer right here. Let's look at this guy right here. Let's see. We want the cube root of negative 750. And we have x to the 5th power y. So this one might take a little bit of work. So let's go ahead and cut this away. For 750, it ends with a 0. So I would start, again, if I'm trying to factor this, if I have no idea what's going on, I use my divisibility rules. And I would say, well, this is 75 times 10. 75 is pretty easy. It's 25 times 3. And 25 is what? It's 5 times 5. 10 is 5 times 2. This index is a 3, so I'm looking for something that's going to be a perfect cube, okay? Forget about the negative because we know if this is index as a 3 and this is a negative, this is going to be a negative right here. So just work with the absolute values. You don't need to worry about the negative anymore. So I have a 5, and a 5. That's 125, okay? So that's going to be your perfect cube. Let's go ahead and say negative 125, like this. And then what's going to be left, you have this 3 times this 2, okay? So let's put times this 3 times 2, or 6. So like this. So I'm going to break this up. Let me make this more clear. I'm going to have the cube root of negative 125 times the cube root of 6 like this. And then let me think about the variables here. So y, I can't simplify that. The exponent here is 1. So let me just throw that in there. And then for x to the 5th power, again, you always want to break this up and say, okay, if this exponent here is greater than or equal to this index here, well then going down, looking for something that's divisible, it's going to be 3, right? So I want to break this up into x cubed times x to what power? Just use subtraction. 5 minus 3 is 2, so x cubed goes here, and x squared goes here. Again, why do I use subtraction? Because the opposite is addition. If I'm multiplying x cubed times x squared, I add exponents. 3 plus 2 gives me 5. So in the reverse situation where I'm trying to figure out what's going to go here, remember I'm taking 3 away from 5 to get back to 2. Okay, so that's all I'm doing. So this guy right here is basically a perfect cube. I can say that this is negative 5x being cubed like this, and I want the cube root of that, and then times the cube root of 6x squared y. So this part I can't simplify, this part I can. So I'll go ahead and say that the result of this is negative 5x, and then times the cube root of 6x squared y. So we have negative 5x times the cube root of 6x squared y. So we want this guy right there. Let's look at question number 8. So we're told to simplify. We have negative 8 times the cube root of negative 32x. This is raised to the 10th power, y to the 6th power. So again, I have my negative 8 out in front. Again, if this is negative, then you know a negative is going to come out. You could pull that out now actually and put negative 1 in front and change that negative 8 into a positive 8, but maybe let's wait for that. So let's put a 3 here for the index. Let me put a negative 1 times. For 32, I'm looking for something that's a perfect cube, so I would do 8. 8's a perfect cube, so let me write 2 cubed, or you could write 8, and then times. You would need another 4, so let's put 4 there. Again, 8 times 4 gives me back to 32. And then for x to the 10th power, let me write that as what? What is the next number going down from 10 that's going to be divisible by 3? Well, it's going to be 9. So I'm going to put x to the 9th power. And again, I need one more to get to 10, right? So I'm going to say times x to the 1st power. Then we'll keep going. Y to the 6th power. Again, 6 divided by 3 is 2. So I can just write this as y squared cubed like that, or you can put y to the 6th power if that's clear for you. It's really up to you. And you can really do this one as y cubed like that, okay, if you really want to make it clear. So let's go ahead and pull out what we can. Let me come down here a little bit, see where we are. So we have negative 8 times. I'm going to take the cube root of, let's go ahead and say negative 2, and then we'll go x cubed, and then we'll go y squared. So all of this stuff is going to be cubed, okay? And so I used this guy, this guy, this guy, and this guy, right? So what's left is we're going to multiply by the cube root. I'm going to have this 4, and I'm going to have this x, and that's pretty much it. So this is going to simplify to the negative 2x cubed y squared. Again, this is what's being cubed, so if I take the cube root of it, that's what I get back. So I'm going to have negative 8 times negative 2x cubed y squared. Negative times negative is positive, so this would be positive 16 x cubed y squared, then times the cube root of 4x. So let's look for 16 x cubed y squared times the cube root of 4x. So we want this answer right there. All right, let's look at question 9. So let's take a look at, we're going to have 3 times the square root of 6 plus 3 times the square root of 32 minus 4 times the square root of 18. So first and foremost, can I simplify 3 times the square root of 6? No. So I'm just going to write that. So 3 times the square root of 6. Then plus. Can I simplify 3 times the square root of 32? Yes. Because 32 is 16, which is a perfect square. It's 4 times 4 times 2. So I'm going to put 3 times the square root of 16 times the square root of 2. Square root of 16 is 4. 3 times 4 is 12. Let's go ahead and write that like that. And then we have minus 4 times the square root of 18. Again, look for a perfect square as one of the factors of 18. 18 is 9 times 2. So 9 is 3 times 3, right? So I can say this is the square root of 9 times the square root of 2. And again, the square root of 9 is 3. So this would be 12, like this, and then times the square root of 2. So you can see that you have like radicals here and here, right? And basically, the 12 and negative 12, those are opposites. So these are going to cancel, right? And you're going to be left with just this 3 times the square root of 6 as your answer. So I'm looking for this 3 times square root of 6 right there. Okay, let's look at question number 10. So we're told to simplify each. We have negative 3 times the cube root of 192, and then minus 3 times the cube root of negative 81, and then plus 2 times the cube root of 3. All right, for 192, again, it ends in 2, so I know it's even. It's obviously going to be divisible by 2. Also, if you sum the digits, 1 plus 9 is 10, 10 plus 2 is 12, so it's divisible by 3. If it's divisible by both 2 and 3, it's going to be divisible by 6. This is 6 times 32, okay? Now, I'm looking for a perfect cube. This is 2 times 3, and this, we know, you can just put 2 to the 5th power at this point. So let's put 2 to the 6th power times 3. Okay, that's going to be 192. Now again, if I'm looking for a perfect cube, you need to write this as 2 to some power, cubed like this. So divide 6 by 3, you get 2. So 2 squared is 4. So we're looking for 4 cubed there, which is 64. Let's go ahead and get rid of this. And let's write this as negative 3 times the cube root of, you could put 64, you could put 4 cubed, whatever you want, and then times your cube root of 3. Okay, now again, we're just going to replace this with 4. Let me get rid of that, put times 4, and then of course this would be negative 12. So minus 12 or negative 12, however you want to think about that. Let's slide this down. Okay, so for the next one, we have minus 3 times the cube root of negative 81. The negative can just come out. So I can pull that out now, erase it from here, put a plus sign there. We just change the sign. Now for 81, I can think about that as 27, which is a perfect cube, times 3, right? So I can say this is the cube root of 27 times the cube root of 3. And basically, this guy right here, the cube root of 27 is 3. 3 times 3 would give me 9. So let's slide this down. And then plus, we have 2 times the cube root of 3. So what I have here is a cube root of 3, cube root of 3, cube root of 3, right? So like radicals. So just go through and say, okay, well, I have negative 12 plus 9. That's negative 3. And negative 3 plus 2 is negative 1. So this would be the negative of the cube root of 3. So I'm looking for this answer right here, which is the negative of the cube root of 3. Okay, let's look at question number 11. So we're told to simplify each. We have negative 2 times our square root of 42x. And then it looks like we are multiplying this by, let me scooch this down so I can fit it, the quantity negative 3, and then times the square root of 12x, and then plus 6x. So again, you're just going to go through and distribute this. Now you could simplify this first if you want, but let's just distribute it and simplify it as we go. Negative 2 times negative 3 is positive 6. And then you would have the square root of 42x times the square root of 12x. Okay, let's think about this. For this guy right here, it's 7 times 6. 6 is 2 times 3. So 7 times 2 times 3 times x. This guy is basically 2 times 2 times 3, then times x. So obviously, if we put these together, you can pull out a 2. Every time you find a pair, you can pull out. So you could pull out a 2, and then you could pull out a 3, right? Which means you can pull out a 6, and then you can pull out an x. So I could pull out a 6x from this, okay? So you would basically have 6 times 6x. So those are all going to be used right there, right there, right there, right there. And inside of the square root symbol, you're just going to have 7 times 2 or 14, right? So that's what's going to be left. This would be 36x and then times the square root of 14. Okay, let's get rid of this. Then next, you have negative times positive, which is negative. 2 times 6 is 12, and then you have x, and then times the square root of 42x. Now, can I do anything with 42x under a square root symbol? Remember, this guy breaks down into 7 times 6, or 7 times 2 times 3. There's no perfect square there in the factoring, so I can't do anything. And x there is just to the first power. So this would be my simplified answer, and let's see if we can find it. So 36x times the square root of 14 minus 12x times the square root of 42x. So I want that guy right there. Okay, let's look at problem number 12. So we have 3 minus 7 times the square root of 5, then times negative 5 plus 6 times the square root of 5. 3 times negative 5 is negative 15. Then 3 times 6 times the square root of 5 would be plus 18 times the square root of 5. Then negative 7 times negative 5 is plus 35. Square root of 5 will come along for the ride there. And then lastly, you have negative times positive, which is negative. 7 times 6 is 42. And then square root of 5 times square root of 5 is 5. Okay, let's clean this up. I need to slide this down a little bit. Let me change my colors up so you can tell what I'm doing. And so 42 times 5, let's do that first. That's going to be 210. So I'll put minus 210 here. And if you do negative 15 minus 210, that's negative 225. Then plus, here you have like radicals, right? Square root of 5, square root of 5. So you just need to add 18 plus 35. That's going to be 53. And then times the square root of 5. So I'm looking for negative 225 plus 53 times the square root of 5. So I want that guy right there. All right, let's look at question number 13. So we have 2 times the square root of 5 over 3 times the square root of 2. So again, for this type of problem, you're just trying to rationalize the denominator. So you have this square root of 2 in the denominator. I'm going to multiply the numerator and denominator by the square root of 2. And essentially, in the numerator, you have 2. Square root of 5 times square root of 2 is just the square root of 10. You can't really make that any simpler. In the denominator, you have 3. Square root of 2 times square root of 2 is 2, so times 2. And 3 times 2, you could do it as 6, but again, you're going to be able to cancel, so I would hold off on that, because you can cancel this common factor of 2 between the numerator and denominator, and so you would get the square root of 10 over 3 as your answer. So let's see, we have the square root of 10 over 3 right there. Okay, let's look at question 14. So it looks like we have 3 minus 4 times the cube root of 5x squared over, we have 4 times the cube root of 10x squared. Remember, when you have a cube root, you have to think about these things a little bit more deeply. You can't just use this guy, whatever it is, and multiply it numerator and denominator like you can with a square root. Okay, I have to get a perfect cube. So 10 is 5 times 2, right? So really I need 2 more copies of 5 and 2 more copies of 2. So what I would need is 5 squared times 2 squared, right, to get to a perfect cube. So down here, let me put the cube root. 5 squared is 25. 2 squared is going to be 4. 25 times 4 is 100. Okay, let's put that down there. And then for x squared, you would need 1 more, so I'm just going to put x there. Okay, so let's put that down there, and then let's put that in the numerator as well. So this is legal. So 100x like this. And let's see what we get. So let's go through here, and we'll say this guy times this guy. So 3 multiplied by the cube root of 100x. Can I do anything to make that simpler? No. Then minus. Now you have 4 times the cube root of 5x squared times the cube root of 100x. So this is going to be the cube root. 5 times 100 is 500. And then x squared times x is x cubed. But I can simplify this because the cube root of x cubed is x. So I can get rid of that from there, put it right here. And actually, let me scooch this down here. I'll put the cube root of 500 like this. You can factor 500 into 125 multiplied by 4. So this guy right here, the cube root of 125 would be 5. So you could pull that out. 5 times 4 is 20. You could pull that out there. So this would be gone, and this would be a 4 inside here, okay? Then put this over. Let's go down here. I have my 4 times the cube root of 10x squared times the cube root of 100x. Well, basically, 10 times 100 is 1,000. So let's put this under the symbol. We'll simplify it. So you could actually write this as 10 like this, and then x like this, and this is going to be cubed to make that more clear. So basically, you take the cube root, you get 10x. So let's put times 10x, and this would be 40x. Before I do that, can I cancel? This is a 3, this is a 20, so nothing common there. No x, you have an x, so no, this would be 40x. And really it doesn't look like there's anything else we can do, unless I'm missing anything, which I don't think I am. Let's see. So I want 3 times the cube root of 100x minus 20x times the cube root of 4 over 40x. So I want that guy right there. All right, let's take a look at question 15, our last question. So we're told to simplify, and let's go ahead and write this out. It looks like we're going to have 3 plus 4 times our square root of 5 over 5 times square root of 5, and then minus 2. All right, so I can't just multiply the numerator and denominator by the square root of 5. In this case, I've got to use the conjugate. So I'm just going to multiply by 5 times the square root of 5. And then this is a minus, so I'm going to make this a plus and then a 2. So then 5 times square root of 5 and then plus 2. Okay, so we just have to crank this out. Remember, you're going to have to use FOIL here in the numerator and also in the denominator, but you can use that formula in the denominator to make it a little bit easier. So in the numerator, 3 times 5 is 15, and then you'd have times the square root of 5. And then you'd have 3 times 2, so that would be plus 6. And then plus you'd have your 4 times 5, that's 20. Square root of 5 times square root of 5 is 5. So let's just put that as 100 right now, like this. And then lastly, you have 4 times square root of 5 multiplied by 2. So let's see, that would be plus 8 times square root of 5. Okay, so 6 plus 100 is 106. So let's just do that real quick. And then if I take these two like radicals, I have square root of 5 and square root of 5. 15 plus 8 is 23. So let's go ahead and say this is 23 times square root of 5, like this. And let's get rid of this. And then for our denominator, again, you can use your little formula. If you're multiplying conjugates, again, take the first guy and square it. So basically 5 squared is 25. Square root of 5 squared is 5. 25 times 5 is 125. And then you're going to subtract away. Square the last guy. 2 squared is going to be 4. So 125 minus 4 is just 121. And really, this is all you can do. So let's look for this. So we're looking for 23 times the square root of 5 plus 106 over 121. So this is what we want right there. All right, let's take a look at our quiz. Again, this topic is very, very easy. For the first question, we want to solve each equation for x. We are given x plus 5 equals 17. So this is just us solving basic equations back from the start of Algebra 1 with the addition property of equality. Remember, we can always add the same number to both sides of an equation. We're not going to change the solution set. So here, I just want to undo what's being done to x, right? I'm adding 5, and I need to get rid of that so I can have x by itself on the left-hand side. So what operation undoes addition? We do subtraction. So I'm just going to subtract 5 away from each side of the equation. Again, if you're not comfortable with this yet, you can always do this in a longer format. You can go x plus 5 and then minus 5, or plus, let me write this like this, so plus negative 5 like this, and then just do the same thing to the other side of the equation, so you maintain the solution. So I added negative 5 over here, and I added negative 5 over here, okay? So this right here, 5 plus negative 5, I have undone what's being done to x. This is 0, right? So x plus 0 is just x, and this equals 17 plus negative 5 is going to be 12. Okay, so that's your solution. If you want to check it, just plug in for x. 12 plus 5 equals 17. That's true. 12 plus 5 would be 17. 17 equals 17. So this is a true statement. So this is the answer we want. X equals 12. Let's pick up the pace. So we have solve each equation for x for number 2. X minus 3 equals 12. Again, undo what's being done to x. So we're subtracting away 3. So just add 3 to both sides of the equation. Add 3 here. Add 3 here. Cancel that. You get x is equal to 15. Right? So this guy right there. All right, let's look at question 3. So we have x minus 1 equals negative 20. Again, what's being done to x? I am subtracting away 1, right? So you undo subtraction with addition. I would add 1 to both sides of the equation. This is going to cancel. You get x is equal to negative 20 plus 1 is negative 19. So that's my solution. So I want this guy right here. Now let's look at question 4. So again, we're solving the equation. We have 2x plus 7 equals x minus 5. Again, hopefully this doesn't throw you off too much. A lot of people say that you can't solve this with just addition and subtraction, but you can. So what you would do here, again, is you're trying to get all your variable terms to one side. So you have 2x here and you have x here. I can legally subtract x away from each side of the equation, right? X minus x is 0. So this is canceled out, okay? And then 2x minus x is just simply x. Then I could subtract 7 away from each side of the equation because I'm undoing what's being done to x, okay? So this is going to cancel, and this equals negative 5 minus 7 is going to be negative 12. Okay, so that's really all it is. If we come over here, we're looking for x equals negative 12. All right, let's look at question 5, the last question here. We have 3x minus 7 is equal to 2x plus 10. Again, I'm going to use that same strategy here. So I'm going to subtract 2x away from each side of the equation. Notice that 3x minus 2x would give you just x. Cancel that. And then you could write minus 7 equals 10 if you want, but you could just do this in line. I'm going to add 7 to both sides of the equation. Again, you're just undoing what's being done to x. So add 7 to both sides. So this equals, this is gone, 10 plus 7 is 17. So x equals 17 is our solution. All right, let's look at our quiz now. So we want to just solve each equation for x. For question 1, we have 5x is equal to negative 25. So again, a very simple process. If you want to solve this equation for x, you need to isolate x on one side of the equation. And to isolate it, you need to undo what's being done to it. So we think about this as 5 times x is equal to negative 25. So how do I undo this multiplication of 5 by x? Well, I divide by 5. That's all I have to do. And to make this legal, I've got to do it to both sides of the equation. And so this cancels with this and gives me a 1. 1 times x is just x. And this equals, over here on the right, negative 25 divided by 5 is negative 5. So x equals negative 5 is my solution. So I want this guy right here. All right, let's look at question 2. So again, we're solving the equation for x, and now we have 13x is equal to negative 195. Again, another very simple problem. We have 13 that's multiplying x. So if you want x by itself, you need to undo this multiplication by 13, so you divide both sides by 13. And so this is going to cancel with this and give you 1. 1 times x is just x, and this is equal to, if you punch this into your calculator, negative 195 divided by 13, that's going to give you negative 15. So I'm looking for this answer right here, x equals negative 15. All right, let's look at question 3. So here we have, again, solving for x, 1/4 times x is equal to 18. All right, so how are we going to solve this? Well, this is still multiplication, and I undo multiplication with division. So I could divide both sides by 1/4, but again, it's quicker just to multiply by the reciprocal, right? We want this left side here to just be x, or you could say 1x. And if I multiply a number by its reciprocal, it becomes 1. So if I multiply this by 4/1, and to make it legal, multiply over here by 4/1, well, what happens is this is going to cancel and become 1. So I have 1x, or just x, and this equals, if we just do 18 times 4, which if you punch that into your calculator, you're going to get 72. So x equals 72 is our solution. All right, let's look at question number 4. So we have this 12x is equal to 5x plus 90. Okay, so again, if you have variable terms on each side, you've got to get those all to one side. Okay, so here it's very easy. I'm just going to subtract 5x away from each side. And then basically what's going to happen is this is going to cancel. 5x minus 5x, that's 0. On the left now, 12x minus 5x is 7x. And this equals, on the right, I just have 90. So now I'm thinking about, okay, well, how can I isolate x? Well, 7 is multiplying it. So divide both sides by 7 to undo that. And then essentially 7 divided by 7 is 1. And so what you're going to have is x is equal to, we'll say this 90 divided by 7, and 7 is a prime number, so really you're not going to be able to simplify that. So we'll just say this is 90 over 7. So this is the one we want, x equals 90 over 7. All right, for question 5, the last question of this quiz, we have 5x plus 2 is equal to negative 8x minus 24. Okay, so again, I want to get all the variable terms to one side, and you have this 5x and you have this negative 8x. I'm just going to add 8x to both sides of the equation. And then let's go ahead and line that out. And then you could do this in one step, or you could do it in two. Let's just do it in two so no one gets confused. 5x plus 8x would be 13x. Then plus 2 is equal to negative 24. Okay, so from here, remember, if I want to isolate x, I first have to isolate the term that contains x. So I want to isolate the 13x first. Okay, so what's being done to 13x? Well, I'm adding 2. So to undo that, I need to subtract 2 away from each side of the equation so that this cancels. And now on the left, I just have my 13x. On the right, negative 24 minus 2 is negative 26. From here, it's very simple because I have 13 that's multiplying x. So to get x by itself, I'm just going to undo that, divide both sides by 13. And again, this cancels with this and gives me 1. So I just have x is equal to negative 26 over 13 is negative 2. So x equals negative 2 is what I'm looking for. All right, let's look at our little quiz. So for question 1, we want to solve each equation for x. So we have this negative 5 times the quantity x plus 1 minus 3 times the quantity 9 minus 10x. We make that x a lot better here. Let me slide this down. I don't think I'm going to fit this the way I'm writing it. And then let's say this is equal to 12x plus 11x. So again, the first thing you want to do is just clean up each side as much as you can. So combine any like terms, use your distributive property to clear any parentheses. Negative 5 times x would be negative 5x. Negative 5 times positive 1 would be minus 5. Negative 3 times 9 would be minus 27. And then negative 3 times negative 10x would be plus 30x. And this equals 12x plus 11x would be 23x. On the left-hand side, you could do negative 5x plus 30x, that's going to be 25x. And then negative 5 minus 27 is going to be negative 32. Okay, so this equals 23x like this. So once we've cleaned up each side as much as we can, so I really can't simplify any further, you want to move all your variable terms to one side and all your numbers to the other. As I've told you in previous videos, I like my variable to be on the left, but maybe you like yours to be on the right. It really doesn't matter. It's just personal preference. So I'm going to subtract 23. I should probably make that better. So 23x away from each side of the equation. And I'm also going to add 32 to both sides of the equation like this. So what I'm going to do is show this canceling and show this canceling. And then what we're going to have is 25x minus 23x, that's 2x. And this is equal to my 32 here. So now that you have it in this format, you can completely isolate your variable, right? Because 2 is multiplying this variable x. So to undo that, I can just divide both sides by 2, the coefficient of x. And basically I get that x is equal to 16. Okay, so this is my solution. Again, you can pause the video and check it by plugging it into the original equation. But let's just go back up and answer this guy. And I'm looking for this guy right here, x equals 16. All right, let's look at question number 2. So we have this negative 8 minus 6 times the quantity x minus 6. This equals negative 11 times the quantity x plus 7. All right, so clean up each side. Negative 8, nothing I can do with that right now. Negative 6 times x is negative 6x. And then negative 6 times negative 6 is plus 36. And this equals negative 11 times x. That is going to be negative 11x. And then negative 11 times 7 is minus 77. On the left-hand side, negative 8 plus 36 is going to give me 28. So I could put negative 6x plus 28 like this. And this equals negative 11x minus 77 like this. All right, so what I want to do now, again, is just to move all the variable terms to one side, all the numbers, or you would say the constants, to the other side. So I'm going to add 11x to each side of the equation. So again, this is going to cancel over here. And then I'm going to subtract 28 away from each side of the equation. And so this right here is going to cancel. Let me slide down here real quick. Negative 6x plus 11x is going to be 5x. And this equals negative 77 minus 28 is going to be negative 105. Again, the last step here, I want to isolate x completely. So to do that, again, what's multiplying x? It's 5. So I'm going to divide both sides of the equation by 5. And I'm going to get that x is equal to negative 21. All right, so coming back up here, I want to circle this one. X equals negative 21. All right, let's look at question 3. So we have this negative 4 times the quantity 1 minus 5x. And this equals negative 4 times the quantity x minus 11. Negative 4 times 1 is negative 4. Then negative 4 times negative 5x is going to be plus 20x. And this equals negative 4 times x is negative 4x. And then negative 4 times negative 11 is plus 44. Okay, so we've cleaned up each side. Again, all I want to do, move all my variable terms to one side, all my constants to the other. So let me go ahead and add 4x to both sides of the equation. And let me add 4 to both sides of the equation. So let's go ahead and cancel this and cancel this. And so I'm going to have 20x plus 4x, that's 24x. And this equals 44 plus 4 is going to be 48. Let me slide down here real quick. And let's go ahead and say we're going to divide this side by 24 and this side by 24. And we're going to have x is equal to 48 divided by 24 is going to be 2. So x equals 2 is our solution. So I'm coming back up here. That's what I'm looking for. X equals 2. All right, let's look at question 4. So we have this negative 12 times the quantity 3 minus 2x is equal to negative 4 times the quantity 1 minus 7x. And let's go through this. So negative 12 times 3 is negative 36. Should probably make that a lot better. And then negative 12 times negative 2x, that's plus 24x. And this equals negative 4 times 1 is negative 4. And then negative 4 times negative 7x is plus 28x. All right, so now that each side is simplified as much as I can, I basically want to move all the variable terms to one side and all the constants to the other. So let me subtract 28x away from each side of the equation. And let me add 36 to both sides of the equation. So let's go ahead and cancel this, and let's go ahead and cancel this. Okay, so 24x minus 28x is going to be negative 4x, and this equals, over here, negative 4 plus 36, that's going to be 32. Okay, so now what I want to do, I want to divide each side by negative 4 so that I can completely isolate x, and I'm going to get that x is equal to negative 8. I'm looking for x equals negative 8. All right, so last problem, again, we have this 12x plus 8 times the quantity 7 minus 2x. this equals the negative of x minus 11. All right, so 12x, nothing I can do with that, plus 8 times 7 is 56, and then minus 8 times 2x is 16x. This equals, again, if you have a negative out in front of parentheses, just distribute it inside to each term. So this is negative x and then plus 11. Over on the left, you can simplify further. You have 12x and negative 16x. That's going to be negative 4x. So you have negative 4x, and then you have plus 56. So this equals negative x and then plus 11. So again, move all the variable terms to one side, all the constants to the other. So I'm going to go ahead and say that I'm going to add x to both sides of the equation. And I'm going to subtract 56 away from each side of the equation. So let's go ahead and cancel this and cancel this. Negative 4x plus x would be negative 3x. And this equals 11 minus 56 is going to be negative 45. And then to finish this guy off, again, negative 3 is the coefficient of x, or it's what's multiplying x. So to undo that, I'm going to divide both sides by negative 3. I'm going to get x is equal to positive 15. Okay, so that's my solution. So we come back up here. We want x equals 15. All right, let's look at our quiz now. So we want to solve each equation for x. And let's see, we're given 1,139 over 72. And then minus, we have 4/9 x. This is set equal to 3/2 x. And then minus 29/8. So again, if you have fractions, I would go through the process of clearing the fractions. And to do that, you look at all the denominators and you think about what is the least common multiple of these denominators. That's going to allow you to form an LCD for all the fractions involved, right? So you have 72, 9, 2, and 8. So it looks like it's just going to be 72, right? Because 72 is 9 times 8. So let's go ahead and multiply everything by 72. So if this guy gets multiplied by 72, the denominator is going to cancel. So you have 1,139. And then minus, if you do 72 divided by 9, that gives you 8. 8 times 4 would be 32. So this is 32, then times x, and this equals, if I do 72 divided by 2, that's 36. And 36 times 3 is 108. So this would be 108x. And then minus 72 divided by 8 would be 9. 9 times 29 would be 261. So I'm going to subtract 108x away from each side of the equation. And let's go ahead and cancel this out. I'm going to subtract 1,139 away from each side of the equation. And let's see what we get. Negative 32x minus 108x would be negative 140x. This is equal to, if I do negative 261 minus 1,139, I'm going to get negative 1,400 or negative 1,400. So let's go ahead to isolate this variable x. I'm going to divide both sides by negative 140 just to finish this process off. This is going to cancel. You're going to get x is equal to, the negative over the negative is positive. Let me go ahead and cancel this 0 with this 0. So what is 140 divided by 14? Well, that's going to be 10, right? So my solution here is x equals 10. And go back up here, and this is what I want. Okay, let's look at question 2. So here we have 57 over 10 times x minus 5/9 is equal to x minus 448 over 45. And what is my LCD here? You've got 10. Let me write this out. This one is a little tricky. So 5 times 2. This one is 3 times 3. And this one is 3 times 3, which is 9 times 5. So for the least common multiple here, 5 occurs once here and once here. So it just goes in once. 2 is going to occur only here. So let's put that in. This is 3 times 3. This is 3 times 3. So let's put in 9. So 45 times 2, or 90. Okay, so that's what I need. And so 90 multiplied by this guy right here, 90 divided by 10 is 9. What is 9 times 57? Punch that into your calculator. You're going to get 513. And then times x, and then minus 90 divided by 9 is 10. 10 times 5 is 50. And this equals 90 times x is 90x. And then minus, if I multiply 90 by this guy, 90 divided by 45 is 2. And then 2 multiplied by 448 is going to be 896. So I'm going to subtract 90x away from each side of the equation. I'm going to add 50 to both sides of the equation. And let's see what that gives us. This is going to cancel. This is going to cancel. 513x minus 90x would be 423x. This equals negative 896 plus 50 would be negative 846. Again, final step, I'm just going to divide both sides by 423 so that I can isolate x right there. So divide here by 423. This cancels. X is equal to, we know this is negative. 846 divided by 423, that's going to be 2. So x here would be equal to negative 2. So this is my solution. So I want x equals negative 2. Okay, let's look at question 3 now. So we have this 3 plus 2x is equal to 1/3. It looks like this is wrapped in brackets. We can use parentheses. Any grouping symbols will work. So x plus 3/2. And let's just go ahead and distribute this first, and then we'll just copy it to another page. So we'll go 3 plus 2x is equal to 1/3 times x is 1/3 x. And then plus 1/3 times 3/2. Well, the 3 here would cancel with the 3 here, and you basically have 1/2 or 1/2. So really, you only have a denominator of 3 and a denominator of 2. So the LCD would be 3 times 2 or 6. So just multiply everything here by 6. 3 times 6 is 18. Then plus 2x times 6 is going to be 12x. This equals 6 times 1/3. 6 divided by 3 is 2. And then 2 times 1 is 2, right? But then you have times x. So let's put 2x here. And then plus 6 times 1/2 is going to be 3. So this is 3 here. Okay. So let me subtract 2x away from each side of the equation. And let me subtract 18 away from each side of the equation. And so this is going to cancel here. And this is going to cancel here. And let's go ahead and look at 12x minus 2x. That's going to be 10x. This equals, if I do 3 minus 18, that's going to be negative 15. Let's go ahead and divide both sides of the equation by 10. So this is going to cancel. X is equal to, we know this is negative. This is not going to be an integer, right? So we're going to just simplify the fraction. So 15, let me write that as 5 times 3. And let me write 10 as 5 times 2. And let's go ahead and cancel this common factor of 5 between numerator and denominator. And so I'll say that x equals negative 3/2. So negative 3/2, that's going to be my solution. So x equals negative 3/2 is what I want. All right, let's take a look at question number 4 now. So we're going to switch it up and look at some decimals. So we're going to have 2.4x. So 2.4x minus 3.2. This is set equal to 0.1x plus you have the 1.5 times the quantity x minus 1.6. If you want to clear the equation of decimals, again, completely optional. If you're using a calculator, it's pretty much not something you would do. But if you wanted to do that, you would first want to clear the parentheses just so that you don't have to clear the decimals twice. So let me just copy this. 2.4x minus 3.2 is equal to 0.1x plus 1.5 times x is 1.5x. And then you would have minus 1.5 times 1.6. Again, if you weren't using a calculator, you do 15 times 16, which is 240. And then you would move your decimal point 2 places to the left. So that would basically be 2.4. So from here, now I can look at all the decimal places. Everything pretty much just has 1, right? So you have 1 there, 1 there, 1 there, 1 there, and 1 there. So how do I move the decimal point 1 place to the right so that I can clear it? You just multiply by 10. So as long as I do it by everything in the equation, I'm pretty much good to go. I'm not going to change my solution set. So I'm just going to multiply everything by 10. And again, all I'm doing is moving my decimal point 1 place to the right. So this would be 24x minus 32. This equals, this would now be 1x or just x, plus this would be 15x, and then minus this would be 24. Okay, so we have it in a familiar format. Let's just go ahead and crank this out real quick. We know x plus 15x is 16x, and this is minus 24 over here. On the left, I have this 24x and then minus 32. So what I'll do from this point is subtract 16x away from each side of the equation. Let's go ahead and cancel that. And then what I'll do from here is add 32 to both sides of the equation. And let's now cancel this. All right, so 24x minus 16x is going to give me 8x. This is equal to, you have negative 24 plus 32, which is basically just going to be 8. Let's divide both sides of the equation by 8. Of course, this cancels, and you're going to get x is equal to positive 1. So this is my solution here. If we come back up, we can just circle this one right here. X equals 1. All right, let's look at question 5 now. So we're told to solve each equation for x. So we have this 2.8 times this quantity. Let's just distribute this now. So we have 2.8 times 1, that's 2.8. And then minus, if you do 2.8 times 2.5x, that's going to give me 7x. And then I'll go minus 1.1. And this equals, you have negative 0.04. And then minus 1.2x. So if you wanted to clear the decimals here, again, you have 1 decimal place, none, 1, 2, and 1. So you've got to go with the highest number of decimal places so that everything gets cleared. So you need to multiply by basically 100, right? Because it has 2 zeros in it. So if you multiply by 100, you move your decimal point 2 places to the right. So 2.8 times 100 would be 280. And then minus 7 times 100 is 700. And then times x. And then minus, this guy would be 110. And this equals, this would be negative 4. And then minus, this would be 120x. So 280 minus 110, if I combine like terms, that's going to be positive 170. So let me write this as negative 700x plus 170 like this. And this equals, I have negative 4 minus 120x. And let me just go ahead and say we're going to add 120x to both sides of the equation. And of course, this is going to cancel over here. Let me subtract 170 away from each side of the equation. So this is going to cancel over here. Negative 700x plus 120x is going to be negative 580x. And this will be equal to negative 4 minus 170 would be negative 174. Let's divide both sides by negative 580. So divide both sides by negative 580. And what is that going to give me? Well, x would be equal to, if I do this on a calculator, negative divided by negative is positive. 174 divided by 580 is going to be 0.3. So you could put 0.3 like this, but this is going to be my solution right here. X equals 0.3. All right, let's look at our quiz. We're told to identify each equation as conditional, a contradiction, or an identity. Give the solution if possible. So if you can solve it, solve it. So for this first one, we have negative 6. Let me write this out. So negative 6 times the quantity 8 minus 3x, and then minus 6 times the quantity negative 2x plus 8. And this is equal to 8x plus 8 minus 4x. Negative 6 times 8 is going to be negative 48. And then negative 6 times negative 3x would be plus 18x. And now you have this negative 6 times negative 2x. So that's going to be plus 12x. And then negative 6 times positive 8 is minus 48. So let me see. Can we clean this up? So 18x plus 12x is going to be 30x. So let's say this is 30x here. And negative 48 plus negative 48, or negative 48 minus 48, if you want to do it that way, is going to be negative 96. So let's put this as negative 96 like this. Okay, so this equals, over here, 8x minus 4x is just 4x, and then plus 8. So it looks like we can get a solution here, and this guy's going to be conditional. So let's go ahead and subtract 4x away from each side of the equation. That will cancel. Let's add 96 to both sides of the equation. And let's go ahead and mark that out. We'll cancel that. 30x minus 4x would be 26x. This equals 8 plus 96 is going to be 104. Let's divide both sides of the equation by 26. And we're going to get that x is equal to 104 divided by 26 is 4. So this is our solution. And again, it's going to be a conditional equation because the equation is made true under the condition that x equals 4. Right? If you plug something else in for x, like 3 or negative 2 million or whatever it is, it's not going to be true. So let's come back up and say conditional x equals 4. That's what we want. All right, let's look at question number 2. So what we're going to do, let me just go through this. So negative 3 times the quantity x minus 8. Let me say this is negative 3x. Again, negative 3 times x is negative 3x. Then negative 3 times negative 8 would be plus 24. And then you'd have minus 8x like this. If you want, you can go ahead and combine like terms. So negative 3x minus 8x would be negative 11x. So let me say that I have negative 11x like this, plus 24. This equals, on the right side, negative 8 times x is going to be negative 8x. And then negative 8 times negative 5 is plus 40. And then you have minus 3x. So you can already see you have a problem. Negative 8x minus 3x would be negative 11x. So this is negative 11x like this. And you have the same thing on each side of the equation, right? So you can cancel this. If I added 11x to both sides, this would be gone. So we would actually end up with something like 24 equals 40, which is obviously a false statement. So when this occurs, we say that we don't have a solution, right? There's no solution. And this type of equation is called a contradiction. So we'll circle this one right here, a contradiction, and there's no solution. Okay, let's look at question 3. So here we're going to have negative 4 times the quantity x minus 3. So now that's going to be negative 4x and then plus 12. And then minus 3 times the quantity x plus 4. So let me do negative 3 times x, so minus 3x. And then negative 3 times 4, that's minus 12. And this equals, let me slide this down so it fits, 5x minus 2x. Okay, 5x minus 2x on the right, that's easy, that's 3x. On the left, 12 minus 12 is 0. You can actually just cancel those out. So get rid of that. Negative 4x minus 3x is going to give me negative 7x. So essentially what I can do here is subtract 3x away from each side of the equation. And so this would actually cancel out, and it would become 0. Right? So you'd have negative 7x minus 3x, that's negative 10x, is equal to 0. And let's slide down here just a little bit. Divide both sides by negative 10, and you're going to get that x is equal to 0. So this guy is going to be conditional, and we'll say that x equals 0 is the solution. All right, let's look at question 4 now. So we have negative 64 over 21, and then plus x, and then equals x, and then minus 12 sevenths, and then minus 4 thirds. Now you see that you have x on each side of the equation, so you can get rid of that immediately, right? You could basically subtract x away from each side. It would be gone. The only thing left is to see if this side equals this side, okay? If these two sides are not equal in terms of having the exact same number, then you're going to have no solution. It'll be a contradiction. If they are the same number, it's an identity, right? Because it's always going to be true. So you can clear the equation by multiplying both sides by 21. And what's going to happen is over here, this would be negative 64 is equal to, if I multiply this by 21, 21 divided by 7 is 3. 3 times negative 12 is negative 36. And then if I do 21 divided by 3, that's 7. 7 times 4 is 28. So this is going to be minus 28 here. And so negative 36 minus 28 is negative 64. So you get negative 64 is equal to negative 64. So this is true, right? This is a true statement. So the variable drops out, you get a true statement. Then you know you have an identity, right? No matter what I plug in for x, it's always going to be true, right? So this is what I want, identity, and then your solution would be all real numbers because I can plug in anything I want for x, and I would always get a true statement. All right, let's look at question number 5. So let's take a look at 5 thirds x plus 29 over 6, and then minus 19 over 6 times x. This equals 29 over 6 plus x. And let me slide this down a little bit so I can fit it. And then we're going to have minus 5 halves x, and then minus 12 sevenths. Well, for the LCD, I've got a bunch of 6's, 3 of those. I've got a 2, and I've got a 3. So you don't have to worry about that because 6 is 2 times 3. And then I've got a 7. So basically it would be 6 times 7 or 42 for the LCD. So we're going to multiply everything by 42. So 42 divided by 3 is 14. And 14 times 5 is 70. So this is going to be 70x. And then plus 42 divided by 6 is 7. 7 times 29 is 203. And then minus 42 divided by 6 is 7. 7 times 19 is 133. And then times x. And if you want, you can go ahead and combine like terms now. 70x minus 133x is negative 63x. So let me write this as negative 63x and then plus 203 like this. So this equals, remember, we're multiplying everything by 42. 42 divided by 6 is going to be 7. 7 times 29, again, is 203. And then plus, this would be 42x. And then minus 42 divided by 2 is 21. 21 times 5 is 105. So this would be 105x here. And then minus 42 divided by 7 is 6. 6 times 12 is 72. 203 minus 72 is 131. So let's put this as 131 like this. 42x minus 105x is negative 63x. So this is minus 63x. And you see we have a problem, right? This is going to cancel, right? Because I can add 63x to both sides of the equation. And I'm left with a false statement, right? 203 is not equal to 131. This is always false, right? So let's go back up and say that it's a contradiction and there's no solution. All right, let's look at our quiz now. So we're told to solve each equation. We're going to be looking at some proportion equations. So x over 7 is equal to 3 over 14. Again, to solve these, generally speaking, you just cross multiply. So I'm going to go 7 times 3, that's 21. Set this equal to 14 times x, that's 14x. And from here, what you can do is just divide both sides by 14. And I like my variable on the left, so we can just change it around, or you can keep it over here. It's really up to you. Let me just keep it on the right. So I'm going to put x is equal to For 21 and 14, they're both divisible by 7. 21 divided by 7 is going to be 3. 14 divided by 7 is going to be 2. So you get x equals 3 halves. Let me erase this real quick and just slide back up here. And this is what we want. X equals 3 halves. Okay, let's look at the next one. So we're solving each equation. So probably want to write this down here. So 3x minus 2 over 5 is set equal to 2x plus 17 over 7. And again, I'm going to cross multiply. Now, when 5 multiplies these guys here, wrap this in parentheses in the numerator because you want to multiply by the 2x and the 17. A common mistake is just to do this. So 5 times 2x and then put plus 17. Okay, you don't want to do that. You want to multiply by the entire quantity there, like that. Let me get rid of that multiplication symbol, not needed. And then 7 times the quantity 3x minus 2. So this is setting up our equation. So 5 times 2x is 10x, and then plus 5 times 17 is going to be 85. And this equals 7 times 3x is 21x. And then minus 7 times 2 is going to be 14. I can just subtract 21x away from each side of the equation. And I can subtract 85 away from each side of the equation. So let's go ahead and cancel this and cancel this. 10x minus 21x is negative 11x. And this equals negative 14 minus 85 is negative 99. Let me slide down here real quick. We'll say divide both sides by negative 11, like this. And we get x is equal to positive 9. So that's my solution right there. So this is what I want. X equals 9. Take a look at another one. So we have 7 times the quantity x plus 1. This is over 8. And then this is equal to, we have negative 2 times the quantity x plus 1. And it looks like then outside of that, we have minus 3. And then this is over, we have 15 here. So you might want to clean this up first before you cross multiply. I don't think it's necessary though. So let's just go through and do it as is. I'm going to go 8 times this guy. So 8 times, I'm going to wrap this all in parentheses, negative 2 times the quantity x plus 1. And then minus 3 like this. Close that down. Maybe we'll use brackets so it's a little bit cleaner. So use some brackets there. It's really up to you how you do this. But 8 has to multiply by the result of that. So let's go ahead and put equals 15 times, I'm going to put this in brackets, 7 times the quantity x plus 1. And again, if you don't want to go through all this, you can go through and simplify first. It's really up to you. It's personal preference. Let's come down here. I'm just going to work inside. Otherwise, you could distribute the 8 to this guy and this guy. Again, it's up to you. It's personal preference. So I'm going to say the 8 is multiplied by, inside of here, this is going to be negative 2x minus 2, and then minus 3. Negative 2 minus 3 is negative 5. So basically, to do this multiplication, you get negative 16x, and then minus 40, like this. Let's put equals and equals. And let me clean that up and make that better. So from here, you would have 7 times x, which is 7x, and then 7 times 1, which is 7. So you have 15 times your 7x plus 7, like this. 15 times 7 is 105. X would come along for the ride. Then plus 15 times 7 is 105. Okay, let me slide down here real fast. And let's go ahead and subtract 105x away from each side of the equation. Let's add 40 to both sides of the equation. So let's go ahead and cancel this and cancel this. Negative 16x minus 105x is negative 121x. And this equals 105 plus 40 is going to give me 145. Let me slide down here a little bit. Let's go ahead and divide both sides by negative 121. And let's see what we get. So we get x is equal to the negative of 145 over 121. Now, can I simplify this? Well, 145 is 29 times 5. Now, 121 is a perfect square, right? It's 11 times 11. So this is the answer we're going to go with. X is equal to negative 145 over 121. This is as simple as we can make this in fractional form. So this is what we want here. X equals negative 145 over 121. All right, let's take a look at a word problem. So it says that at a local gas station, it costs $76.96 to fill up a car with a 13-gallon tank. How much would it cost at the same gas station to fill up an SUV with a 28-gallon tank? And obviously it doesn't say this in the problem, but we're assuming it's in the same time frame where the prices haven't changed, right? So essentially what you would do is set up yourself a little proportion. So if you wanted to figure out, like, for example, this 76.96 in the numerator over 13 in the denominator, that would give you the unit rate or the price per gallon of gas, right? We've all done that. We go to the gas station. I guess the number is printed on the side for you when you're pumping the gas. But let's say you were buying food or something like that, and you bought 15 apples and the total was $45. I know that's a lot for an apple, but just for the sake of the example, you would divide 45, the total price paid, by the number of apples, which is 15, and you would find that you get $3 per apple. Okay, it's the same thing here. Total price paid is 76.96 divided by the amount you got, which is 13 gallons. So this would give me a price of $5.92 per gallon. Okay, so what I'm going to do is I'm actually going to set this equal to, this person wants to fill up a 28-gallon tank. So let me put 28 in the denominator and let me put X in the numerator. And of course, you don't need to do this. We already know that the price per gallon is $5.92. So you could just multiply 28 by 5.92, you'd have your answer. But let's just go through it this way, get a little extra practice in. So I'm going to say 13x, right? 13 times x is equal to, I'm going to do 28 times 76.96, and that's going to give me 2,154.88. Divide both sides by 13, and we're going to find, let me make this cleaner, we're going to find that x is equal to 165.76. So that tells me that for 28 gallons to fill that guy up, it's going to be $165.76. Okay, let's look at question 5. So it says that Max went to the local store and priced out a sound system for $171. This is excluding the state and local sales taxes that we pay when we buy something. So he calculated the state and local sales taxes, and the total amount for the system was $184.68. A week later, he found the same system on sale for $159. So what we want to know is how much would Max need to pay in total if he included the state and local sales taxes. So again, a lot of ways you could solve this. What I'm going to do is just set up myself a little proportion. So I'm going to start with 171 over 184.68. So this right here in the numerator is the price without any sales tax. This is the price with sales tax. And I'll set this equal to, this is the price, 159, without sales tax. And I'm going to put X down here for the price with sales tax. So to solve this, I can cross multiply. I would have 171X is equal to, let's punch this into the calculator, 159 times 184.68. That's going to give me 29,364.12. And just divide both sides of the equation by 171. I'm going to say that X is equal to 171.72. So the price with tax would be $171.72. So this is the answer we want right there. All right, let's take a look at our quiz. So we're asked for the first question to convert each repeating decimal into a fraction. So what we're given here is this 0.73. And you'll see that you have this bar on top of the 3. Again, from the lesson, we know that that tells me that that 3 continues forever and ever and ever. And what we want to do is set a variable. You could use X or Y or Z, whatever you want to use, equal to this guy right here. And you could write it in this form, or a lot of people find it better to actually write it in this form. So they'll list a few 3s and then put your 3 dots or your ellipsis there just to show that that pattern continues forever. Now, the first thing you need to figure out is how many digits are in this repeating pattern. In this case, it's just going to be 1 because there's one digit, the 3, that continues forever. So you're going to have this 10 to the power of n, where n is that number that I just talked about. In this case, it's 1. And you're going to multiply both sides of the equation by that 10 to the power of n. So in this case, I'm multiplying both sides of the equation by 10 because n is 1, 10 to the power of 1 is 10. So that would give me 10x on the left-hand side. On the right-hand side, that would move this one place to the right, and that would give me 7.3. And then again, you can list as many 3s as you want after this. So let's just list a few of them here. Really, there is no right or wrong amount of 3s that you list because it continues forever. Now, the next part is pretty simple. You're just going to subtract the first equation away from the second equation, and basically you're just matching up sides to do this. So on the left-hand side, I'm going to do 10x minus x. On the right-hand side, I'm going to go 7 point, again, the 3 repeats forever, minus this 0.7, and again, the 3 repeats forever. So we have this 0, and then point, I'm going to put the 7, and then the 3s just repeat forever. So you can just match up what you have. And this makes it visually obvious what's going to cancel here. Again, how do we do this? We know that all of these guys are the same. If I'm doing a subtraction here, well, this is going to cancel out. What I'm left with on the right-hand side is 7.3 minus 0.7. So that's something I can do. You can use your calculator if you want. I think we can probably just do it here by borrowing. Let's go ahead and make this a 6 and this a 13. 13 minus 7 would be 6. Bring down the decimal point there and bring down the 6. On the left-hand side, 10x minus x would be 9x. Now, what we want to do from here is put this into a whole number here because we want to end up with a fraction. So I'm just going to clear this decimal by multiplying both sides by 10. So that would give me 90x on the left. On the right, I would have 66. As a final step, I'm just going to divide both sides of the equation by 90 so that I can completely isolate x. Let me come down here. And I'll say x is equal to 66 over 90. But we can simplify this fraction and make it a little bit better. 66 I'm going to write as 6 times 11. And for 90, I'm going to write it as 6 times 15. And now what we can do is cancel this 6 with this 6, and I'm left with x equals 11 over 15. Now remember, in the beginning I said x was equal to 0.73, where the 3 repeats forever. So if x is equal to this and x is equal to that, then we can come back up here and say that this 0.73, again where the 3 repeats forever, is equal to 11 over 15. So my answer here is this guy right there. All right, let's look at question number 2. So again, we're asked to convert each repeating decimal into a fraction. This 0.49, where the 49 repeats forever. Now, this guy actually qualifies for a shortcut. So this is something you probably want to know. If your repeating pattern starts immediately after the decimal point. So in this case, the 4 is where your repeating pattern starts. You have 4, 9, then 4, 9, then 4, 9. Well, you can use this shortcut where basically you take your repeating pattern. In this case, it's the 4 and the 9. Put that in your numerator. Then put it over. You're going to count the digits in the repeating pattern. In this case, it's going to be 2. And you put that number of 9s in the denominator. So the denominator is just 99. Okay, so 49 over 99. So that's going to be our answer. For those of you who want to get some practice with this the long way, we can do that as well. Again, let's just say x is equal to this 0.49 like this. And again, you could put the bar here. You could put the 49, 49, whatever you want to do. It's really up to you. In this case, your n value, again, we're multiplying both sides by 10 to the power of n. So the n value is 2 because there's 2 digits in this repeating pattern. So I'm going to multiply both sides by 10 squared, or 100. So I would get 100x is equal to, multiply this by 100, it goes 2 places to the right. So you get 49 there. And then after that, I'll put 0.49 with my bar on top. I'm just going to subtract this equation from this equation. So I'm going to subtract away x, and I'm going to subtract away 0.49, again, where the 4 and the 9 repeat forever. So it's crystal clear here. This is going to cancel out, right? That's gone. And I'm just left with 99x is equal to, in this case, 49. You can see how our shortcut was accurate earlier. We divide both sides by 99, and we're going to end up with x is equal to 49 over 99. So again, coming back up here, we got that with the shortcut. That's going to be our conversion, right? So 0.49, where the 4, 9 continues forever, is equal to, in fractional form, this 49 over 99. All right, let's look at our third question now. Again, we just want to convert the repeating decimal into a fraction, and this one will be 0.4, and then you're going to have this 099. Let me put the bar over the 0, the 9, and the 9, and let's paste this in here. And it's just the same procedure over and over again, so I think you got it at this point. We'll set x equal to this, and you have 3 digits here in the repeating pattern. So you want 10 to the 3rd power, or 10 cubed, which is 1,000. You're going to multiply both sides of the equation by that. So you're going to have 1,000x, and then this will be equal to, this is going to go 1, 2, 3 places to the right. So let's write 4, then 0, then 9. I'll put my decimal point, then 9. What's going to come after this is the pattern's going to continue. Let me change colors here so we can show this. You have your 0, your 9, and your 9. Again, that's repeating forever. All right, so we're subtracting equation 1 from this equation 2. So let's go minus x, and let's go minus 0.4099 like this. And again, it's obvious what's going to cancel here. This guy is gone. And then if we look at what's left, 9 minus 4 would be 5. Bring down the decimal point, bring down the 9, bring down the 0, bring down the 4. Okay, over here, 1,000x minus x is obviously 999x. Let's set these two equal to each other. And what do we want to do? Well, I don't want this decimal point here, so let's multiply both sides by 10. I'm going to get 9,990x is equal to 4,095. Let's divide both sides by 9,990. Let's go ahead and do that over here. And let's say that we have x is equal to this 4,095 over 9,990. Now, this fraction is kind of big. We're not used to simplifying things like this. And what I would do is just use my divisibility rules to chop it down to something that's manageable. You would notice that this ends with a 5 and this ends with a 0, so I know that each is divisible by 5. If I divide 4,095 by 5, I would get 819. So let's write that in there. If I divide 9,990 by 5, I get 1,998. Now, to continue with this guy, I think they're small enough to where we can factor them. This guy right here, if you notice from your divisibility rules, you can sum the digits. 8 plus 1 is 9. 9 plus 9 is 18. So 18 is divisible by 9, so 819 will be as well. If you divide it by 9, you're going to get 91 times 9. And of course, you could write 9 as 3 times 3. And 91 is 7 times 13. So let's write 3 times 3 times 7 times 13. Okay. What about this guy right here? It's an even number, so I know it's divisible by 2. If you divide it by 2, you get 2 times 999. So this would obviously be divisible by 9. You could do 9 or 3 times 3 times 111. So times 111. Now 111, again, you could just sum the digits. 1 plus 1 is 2. 2 plus 1 is 3. So we know it's divisible by 3, and it's going to be 3 multiplied by 37. So again, you can just spend some time and go through and factor everything and then see what's going to cancel. In some cases, the numbers get ridiculously big and then you really need to use a computer. But these are small enough. It takes a little bit of time, but you can do it. So we'll cancel this 3 with this 3. We'll cancel this 3 with this 3. And it looks like that's all I can do. I'm going to have 7 times 13, which is 91, over, I'm going to have 2 times 3, which is 6, times 37, which is 222. So let me make the 2 better there. So I'm looking for 91 over 222. So I want this answer right here. So 91 over 222. If I do that on my calculator, I'm going to get this 0.4 and then 0.99 repeating forever. Okay, let's look at question number 4. So here we have the 0.5 and then 2524. Let's put the bar over the 2524. So we got 4 digits there. And that just means we're going to multiply both sides by 10 to the 4th power now, which is going to be 10,000. So I'm going to have 10,000x is equal to, this is going to go 4 places to the right. So 1, 2, 3, 4. So you have 5252 point. You'll have that 4 there, and then your pattern repeats. So let's put 2524 like this. And then again, you're just going to do your subtraction. I think it's pretty easy at this point. So we're just going to subtract x away from here. We're going to subtract the 0.52524, again, where this part repeats. And again, it's pretty obvious to see that this part's going to cancel out. And what you're going to have, 4 minus 5, you need to borrow. So let's put this as a 1 and this is a 14. 14 minus 5 would give you 9. Bring down the decimal point. This would be a 1, a 5, a 2, and a 5. And let's make this 9,999x. So these two are equal. Let's slide down here. And let me go back to black. I think that shows up a little bit better. So let's multiply both sides by 10. So 99,990x is equal to 52,519. So let's divide both sides by 99,990. Divide over here, 99,990. Okay, slide down here. And let me just write this and we'll try to simplify it. So x is equal to 52,519 over 99,990. Now, it turns out that you're not going to be able to simplify this, but if you wanted to go through this, what I would do, this 52,519 is not something that you're easily going to factor. Okay, so this is one that's super difficult or really tedious where you have to figure out what the square root is and then test all the numbers going up to the square root. And you're going to find out that it's 29 times 1,811. Let me just write that there for reference. So this is 29 times 1,811. Now, down here, this is the one that I would actually work on because it is something you could factor pretty easily. It ends with a 0, so I could start with that. I could say, okay, well, this is 10 times 9,999, And this is pretty easy to factor. You could say it's 9. Let's go ahead and say this is 9 times 1,111. So 10 is obviously 5 times 2. And 9 is 3 times 3. Let's get rid of this. And this guy right here, if you look at it, if you sum the digits in the odd places, so 1 plus 1 is 2. And then if you sum the digits in the even places, 1 plus 1 again is 2. You do the subtraction, you get 0. So I know it's divisible by 11. And if I divide it by 11, I'm going to get 101. So I'm going to go ahead and say that this is times 11 times 101. So this is my prime factorization. Again, you might not be able to figure this one out. You might need a computer for that because it's just so much work. But this one is pretty easy to do. So what you could do, again, if you don't have a computer next to you that's set up to do this for you, then you could factor this part completely. And then you could check this by each of these factors to see, hey, will it cancel with anything? And if it can't, well, you don't really need the prime factorization. You just need to know if it's going to cancel so you can simplify it. So in this case, you see that nothing would cancel. And so we're just going to report this as the answer. So the 52,519 over the 99,990. So we want this guy right there. All right, for question 5, let's look at 0.19795. Again, for most of you, I think that you pretty much got it at this point. If you're struggling, then hopefully this last example will get it for you. You have 4 digits in the repeating pattern, so you want to multiply both sides by 10 to the 4th power, which is going to be 10,000. So I'm going to have 10,000x is equal to, this is going to go 1, 2, 3, 4 places to the right. So I'm going to write 1979, then my decimal point, then the 5, and then I'm going to repeat that pattern. So what I'm going to do here is I'm going to say I have the 9795, put the bar over it. Then from here, all I'm doing is subtracting this equation away from this equation. So let me subtract away x, and let me subtract away this 0.1, and then your 9795. Let's put this as this, and then let's show this as canceling out. On the right-hand side, 5 minus 1 is 4. Bring down the decimal point, then you have your 9791. This will be equal to, subtract away here, and you've got 9,999x. Again, I'm going to clear this by multiplying both sides of the equation by 10. So I'm going to say now 99,990 times x is equal to, this will be 19,794. Let's divide both sides by 99,990. So we're going to divide here, 99,990. Remember, this is the same denominator we had in problem 4. So you should already know how to factor that. Let's put x is equal to, I want to put 19,794 over, remember this was 2 times 3 times 3 times 5 times 11 times 101. Now, think about this guy up here. It's an even number, so I know at minimum I can cancel a 2. I know, let me just mark these out. I know for a fact that I can't use a 5. I also know if I go 1 plus 9 is 10, 10 plus 7 is 17, 17 plus 9 is 26, and then 26 plus 4 is 30. So I know that this guy, because it's divisible by 2 and 3, is divisible by 6. So let me line this 2 and this 3 out over here, and I'm going to divide this in my calculator by 6, and I'm going to get 3,299. So let's get rid of this. Now, if I look at this guy from here, I know that it's not divisible by 3 anymore because it would have been divisible by 9, and it wasn't. So what I can do is say, okay, well, I've already highlighted the 5. I can highlight the 3. Let's check 11. So 3 plus 9 is 12, and you would subtract away 2 plus 9, which is 11. That gives me 1. 1 is not divisible by 11, so it's not going to be divisible by 11. And then for 101, you could just check that really quickly in your calculator, and you can see that it isn't. So we really don't need to do anything else other than multiply these numbers back together. 3 times 5 is 15. 15 times 11 is 165. Then times 101 is going to give me 16,665. So let me put a comma here. And we'll say x is equal to 3,299 over 16,665. So this is what I want right here. This 3,299 over 16,665. All right, let's take a look at our quiz. We're asked to solve for r. And we're given I is equal to PRT. Some of you know this is the formula we use with simple interest, but again, we'll get to that later on in the next section. If we want to solve this for R, let's go I equals P times R times T. What's being done to R? Well, it's being multiplied by P and T. So I'm just going to divide both sides of the equation by pt like this. And we'll see that this is going to cancel and this is going to cancel. And we're going to get r is equal to I over p times t. So I'm looking for r is equal to I over p times t. So I want that guy right there. Now for question 2, we want to solve for g. So we have s is equal to 1/2 multiplied by gt squared. So because this is a fraction here, let me just write this as t squared over 2 like this. And I'm just going to multiply both sides by the reciprocal. So 2 over t squared. So 2 over t squared like this. And then we're going to show this as canceling with this and this with this. So I'm going to have g is equal to, you're going to have this 2s over this t squared. So I'm looking for g is equal to 2s over t squared. So I want this guy right there. All right, let's take a look at question 3. We want to solve this guy for x. And we have x over y minus 1 is equal to, we have zx and then plus b. So if I want to solve for x, I have that here and here. Let's first clear our denominator. Let's multiply this side by y minus 1. I'm just going to wrap that in parentheses for clarity. And over here it's necessary because I'm going to have to do FOIL here. So what's going to happen is on the left, this is going to cancel. So I just have x is equal to. On the right, I'm going to do my FOIL. So zx times y would be zxy, and then minus, you have zx times 1, which is just zx, and then you have this b times y, which is plus by, and then you're going to have a minus there. B times 1 is just b. Now this is a z. Maybe I should put like a mark here or something so that that's clear. It's not a 2, okay, so I don't want anybody to get confused. So I'm going to think about moving this guy over here and this guy over here, so all the terms with x involved can be on one side and everything else can be on the other. So to do that, I would just subtract this zxy, and I would add zx to both sides of the equation. So let me go minus zxy, and let me go plus zx like this. And that kind of looks like a weird 4. I'm not that good at making z's, so let me actually erase all of this. I don't want to get people doubly confused, but this is a z here that I'm writing, or attempting to write. So let's come down here, and I'm going to show this is canceling and this is canceling. And you're going to have x plus, this is a zx, not a 2x, and then minus zxy. Okay, so a z and a z. Just want to make that crystal clear again. This equals by minus b. Now, how can we get x by itself? Notice that it's here, and it's here. Well, basically at this point, we have to factor it out. So we think about it being here, here, and here. And if we pull it out in front of a set of parentheses, I just have x by itself. And it's multiplied by, this would be a 1, and then plus, this would be a z, and then minus, this would be a zy. Let me make the z a little bit better. And this is equal to by minus b. And let's divide both sides of the equation by 1 plus z minus zy. Let's do that over here. So 1 plus z minus zy. And we can cancel this with this. So that's gone. And now I have x by itself on the left-hand side, and it's going to be equal to by minus b. You could factor the b out if you want. You could put b times the quantity y minus 1. I don't remember how the answers are put up there, so I'll have to check that. And this is over. We have 1 plus z minus zy. Let's see if we can find this. So x equals, it looks like it's this one we want. So by minus b, and then over, you have the 1, you have minus cy, and then you have plus z. So it's in a different order, but it's the same answer. So this is what we want right here. Okay, let's look at question 4 now. So we want to solve for y, and what we're given is w is equal to 3y minus x over y. Okay, so we're solving for y, and it looks like what I would do first is multiply both sides of the equation by y, so I can just clear that denominator. So this is going to cancel. And on the left, I have wy. On the right, I have 3y minus x. Now again, if I want to solve for something, I've got to first take all the terms with that variable in it and push it to one side, and everything else has to go to the other. Okay, so what I would do here is move this guy. So you have a y there and a y there. I'm going to move this guy over here. So let's subtract 3y away from each side of the equation. And let's say that we have wy minus 3y is equal to, you'll have negative x. Now again, I'm just going to factor this y out. And what's that going to give me? Well, if I pull it out from here and here and place it out in front of some parentheses, I'll have y times the quantity w. Let me make this w a little bit better. So w minus 3 is equal to this negative x. And again, if I want to solve for y, I need to divide both sides by this w minus 3. So divide by w minus 3. And this guy right here is going to cancel. And you're going to get y is equal to, you can put the negative out in front if you want, and then you'll put x over w minus 3. Okay, so it looks like we want this answer right here. Y equals, you have negative x over w minus 3. Again, this is the negative out in front, but I could put it here, or I could actually wrap this in parentheses and put it down here if you want, but this is the answer we're looking for. Okay, let's look at question 5 now. We're asked to solve for x. So we have z squared, and then we have x minus b squared, and then we have x is equal to z plus b. Okay, so solving for x, you have an x here and here. So really what I'd want to do from here is just factor this guy out. So let's put this right here, put this x, and then z squared minus b squared like this, and this equals z plus b. And so let's divide both sides of the equation by this z squared minus b squared, like this. So z squared minus b squared like this. And then let's cancel this with this. And so x is on the left by itself, and it equals z plus b over this z squared minus b squared. Now, you might remember this from factoring, and you might have forgotten it at this point, but this is the difference of squares, right? If I have z squared minus b squared, this would factor into your z plus b, then times z minus b, right? Z times z is z squared. The outer and inner would cancel, and then positive b times negative b would be minus b squared. Okay, so that's where that comes from. Now you'll notice here that you can actually cancel a common factor of z plus b between the numerator and denominator. And so my answer here would be that I have, let me write this down here. So x equals 1 over z minus b. So I'm looking for this answer right here. So x equals 1 over z minus b. All right, let's take a look at our quiz. We're told to solve each inequality. Looks like we have this negative 2 and then minus this quantity 1 minus 11x. This is greater than 6 times the quantity 3x plus 4. Let me slide this down so we can fit this on the screen. Then minus 10x. I'm just going to clean up each side first. So this is negative 2. I have a negative out in front of parentheses. So I'm just going to change the sign of each term. So this will be minus 1 and then plus 11x. This is greater than, this will be 6 times 3x, that's 18x. And then plus 6 times 4, that's 24. And then minus 10x. On the left, negative 2 minus 1 is negative 3. So let's write 11x minus 3 like this. This is greater than. On the right, 18x minus 10x is 8x, and then plus 24. All right, so from here, I'm just going to subtract 8x away from each side of the inequality. And so this is going to cancel. Then I'm also going to add 3 to both sides of the inequality. And let's cancel this. So 11x minus 8x would be 3x, and this is greater than. 24 plus 3 is going to be 27. As a final step, let's divide both sides of the inequality by 3. We'll say x is greater than 9. So this would be my solution, and I'm looking for x is greater than 9. All right, let's look at question 2. So we have negative 6x plus 2 times the quantity 11x plus 3, and this is less than 4 plus 3 times the quantity 6x minus 4. All right, so on the left-hand side, I've got negative 6x plus 2 times 11 is 22, then times x, then plus 2 times 3 is 6. This is less than, you have your 4, and then plus 3 times 6x is 18x, and then minus 3 times 4 is 12. All right, on the left-hand side, negative 6x plus 22x is going to give me 16x. So let's write 16x. And then plus 6 is less than. If you do 4 minus 12, that's negative 8. So let's go 18x minus 8, like that. And then let's subtract 18x away from each side of the inequality. And then let's cancel this over here. Let's subtract 6 away from each side of the inequality. And so let's cancel this over here. 16x minus 18x is going to be negative 2x. And then this will be less than negative 8 minus 6 is negative 14. I'm going to divide both sides of the inequality by negative 2. But remember, if you multiply or divide an inequality by a negative number, you have to flip the direction of the inequality. So let's go ahead and flip this guy, and we'll cancel this and say x is now greater than negative 14 over negative 2 is positive 7. So x is greater than 7. So I want x is greater than 7. All right, let's look at question 3. again, just solving the inequality, we have 2x plus 9 times the quantity 12 minus 3x. This is less than or equal to negative 6 times the quantity 11 plus 9x. All right, on the left-hand side, you have your 2x, and then plus 9 times 12 is 108, and then minus 9 times 3 is 27, and then times x. This is less than or equal to negative 6 times 11 is negative 66, and then negative 6 times 9x would be minus 54x. All right, on the left-hand side, 2x minus 27x is negative 25x, and then plus 108. This is less than or equal to, I'll put negative 54x and then minus 66. All right, so let me add 54x to both sides of the inequality. Let's subtract 108 away from each side of the inequality. So I'm going to cancel this and I'm going to cancel this. Negative 25x plus 54x is going to be 29x. This is less than or equal to negative 66 minus 108 would be negative 174. As a final step, I'm going to divide both sides of the inequality by 29. This will cancel. I'll get x is less than or equal to. This will be negative. 174 over 29 is going to be 6. So x will be less than or equal to negative 6. That's my solution. So I want this x is less than or equal to negative 6. Okay, let's look at question 4. So it looks like we're going to have this 30 times the quantity x minus 1, then plus 10x minus 20 is greater than 10 times the quantity 4x minus 5. All right, so on the left-hand side, we're going to do 30x and then minus 30, and then plus 10x and then minus 20. And then this will be greater than 10 times 4x, that'll be 40x, and then minus 10 times 5 is 50. Now on the left-hand side, 30x plus 10x would be 40x. So this would be 40x, negative 30 minus 20 would be negative 50. And this is greater than 40x minus 50. So you see you have a problem. You have the exact same expression on each side of the inequality. So this is going to lead to no solution, okay? If this was a greater than or equal to, you'd have an infinite number of solutions. But that's not what we have here. Because what I could do is I could subtract 40x away from each side of the inequality. And I could say that, well, this is going to cancel and this is going to cancel. So now I have negative 50 is greater than negative 50, which is false. So I could go back and say that there's no solution here. All right, let's look at question 5. So here we have negative 8 times the quantity 8x plus 2, and then plus 7 times the quantity negative 11 plus 5x, and I'll put is less than, we have 11x minus 4 plus x minus 7. Okay, on the left-hand side, let's do negative 8 times 8x, that's negative 64x. Then negative 8 times 2, that's minus 16. And then you have 7 times negative 11, that's minus 77. Then you have 7 times 5x, that's plus 35x. This is less than 11x minus 4 plus x minus 7. So if we look at negative 64x plus 35x, that's going to give me negative 29x. Then if I do negative 16 minus 77, I'm going to get negative 93. And so let's say this is less than, over here 11x plus x would be 12x. And then negative 4 minus 7 would be minus 11. And let's add a 93 to each side of the inequality. And let's subtract 12x away from each side of the inequality. And so this would cancel, and this would cancel. Negative 29x minus 12x would be negative 41x. This will be less than, if you do negative 11 plus 93, that's going to give you positive 82. If we divide both sides of the inequality by negative 41, remember, because we're dividing by a negative, we have to flip the direction of the inequality symbol. So this right here is going to cancel. You'll have x is now greater than 82 over negative 41 is negative 2. So this would be my solution. X is greater than negative 2. So I'm looking for this guy right here. X is greater than negative 2. All right, let's take a look at our quiz. So for the first question, we're asked to solve each inequality for x. And what we're looking at here is a 3-part inequality. So we have 8x plus 3 is greater than negative 69, and it's less than or equal to 35. So let's rewrite this. So 8x plus 3 is going to be greater than negative 69, and it's less than or equal to 35. So the idea for this type of inequality is that you want to isolate x in the middle. So you can do the same thing to each part. Now, I first need to isolate this 8x part if I want to eventually isolate x. So what's being done to this? I'm adding 3. So let me subtract 3 away from each part here. And basically, this guy over here is going to cancel. So negative 69 minus 3 would be negative 72. And this would be less than, you're going to have your 8x, which is less than or equal to. If I do 35 minus 3, that's going to be 32. Now, I want x by itself, and what's being done to x is it's being multiplied by 8. So as a final step, let me divide each part here by 8. And basically, this guy right here is going to cancel. So this will be gone. And in the middle now, I have x, and this is greater than negative 72 divided by 8 would be negative 9. And then I'll say, and it's less than or equal to 32 divided by 8 is positive 4. So we're looking for this answer right here, which is that x is greater than negative 9, and it's less than or equal to 4. Okay, let's look at the second question. So we have negative 11 over 6 is less than or equal to, we'll have this 2x plus 2/3. Let me make the 3 a little bit better there. And then we'll say, which is less than negative 1/3. Okay, so you can choose to clear the fractions if you want. Your least common denominator here, you have a denominator of 6, 3, and 3, so it's going to be 6. So you can always do the same thing to each part. So what I can do is I can multiply each part by 6. So if I do that, negative 11 over 6 times 6 would be negative 11. This would be less than or equal to 2x times 6 would be 12x. And then we'll go plus 2/3 multiplied by 6. 6 divided by 3 is 2. 2 times 2 is 4. And we'll say this is less than negative 1/3 times 6. We know that's negative. 6 divided by 3 is 2. So this would be negative 2. Okay, so we've cleared the inequality of any fractions. And now we just go through our normal steps. And basically, I want to isolate this 12x. So what I'll do is I'll subtract 4 away from each part here. And let's just cancel this out. So in the middle, I'm going to have this 12x. We'll say this is greater than or equal to negative 11 minus 4. Well, that's going to give me negative 15. We'll say, and this is less than negative 2 minus 4 is going to be negative 6. So the last step here is to divide everything by 12. That's what's multiplying x. And we're going to have some fractional answers, but that's okay. So let's come down here and say that we'll have this canceling with this. So x is greater than or equal to. We know this fraction would be negative. Let's write 15 as 5 times 3. Let's write 12 as 4 times 3. And then let's cancel this common factor of 3 between numerator and denominator. So this would basically be negative 5/4. So let's put negative 5/4 over here. And then we'll put less than over here. Negative 6 divided by 12, we know this would be negative 1/2. So basically, x needs to be greater than or equal to negative 5/4 and less than negative 1/2. All right, so let's look for this answer. So we're looking for this guy right here. Again, x is greater than or equal to this negative 5/4 and less than negative 1/2. Okay, let's look at question 3. Again, we're asked to solve each inequality for x. So we say we have negative 4 is less than negative 2x minus 6, which is less than or equal to positive 10. And what we can do is, again, isolate this negative 2x part to start. So let me add 6 to each part here. That will take care of this. So what I'm going to have all the way on the left, negative 4 plus 6 would be positive 2. This is less than. We'll have just the negative 2x here because this part has canceled. And we'll say which is less than or equal to 10 plus 6 would be 16. All right, so now I want to isolate x in the middle. And I have that negative 2 that's multiplying that. So let's divide each part here by negative 2. But again, it's very important to remember, if you're working with inequalities and you multiply or divide by a negative, you have to flip the direction of all the inequality symbols that are involved. So this has to be a greater than, and this has to be a greater than or equal to. So this is going to cancel. I'll put x in the middle. And then 2 divided by negative 2 is negative 1. 16 divided by negative 2 is negative 8. So let's slide down here. You always want to rewrite this in the order of the number line. So in other words, negative 8 is to the left of negative 1 on the number line. So I would want to put negative 8 over here in the leftmost position and negative 1 over here in the rightmost position and x in the middle, and just reorder this to where it matches this. We know x is greater than or equal to negative 8, so let's write that. And we know that x is less than negative 1, so let's write that. So basically that would be my answer here. So we can say that x is greater than or equal to negative 8 and less than negative 1. So we want this answer right here. All right, let's look at question number 4. So here we're going to have 3 halves is less than or equal to 1 plus 1/4 x, which is less than or equal to 2. So you can choose to clear the fractions here. I think it's probably worth your time to make the problem easier. You have a denominator of 2 and a denominator of 4. So the LCD would be 4. So you can multiply each part here by 4. So 3 halves times 4. 4 divided by 2 would be 2. 2 times 3 would be 6. So this is less than or equal to. If I multiply 1 by 4, I get 4. Then plus 1/4 times 4 is 1. Then times x would just be x. And this is less than or equal to 2 multiplied by 4 would give me 8. All right, so from here, what I want to do is subtract 4 away from each part so that I can isolate x. So I'll subtract 4 away over here, and over here, and over here. So of course, this is going to cancel. And we'll say that x is greater than or equal to 6 minus 4 is 2. And then we'll say, and it's less than or equal to 8 minus 4 is 4. So we're looking for this answer right here, where again, x is going to be greater than or equal to 2 and less than or equal to 4. All right, let's look at question number 5. So we have 5x minus 9 is greater than negative 54. We'll say, and it's less than 36. So let's add 9 to each part here and see where that gets us. We know that this part would cancel. So what we have here is 5x in the middle, and this is greater than negative 54 plus 9 is negative 45. We'll say, and this is less than 36 plus 9 would be positive 45. So to get x by itself, I'm just going to divide each part here by 5. So let's cancel this. We'll say x is greater than negative 45 divided by 5 would be negative 9. And we'll say, and x is going to be less than 45 divided by 5 is 9. All right, so we're looking for this answer here, where x is greater than negative 9 and less than 9. Let's take a look at our quiz. For the first question, we're asked to solve each inequality. And we're going to be looking at 13 plus 5x is greater than 6x plus 16. Then we have our keyword and. Then we're going to have this negative 17 minus 6x is less than. We'll have negative 9 minus 4x. Okay, so let's look at this first guy up here on the top. We're going to have this, I'm just going to write 5x plus 13 is greater than 6x plus 16. We'll just solve this really quickly and we'll come back up. So let's subtract 13 away from each side of the inequality. Let's also subtract 6x away from each side of the inequality. Let's cancel this and cancel this. 5x minus 6x would be negative x. This is greater than 16 minus 13 would be positive 3. Again, you can either divide both sides by negative 1 or multiply both sides by negative 1. Whatever you do, don't forget to flip the direction of the inequality symbol. So this would be a less than now. And again, I'm just going to do this here. So I'm just going to divide both sides by negative 1. So this would be x is less than 3 divided by negative 1 is negative 3. So I'll just have that solution there, and I'll just write my keyword and. For this guy right here, let me just recopy it. So negative 17 minus 6x is less than negative 9 minus 4x like this. And what I'll do here is add 4x to both sides of the inequality, just like this. And then from here, I will add 17 to both sides of the inequality. Let's see, we're going to cancel this guy and we're going to cancel this guy. So negative 6x plus 4x would be negative 2x. This would be less than negative 9 plus 17 would be positive 8. So what I want to do now is divide both sides of the inequality by negative 2. And again, we want to flip the direction of the inequality symbol. So this cancels. You're going to get x is greater than 8 divided by negative 2 is going to be negative 4. So I'm going to look for the leftmost number in terms of the number line. That's negative 4. So let me start by saying x is greater than negative 4. Then I'm going to put and. We're going to put the x is less than negative 3. When you write it this way, I think it makes it easier to write your three-part inequality. So x is always going to be in the middle for a three-part inequality. And then it's going to be greater than something. In this case, it's greater than negative 4. And then it's going to be and less than something. In this case, it's less than negative 3. That's why writing it in this manner, to where negative 4 is the leftmost on the number line and negative 3 is the rightmost on the number line, it makes it a little bit easier to make your three-part inequality. Okay, so coming back up here, just looking for our solution, we want this guy right here. X is greater than negative 4 and less than negative 3. Okay, let's look at question 2. So again, we're asked to solve each inequality, and we're going to have 3x plus 3 is greater than 3 minus 7x. Then we have our keyword and. We have 9x plus 13 is less than 20 plus 8x. Okay, so let's go through the first one. So again, 3x plus 3 is greater than 3 minus 7x. We see that we have a 3 on each side of the inequality. When you see that, you can just cancel it because you could legally subtract 3 away from each side of the inequality, but this is just a little bit quicker. I'm going to add 7x to both sides of the inequality. This would cancel. And remember, if you're canceling things with addition or subtraction, you end up with 0. So you want to make sure you write that. So this is a greater than here. Over here, 3x plus 7x would be 10x. And of course, if we divide both sides of the inequality by 10, we're going to find that this cancels and x is greater than 0. Let's put 9x plus 13 is less than 20 plus 8x. And let's subtract 13 away from each side of the inequality. Let's subtract 8x away from each side of the inequality. And what I'll do is cancel this guy, and I'll cancel this guy. 9x minus 8x would be x, and this is strictly less than. 20 minus 13 would be 7. Let's put our keyword and in there. Let's drag this up here. So you see how you have it to where 0 is the leftmost number on the number line, and it's the leftmost in the statement here. And 7 is the rightmost number on the number line, and it's the rightmost in the statement. You could rearrange it, and it's not technically incorrect. But when you write it like this, it makes it easier to make your 3-part inequality. What you want to do is put x in the middle, and then think about, okay, well, what's it greater than? What's greater than 0? And what's it less than? Well, it's less than 7. So x is greater than 0 and less than 7. So coming back here, I want this guy right here where we say x is greater than 0 and less than 7. All right, for question 3, again, we want to solve each inequality. This one's going to be more tedious because we have fractions. So we have 3 halves x minus 7 fourths. This is greater than 1 plus 5 thirds x. Then we have our keyword or. We have negative 7 thirds x minus 2 thirds. This is less than 3 halves x minus 3 halves. Okay, so if you want to clear the fractions, from the first guy right here, you have a denominator of 2, a denominator of 4, and a denominator of 3. So the LCD would be what? It would be 4, which is 2 times 2, times 3, which is 12. So if I multiply 3 halves by 12, 12 divided by 2 is 6, and 6 times 3 is 18. So let me write 18x, then minus, if I divide 12 by 4, I get 3. 3 times 7 is 21. This is greater than, multiply this by 12, I get 12, then plus. 12 divided by 3 is 4. 4 times 5 is 20. So this is 20x. So let's add 21 to both sides of the inequality. That's going to cancel. And let's subtract 20x away from each side of the inequality. That's going to cancel. So 18x minus 20x is going to give me negative 2x. This will be greater than 12 plus 21 is going to be 33. To finish things up, let's divide both sides of the inequality by negative 2. And let's not forget to flip the direction of this inequality symbol here. So this will be a less than now. So let's show this as canceling. We have x is less than 33 over negative 2. So let's put negative 33 over 2. Of course, 33 is an odd number, so it's not going to be divisible by 2. Okay, so let me write the word or in there so we don't forget, because I think this is going to get cut off. So from this guy right here, again, your LCD now would be 6. You have a 3, a 3, a 2, and a 2. So if I multiply everything by 6, 6 divided by 3 is 2. 2 times negative 7 is negative 14. Then x, then minus. 6 divided by 3 is 2. 2 times 2 is 4. This is less than. 6 divided by 2 is 3. 3 times 3 is 9. Then times x, then minus. Again, 6 divided by 2 is 3. 3 times 3 is 9. Doesn't look too bad from here. Again, if you don't want to clear fractions, that's up to you, but I think it's worth it with fractions, but not worth it with decimals. So let's add 4 to both sides of the inequality. Cancel that. Let's subtract 9x away from each side of the inequality. Cancel that. Negative 14x minus 9x is negative 23x, and this is strictly less than. Negative 9 plus 4 is going to be negative 5. So to finish things up, let's divide both sides of the inequality by negative 23. This is again going to flip. And what we'll have here is this canceling, and we'll show x is now greater than, negative over negative is positive, and you have 5 over 23, and each of those is a prime number, so you can't simplify that. So we have our solution here. X is less than negative 33 over 2, or x could also be greater than 5 over 23. Okay, so this is what we want. X is less than negative 33 over 2, or x is greater than 5 over 23. Okay, let's look at question 4. So what we're given here is 8x plus 16 is less than or equal to 6x minus 4. Okay, then we have or. We have 13x minus 12 is greater than or equal to 6x minus 5. What I would do is start with the 8x plus 16 is less than or equal to 6x minus 4. So let's subtract 16 away from each side of the inequality. That cancels. Let's subtract 6x away from each side of the inequality. That cancels. 8x minus 6x is 2x, and this is less than or equal to. Negative 4 minus 16 is going to be negative 20. Let's divide both sides of the inequality by 2. This cancels. You get x is less than or equal to negative 20 divided by 2 is negative 10. Okay, so this was an or, so let's write that because I think it's going to get cut off, and you might forget. So for this one, let's crank that out real quick. We have 13x minus 12 is greater than or equal to 6x minus 5. All right, so let's add 12 to both sides of the inequality and subtract 6x away from each side of the inequality. This cancels, this cancels. 13x minus 6x would give me 7x. This is greater than or equal to negative 5 plus 12 is going to be 7. So if we divide both sides of the inequality by 7, this cancels. You get x is greater than or equal to 1. So let's write this x is greater than or equal to 1. So what we're looking for is this one here. X can be less than or equal to negative 10, or x can be greater than or equal to 1. Okay, let's look at question 5. So we have 5 times the quantity negative 2x plus 2 is greater than or equal to negative 7 times the quantity x plus 2. Might as well distribute this now. So 5 times negative 2 is negative 10. So let's put negative 10x and then plus 5 times 2 is 10. This is greater than or equal to negative 7 times x is negative 7x. And then plus negative 7 times 2 would be negative 14. Let's just write minus 14 like this. Let's get rid of this. Then I'm going to have my keyword and. For this one, let's just distribute it now. So 4 times x would be 4x. Then plus 4 times 2 would be 8. This is greater than or equal to. You have negative 8 times 5x. That's minus 40x. Then you have negative 8 times 10. That would be minus 80. Okay, so for the first one, your negative 10x plus 10 is greater than or equal to negative 7x minus 14. Again, we'll subtract 10 away from each side of the inequality. That'll cancel. We'll add 7x to both sides of the inequality. That'll cancel. If I look at negative 10x plus 7x, that's negative 3x. This is greater than or equal to negative 14 minus 10 would be negative 24. So let's divide each side of the inequality by negative 3. This cancels. I have x is less than or equal to negative 24 divided by negative 3 is positive 8. All right, so let's write and here. Then we'll take the next one. So 4x plus 8 is greater than or equal to negative 40x minus 80. So let's subtract 8 away from each side of the inequality. That's gone. Let's add 40x to both sides of the inequality. So that's gone. You're going to get 44x is greater than or equal to. This negative 80 minus 8 is going to be negative 88. So let's divide both sides of the inequality by 44. This is going to cancel. You get x is greater than or equal to. Negative 88 divided by 44 would be negative 2. So again, when you work with and, it's probably a little bit better to think about this when you think about the smallest number. Again, think about the number line. What's the leftmost? It's negative 2. So let me write that first. So x is greater than or equal to negative 2. Write your keyword and then you have x is less than or equal to 8. Again, you don't have to do this, but I think it makes it a lot cleaner and a lot clearer in terms of writing your solution. So you have x in the middle if you're writing a three-part inequality. What is it greater than? Well, it's greater than or equal to negative 2. So it's greater than or equal to negative 2. What is it less than? Well, it's less than or equal to 8. So it's less than or equal to 8. So once it's written in this format, we're really quickly able to identify the proper three-part inequality that we need. And so I'm looking for this answer right here, where x is greater than or equal to negative 2 and less than or equal to 8. All right, let's take a look at our quiz. So we're told to solve each equation. And what we have is 1 minus 8 times the absolute value of, we have 10 plus 10x. Let's just write that as 10x plus 10. And then we'll set this equal to 1. So what we want to do is isolate the absolute value operation on one side and then just have a single number on the other. So let's subtract 1 away from each side of the equation. So that's going to cancel. So now what I'll have is this negative 8 times the absolute value of 10x plus 10. And this is equal to, this would cancel and be 0. So since I have this negative 8 that's multiplying this guy, I'm going to divide both sides of the equation by negative 8. Let me slide down here real quick. And so this is going to cancel. And then we'll have the absolute value of 10x plus 10 is going to be equal to 0 divided by negative 8 is just going to be 0. So for this type of equation where the right side is 0, you only have to set up one single equation. So I only have to do 10x plus 10 is equal to 0. I don't need a compound equation with or there because if you think about numbers whose absolute value would be 0, well, 0 is the only one that can produce that. So let's slide down here. And let's think about subtracting 10 away from each side of the equation. That would cancel. And you get 10x is equal to negative 10. Let's divide both sides of the equation by 10. This would cancel. You get x is equal to negative 1. So that's what I'm looking for. So I just want x equals negative 1. Okay, let's look at question 2. Again, we're asked to solve each equation. So let's go 1 plus 2 times the absolute value of 3x minus 8. And this equals 27. Okay, so on the left-hand side, let me subtract 1 away from each side of the equation. Let's cancel this. And we'll have 2 times the absolute value of 3x minus 8. We'll set this equal to 27 minus 1 is 26. Let's divide both sides of the equation by 2. And we'll have this canceling. So the absolute value of 3x minus 8 is equal to 26 divided by 2 is 13. Okay, so for this one, it's a usual setup for us. And what we're going to do, this kind of looks like 81. So let me fix that and put this in black. Let me put this in black here as well. What we're going to do is we're going to take 3x minus 8, so the expression inside the absolute value bars, we're going to set it equal to 13. Then we're going to say or, we're going to take that expression again, so the 3x minus 8, and we're going to set it equal to the negative of this number, so negative 13. So what I'll do here is I'll add 8 to both sides of the equation, and this will cancel. We'll have 3x is equal to 13 plus 8 would give me 21. Let's divide both sides of the equation by 3. This would cancel. You get x is equal to 7. So then over here, let's add 8 to both sides of the equation. We're going to get 3x is equal to negative 13 plus 8 is going to be negative 5. Let's divide both sides of the equation by 3. This would cancel. So I'm going to put or x is equal to negative 5/3. So you're going to get x equals 7 or x equals negative 5/3. So coming back up here, this is what I want. X equals 7, and then or you could also have x being equal to negative 5/3. Okay, let's look at question 3. So we have 9 times the absolute value of 8x minus 2, and then plus 10 is equal to 28. All right, so let's subtract 10 away from each side of the equation to kick things off. What I'll have here is 9 times the absolute value of 8x minus 2, and this equals 28 minus 10 is 18. Let's slide down here. Let's divide each side of the equation by 9. And so this is going to cancel here, and we'll have the absolute value of 8x minus 2 is equal to 18 divided by 9 is 2. Slide down here, and basically I just want to set up, I'll say 8x minus 2 is equal to 2, then or we'll do 8x minus 2 is equal to, again, the negative of 2. So from here, just solve these two equations. So we'll add 2 to both sides of the equation here. This will be 8x is equal to 4, divide both sides by 8, and of course this is going to cancel, and you're going to have that x is equal to 4 divided by 8 is basically a half, or you can put 0.5 if you want, it's really up to you. Then over here, let's add 2 to both sides of the equation. This will cancel, and you'll have 8x is equal to negative 2 plus 2 is 0. So obviously there, x is going to be 0, but for completeness, let's divide both sides of the equation by 8, and we'll show this or here, x is equal to 0. So we can say that x is a half or x is 0. Let's come back up here. We want x equals 1/2 or 0. All right, let's look at question 4. So we have 5 times the absolute value of 10 minus 5x, then minus 8 is equal to negative 48. All right, so the first thing I'm going to do is add 8 to both sides of the equation. That way I can cancel this away. I'll have 5 times the absolute value of 10 minus 5x is equal to negative 48 plus 8 is going to be negative 40. So you already see that you're going to have a problem. This has to be completely isolated in terms of the absolute value operation before you determine that there's a problem. But I can already see that there's a problem because my next step is what? I'm going to divide both sides by a positive 5. And I know a negative divided by a positive is still a negative. So this would be isolated and equal to a negative. So I know in advance there's going to be no solution. But for the sake of completeness, let's go through everything. And let's say that we have the absolute value of 10 minus 5x is equal to negative 40 divided by 5 is negative 8. And again, if you have the absolute value operation isolated and it's set equal to some negative value, there's no solution. It's not possible to plug something in for x here and then perform this whole operation and take the absolute value and get a negative number. You can't get negative 8, you can't get negative anything. The result of this whole thing will either be 0 or some positive number. So this is not possible. So there is no solution here. Okay, so let's go back up and mark this one right here. All right, let's look at question number 5 now. So what we'll have is the absolute value of 13x minus 4. This is equal to the absolute value of negative x plus 11. So for this type of setup, what you want to do is first just drop the absolute value bars. So pretend like they're not there. So you would solve the equation 13x minus 4 is equal to negative x plus 11. So that is your first setup. Then you're going to go OR. The second setup, just drop the absolute value bars. So let me go 13x minus 4 is equal to negative x plus 11. Now pick one of these expressions. It doesn't matter if you pick the one on the left or on the right, but it can't be both. You're just going to pick one. You're going to wrap it in parentheses. You're going to put a negative out in front. So I want the negative of one of these. So let's just use this one like this. And again, you could have wrapped this one and put a negative out in front. It would turn out the same way. Okay, so it's really up to you. So let me move this down a little bit so it all fits. Okay, on the left, what we're going to see is we're going to add 4 to both sides of the equation. And I'm going to add x to both sides of the equation. So this will give me 14x. That'll cancel. This will be equal to, this will cancel. 11 plus 4 is going to be 15. So let's divide both sides of the equation by 14. And we're going to get that x is equal to 15 divided by 14. Well, it's just 15 over 14. You really can't do anything there because 15 is 5 times 3 and 14 is going to be 7 times 2. So x equals 15 over 14. Okay. Actually, let me just get rid of this, and let's work on this one now. So I'm going to distribute this negative to each term inside the parentheses. So in other words, what I'm going to do is just make each term inside the parentheses into its opposite. So you would have negative 13x and then plus 4. This is negative x plus 11. Okay, so let's take the time and add x to both sides of the equation here. And then let's also subtract 4 away from each side of the equation. So let's cancel this one and this one. Let me slide down here a little bit. So we have negative 13x plus x, that's negative 12x. And this equals 11 minus 4 would be 7. So as a final step, let's divide both sides of the equation by negative 12. And so we're going to cancel this with this. And I'm going to have x is equal to negative 7 over 12. So I'm just going to come back up here. And I'm just going to say that x could be equal to negative 7 over 12. Again, usually you just write your solution like this. You say x is equal to, let's go negative 7 over 12, comma, 15 over 14. So I'm looking for this guy right here. So x could be equal to 15 over 14, or we could have negative 7 over 12. All right, let's look at our quiz. We're told to solve each inequality. And what we have here is negative 3 multiplied by the absolute value of negative 5x minus 1. Then we're subtracting away 2. And this is less than or equal to negative 89. Okay, so the first step here, when you solve an absolute value inequality, is to isolate the absolute value bars. I know we have a negative over here on the right-hand side, but don't make any decisions yet until this guy is isolated. So what I want to do is add this 2 to both sides of the inequality. And then this is going to cancel. So we'll have negative 3 times the absolute value of negative 5x minus 1. This is less than or equal to negative 89 plus 2 is going to be negative 87. Let's divide both sides of the inequality by negative 3. Remember, if you do this, you have to flip the direction of the inequality symbol. So this will now be a greater than or equal to. And what's going to happen is this would cancel with this. So I have the absolute value of negative 5x minus 1 is greater than or equal to. Let me actually slide this down a little bit like this. Negative over negative is positive. You're going to have 87 over 3. Now, 8 plus 7 is 15, and 15 is divisible by 3, so I know 87 will be. And if I do that on my calculator, 87 divided by 3, I'm going to get 29. Okay, so now this looks like something we know how to solve. And basically, if you have a greater than or equal to, like we have in this case, you want to set up a compound inequality with OR. So that means I'm going to take what's inside the absolute value bars, so negative 5x minus 1, and I'm going to say it's greater than or equal to 29. Then OR, I'm going to take what's inside the absolute value bar, so negative 5x minus 1. I'm going to flip the direction of this, so this will be less than or equal to, and then I'll make this negative, so this will be negative 29. All right, so let's start with this one on the left. I'm going to add 1 to both sides of the inequality. That would cancel. You would have negative 5x is greater than or equal to. 29 plus 1 is going to be 30. Let's now divide each side of the inequality by negative 5. So let me circle this and show that this is going to flip. So now it's a less than or equal to because, again, we divided by a negative. This cancels. We have x is less than or equal to. 30 divided by negative 5 is going to be negative 6. Let me actually just erase this, and let's just drag this up here. So we have our first part, which is x is less than or equal to negative 6. Let me scooch this down just a little bit so it fits in there nicer. So over here, let me add 1 to both sides of the inequality. That cancels. You have negative 5x is less than or equal to negative 29 plus 1 is negative 28. Let me divide both sides of the inequality by negative 5. And we'll see that this is going to cancel. This is going to flip. So now it's going to be a greater than or equal to. And so what we're going to have here is that x is greater than or equal to negative over negative is positive. This would be 28 over 5. Let's get rid of this. Drag this up here. So x is less than or equal to negative 6, or x is greater than or equal to 28/5. All right, so coming back here, again, I want this one, x is less than or equal to negative 6, or x is greater than or equal to, you have your 28/5. So this guy right here. Okay, let's look at question 2. So now we're going to see 8 times the absolute value of 2x minus 8. And then plus 8 is less than or equal to 104. So again, what I want to do is isolate the absolute value operation on one side, have a number on the other. So let's subtract 8 away from each side of the inequality. Of course, this would cancel. So on the left here, you have 8 times the absolute value of 2x minus 8. And this would be less than or equal to 104 minus 8 is going to give me 96. So from here, let's divide each side by 8 so we can completely isolate that absolute value operation. And of course, this is going to cancel. You have the absolute value of 2x minus 8 is less than or equal to. If I do 96 divided by 8, that's going to be 12. So from here, I have a less than or equal to. So that means I want a compound inequality with and. It's actually easier to write this as a 3-part inequality. So what I'm going to do is I'm going to take this 2x minus 8, and I'll say that it's less than or equal to 12. And then remember, you're also going to say that it's greater than or equal to negative 12. Okay, so if you want to write this with and, you can, but I think it's a little bit quicker to solve it as a 3-part inequality. So let's go through here, and let's add 8 to every part. And this, of course, is going to cancel. And I'll have 2x isolated in the middle. This is greater than or equal to. We have negative 12 plus 8. That's going to be negative 4. And then over here, we'll say is less than or equal to 12 plus 8 is going to be 20. So as a final step here, let's divide each part by 2 so we can completely isolate x. So this is going to cancel. You'll have x is greater than or equal to. Negative 4 divided by 2 is negative 2. We'll say and it's less than or equal to 20 divided by 2 is 10. So here x is greater than or equal to negative 2 and less than or equal to 10. So I'm looking for this one right here. Again, x is greater than or equal to negative 2 and less than or equal to positive 10. Okay, let's look at question 3. So we're going to have 9 plus 3 times the absolute value of 5x minus 10. This is greater than or equal to negative 51. So from here, again, if you see something on the right side that's negative, don't immediately make a decision. Always isolate your absolute value operation first, because you need to get information, even if it is negative, about whether it's going to be all real numbers or no solution. Okay, so what I want to do here is first subtract 9 away from each side of the inequality. This will cancel. And what I'll have is 3 times the absolute value of 5x minus 10. This is greater than or equal to. What is negative 51 minus 9? That's going to be negative 60. Let me slide down here. And let's divide each side of the inequality by 3. And so we see that this would cancel here. And what I'd have is the absolute value of 5x minus 10 is greater than or equal to. Negative 60 divided by 3 is negative 20. Now, we have the absolute value operation isolated, so we can make a decision. We would say that the result of this right here is going to either be 0 or some positive value. That's what the absolute value operation does. Now, is 0 or some positive value going to be equal to some negative value? No. Will it be greater than some negative value? Yes, always. So for this guy, you would say that the solution is all real numbers. So all real numbers. Because no matter what I plug in for x, once I perform these operations here and take the absolute value, it's always going to be either 0 or positive, so it will always be greater than this negative 20. So let's select all real numbers as our solution. Okay, let's look at question number 4. So here we have 2 times the absolute value of x plus 1/2, and then minus 3/4. This is less than negative 39/4. Okay, so for this guy, if you want to clear the fractions, you can multiply both sides by the LCD, which is 4. Don't worry about inside the absolute value bars yet. You're still going to have a fraction there. So what we're going to do is we're going to say that I'm going to multiply this side right here by 4, and I'm going to multiply this side by 4. And essentially 4 times 2 is going to give me 8. And then you still have times the absolute value of x plus 1/2. So you still have a fraction, but it's inside the absolute value bar, so don't worry about it for right now. Then minus 4 times 3/4 would be 3. This is less than 4 divided by 4 is 1. So this is just negative 39. So again, don't make any decisions about what you need to do until you isolate the absolute value bars. I know we have a negative there, but in some cases that would flip. So let's go ahead and add 3 to both sides of the inequality. That would cancel. We have 8 times the absolute value of x plus 1/2. And this would be less than negative 39 plus 3 is going to be negative 36. And then from here, what I'm going to do is divide both sides of the inequality by 8. So this would cancel. And I have the absolute value of x plus 1/2 is going to be less than. We know this would be negative. Each here would be divisible by 4. If I divide 36 by 4, I get 9. If I divide 8 by 4, I get 2. So from here, you would think about the fact that you have a negative value over here. So negative 9/2, and now you have a less than. So this is a different situation than having a greater than, because again, as we talked about in the last problem, the result of this will always be 0 or positive. So it is not possible that it will ever be less than negative 9/2, because 0 or something that's positive will always be greater than some negative value. So for this type of problem, you have no solution. Okay, there is no solution here. Again, some people write the symbol for the null or empty set. Okay, so coming back up here, we would just say there's no solution. Okay, let's look at question 5. So we have this negative 3.1 plus 0.2 multiplied by the absolute value of 1.5x, then plus 2.4. Let me slide this down. I don't think I gave myself enough room. This is greater than, this is negative 2.89. Okay, so you know my feelings about decimals at this point. I think it's a waste of time to clear them because you can just work with your calculator with this. But I think in the interest of being complete, because some people would do this, I'm just going to clear the decimals, even though, again, I think it's a waste of time. So what I would do here, since the highest number of decimal places, again, don't worry about what's inside the absolute value bars right now. Just think about this one, and this one. So you have 2. So let's multiply everything by 100. So this would be negative 310 plus this would be 20 times the absolute value of 1.5x plus 2.4. Again, inside the absolute value bars, that's just going to stay. And then we'll say is greater than, if this gets multiplied by 100, it's negative 289. Okay, so from here, let's add 310 to both sides of our inequality. This would cancel. We have 20 times the absolute value of 1.5x plus 2.4. This is greater than, if I do negative 289 plus 310, I get 21. Let's divide both sides of the inequality by 20. And what is this going to give me? Let me cancel this with this. And let's write this as the absolute value of 1.5x plus 2.4 is greater than, now 21 and 20, there's no common factors other than 1. 20 is basically 2 times 2 times 5, and 21 is 7 times 3. But what I would do is if you got a problem with decimals, I would go ahead and divide this and put it in decimal form. So if I do 21 divided by 20 on my calculator, I get 1.05. So that's a nice clean decimal. So let's use that. And what we're going to do, since we have a greater than, we're going to set up a compound inequality with OR. So let's go 1.5x plus 2.4 is greater than 1.05. You can clear the decimals here, and then you can apply it to the other one. So let's do that real quick. I'm going to multiply everything by 100. So this would be 150x plus 240 is greater than 105. So now you're just going to go OR. Use the same numbers. So I'm going to go 150x plus 240. I'm going to flip this to a less than, and I'm going to change this to a negative. Okay, so that's all you really have to do. And then from here, I would just subtract 240 away from each side of the inequality. This is going to cancel. We're going to have 150x is greater than 105 minus 240 is going to be negative 135. Let's divide each side by 150. And we'll have x is greater than, let me show this is canceling. This would be negative. Now, since we were working with decimals, let's just divide it in our calculator. You're going to get 0.9. So x is greater than negative 0.9, or you could write x is greater than negative 9/10 if you wanted to write it that way. And then for this one, let's subtract 240 away from each side of the inequality. That cancels. You'll have 150x is less than negative 105 minus 240 is negative 345. So let's divide both sides of the inequality by 150. And what's going to happen is this will cancel. You'll have x is less than, this will be negative. Let's do 345 divided by 150 in our calculator. you're going to get 2.3 there. So again, because I'm working with decimals, that's how I'm going to list this answer. If you want to use fractions, that's up to you. I'm going to say x is less than negative 2.3. Okay, so let's look for our answer. We want x is less than negative 2.3 or x is greater than negative 0.9. So we're looking for this guy right there. Let's now take a look at the section quiz. For the first question, we're asked to solve each equation for x. And we are given this 5x plus 11 is equal to 4x minus 2. And remember, your goal is to get it in the form of x equals some number, okay, whatever that's going to be. And to do that, the first thing you do is simplify each side. Then you move all your variable terms to one side, all your constants, or you can say numbers, to the other. And then you isolate the variable. And then once that's done, you can check it if you want. Again, this is something that I advise you to do, but in some cases, you just don't have time. So let's get rid of this and let's go through the procedure. Each side is already as simple as we can make it. So let's move all the variable terms to one side and all the constants to the other. So I'm going to subtract 4x away from each side of the equation. And I'm going to subtract 11 away from each side of the equation. Let's show this is canceling and this is canceling. 5x minus 4x is just x, and this equals negative 2 minus 11 would be negative 13. That's my solution. Again, if you want to check this on your own, you can pause the video. You're going to plug a negative 13 in for each occurrence of x in the original equation, and you'll verify that you get the same result on the left as you get on the right. All right, let's look at question 2. So here again, we're solving each equation for x. We have negative 6x plus 3 is equal to negative 8x minus 5. Each side is already simplified. So let's go into the step where we add 8x to both sides, and let's subtract 3 from both sides. So again, move all the variable terms to one side, all the constants to the other, and then this is going to cancel, and then this is going to cancel. So on the left-hand side here, I have negative 6x plus 8x, that's going to be positive 2x, and this equals negative 5 minus 3 would be negative 8. To finish this up, we want to isolate the variable. And again, if 2 is multiplying x, then to undo that, I need to divide both sides of the equation by 2. This would cancel. You get x is equal to negative 8 divided by 2 is negative 4. So I'm looking for x is equal to negative 4. So I want that guy right there. Okay, let's look at question 3. So again, solving the equation for x, we have negative 2 times the quantity x plus 7, then minus the quantity 8 plus 4x. This equals negative 8x plus 3x. Okay, so on the left-hand side, let's clean up using our distributive property. So I have negative 2 times x, that's going to be negative 2x. Then negative 2 times 7 would be minus 14. This negative in front of the parentheses just means that you change the sign of each term inside. You can think about it as just multiplying each term by negative 1. So this would be minus 8 and then minus 4x. And this equals negative 8x plus 3x would be negative 5x. Okay, so on the left-hand side, I can make things simpler because I have like terms here. Negative 2x minus 4x would be negative 6x. And then negative 14 minus 8 would be negative 22. And of course, this is set equal to negative 5x. Okay, so from here, again, once I've simplified everything, I want all the variable terms on one side and all the constants on the other. So I'm going to add 5x to both sides of the equation. And I'm also going to add 22 to both sides of the equation. So let's show this is canceling here, and this is canceling here. And on the left-hand side, what I have is negative 6x plus 5x. That's negative 1x, or you could just put negative x. And this equals, over here, I just have 22. So very easy to get the solution. Remember, this is not done because we don't have x. We have the negative of x. So to fix that, you can multiply both sides by negative 1, or you can divide both sides by negative 1, whatever you want to do. Let's just multiply both sides by negative 1. I think we usually divide by negative 1 in each case, so let's just get a little change up. So basically, this negative would cancel with this negative, and you have x by itself. And this equals 22 times negative 1 is just negative 22. So I'm looking for x equals negative 22. Okay, let's look at question 4. So we have 12 times the quantity 8x plus 1, then minus 11 times the quantity 10x plus 1. This is equal to negative 6x minus 7x. So again, let's clean up as much as we can. Over here, 12 times 8 is 96. So let's put 96 here, then times x, then plus. 12 times 1 is 12. Then I'm going to treat this as negative 11, so I don't make a sign mistake. Negative 11 times 10 would be negative 110, then times x. And then negative 11 times 1 would be negative 11. And this equals, over here, negative 6x minus 7x would be negative 13x. On the left-hand side, 96x minus 110x would be negative 14x. And then 12 minus 11 is just going to be 1. So this equals negative 13x like this. So now again, we're going to move all the variable terms to one side, all the numbers to the other. So let's add 13x to both sides of the equation. And let's subtract 1 away from each side of the equation. Let's show this is canceling and this is canceling. If I have negative 14x plus 13x, that's going to be negative x. And this equals, over here I just have negative 1. Again, to get x by itself, you have a negative there. So you could just multiply both sides by negative 1 or divide both sides by negative 1. Let's change it up and just divide both sides by negative 1. So I'm going to say x here is going to be equal to, this cancels. We'll have negative 1 over negative 1, which is just positive 1. This is what we want, x equals 1. Okay, let's look at question 5. So it says to identify each equation as conditional, a contradiction, or an identity. Give the solution if possible. So we have 4/5 x minus 18/5 x is equal to negative 14/5 x plus 3/2. Okay, so if you have fractions in an equation, remember you can clear them by multiplying both sides of the equation by the least common denominator. And the least common denominator is found by finding the LCM, or the least common multiple of the denominators. So we have 5, we have 5, and we have 5. 5 is a prime number. Then we have 2. 2 is also a prime number. So in this case, the LCD is 5 times 2, or 10. So you're going to multiply every term here in this equation by 10, right? Or both sides of the equation by 10, however you want to think about that. So I'm going to take 10 and divide it by 5 and get 2. 2 times 4 is 8. So this would be 8x minus 10 divided by 5 is 2. 2 times 18 is 36, then times x. This equals 10 divided by 5 is 2. 2 times negative 14 is negative 28, then times x. Then plus 10 divided by 2 is 5. 5 times 3 is 15. Now, on the left-hand side, 8x minus 36x is negative 28x. This equals negative 28x plus 15. So most of you see that there's a problem, right? You have the same thing on each side of the equation, which means legally you can get rid of it. I can add 28x to both sides of this equation, and what happens? Negative 28x plus 28x, in each case, that is going to cancel. So this is gone and this is gone. Again, if you're doing addition or subtraction and you're canceling, your result is 0. So if there's nothing left on this side, you need to put a 0 there. So we're going to put 0 is equal to, in this case, 15. This is a false statement, right? So this is a false statement. So that tells me that the equation doesn't have a solution. So we'll come back up here. And what we want to do is say that our answer here is a contradiction and there's no solution. So we'll put this like this. Okay, let's look at question 6. Again, we're just asked to solve each equation for x. We have negative 3/4, then minus 3x is equal to, this looks like negative 5/2, and then times the quantity. Now, it's got brackets there, but you could use parentheses if you want. It's just grouping symbols. So negative 2/3 x, and then minus 5/2. So if you want to clear the fractions, what you need to do here, since you have parentheses or if you had brackets, you need to actually distribute first, so you don't end up doing double work. So let's write this as negative 3/4 minus 3x is equal to negative 5/2 times negative 2/3. The 2's there are going to cancel, right? Negative times negative is positive, so you're going to have 5/3 times x. Then we have negative times negative, which is positive. The 5 times 5 would be 25. 2 times 2 would be 4. And now what's my LCD? Well, the denominators, you have 4 and you have 3. So it would just be 4 times 3, which is 12. So if I multiply everything by 12, 12 divided by 4 is 3. 3 times negative 3 is negative 9. Then minus. If we have 12 times 3, that's 36. So this is 36x. And this equals 12 divided by 3 is 4. 4 times 5 is 20. Then times x. Then plus. 12 divided by 4 is 3. 3 times 25 is 75. So I can subtract 20x away from each side of the equation. Again, that's just moving all the variable terms to the left. So this is going to cancel. And then I'm going to add 9 to both sides of the equation. And this is going to cancel. And that's just moving all the numbers to the right. So negative 36x minus 20x would be negative 56x. And this equals, if we do 75 plus 9, that's going to give me 84. So as a final step, to get x by itself, I'm going to divide both sides of the equation by negative 56. So this would cancel. And you get x is equal to, I know this is negative. Let's think about 84. I know it's divisible by 7, so let's go 12 times 7. And I know 56 is divisible by 7. Let's go 8 times 7. Now you can see that there's also going to be a common factor of 4, so you can further break this down and put this 12 here as 4 times 3. And you can put this 8 here as 4 times 2. So basically, you can cancel a common factor of 28 between the numerator and denominator. So let's get rid of that. And x is going to be equal to negative 3/2. Okay, so x equals negative 3/2. That's what I want. All right, let's look at question 7. So we're given 0.5x plus 10.76 is equal to negative 3 times the quantity 1.7 minus 2.2x. So most of you know that I feel that clearing decimals is a complete waste of time, but we're just going to do it for the sake of completeness. So we'll do 0.5x plus 10.76. Not going to do anything yet because I want to clear these parentheses. So negative 3 times 1.7 is negative 5.1. Then we'll have negative times negative, which is positive. 3 times 2.2 is 6.6, and then you would have x. So now to clear the decimals, again, you look at how many decimal places each term has. So this guy has 1, 2, 1, and 1. So you go with the highest number of decimal places, and you want to multiply each side of the equation by 10 raised to that power. In this case, the highest number of decimal places is 2, so we want 10 squared or 100. So I'm just going to move the decimal point everywhere, 2 places to the right. So for this one, it would be 50x, then plus this would be 1076. This equals, this would be negative 510, then plus this would be 660x. So from here, let me move all the variable terms to one side, all the constants to the other. I'm going to subtract 660x away from each side of the equation, and let me subtract 1076 away from each side of the equation. So this is going to cancel here, and this will cancel here. On the left, 50x minus 660x would be negative 610x. This equals negative 510 minus 1076 is negative 1586. All right, so what I'm going to do now to get x by itself is divide both sides of the equation by negative 610. So we know in advance this is going to cancel. This is going to be positive. Now what I'm going to do, since I got a problem with decimals in it, I'm just going to give a decimal answer. And if you punch that into your calculator, you get 2.6. So I'll just circle x equals 2.6 as my answer. All right, let's look at problem number 8. So here we're asked to convert each repeating decimal into a fraction. And what we have is you have this 958, where the 958, those 3 digits repeat forever. As I told you before, if your repeating pattern starts immediately after the decimal point like it does here, you can use a little shortcut. So you just take these numbers here, the 9, the 5, and the 8, you put that in the numerator, and then in your denominator, you're going to put the same number of 9s in the denominator as the number of digits you have in this pattern. So here we have 1, 2, 3 digits. So I'm going to go 9, 9, 9. So this is going to be my answer here. So it's 958 over 999. And again, you can do this the slow way if you want, but we're going to have another example of that in a moment. Okay, so let's look at this one. Question number 9. Again, convert each repeating decimal into a fraction. So for this particular one, you can't use the shortcut. So you have to go through the long way. And there's lots of long ways to do this. But I'm going to first say x is equal to this guy. So 0.621. And then you'll have your 8, 9 here with a bar on it. And basically what I'm going to do is say that I have 2 guys there in my repeating pattern. So I want to multiply both sides of the equation by 100, or 10 squared. So what's going to happen is over here I would have 100x is equal to, this would go 2 places to the right. So I would have 62 point, and then 1, and then you'd have your 8, 9, where that repeats forever. Okay, so 8, 9, 8, 9, 8, 9, so on and so forth. Now what you're going to do from here is subtract equation 1 from equation 2. So this would end up being minus x over here. This would end up being minus 0.621 and then 8, 9. Now to get this to match up, remember the 8, 9 continues forever. So what you could do is just write another 8, 9 here like this. And you could do it like this and put the 3 dots just so it lines up so that you're mentally able to say, okay, looking at this guy, this is going to be cut off here, and out to infinity, this is always going to be the same. So if I'm doing a subtraction here, this is going to cancel and just become 0. So really all I need to do is 9 minus 1, which is 8, 8 minus 2, which is 6. I'll borrow here and say 11 minus 6 is 5, put my decimal point there. This would be a 1, and this would be a 6. So this is what I'm looking for here. On the other side, I would have 99x. So this is what we're working with. And then from here, I can multiply both sides by 1,000 to clear the decimal point there. And so that's going to give me 99. I'm going to put 1, 2, 3 zeros there, and then my x. This equals, I'm going to go 61,568. Let me put a comma in there as well. So from here, I'm just going to divide both sides of the equation by 99,000. So divide by 99,000, and I'll get rid of this. This is just going to cancel away, and you have this. Now, this doesn't actually match anything here, and that's because this fraction can be simplified. So what I would do here when you have something really large and your teacher asks you to go through and simplify, I would first say, okay, well, both of these guys are even. So I know they're divisible by 2. Looking at this bottom one, I know it's divisible by 4 and also 8. So I would probably start there. I know off the top of my head that 568 is divisible by 8. 568 divided by 8 is 71. So that tells me this whole number will be. So I would start by canceling a common factor of 8 and see what that gets me. If I divide this guy by 8, I'm going to get 7,696. If I divide this guy by 8, I'm going to get 12,375. Now again, if you didn't get 8 right away, that's fine. You could have started with 2 and then done another 2 and then another 2. You will eventually get to this answer. Okay, so they're always going to give you a way to get it, but this is basically what we're looking for. This 7,696 over 12,375. Okay, let's look at question 10. We're asked to solve each equation, and we have 2x plus 7 over 3 is equal to x minus 1 over 4. So again, this is just a simple proportion equation. All you really need to do is cross multiply here. So we would have 3 times the quantity x minus 1. So 3 times the quantity x minus 1 is equal to 4 times the quantity 2x plus 7. So using my distributive property, 3 times x is 3x, then minus 3 times 1 is 3. This equals 4 times 2x, that's 8x, then plus 4 times 7 is 28. Let's move all the variable terms to the left. So let me subtract 8x away from each side of the equation. Move all the numbers to the right. So let's add 3 to both sides of the equation. And let me make this 3 better. It's not really legible. And I'll cancel this and I'll cancel this. So 3x minus 8x would be negative 5x. This equals 28 plus 3 is going to be 31. Let's divide both sides of the equation by negative 5. This cancels. And we're going to get that x is equal to negative 31 fifths. So I'm looking for this answer right here. All right, let's look at question number 11. So the distance between Greenville, and I think this is pronounced maybe Bracklewhite or Bracklewhite, I'm not really sure, it's a fake name, is 3,000 miles. On a given wall map, this distance is represented by 10 inches. If the distance between Chesterfield, and I think this is Carlisle, is 7,800 miles, how far apart are they on the same wall map? So really for this one, you just set up a simple proportion. So I'm going to start with this guy to this guy. So we know that the distance, the actual distance is 3,000, I put 300, so 3,000 miles. And on the wall map, this is 10 inches. Okay, so that's all you really need to know. We'll set this equal to, over here, it tells you that the actual distance between these two is 7,800 miles. So 7,800 miles. And we don't know how far apart they're on the wall map. That's what we want to find. So let's just put x inches. So really simple. So we just cross multiplied to set everything up. So 10 times 7,800 is 78,000, like this. And I'll set this equal to, this would be 3,000. So 3,000 times x. To solve this for x, let's divide both sides by 3,000, just like this. And see what we get. We'll have x is equal to, this of course cancels, 78,000 divided by 3,000 is going to be 26. So looking at this guy, I know that x was 26, so it's 26 inches. So I want to circle this one for 26 inches. All right, let's look at question 12. So we're given s equals 2, and this is an L. I know some people will think that's a 1. Let me write it like this. So LW plus 2WH plus 2HL. All right, so looking at this equation, we want to solve for h. So there's an h there and an h there. Since we can't really simplify anything, we would want to move all the terms with h in it to one side and then everything else to the other. So I like my variable to be on the left. Let me do this the slow way so no one gets lost. I'm going to subtract this 2LW away from each side of the equation, and I'm going to cancel this. So I'm going to write this on the right, even though right now it's on the left. So on the right, I'm going to put s minus 2LW, and that's completely legal. I'm going to say that equals, over here, I'm going to put 2WH, then plus 2HL. Now, how can I get h by itself? You have an h there, you have an h there. What operation would legally allow me to bring this out and put it in front of a set of parentheses? Remember, that's factoring. So I can put an h there. Inside the parentheses, I would have 2w plus, you have 2l. So 2l. I know the l is kind of cut off there, but that's what you have. Then this is equal to s minus 2lw. From here, h is being multiplied by this quantity 2w plus 2l. So to get h by itself, I'm going to divide both sides by that quantity, 2w plus 2l. So over here, 2w plus 2l. Now, I need parentheses here because this is a quantity that's being multiplied by h. So I'm going to cancel this and this. You don't really need parentheses over here. You could put parentheses, but they don't really do anything. So you can really just remove them. So now I have that h is equal to, you have s minus 2lw over 2w plus 2l. All right, so looking through my answers here, it looks like I want this one down here. H is equal to, we have s minus 2lw, then over 2w plus 2l. So this guy right there. Okay, let's look at question 13. We're asked to solve each inequality for x. So we have negative 31 over 12 is less than or equal to negative 1/2 x minus 4/3. Then this is less than or equal to negative 35 over 24. So you can clear the inequality here of the fractions. The LCD here would be 24. You have 12, you have 2, you have 3, and you have 24. So it would be 24. So if I multiply everything by 24, 24 divided by 12 is 2. 2 times negative 31 is negative 62. So this is less than or equal to, 24 divided by 2 is 12, so this would be negative 12, and then times x, and then minus. 24 divided by 3 is 8, 8 times 4 is 32, and then I'll put my less than or equal to, 24 divided by 24 is 1, so this is just negative 35. Okay, so what we have here is a three-part inequality, and I'm just going to do the same thing to each part. I'm trying to isolate the x in the middle, so I'm going to first add 32 to each part here. Let's see where that gets us. This would cancel. On the left-hand side, negative 62 plus 32 would be negative 30. I'll put this as less than or equal to. This canceled, so you have negative 12x. And I'll say this is less than or equal to negative 35 plus 32 is negative 3. So now in order to isolate x here, I've got the negative 12 that's multiplying it. I'm going to divide each part by negative 12. The key here is to remember, when you multiply or divide an inequality by a negative, you have to flip the direction of the inequality symbol. We start with negative 30 over negative 12. We know that's going to be positive. 30 is 6 times 5, and 12 is 6 times 2. So let me just write that real quick. This is 5 times 6, and this is 2 times 6, and this would cancel. So this would be 5/2. So we'll put 5/2. We're going to flip this to a greater than or equal to. This cancels, so it's just x. We're going to flip this to a greater than or equal to. And this, we know that it's positive. 3 over 12, we know each is divisible by 3. This would be 1/4. We want to rewrite this in the order of the number line. So I want to put the smallest number all the way to the left. So I'll put 1/4 is less than or equal to x, which is less than or equal to this 5/2. And looking through my answers, I want this guy right here. Again, x is greater than or equal to 1/4 and less than or equal to 5/2. Okay, let's look at question 14. So we have, and I'm probably just going to distribute this as I read it. So negative 6 times the quantity 1 plus 6x, that would be negative 6 and then minus 36x. This is less than, you have negative 6 times the quantity 1 plus 11x, so that would be negative 6 and then minus 66x. And then you have plus 6x. All right, so right away you can see that you have negative 6 over here and over here. If you have the same thing on each side of an inequality or an equation, you can get rid of it, right? Because I could add 6 to both sides of the inequality and it would be gone. So what I would do here, negative 66x plus 6x, that is going to give me negative 60x. And then over here, my negative 36x. So I'm just going to add 60x to both sides of the inequality. Remember, if this cancels in its addition or subtraction, you want to put a 0 there, right? So negative 60x plus 60x is 0. So you want to actually show that there because there's nothing else. Then over here, negative 36x plus 60x would be positive 24x. And I could finish this up by dividing both sides of the inequality by 24. This cancels. You get x is less than 0. So I'm looking for this right here. X is less than 0. All right, for question 15, we have this 10 times the quantity 3x minus 14. So I'm going to distribute now. So this would be 30x minus 140. And then you have minus 14 is less than, you've got negative 10 times the quantity 6 minus 3x. So negative 10 times 6 is negative 60. And then negative 10 times negative 3x is positive 30x. So looking at this, you see 30x here and 30x here. You can just get rid of that. So what am I left with? Is the statement true or is the statement false? When you get this type of situation, it's either going to always be true or never be true. So negative 140 minus 14 is negative 154, and we're saying this is less than negative 60. Yes, this is a true statement, and so this inequality will always be true no matter what you plug in for x for any real number. So this is what I want. I want all real numbers as my solution. Okay, let's look at problem 16. So it looks like we have 0.53 is less than 2.6 plus 2.3x, which is less than or equal to 8.35. Okay, so I'm going to multiply everything by 100. So this would be 53 is less than 260 plus 230x, which is going to be less than or equal to 835. So again, completely unnecessary if you're working with a calculator. I'm just doing it for the sake of completeness. So let's subtract 260 away from each part here. See where that gets us. This cancels. 53 minus 260 would be negative 207. This is less than 230x, which is less than or equal to 835 minus 260 is 575. All right, so let's divide each part here by 230 and see where that gets us. So using my calculator, if I divide negative 207 by 230, I'm going to get negative 0.9. Again, if you want to write that as a fraction, that's up to you. We'll say this is less than, this cancels, so we have x. And then we're going to say this is less than or equal to 575 divided by 230, that's going to be 2.5. Okay, so coming back here, we see we want this answer here. We want x is greater than negative 0.9, and it's less than or equal to 2.5. Let's take a look at problem number 17 now. So we're told to solve each inequality, and we're going to have 18 plus 12x is less than 18 minus 9x. Then we have our keyword and we have 2 plus 10x is greater than 1 plus 9x. Let's start with the one on the top. You have this 18 here and this 18 here. Obviously, you could subtract 18 away from each side. You would end up with 12x is less than negative 9x. I could then add 9x to each side, like this. And what that's going to do is cancel over here. Remember, it's going to be 0. So negative 9x plus 9x is 0. Because we don't have anything else over here, we want to show that. This is going to be a less than here. Then 12x plus 9x is 21x. As the final step, let's divide both sides of the inequality by 21. This will cancel. You'll have x is less than 0. Okay, so I'm going to write the keyword and here just so we don't forget. And then for this guy right here, we have 2 plus 10x is greater than 1 plus 9x. What I'll do is subtract 9x away from each side of the inequality, and I'll subtract 2 away from each side of the inequality. Let's do some canceling. So we see that this would cancel and this would cancel. On the left-hand side of my inequality, I'm going to have 10x minus 9x, which is going to be positive x. This will be greater than 1 minus 2 would be negative 1. So we see here we have x is greater than negative 1. Okay, so the way I like to write this if I have an and, I want to put this guy here on the left. Then I want to write my and what I'll do is I'll put the x is less than 0 on the right. And the reason I do that is because it makes it clearer in terms of writing the three-part inequality. I see what x is greater than, and I see what x is less than. If you wanted to put this on a number line just to be crystal clear, let's say this was negative 1, and let's say this was 0. Well, thinking about this, we're saying that x is greater than negative 1, so it's greater than negative 1, but it's less than 0. So it's basically going to be in this interval here on the number line, which would be the numbers between negative 1 and 0, right? Not including either one. So as a three-part inequality, you would say x is going to be greater than negative 1 and less than 0. So just coming back up here, this is the solution that we want. Again, x is greater than negative 1 and less than 0. All right, let's take a look at question 18 now. We're told to solve each inequality. So we're going to have this 2 times the quantity 9x plus 1. Then we're adding 5 to that. This is greater than negative 7 times the quantity 3x plus 6 and then plus 10. Then we have our keyword or. Then we'll have 10 minus 12 times the quantity x plus 4. This is greater than 7 times the quantity 2x plus 5 and then plus 5. Okay, so for the top guy right here, let's go through and just clean up, use our distributive property. So 2 times 9x would be 18x, then plus 2 times 1 is 2, then plus 5. 2 plus 5 is going to be 7, so let's just write this as 18x plus 7. This is greater than, over here, negative 7 times 3x would be negative 21x. Then negative 7 times 6 would be minus 42, then plus 10. Negative 42 plus 10 is going to be negative 32. So to solve this, let's just add 21x to both sides of our inequality. Let's also subtract 7 away from both sides of the inequality. That cancels, that cancels. 18x plus 21x is going to be 39x. This would be greater than negative 32 minus 7 would be negative 39. So to finish this up, let's divide both sides of the inequality by 39. This cancels. We're going to have x is greater than negative 39 divided by 39 is negative 1. All right, for this other one here, let's write 10. I'm going to treat this as negative 12 for distributing. So negative 12 times x would be minus 12x. And then negative 12 times 4 would be minus 48. This is greater than 7 times 2x is going to be 14x. And then plus 7 times 5 is 35. And then plus 5. So 35 plus 5 is going to be 40. Let's erase this and put 40 here. Then over here on the left, 10 minus 48 would be negative 38. So let's put negative 38 there. We're going to subtract 14x away from each side of our inequality. Let's also add 38 to each side of the inequality. This would cancel and this would cancel. Negative 12x minus 14x would be negative 26x. We have a greater than. 40 plus 38 is going to be 78. Let's divide both sides of the inequality by negative 26. And of course, if we divide both sides of an inequality by a negative, we have to flip the direction of our inequality symbol. So instead of a greater than, we're now going to have a less than. This cancels. So x is less than. 78 divided by negative 26 would be negative 3. So recall this was an or. And actually, let me rewrite this. I like to put the leftmost guy in terms of the number line on the left. So let me just write x is less than negative 3 here. I'm going to erase it from here. I'm going to put my keyword or in there, and then I'm going to put x is greater than negative 1, just so that it's consistent. Again, if you want to think about this on the graph, all this is saying is that basically, let's say this is 0, this is negative 1, negative 2, negative 3. Well, x could be any number that's less than negative 3. So from here out to negative infinity. Then x could also be any number that's greater than negative 1. So from here out to positive infinity. So that's what this guy looks like graphically. We're going to take this solution right here. We want this x is less than negative 3 or x is greater than negative 1. Okay, let's look at question number 19. So now we're getting into some absolute value equations. So we have 4 minus 7 times the absolute value of 5x plus 4. This is equal to negative 24. Now, before you decide that there's no solution, again, if you see a negative over here, don't immediately say that there's no solution. You have to go through the process of isolating these absolute value bars, or you could say the absolute value operation, and then seeing if the number on the other side is negative. So over here, let's subtract 4 away from each side of the equation. That's gone. You have negative 7 times the absolute value of 5x plus 4. This equals negative 24 minus 4 would be negative 28. Let's divide both sides of the equation by negative 7. So like this, and let's cancel this with this. And so what we have is the absolute value of 5x plus 4 is equal to negative divided by negative is positive, 28 divided by 7 is 4. So you see that now that we have this guy isolated, we can get a solution because this guy is positive over here. So again, a lot of people make that mistake. They see a negative on the right-hand side. They immediately exit the problem and say no solution when you actually have to do a bit of work to see if there's no solution. So for this type of equation, again, it could be true that this expression right here is equal to 4, or because of the absolute value operation, it could be equal to negative 4. Because when we take the absolute value of negative 4, we're right back to that number 4. So I could say 5x plus 4 could be equal to 4, or 5x plus 4 could also be equal to negative 4, because again, if I get negative 4 in here, the absolute value of that is going to flip it back to positive 4. So let's just solve these two equations. And I'm going to subtract 4 away from each side over here. That cancels. I get 5x is equal to 0. Divide both sides by 5. And I get x is equal to 0. So or over here, subtract 4 away from each side of the equation. That cancels. 5x is equal to negative 8. Divide both sides by 5. And you get this cancels. X is equal to negative 8 fifths. So again, I would probably write this as x equals negative 8 fifths. And then I'll put a comma and then 0. So I'm looking for this answer right here. X equals 0, comma, negative 8 fifths. All right, let's look at question 20. So we have 4 times the absolute value of x plus 1, then plus 6 is equal to negative 38. So in this case, I can already eyeball that and see that there's no solution. I'm just going to tell you that in advance. But you always want to go through and isolate this first. So let's do that. The reason I know that it's going to be no solution is because I can see here that when I subtract away 6, this is still going to be negative. And when I divide by 4, this is still going to be negative. But I'm going to subtract away 6, and this is going to be 4 times the absolute value of x plus 1 is equal to negative 38 minus 6 is going to be negative 44. We'll divide both sides of the equation by 4. And so this cancels, and you get the absolute value of x plus 1 is equal to negative 44 divided by 4 is negative 11. So again, this is not possible. And the reason for that is simple. The absolute value operation is always going to give you a result that is 0 or positive. So it can never, ever, ever be equal to negative 11. So there's no solution here. Okay, let's look at question 21. So again, we're asked to solve each inequality. So we have 10 minus 6 times the absolute value of 7x minus 5. This is less than negative 86. So what I want to do here is isolate again my absolute value operation before I make any decisions about anything. So let's first subtract 10 away from each side of the inequality. This cancels. You'll have negative 6 times the absolute value of 7x minus 5. This is less than negative 86 minus 10 is negative 96. Let's divide both sides of the inequality by negative 6. Remember, because you're working with an inequality, if you divide by a negative, you have to flip the direction of the inequality symbol. So this would cancel. What you'd have here is the absolute value of 7x minus 5 is greater than negative 96 divided by negative 6. That's going to give me positive 16. So recall from the lesson and also from the practice tests and the quizzes that if this is isolated and you have a greater than, you want to set up a compound inequality with OR. So I want to say that 7x minus 5 could be greater than 16, or 7x minus 5 could be less than negative 16. All right, so from here, let's add 5 to both sides of the inequality. That cancels. You get 7x is greater than 16 plus 5 is 21. Divide both sides of the inequality by 7. This cancels. You get x is greater than 3. Over here, let's add 5 to both sides of the inequality. That cancels. You're going to get 7x is less than negative 16 plus 5 is going to be negative 11. Divide both sides of the inequality by 7. That cancels. You're going to get x is less than negative 11 over 7. So coming back, we want this answer here. We could say x is greater than 3, or x could be less than negative 11 over 7. All right, let's look at question number 22. So we have 3 minus 2 times the absolute value of 3x minus 3. This is greater than negative 21. All right, so I'm going to subtract 3 away from each side of the inequality. That'll cancel. I'll have negative 2 times the absolute value of 3x minus 3 is greater than negative 21 minus 3 is negative 24. Let's divide both sides of the inequality by negative 2. This is going to flip, and this is going to cancel. So we have the absolute value of 3x minus 3 is now less than negative 24 divided by negative 2 is positive 12. So if we have a less than and this guy's isolated, you want to set yourself up a little 3-part inequality. So we're going to take this guy and put it in the middle. So we'll say 3x minus 3 could be greater than, you'll put negative 12, and less than positive 12. And we just solve this by adding 3 to each part to kick things off. This is going to cancel. And you'll have 3x is greater than negative 12 plus 3 is going to be negative 9. And we'll say, and it's less than 12 plus 3. Let me make this 3 better. I think it's not legible. So 12 plus 3 is 15. Let's divide each part here by 3, like this. This cancels. We'll have x is greater than negative 9 divided by 3 is negative 3. We'll say, and it's less than 15 divided by 3 is 5. So this would be my solution. X is greater than negative 3 and less than 5. So I'm looking for this right here. X is greater than negative 3 and less than 5.